Introduction. Did you know that most corporate-level applications are powered by Java? If you are new to Java and have been hesitant to jump in, you have come to the perfect place. In this course, we will embark on a structured, step-by-step exploration of Java. Starting with the fundamentals, we will gradually move into more advanced topics, all presented in a way that's easy to understand and apply. With over 20 hours of instructional content, including tutorials, you will have plenty of chances to practice and master what you have learned. Whether you are a complete beginner or someone with a bit of programming experience, this course is tailored to fit your needs. And if you already have a background in programming, you will be able to quickly move through the material and elevate your skills. And here's the best part. If you are looking to land a job in Java or take your career to the next level, this course is exactly what you need. Plus, with our 30-day money-back guarantee, there's no risk involved, just the opportunity to gain valuable skills. So why wait? Enroll today and start your journey towards mastering Java. Course overview. Hello, everyone. Please spend a couple of minutes with me to know what exactly you are going to learn in this entire course. I have broken down this entire course in 9 different sections that includes quizzes as well as practice exercises. Then starting with section 1, which is about the introduction, we will go through the computer languages and what are the different types of computer languages out there before you actually jump into Java. Then we will get into the object-oriented programming. Why do we use that? What's the difference between a regular programming and object-oriented programming? Then we will talk about programming application examples, like what are the applications that are built using all these different type of programming languages and codes. Then we will talk about the programmer and developer. This is one of the questions that I get asked many times. Can you tell me the difference between a programmer and developer? So I am adding that for you, so you will know from the get-go the difference. Then moving on to section 2, which is starting right on to Java, we will go into the introduction to Java, the importance and how to succeed as a Java developer. We will talk about the tools like JDK, JVM, and ID. Then we will jump into section 3, where we will design our lab. So we will get our hands dirty and start the work and start writing the code. So together we will design the lab and do the installation of JDK in Windows as well as in Linux. So I have given you both options to pick from. Then we will go through the introduction. Moving on to section 4, which is Java Basics. Always start with basic to make sure that you know everything just from the get-go. First, Java code. This is where we will write Hello World, the first very code that will do it together. Then getting into Java variables and expressions types in Java primitive data and types. Example type casting in Java float versus double primitive data types, character strings operators, and much more. Moving on to section 5, which is ID, which stands for Integrated Development Environment. We will start with introduction. Then we will get into the installation of IntelliJ IDEA. And again, I am not taking anything for granted. I am covering Windows as well as Linux, so you can cover both, then getting into the functionality, conditional statements operators, so many different operators that we will cover one by one. Then getting into section 6, expression and statement keywords, whitespace, indentation control statements. Then we will talk about concept, different concept as a nested, then methods overloading exercise return statements. Coming to section 7, control statements. There are many statements we're going to go through. We are going to go through loops, debugging, local variables, classes, input scanners. Then section 8, object-oriented programming, more detailed into advanced level classes and objects, getters, setters, constructors, reference instances, handlers, inheritance overloading and overriding, strings. We are going to go through composition, encapsulation, and polymorphism, which are the main pillars of object-oriented programming. You will learn more about this when we get through this. So right now I'm just setting your expectations, and in the 9th section is about arrays. Everything in utility array, reference, value types, runtime, multi-dimensional arrays, and so much more. Finally, we arrive at the last section, section 9, which is about array list and linked list, starting with list, exploring linked list in relation to arrays, diving into queue and stack, and working with iterators, autoboxing, unboxing, and enumeration. Now you at this time ask yourself, Is this the course that you are looking for? I'm telling you, and I bet you this is the course. We'll get you everything you need to know about Java. So let's go ahead and enroll. What is computer language? Before we explore the topic of Java programming, first, it is very important that we understand what is computer language. Computer does not know any human language, so they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language that's 0 and 1 language, it's called binary. Computers store all characters as numbers on hard disks. Because computers don't know what is hello or how are you is. Computers convert that into these numbers, zeros and ones. And that's how it stores that information into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power, or if your battery runs out of your laptop, your computer will shut down. So, computer transmits the data to save that data. It actually uses 0 and 1, and that 0 and 1 concept came from the electricity. 0 means off, and 1 means on. So this I or 1 that you probably see on your Switch, if you go to your Switch right now, or if you have an older Switch, probably newer Switch don't have those 0 and 1 anymore. But if you find one in your house, you're going to look at it closely. And you're going to see one on top, or at the bottom, depends which country you are in. So the 1 means that turn on, 0 means to turn it off. Similarly, the computer sends or saves the data on the computer or transferred the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. Each letter that we have has a number, or a binary number associated with it. So, like A has 1,000,001, B has 1,000,001, and so on. So, now let's say if you type it in, hello, on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory. This hello means these digit, so process it. So, the first thing you will do is, we'll take the first character, which is H. And by looking at the chart, you will see the H translates to 1,000,000, meaning on off off. On off off off, same thing E, 1,000,101. L, and O. Oh, 1,001,111. So that's like a cheat sheet the computer has, and computer knows that. When the letter H comes in, or E comes in, I'm going to have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, on off, on off, on off. And that's how it actually moves the data from one computer to another, or from your keyboard to the hard disk. I hope now you have a better understanding of computer language. You might be wondering why programming languages like Java, Python, Ruby, and so on are necessary if computer already has its native binary language. That's an excellent question. Now, allow me to clarify one thing. It is indeed possible to write programming code directly in binary language, but it would be very tedious and time-consuming. The reason we use these programming languages is that they enable us to write code in a manner that is more accessible for humans to understand, debug, and of course troubleshoot, in case there is an issue. So ultimately, regardless of the programming language that you use, the code you write is executed by the computer hardware in the form of binary instructions. In addition, binary language is commonly known as low-level language, while other programming languages are referred to as high-level languages. It is important to note that the term low or high level do not imply any kind of ranking. Binary language is considered low level because it directly interacts with the computer hardware, while the other programming languages operate on top of it. When a higher level language communicates with a computer, there is an intermediary component that translates it into machine or binary language. This essential bridge that you see, that middle piece between them, is known as a compiler software. So, I hope this clarifies the concept of a computer's native language and why we utilize other programming languages. In the next video, we will cover some of the commonly used programming languages available. Types of programming languages. In this lecture, we will provide an explanation of the various types of programming languages. As discussed previously, programming languages are commonly categorized into two types: low-level and high-level. Low-level languages are designed to be understood directly by the machine and executed by the CPU. On the other hand, high-level languages are more user-friendly and resemble human language. By utilizing these high-level languages, programmers can write code more efficiently and effectively, reducing errors and saving time. Also, high-level languages are designed to be closer to natural language and allow programmers to express their intentions. So coming back to the topic, there are various types of programming languages, each designed with different purposes and applications in mind. Here are some of the main categories. First one is procedural programming languages. In procedural programming, a program is divided into a series of procedures or functions that are executed in a sequential manner. These procedures contain a series of instructions that are performed step by step to solve a problem or complete a task. Examples include C, Pascal, and Fortran. Next one is object-oriented programming language, which is the primary focus of our course. The OOP, object-oriented programming language, organizes code around objects. Now, what is an object? An object can be anything that you see around you, for example. A table, chair, a phone, a glass, cat, a game player, or even a button. It describes what a thing is and what it can do. Examples of these languages are Java, C++, Python, C#, Ruby, PHP, etc. I will cover the object-oriented programming in more detail in the next video. The next one is functional programming languages. Functional languages see computation as performing calculations just like in math. They focus on making things unchangeable and avoiding actions that can cause unexpected consequences. Examples include Haskell, Lisp, and Erlang. Then there are scripting languages. These languages are designed for scripting and automation tasks. They are often understood and processed as they are read, and they can handle different types of data without strict rules. Examples include Bash, shell scripting, C Shell, JavaScript, Perl, Ruby, and so on. Markup languages. These languages are used to define the structure, presentation, and behavior of documents. They are not traditional programming languages, but are essential for web development. Examples are HTML, XML, and CSS. Query languages. These languages are designed specifically for querying and manipulating databases. SQL, which stands for Structured Query Language, is the most well-known example. Some others are domain-specific languages, concurrent programming languages, logic programming languages. What is object-oriented programming? In this lecture, we will discuss object-oriented programming in more detail, and I will try my best to explain it in a very simple way. In object-oriented programming, we mainly deal with objects. An object can be anything, like a person, place, or thing. It has a specific structure and can do certain things. If we think about things that are not considered objects, we're talking about entities that don't have a clear shape or form and don't do anything specific. Examples of such non-object entities are emotions, like happiness, or abstract ideas like freedom. These things are not classified as objects because they don't have a physical structure and don't show actions in the same way as concrete objects do. Let me explain you the object-oriented programming through an example. Going back to the basics of programming, which is procedural or sequential programming. In this programming, you write a code in a sequence. For example, we want to write a code, which will have a set of instructions, and for that, we will use an example of driving a car and pick up groceries. So the code will look something like this. Unlock the car. Start the car. Check your rear view and side view mirrors. Fasten your seatbelt. Drive to the nearest grocery store. Buy a loaf of bread and a dozen eggs. Unlock the car. Start the car. Check your rear view and side view mirrors. Fasten your seatbelt. Drive back home. Now, if you notice that actions 1, 2, 3, and 4 are similar to actions 7, 8, 9, and 10. Imagine if you have to stop off at other stores as well, then you are repeating these steps again and again, which is of course not efficient. So what we do is we can define an object, and it functions in something we call a class. So it will be class of an object, and the object will be the car. For example, we define car as an object, and its class that have functions of unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt. Now, if we write our code again, it will become a lot easier to manage. Look at that. Object is the car. Drive to the nearest grocery store. Buy a loaf of bread and a dozen eggs. Then again, object is the car. Drive back home. So see, now our code suddenly became from 11 lines to 5 lines. Therefore, object-oriented programming is a way of writing computer programs that focuses on organizing and managing data by grouping it together with the code that operates on that data. In simple words, object-oriented programming treats everything in a program as objects that have their own unique characteristics and behaviors. It helps programmers to create modular and reusable code by breaking down the program into smaller, self-contained objects that interact with each other. Just like we create a car as an object that has its own self-contained program. This approach allows for easier understanding, maintenance, and expansion of the program. Application examples of different programming languages. So far, we have learned all the different types of programming languages. Now, let's spend some time to understand which language is best suited for which application. I want to start off with C++, is a powerful and versatile programming language that was developed as an extension of C programming language. It was created in the late 1970s with the intention of adding object-oriented programming features. So let's take a few examples of C++ applications that are available today. The very first one is the operating systems. Most of the operating systems that you use or build on your computers nowadays are built using C++, and examples are like Windows, Mac OS, and Linux. Then, there are many games that are built using C++, such as Grand Auto Theft, The Witcher, World of Warcraft, Doom, League of Legends. Moving on to graphics and multimedia applications, such as Adobe, Autodesk, Blender, and DirectX. Then there are financial systems that are built using C++. Some of them are like trading systems, risk management software. Then there are database management systems that uses C++ language. And those database management system examples are like MySQL, PostgreSQL, and MongoDB. And then the embedded systems are also built using C++. And those systems are automotive systems, medical devices, and smart home automation. That's about C++. Now, let's talk about our main focus of the course, Java. Java is programming language that can run on different computer systems without needing changes. Examples of Java applications are big business software, such as Customer Relation Management System, Human Resources Management System, Supply Chain, and so on. Also, Java is heavily used on websites, such as banking system, e-commerce platform, content management system. Mobile apps are also built using Java, primarily in Android. Mobile apps examples are WhatsApp, Facebook, Instagram, Spotify, Airbnb, Uber, and the list goes on. Then other applications, such as scientific applications, are used or are built using Java. and examples are image analysis, processing, computational chemistry, bioinformatics, astronomy, and so on. Then not to forget the games. There are many games that are built using Java, such as Minecraft, RunEscape, and many other puzzle and game or card games that are used using Java language. The next one is Python, which is easy to learn and understand. Example of Python applications are web development. Now, you probably notice web development is something that can be done using many different languages. It depends the purpose of your website. You could use different languages to build it. The examples of Python web applications are Instagram, Pinterest, Dropbox, and Reddit. Data analysis and visualization is another form of application that is built using Python. And examples are Jupyter Notebook, Pandas Data Frame, Seaborn. Then moving on, machine learning and artificial intelligence applications are built using Python. And some of them are image classification, virtual assistant, healthcare applications. Moving on to the list of applications, using Python is scientific computing. Then we have automation and scripting application. We also have desktop GUI application that can be built using Python, and examples of those GUI applications are like calculator, text editor, music player, spreadsheets, and so on. Then not to forget games. Game development can be done using Python as well. In the example of games are Snake Game, Tic-Tac-Toe, Hangman, Sudoku, and many other applications. Then moving on to C#. While C# is a programming language made by Microsoft, it is used to create different type of applications, such as Windows desktop application like text editor, media player, file compression. Then there are web applications such as e-commerce website or real estate listing platforms, booking and reservation system, online learning management system. Other applications are like mobile application, which are fitness tracking, expense tracking, newsfeed, task manager. Then games, 2D platformer, racing games, adventure simulation games can be built using C#. Then moving on to Ruby. Ruby is a dynamic object-oriented programming language known for its simplicity and readability. Examples of Ruby applications are web applications, mainly used for social networking websites, online marketplaces, and blogging platform. Then we use command line tools, or we build command line tools using Ruby. And those tools are like backup utility, password generator, network monitoring tools. Then there are automation scripts that are built using Ruby, mainly used within the operating system for tasks, such as scheduler, database maintenance, deployment. Then applications. Other applications are like testing and quality insurance. And the last one, and not to forget the most famous one, that is coming nowadays, really famous, are the chatbots. Those chatbots are used for customer support, travel assistance, job search, and language learning. So, now I'm sure you understand why we have so many different programming languages, and which one is best suited for your needs. Programmer versus developer. In this lecture, our focus will be on understanding the distinction between a computer programmer and a software developer. We will explore the unique roles and responsibilities associated with each profession. A computer programmer is defined as a person who has expertise in programming languages and uses such languages to create code for applications. Additionally, they might help write tests for these apps. A software developer, on the other hand, is more involved in the application's design. They spend a lot of effort ensuring the usability and behavior of the application, including how users interact with it, the application's flow, and its accessibility. Software developers frequently collaborate extensively with clients to fully grasp their needs and choose the best possible solutions to include into the application. The primary focus of a software developer is to prioritize understanding the customer's needs and finding effective solutions to address those needs. They place a strong emphasis on creating user-friendly applications that effectively solve the customer's problem. Let's consider a scenario where ABC Bank is a well-established financial institution, recognizes the increasing demand for mobile banking services among its customer base. To meet this demand and provide customers with convenient and secure access to their accounts, ABC Bank decides to develop a mobile banking application. The project begins with a team of software developers in this scenario. They work closely with ABC Bank's product managers, business analysts, and user experience designers. They conduct user research, gather insights, and analyze customer needs and expectations from a mobile banking application. Based on this information, the software developers create wireframes and design mock-ups of the application's user interface. They focus on designing an intuitive and visually appealing interface, ensuring easy navigation and smooth user interactions. They incorporate user-friendly features, such as Touch ID or facial recognition, for quick and secure authentication, as well as options for personalized notifications and account alerts. Throughout the development process, software developers maintain a constant feedback loop with stakeholders and customers, conducting usability testing sessions and gathering feedback to iterate and improve the application's design and functionality. They prioritize understanding customer needs, designing a user-friendly interface, and ensuring an optimal user experience. While the computer programmers in this scenario collaborate with the bank's department, software architects, and software developers. They are proficient in programming languages such as Java and Swift. Their primary responsibility is to implement the technical requirements and architecture defined by the team. The programmers start by creating the authentication module, enabling users to securely log into their accounts. They implement encryption protocols and establish secure connections with the bank's servers to safeguard sensitive information. They then focus on developing the core functionalities of the mobile banking application, such as displaying account balances, transaction histories, and e-statements, as well as integrating secure payment gateways for fund transfers. They ensure that the application adheres to industry standards and best practices to mitigate security risks. The computer programmers also work closely with the quality assurance team to write comprehensive test cases and conduct rigorous testing, including functional and security testing. They prioritize the technical implementation of the application's features, ensuring reliability and accuracy. Introduction to Java. In this lecture, we will start with our primary focus of Java. Previously, we covered high-level and low-level programming languages and the purpose of each language and its applications. So, now let's start with the definition. As per Wikipedia, Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let programmers write once, run anywhere, meaning that compiled Java code can run on all platforms that support Java without the need to recompile. Now let's put in very simple words. Java is a programming language that allows you to create software and applications for various devices, like computers, smartphones, and more. Whenever, you will go to find the purpose of Java. One advantage of Java will be repeated and highlighted in all of its purposes that Java is a platform-independent language. Because of this advantage, Java is also called a two-stage system. This means that Java source code is converted to machine code in 2 steps. In first step, the code is translated into a special format called bytecode by a program compiler. And in the second step, the bytecode translated into machine code by a program called an interpreter. This special process makes Java more secure because the code runs in a controlled environment, preventing any harmful actions. So, thanks to this Java feature, which made Java more secure and gave it the ability to run on different devices without any changes. Java was also designed to be easy to learn and use, and to be efficient and reliable. These characteristics have contributed to the popularity of Java and have made it a widely used language for building a variety of applications. Now, let's talk about the history of Java. So, Java was originally developed by James Gosling, Mike Sheridan, and Patrick Naughton at Sun Microsystems in the early 1990s. The project was initially referred to as Oak after an oak tree that stood outside James Gosling's office. However, the name Oak faced legal challenges when Sun Microsystems realized that another company already had the rights to that name. As a result, they had to look for an alternative. Eventually, in 1995, the name Java was chosen as a replacement for Oak. The name Java is said to be inspired by the coffee beans from Java Island in Indonesia, reflecting the team's passion for coffee. That's why, if you see the logo of Java, it's a coffee cup, because it is connected to coffee beans from Java Island, Indonesia. In the logo, the rising steam adds a fun and lively element, representing the language's energetic and dynamic nature. So, Java was seen as a unique and catchy name that could be trademarked without any issues. Using Java, James Gosling, Mike Sheridan, and Patrick Naughton initially wanted to make a system for interactive television, but later they changed it to work on the World Wide Web. So, Java was designed for one purpose, but ended up being used for something else, and became so popular on the internet. Java became available to the public in 1995, and became very popular because of its special feature, called Write Once, Run Anywhere. In 2010, Oracle Corporation bought Sun Microsystems, and that's when they got the Java programming language. Nowadays, Java is super famous and liked by many programmers all over the world. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Importance of Java. In this lecture, we will discuss the importance of Java. Java is an important programming language that has a significant impact on the software development industry. Java has gained widespread adoption and is considered one of the most popular programming language in the industry. It has a large community of developers and extensive usage across various domains. Therefore, Java is also known for its flexibility, which allows developers to adapt and extend the language to suit various programming needs. Some of the key aspects highlighting Java. Flexibilities are libraries and framework, compatibility with existing system development tools and ecosystem, community support, platform independence and backward compatibility, robustness and security. Let's go over them one by one and discuss them in more detail. The first one is libraries and framework. Java benefits from an extensive collection of libraries and framework that enhances its flexibility. These libraries cover a broad range of functionalities, such as database connectivity, networking, web development, machine learning, and a lot more. Then the next one is compatibility with existing systems. Java's compatibility with legacy systems is another factor contributing to its flexibility. Java supports various integration mechanisms, such as Java database connectivity, remote method invocation, and Java message service, allowing seamless interaction with existing databases, systems, and services. Development tools and ecosystem is another important feature of Java. Java offers a robust ecosystem of development tools, including powerful integrated development environment, like Eclipse, IntelliJ IDEA, and NetBeans. These tools provide features such as code completion, refactoring, debugging, and profiling, empowering developers to work efficiently and adapt their code as needed. The next one is the community support. Java benefits from a large and active community to developers who contribute to its flexibility. The community actively develops and maintains open source projects, libraries, and frameworks that extend Java's capabilities. This community report ensures a constant flow of new ideas, innovations, and solutions, enabling developers to adapt Java to their specific programming needs. Moving on, One of the most important features of Java is platform independence. So Java platform independence is a fundamental feature that distinguishes it from many other programming languages. It allows Java programs to run on any platform that supports Java, regardless of the underlying operating system or hardware architecture. This means that a Java application developed on one platform can be easily executed on another platform without requiring any modification or to the code. The key to achieving platform independence in Java is the Java Virtual Machine. In short, JVM. The JVM is an integral part of Java runtime environment, responsible for interpreting and executing Java bytecode. This eliminates the need for developers to rewrite or recompile their code for different operating systems, of course saving time and effort. Then Java has another valuable feature called backward compatibility. This means that newer versions of Java are made to work seamlessly with older versions. Applications built using older version of Java can still run smoothly without needing significant changes when upgrading to newer versions of Java. Then, moving on to the next one, which is robust and security. Java was designed with a strong emphasis on reliability, robustness, and security. Its strict compile time checks, exception handling mechanism, and memory management, which contributes to creating stable and bug-free applications. Additionally, Java security features, such as sandboxing, strict access control, and cryptography libraries, help protect against potential vulnerabilities and threats. In conclusion, all these Java features makes it a versatile and reliable programming language for a wide range of applications and ever-evolving software development landscape. How to succeed as Java developer. We are going to talk about how to succeed as a Java developer. One of the primary reasons to consider learning Java is its extensive adoption by top companies. With a history spanning over 20 years, Java has established itself as stable and reliable programming language favored by prominent corporations now. According to StackShare, around 10,000 companies include Java and their tech stack, including industry leaders such as Google, Netflix, Facebook, Airbnb, Uber, and many more. While these companies also utilize other emerging technologies, but Java remains a key component in their software development ecosystem. It is no surprise that highly trained and skilled Java developers are in high demand with attractive salaries, of course. According to Indeed.com, the average base pay for entry-level Java developers is around $70,000 per year, but potential for significant growth as experience and skills increase. Now, salaries can reach up to $150,000 to $200,000 per year for experienced Java developers. According to Stack Overflow, that conducted a survey in 2022, Java consistently ranks among the most popular programming languages. So, now let's get back onto the topic, how to succeed as a Java developer. It is important to stay up to date with the latest advancement frameworks and best practices through continuous learning. Explore online resources. There are many online resources where you could get your training, documentation, tutorials, and participate in forums to expand your knowledge. Apply your knowledge by working on real-world projects. Then engage with the Java community, join developers forum, and participate in open source project. There are many that you will find online, so collaborating with other developers exposes you to diverse perspectives, fosters learnings, and helps you stay connected with the latest trends and opportunities. Then familiarize yourself with powerful Java development tools like Eclipse, NetBeans, and IntelliJ IDEA. Now these IDE offers a wide range of features that streamline the development, debugging, and code maintenance, ultimately boosting your productivity. They're not to forget to write clean, efficient, and well-structured code, followed coding conventions, use proper naming conventions, and leverage design patterns to ensure your code is maintainable and scalable. Then another advice is invest time in understanding the core concept of Java, including object-oriented programming, inheritance, polymorphism, and exception handling. A strong foundation will empower you to tackle complex projects with confidence. Then actively seek feedback from peers, mentors, and experienced developers to enhance your skills. Embrace constructive criticism, learn from your mistakes, and strive for continuous improvement in your coding practices. By following these guidelines and continually refining your skills, you can position yourself for success as a Java developer, opening up a world of opportunities for you in a language known for its versatility, industry support, and robustness. In this lecture, we will talk about the Java software tools, such as JDK, JRE, JVM, and IDE. To write and run a Java program, we first set up Java environment. Now, what is an environment in general sense? An environment refers to the surrounding or conditions in which something exists or operates. In the context of setting up a Java environment, it specifically refers to the configuration and preparation necessary for running Java programs, either on your local machine or on a server. Setting up a Java environment involves installing the necessary software and tools that are required to develop and execute Java programs. So, the first thing that we installed is JDK, which stands for Java Development Kit. It contains all the tools required to run Java programs. JDK includes Java Compiler, which is used to translate Java code into a form that can run on a computer, as well as a set of libraries and tools that are needed to develop Java applications. Now, JDK includes a component called JRE, which stands for Java Runtime Environment. JRE includes libraries, as well as Java Virtual Machine. In short, JVM, which is the most important Java component. JRE is a software package that provides a runtime environment in which applications can be executed. So JVM, which is a part of JRE, is a program that interprets Java bytecode and executed on a computer, as well as a set of libraries and tools that are needed to run Java applications. Then we must have a code editor. We will use an IDE IntelliJ in our course, which stands for Integrated Development Environment. You can use other code editors, such as Eclipse or Visual Studio Code, but we'll stick around with IDE throughout this course. An IDE typically consists of a source code editor, build automation tools, and a debugger. Some IDEs also include a compiler or interpreter. So, to put it in simple words, JDK, JRE, and JVM are stored one inside the other, level by level. Now, we discussed how Java code is actually run. Our Java code executes in two steps. The first step is compilation, and the second step is execution. Let's talk about the first step. The code we write in Java is called source code. The source code is stored in a file. With the extension .java, all of this source code is sent to the compiler, which is included in the JDK, and the compiler converts it into bytecode with the extension .class. This bytecode can be run on any other system that has JRE installed. If you write Java code in Linux, Windows, or Mac, we simply convert it to bytecode, which can then run on any systems. Therefore, Java is called a portable or multi-platform language. The first step, compilation, is covered now. Now, come to the second step, which is the execution. In this step, the JVM takes this bytecode and converts it into native code. So, the native code is the code that a machine can understand. Now tell me, what is the name of the native code that we talked about earlier? What is it called? It's called binary, if you guessed it right. Excellent job. Once your bytecode has been converted into that binary or native code, your machine will be able to understand it regardless of which operating system it is running on. So in summary, we write Java code and save it in the .java extension, and it's going to be known as source. Code then JDK has a compiler that converts this source code into bytecode with the class extension. This process is known as compilation. Then this bytecode is given to the JVM that is inside the JRE. This bytecode is converted into the native code by the JVM. This is called execution. So, I am sure by now you have a better understanding of each Java components and how they work together. I will see you in the next lecture. Lab setup. In this lecture, we will go through our lab design. The lab that you will be practicing Java throughout this course. So, the very first thing you need to do is to download and install JDK. We will be covering the installation of JDK on Windows and on Linux. So, first identify what kind of computer you have. Also make sure you have the available resources, like memory, CPU, disk space. When installing JDK on Windows, it's important to remember that. Most modern computers use the 64-bit edition of Windows. Therefore, you should install the 64-bit version of JDK to ensure compatibility and take advantage of the system's capabilities. So, for installing JDK on Windows, your computer should meet the minimum system requirements, which typically include at least 2 GB of RAM, a processor with a speed of 1 GHz or higher, and around 200 MB to 500 MB of free disk space for the installation. These specifications ensure that JDK functions properly on your Windows system. Here, good news is, when you install the latest version of JDK on Windows, there's no need to separately install the JRE. The JDK installation already includes both the JDK and the JRE. So, everything you need is bundled together in one installation. When JDK is installed successfully, it also installs a command line tool called Java Shell. In the beginning lectures, we will use JShell to quickly explore Java features without writing full programs. After learning Java basics, you will install IntelliJ IDEA. That is an integrated development environment, in short IDE. This IDE allows us to create fully documented programs and projects efficiently. Now, we will talk about JDK installation on Linux. To begin with JDK installation on Linux, you will first need to set up the Linux operating system on VirtualBox. Then, you can log in into Linux operating system and proceed with the JDK installation. After that, you will write some installation commands on terminal. That will install JDK on Linux operating system. If we talk about the system requirements for JDK installation on Linux, they are the same as for Windows. And also same process for JShell. But for installation of IntelliJ IDEA, we will use some installation command for IntelliJ IDEA in Linux terminal. Once the setup is completed, on both Windows and Linux operating systems, both systems have Java environments. Now, when you will create a Java source code file with the extension .java on a Windows or Linux operating system, the Java compiler will translate the .java file into bytecode, which will now be saved with the class extension. Then this class file, which has bytecode inside it, will translate it into machine code by the interpreter. This interpreter is basically called JVM. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Install JDK for Windows. In this lecture, we will learn about how to install JDK for Windows 10 and 11. If you're using a Mac, Linux, or have already installed JDK on Windows, then skip this lecture. If you are running Windows 10, please keep in mind that most modern computers run the 64-bit edition of Windows 10, and Windows 11 is already in the 64-bit edition. If you're using a 32-bit version of Windows 10, that's where things may become tricky. You can do this by downloading an older version of JDK that is compatible with your Windows system. As a result, The JDK installation process is the same, whether you're using Windows 10 or Windows 11, 64-bit version. Now, let's begin our JDK installation on Windows. Write this URL, java.sun.com, in your favorite browser. Now, click on the Java C17, 0.5 LTS version. If you don't know why we take this version, then see our previous lecture, Introduction to Java version 17 LTS. You should now see 3 tabs, Linux, MacOS, and Windows. So, select the Windows tab and click on the x64 installer download link. This will download the installer file to your computer. Now the download begins. Once the download is complete, open the installer file and follow the prompts to install the JDK. Make sure to remember the installation location, as you will need it later. Here is my installation location. After the installation is complete, you will need to set the Java_home environment variable to point to the JDK installation folder. To do this, follow these steps. Go to the Start menu and search for Environment Variables. Click on Edit the System Environment Variables button. Click on the Environment Variables button. Under the System Variables section, scroll down and find the Path variable. Click on the Edit button. Click on the New button and add the path to the JDK installation folder. You see here my JDK installation path. Now, paste this path here. Click OK to save the changes. To test the JDK installation, open a command prompt and enter the following command, java-version. This should display the version of the JDK that you have installed. If you see an error message, make sure that the JDK installation location is correctly set in the path environment variable. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Install JDK for Linux. In this lecture, we will learn about how to install JDK for Linux. We're going to install JDK version 17 LTS on CentOS Linux. Check out the relevant videos for your operating system if you use Windows. So let's start. I am setting up a virtual machine using VirtualBox on Windows, installing CentOS Linux as the operating system on the virtual machine, and connecting PuTTY software with CentOS Linux. So, PuTTY is available for Windows, Mac OS, and Linux operating systems. And it can be used to connect to any computer that has a supported network service running, such as an SSH server. You may use it by installing CentOS Linux or any other Linux flavor as a dual boot system, or in a virtual machine. Now, come to the installation. First, we run our machine as the root user, and then given root password. Now, we use the command java-version to see if JDK is installed or not. This statement tells us that Java is not installed on this system. To download JDK 17 LTS from the CentOS terminal, you can follow these steps. First, you update the package manager's database. For this, run the sudo yum update command to update the package manager's database. It takes some time, according to the speed of your internet connection. So, my Linux machine is already updated. Now, download Oracle Java JDK 17 LTS. For this, run the wget with this download link command in the terminal. This will download JDK 17 LTS and all the required dependencies. It takes some time. After download completed, now install Oracle Java JDK 17 using the RPM command and press enter. It takes some time. Now, to verify that JDK 17 LTS has been installed correctly, run the java-version command. This should display the version of the JDK that is currently being used. The output should look something like this. I hope you learned something useful in this lecture as well, and I'll see you in the next one. JShell Introduction. In this lecture, we will talk about what JShell is and why we use it, and we will also see how to use it on Windows and Linux, and run some important commands on it. Let's start with, what is JShell? JShell is a command line tool in Java that allows you to execute Java code snippets and commands in an interactive manner. It is included in the Java development kit starting from version 9. The next is why we use JShell. Because when you enter code at the JShell prompt, the tool will immediately execute the code and print the results to the console. For example, if you enter a simple math expression, such as 2 plus 2 at the JShell prompt, the tool will execute the expression and print the result 4. JShell can be used in conjunction with other tools, such as IDs, text editors, and build systems. JShell provides a number of commands that you can use to control the execution of your code, such as /list to list the code snippets you have entered, or /exit to exit the JShell tool. With all of JShell's features, it also has some limitations. Thus, after some practice writing Java code on it, we will move on to the IDE. So, the limitation of JShell is that it does not replace the need for an IDE. It's just a handy tool to quickly get started with Java. It is not intended for use as a full-featured development environment, and may not be suitable for larger or more complex projects. JShell only includes support for the core Java language features and standard library. If you want to use third-party libraries, you will need to use a full Java program. Now come to the installation of JShell. It is automatically installed when you install the JDK. In our case, we installed JDK version 17 LTS. So let's start with Windows. Now open the Windows terminal by typing CMD in the Windows Start search bar or by pressing the Windows +R keys, typing CMD in the Run dialog, and then pressing Enter. But in CentOS Linux, you can do this by pressing Ctrl+Alt+T or by clicking on the terminal icon in the taskbar. Now that the terminal is open, we type JShell here. Now we see JShell here, and that is the version of Java that we use. If we want to see the introduction of JShell, just type the command /help intro and press Enter. Here is its introduction. If we want to see JShell commands and what they are used for, then just type /help. Here are these commands. Just a couple of the most popular commands will be covered, not all of them. As you can see, there are commands to save and open files, reset JShell to the time of its installation, review your typing history, and other things. Let's look at the list command, which is the top command there. The /list command is a JShell command that allows you to view the code snippets and commands you have entered in the current JShell session. To use the /list command, you can enter /list at the JShell prompt, followed by a range of snippet numbers to list. For example, if we type 2 plus 2 and then hit Enter, now it shows the result of 4. Now type /list command and press Enter. It shows the code that we wrote before. Now use the /exit command to quit from JShell. For this, just type /exit and press Enter. Now it says goodbye, and we are done with it. Now let's try JShell on CentOS Linux. If you are using dual boot system CentOS, then you can open Terminal by pressing Ctrl+Alt+T or by clicking on the terminal icon. As I previously mentioned, I am using PuTTY to connect with my CentOS machine. For this, first I log into my Linux machine using PuTTY. Now I type JShell. Now we see JShell here, and that is the version of Java that we use. If we want to see the introduction of JShell, just type the command /help intro and press Enter. Here is its introduction. Now it will work the same as Windows, as we've seen before. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Java First Program using Notepad and Command Prompt. In this lecture, we will talk about how to write Java First Program using Notepad and Command Prompt. This is the only lecture where we will write Java code on Notepad and run it on the Windows command prompt. Otherwise, we will write Java code using JShell and then go to the IDE. So, the purpose of this lecture is to show a clear understanding of how Java runs. Why Java is referred to as a two-stage system language, how Java converts source code to bytecode in the form of a class file, and how the JVM interpreter executes it. To begin the demonstration, open Notepad. Here we write a Java program that prints "Hello World" on the screen. Now we write it after the code is finished. Then we save it with the name Hello World, which is the same as the class name, with the .java extension because it's a Java rule. And I save it in a directory that I have already created called java-code, as you can see. Remember that the main purpose of this lecture is to learn about how Java is basically run, so I will explain this code in the coming lectures. Now open Windows Command Prompt and give it the path where my Java source code file is saved. This is where I keep my Java source code. You can also see its type here. Now, go to the command prompt and type javac, which stands for Java compiler, followed by the name of a Java file with a .java extension, and then press enter. The Java compiler now converts the source code into bytecode and creates the file with the .class extension. Here you can see this file and its type. Now we will open it and see what's inside. We can see that it's a bytecode that is not in a human-readable form. Now come to the command prompt again. Now call the JVM interpreter to convert this bytecode into machine language. For this type Java, and then class name that is Hello World and press enters. Now you can see the output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about how to write a Java program called Hello World using JShell. Hello World is a simple program that is often used as a starting point when learning a new programming language. This program typically just displays the words Hello World on the screen. It's a basic program that allows you to test the syntax of the language and get a sense of accomplishment after completing it. Even experienced programmers can feel a sense of accomplishment after writing their first Hello World program in a new language. Completing this simple task is often seen as the first step towards being able to write more complex programs. Before we start writing Java code, we must remember the rules of how to develop a Java program. Here are some basic rules to follow when writing Java code. Java is case-sensitive, so be careful when using keywords, variables, and method names. Every statement in Java must end with a semicolon. Java uses curly braces to group blocks of code. Java is an object-oriented programming language, so all code is organized into classes. Each class must have a unique name and should be saved in a separate file with the same name as the class, followed by the .java extension. Every Java program must have a main method, which is the entry point of the program. The main method has the following signature: public static void main parenthesis string square brackets args. Java uses camel case for naming conventions. This means that the first letter of each word in a multi-word identifier is capitalized, except for the first word, which is all lowercase. For example, Hello World is a valid identifier in Java. Java uses the / symbol to start a single-line comment, and the /* and */ symbols to start and end a multi-line comment. Comment plays very important role in Java or any other programming language. Comments help to document the code, making it easier for others or even yourself to understand what the code does. This can be especially useful if the code is being worked on by a team of developers or if it is being maintained over a long period of time. Comments can serve as a reminder of the purpose of a particular piece of code, which can be helpful if you need to make changes to the code later on. Comments can help to improve the readability of the code, making it easier to follow the logic of the program. These are the general rules that must be followed when writing complete and comprehensive Java code. Now come to JShell. So, when we write code in JShell, it only allows us to write and run Java code snippets and expressions, which are small pieces of code. For example, in the previous lecture, we wrote a complete Java program that prints "Hello World" on the screen. Here, you can see that, and this code is written according to Java rules. Now we see this statement, system.out.print, and it used to print content on the screen. As a result, we can use only this piece of code only, rather than writing the entire Java class in JShell. That's the reason we write Java code snippets in JShell. Now for demonstration, Open the command prompt and then type JShell. Now we are in JShell. Now we write the statement system.out.print after that. Use parentheses and the double quotation, and inside it, we write hello world. Using this statement, we are telling Java to print hello world on the screen. Now press the Enter key. Here is the output that says hello world. When we use single quotation marks around hello world instead of double quotation marks, we get the error, which is unclosed character literal. Because we define a string with a single quotation mark here, that is not the Java rule. The single quotation used for character. We discuss character and string comparison in the coming lectures. This error is also displayed when we miss any quotation like this, as we can see. Now remove the last bracket and press Enter. What does it mean? As you can see, the gesture prompt has changed, and it is now 3 dots followed by a greater than symbol. It is telling us that JShell is ready for another line of code to be typed in, and you can keep adding new lines of code by pressing Enter in between without anything actually running until you complete the set of brackets. If we want to exit without writing any lines, we can do so by pressing Ctrl+C. Now we write the bracket and press Enter, and that's the output. As you can see, we don't write a semicolon at the end, because in JShell, a semicolon is optional. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about variables in Java. Before we get into variables, let's first define keywords. In Java, a keyword is a word that has a specific meaning in the programming language. These words are reserved, meaning they cannot be used as names for variables, methods, or other identifiers in your code. Keywords are also case-sensitive, so int is a different keyword than with start capital INT or all in capital INT. There are several types of keywords in Java, including primitive data types. These include keywords like int, double, and char, which are used to represent basic types of data in the language. Control statements, these include keywords like if, else, and while, which are used to control the flow of a program's execution. Modifiers, these include keywords like private, public, and final, which are used to modify the behavior or accessibility of a class, method, or variable. Other keywords, there are several other keywords in Java, such as this, super, and null, which serve various purposes in the language. We will discuss all this step by step in the coming lectures. Now come to the variable. What are variables? All variables are means for storing data in our computers. Variables that we declare in a program may be accessed by the name we give them, and the computer handles the difficult task of determining where they are stored in the RAM. Now, as their name implies, variables may be modified. Its contents may change. In other words, we must thus advise the computer of the kind of data we want to keep in the variable before giving it a name. We may create a wide range of various forms of data for our variables, some of which you saw in the keyword list earlier. These are often referred to as data types. As you may have predicted, Java uses some data types, known as basic data types, as keywords. In other words, a variable is a named location in memory, where a programmer can store a value of a specific data type. Variables are used to store information that can be changed or used later in a program. For example, to declare an integer variable named age, you would write int age semicolon. Once a variable is declared, you can assign a value to it using the assignment operator =sign. For example, to assign the value 25 to the variable age, you would write age =25 semicolon. Java has several primitive data types, including integers as int, floating point numbers as float and double, characters as char, and booleans. The data type of a variable determines the kind of information it can store and the operations that can be performed on it. It's important to choose appropriate data types for your variables, as this can affect the performance and accuracy of your program. For example, using an integer data type to represent a decimal value may result in loss of precision. In addition to primitive data types, Java also supports object data types, which are variables that reference objects. Objects are complex data structures that contain both data and behavior methods. We'll cover objects in more detail in later lectures. Let's open JShell to see how to define our first variable. To define an integer variable named age with the value 25 using JShell, you can use the statement int age equals $25 and press enter. Now this will create a variable of type int with the name age and assign the value 25 to it. It's important to note that in Java, every statement must end with a semicolon. The semicolon indicates the end of a statement and is necessary for the compiler to correctly parse your code. Once you have defined a variable, you can use it in your JShell commands by referencing its name. For example, you can print the value of the variable age like this: system.out.print parenthesis, then use variable age inside it, followed by a semicolon to finish the sentence. This will print the value of the age variable to the console. You can also change the value of a variable by assigning a new value to it using the assignment operator. For example, to change the value of the age variable to 30, you can use the statement age equals 30 semicolon. This will assign the value 30 to the age variable, replacing its previous value. Here we use a word statement. Now we discuss it. In Java, a statement is a piece of code that performs a specific action or task. A statement can be a simple statement that performs a single action, or it can be a compound statement that contains multiple statements and control structures. There are several types of statements in Java, including expression statements, declaration statements, and control statements. First, we discuss expression statements. So, expression statements are statements that contain an expression, which is a combination of variables, operators, and method calls that evaluates to a value. An expression statement is usually followed by a semicolon. Int age equals 25 semicolon is an example of an expression statement. Then the declaration statements. These are statements that declare a new variable, field, or method. A declaration statement usually specifies the data type and name of the entity being declared. There are also two concepts used in variables: declaration and definition of variable. Declare means to create a variable with a data type but not assign it a value. Like int age semicolon. Here we not assign any value to it. This is also called a declaration statement. And definition refers to when we assign it a value. For example, int age equals 25 semicolon. Then control statements. These are statements that control the flow of execution in a program, such as if statements, while loops, and for loops. All of this will be covered in the upcoming lectures. Then block statements. These are statements that are enclosed in curly braces and can contain multiple statements and declarations. A block statement is often used to group related statements together or to define the body of a control statement or method. Now we solve a practice question, that is, use the system.out.print method to alter the myAge variable's value from 30 to 65 and print the new value. Now come to JShell. First we declare an integer variable named myAge and assigns it the value 30. Then it uses the assignment operator =, to change the value of myAge variable to 65. Finally, it uses the system.out.print method to print the value of age to the console. Now this code is executed, it will output the output that is 65. It's important to note that the value of a variable can be changed at any time during the execution of a program by assigning a new value to it using the assignment operator. This is a useful feature of variables, as it allows you to store and manipulate data in your programs. Let's use the JShell command /list to list all of the statements we've run and given values to. For this, just type /list and press enter. This will show lists of all the Java statements you've executed in JShell. Now we clear the shell screen using Ctrl+L. Now we see another example, using the arithmetic symbol plus and then storing it in a variable. Now let's define this statement. Here my number is a variable of type int that is being assigned the value of the result of the expression 5 plus 10. The =, symbol is the assignment operator, which means that the value of the expression on the right side of the operator is being assigned to the variable on the left side. In this case, the expression 5 plus 10 is evaluated to produce the value 15, which is then assigned to my number. After this line of code is executed, my number will have the value 15. Now we print the value of my number using system.out.print method. Here is output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about variables and expressions. In the previous lecture, we discussed variables, how we store data in them, and how we use them. Now we will work on some complex mathematical expressions and store them in variables. Here we can see a literal value in the expression, and its result is stored in a literal variable. That is int literal variable equals sign parentheses 20 divided by 2 plus parentheses 10 plus 2 semicolon. The expression parentheses 20 divided by 2 plus parentheses 10 plus 2 in Java is a simple arithmetic expression that combines addition and division. The division operator performs division, and the plus operator performs addition. In Java, the division operator returns a floating point result, even if both operands are integers. The parentheses in the expression parentheses 20 divided by 2 plus parentheses 10 plus 2 are used to specify the order in which the operation should be performed. In this case, the operations within the parentheses are evaluated first, followed by the operations outside the parentheses. Therefore, the expression parentheses 20 divided by 2 plus parentheses 10 plus 2 will be evaluated as parentheses 10 plus parentheses 12, which is equal to 22. The result of the expression is then assigned to the literal variable, which is an int variable. The value of literal variable will be 22. Now, run the J shell and create a variable called literal variable with an int data type and given this expression as a value to this variable. Now press enters, and here you can see the result. Now in the next example, we create a variable named second variable, give it a value of 50, and add this variable to the previously created variable named literal variable, and the result is stored in the sum variable. For this, now creates a variable called second variable of type int and assigns it the value 50. Now use the /var command to see a list of all previously defined variables and their values. Here we can see all these values. Now we add a literal variable and a second value variable with the plus operator. And the result is saved in the newly created int data type variable sum. Now, list again using /var command. Here you can see these. Now, suppose I change the value of the second variable by multiplying it by 3. For this, we write second variable equals sign second variable multiply by 3. In this example, the value of second variable is initially 50. The second line of code multiplies this value by 3 and stores the result 150 back in second variable. After this line of code is executed, the value of second variable is 150. Now we add the new second variable value in sum variable. For this we write sum equals sign sum plus second variable. Here the value of sum is initially 72. The second variable is add in this value of sum and stores the result 222 back in sum variable. After this line of code is executed, the value of sum is 222. So, these are some important variations using variables. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about primitive data types in Java. A primitive is a basic type of data that is built into a programming language. Primitives are the most basic data types available in a language and are used to represent simple values such as numbers and characters. In Java, there are 8 primitive data types that are byte, short, int, long, float, double, char, and boolean. Now come to see all these briefly. Byte is a 8-bit signed integer. Short is a 16-bit signed integer. Int is a 32-bit signed integer. Long is a 64-bit signed integer. Float is a single precision 32-bit floating point number. Double is a double precision 64-bit floating point number. Char is a single 16-bit Unicode character. Boolean is a true or false value. What does signed and unsigned mean here? In Java, a signed data type is one that can represent both positive and negative numbers. All of the primitive integer data types byte, short, int, and long are signed, which means that they can hold both positive and negative values. An unsigned data type, on the other hand, can only represent non-negative positive or zero values. Java does not have any built-in unsigned data types, so you cannot use unsigned values directly in your Java programs. Now start with byte. In Java, a byte is a primitive data type that represents 8-bit signed integer. It can be used to store small whole numbers. A byte is typically used to save space in large arrays. It has a range of values from -128 to 127 and can be used to store small whole numbers, where the memory savings can be significant. Arrays concepts will be discussed in the coming lectures. It is also used when working with binary data, such as reading or writing files. Use example of how you might use a byte in Java. Now open JShell and write byte b equals sign 100 semicolon. In this example, the variable b is of type byte and is initialized with the value 100. It easily stores it. If we change the value from 100 to 128 and press enter, it is now given an error. Why? Because it has a range of values from -128 to 127. So, it can be used to store small whole numbers only. The next is short data type. In Java, a short is a primitive data type that represents a 16-bit signed integer. It has a range of values from -32768 to 32767 and can be used to store small whole numbers. For example, we define a variable with short data type that is short b equals sign 100 semicolon. In this example, the variable b is of type short and is initialized with the value 100. It easily stores it. So, it can be used to store small whole numbers only. The next is int data type. In Java, an int is a primitive data type that represents a 32-bit signed integer. It has a range of values from -21474833648 to 21474833647 and can be used to store whole numbers. An int is the most commonly used integer data type in Java, because it provides a good balance between the ranges of values that it can hold and the space that it takes up in memory. For example, type int I equals sign 1,000 semicolon. In this example, the variable I is of type int and is initialized with the value 1,000. You can also use the int data type in combination with other data types and operators. For example, int I1 equals sign 5,000 semicolon. Int I2 equals sign 25,000 semicolon. Int I3 equals sign I1 plus I2 semicolon. In this example, I1 and I2 are both int variables, and their sum is assigned to I3, which is also an int variable. It is important to note that the int data type should only be used for whole numbers. If you need to store fractional values, you should use a floating point data type such as float or double. The next is long data type. In Java, a long is a primitive data type that represents a 64-bit signed integer. It has a range of values from -9.2233710 to the power 18 to 9.2233710 to the power 18 and can be used to store large whole numbers. A long is typically used when an int is not large enough to hold the desired value, or when a program needs to store a large range of whole numbers. For example, write long L equals sign 10,000 L semicolon. In this example, the variable L is of type long and is initialized with the value 1,000. The L suffix indicates that the value is a long literal. You can also use the long data type in combination with other data types and operators. It is important to note that the long data type should only be used for whole numbers. If you need to store fractional values, you should use a floating point data type such as float or double. The next is float data type. In Java, a float is a primitive data type that represents a single precision 32-bit floating point number. It has a range of values that is approximately ±3.40282344710 to the power 38f and can be used to store fractional values. A float is typically used when a program needs to store a decimal value that is less precise than a double, or when it needs to save space in large arrays. For example, write float f equals sign 3.14f semicolon. In this example, the variable f is of type float and is initialized with the value 3.14. The F suffix indicates that the value is a float literal. It is important to note that the float data type has less precision than a double and may not be suitable for all decimal values. If you need to store a decimal value with higher precision, you should use the double data type. The next is double data type. In Java, a double is a primitive data type that represents a double precision 64-bit floating point number. It has a range of values that is approximately plus minus 1.79710 to the power 308 and can be used to store fractional values. A double is typically used when a program needs to store a decimal value with a high degree of precision, or when it needs to store a very large or very small number. For example, write double D equals sign 3.14 semicolon. In this example, the variable D is of type double and is initialized with the value 3.14. You can also use the double data type in combination with other data types and operators. It is important to note that the double data type has more precision than a float, but may be slower to execute and may take up more space in memory. If you do not need a high degree of precision, you may be able to use the float data type instead to save space and improve performance. The next is char data type. In Java, a char is a primitive data type that represents a single 16-bit Unicode character. It has a range of values from U1000 or Zerta or 65,535 inclusive, and can be used to store any character in the Unicode character set. A char is typically used to store individual characters, such as letters, digits, and symbols. For example, write char C equals sign a semicolon. In this example, the variable C is of type char and is initialized with the value A. The value of a char is written as a single character enclosed in single quotes. You can also use the char data type in combination with other data types and operators. It is important to note that the char data type is not the same as the string data type, which is used to store a sequence of characters. A char can only hold a single character, while a string can hold multiple characters. The next is Boolean data type. In Java, a Boolean is a primitive data type that represents a true or false value. It is used to represent the results of a logical operation or a condition. A Boolean can only take on one of two values, true or false. It is typically used in control statements, such as if statements, to determine whether a certain condition is met. For example, write Boolean b equals sign true semicolon. This b variable only stores a true or false value and nothing else. Now we discuss all 8 primitive data types in Java. Now we discuss string. What is string, and why is it not a primitive data type in Java? So, the answer is, in Java, a string is a class, not a primitive data type. This means that it is a reference type, rather than a value type. A string is a sequence of characters, and is used to represent text in a Java program. It is one of the most commonly used classes in Java, because it is used to represent text in almost every Java application. The reason that string is not a primitive data type in Java is because it is a more complex data type than the primitive types. It is a class that provides a number of methods for manipulating strings, such as concatenating, comparing, and searching for substrings. For example, create a variable with string as equals sign hello world semicolon. In this example, the variable s is of type string and is initialized with the value hello world. The value of a string is written as a sequence of characters enclosed in double quotes. You can also use the string class in combination with other data types and operators. For example, create 3 string variable that are string s1 equals sign hello, string s2 equals sign world, and then add them. String s3 equals signs 1 plus 2. In this example, s1 and s2 are both string variables, and their concatenation is assigned to s3, which is also a string variable. The plus operator is overloaded for string objects, and is used to concatenate strings. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about primitive data types examples. We discussed primitive types and their role in Java in the previous lecture. We will now look at some practice exercises. Now start with byte data type. In Java, the byte data type is an 8-bit signed integer. It can hold values from -128 to 127. Here are some examples of how you can combine the byte data type with other primitive data types in Java. Byte plus byte, you can add two byte values together using the plus operator. The result will be of type int. For example, adding two byte values together in Java by creating two variables, x and y, and assigns them values, then stores their results in a sum variable with an int data type. In this lecture, we will talk about primitive data types examples. We discussed primitive types and their role in Java in the previous lecture. We will now look at its some practice exercises. Now start with byte data type. In Java, the byte data type is an 8-bit signed integer. It can hold values from -128 to 127. Here are some examples of how you can combine the byte data type with other primitive data types in Java. Byte plus byte, you can add two byte values together using the plus operator. The result will be of type int. For example, adding two byte values together in Java by creating two variables, x and y, and assigns them values, then stores their results in a sum variable with an int data type. Now create them. For this, open JShell and write byte x =10 semicolon and byte y =20 semicolon and then int sum =x plus y semicolon. System.out.print parenthesis sum semicolon. In this example, the variables x and y are both of type byte. The plus operator is used to add them together, and the result is stored in the sum variable, which is of type int. Note that when you add two byte values together, the result is always of type int. The question is why the result is of type int. In Java, when you add two values of different data types, the result is always of the data type that can hold the largest range of values. This is known as widening primitive conversion. In the case of byte and byte, the result of adding them together will be of type int, because the int data type has a larger range of values than the byte data type. We already discussed ranges in the previous lecture. So, here is a table showing the range of values for each of the primitive integer data types in Java. As you can see, the int data type has a much larger range of values than the byte data type, so it can hold the result of adding two byte values together without losing any precision. We can add a byte value to a short value using the plus operator. The result will be of type int. For example, adding byte and short values together in Java by creating two variables, x and y. X is a byte and y is a short variable and assigns values, then stores their results in a sum variable with an int data type. Now create them that are byte x =10 semicolon and short y =20 semicolon and then int sum =x plus y semicolon. System.out.print sum semicolon. In this example, the variable x is of type byte and the variable y is of type short. The plus operator is used to add them together, and the result is stored in the sum variable, which is of type int. Note that when you add a byte value to a short value, the result is always of type int, because the short data type is too small to hold the result. Now same as others, like if we can add a byte value to an int value using the plus operator. The result will be of type int, because int has a large range compared to a byte. And if we want to add a byte value to a long value using the plus operator, the result will be of type long, because long has a large range compared to a byte. And if we want to add an int value to a float value using the plus operator, the result will be of type float, because float has a large range compared to a int. And if we want to add a double value to a double value using the plus operator, the result will be of type double. If we check the range of any data type in Java, that is, start from the minimum value to the maximum value. For check minimum value, we can write name of data type, then dot operator, then write min_value, and for maximum value, use name of data type, then dot operator, then write max_value. Now we check the range of short data type. For this, Use this line of code, that is, system.out.print parenthesis start double quote min range of short is colon end double quote plus short dot min underscore value plus start double quote and sign max range of short is colon end double quote plus short dot max underscore value end parenthesis semicolon to display the range of short data types. This code is printing a message to the console that displays the minimum and maximum values that can be stored in a variable of type short in Java. The short class is a wrapper class for the short primitive data type. It provides several static fields that you can use to access the minimum and maximum values that can be stored in a short variable. We discuss class types in the coming lectures. These fields are min underscore value and max underscore value, respectively. The system.out.print method is used to print the message to the console. The message is a string literal that concatenates the minimum and maximum values using the plus operator. When this code is executed, it will print this message to the console. Short minimum is range minus 32768 and maximum range is plus 32767. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Typecasting in Java. In this lecture, we will talk about the typecasting concept in Java. So, casting in Java is the process of converting one type of data to another. There are two types of casting in Java: widening casting and narrowing casting. The widening casting is a type of casting that converts a smaller data type to a larger data type. This is also known as implicit casting. For example, converting an int to a double. In the previous lecture, we did it similarly to when we added byte and short and saved it as an int data type. Because int has a larger range than short and byte. To see an example, open JShell. Now, if we create two variables, one of which has an int data type and the other of which has a double data type. Here you can see that we create both variables with different data types in a single line. This is possible in Java because we use a semicolon at the end of both variables, and a semicolon ends a statement. Here you can see that a double variable has an automatically assigned value of 0.0. If we declare a variable with no value, the Java compiler will assign it a default value of 0 in the case of int, double, and float. When we declare a character variable as empty, the default value is 0, 0, 0. So, the value of I is an int with a value of 123. The value of I is then assigned to the double variable d without the need for explicit casting. Widening casting is allowed in Java because the range of values for the target data type in this case, double, is larger than the range of values for the source data type, that is int. As a result, the value of I can be safely converted to a double without the risk of data loss. Look at another example. Now, we create two variables short s and int j. The value of the variable s is a short with a value of 100. The value of s is then assigned to the int variable j using widening casting. In this case, the short data type is being converted to an int data type. This is allowed in Java because the range of values for the target data type, in this case int, is larger than the range of values for the source data type, that is short. As a result, the value of s can be safely converted to an int without the risk of data loss. If we convert char to int, see this example. For this, create two variables char c and int k. The value of the variable c is a char with a value of a. The value of c is then assigned to the int variable k using widening casting. In this case, the char data type is being converted to an int data type. This is allowed in Java because the range of values for the target data type, in this case, int, is larger than the range of values for the source data type, in this case, char. As a result, the value of c can be safely converted to an int without the risk of data loss. It's important to note that the value of c is not converted to the character a, but rather to the ASCII value of a, which is 65. This is because Java stores characters as 16-bit unsigned integers, with each character being assigned a unique ASCII value. ASCII American Standard Code for Information Interchange is a character encoding standard that represents characters using 7-bit integers. ASCII was originally developed for use with teletypes and is based on the English alphabet. It includes codes for upper and lowercase letters, numbers, punctuation marks, and a few special characters. In Java, ASCII codes can be used to represent characters in a char data type. For example, the ASCII code for the letter A is 65, and then we would assign the value A to the variable C. We can also use the char cast to convert an ASCII code to a char data type. Like this. Int ASCII code is equal to 65 semicolon, and then write char C is equal to parenthesis char ASCII code semicolon. In this example, the value of ASCII code is an int with a value of 65. The value of ASCII code is then cast to a char and stored in the variable C. The resulting value of C is a. It's important to note that ASCII is a limited character encoding and does not support characters from other languages or symbols. Unicode, which uses a larger number of bits per character, is a more modern character encoding standard that supports a wider range of characters. The next type is narrow casting. Narrowing casting the type of casting that converts a larger data type to a smaller one. This is also known as explicit casting. For example, converting a double to an int, it's important to note that casting can result in data loss if the value of the data being converted is not within the range of the target data type. For example, if you try to cast a double with a value of 3.14 to an int, the decimal value will be lost, and the resulting value will be 3. As you can see. Now we see another example. In this example, create two variable float f and int a. The value of f is a float with a value of 3.14f. The value of f is then cast to an int and stored in the variable a. Take note of the most important point is Java does not automatically check if a value fits within the range of a variable because it is the responsibility of the programmer to ensure that the values assigned to variables are within the appropriate range. For example, if you have an int variable with a range of -21474833648 to 21474833647, it is up to you to make sure that the values you assign to the variable fall within this range. If you try to assign a value that is outside of the range of an int, you will get an error. This is because Java is a statically typed language, which means that the data type of a variable must be known at compile time. This allows the compiler to catch errors such as out-of-range assignments and ensures that the code is correct before it is executed. However, it is possible to use type casting to convert a value to a different data type, even if the value is outside of the range of the target data type. This can be useful in certain situations, but it can also lead to data loss if the value being converted is not within the range of the target data type. It is important to be careful when using type casting to avoid unintended consequences. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Float versus double. In this lecture, we will discuss in detail the comparison between the float and double primitive data types. We talked about both of them briefly in the previous lecture on data types in Java, such as their range and definition. So, let's talk about the float data type. In Java, a float is a single precision 32-bit IEEE 754 floating point data type. It is used to represent fractional values and is often used in situations where the precision of a double is not required. What does IEEE 754 mean in this context? IEEE 754 is a standard for representing floating point numbers in computers. It specifies the representation of numbers with a fractional component, like 3.140.1, as well as how to perform operations like addition, subtraction, and multiplication on those numbers. A 32-bit floating point number is a binary number that consists of 32 bits or digits that represent a numerical value. The single precision part of the name refers to the fact that these numbers use a single set of 32 bits to represent the value. The IEEE 754 standard specifies the format for representing these 32-bit floating point numbers. It defines the bits that represent the mantissa, or fractional part, of the number and the bits that represent the exponent, or the power of 10 by which the mantissa is multiplied. In Java, the float data type is used to represent single precision floating point numbers in accordance with the IEEE 754 standard. Single precision means the arrangements that it consists of one sign bit s, 8 exponent bits e, and 23 mantissa bits m as shown in figure. To see an example, let's open JShell. Now, We create two float variables and print them separately. As we can see here, the float data type is used to represent single precision floating point numbers in Java. A float value must be followed by the letter small f or capital F to indicate that it is a float and not a double. After declaring and initializing the float variables, the code prints their values to the console using the print method. The print method prints the string that is passed to it. So, when this code is run, it will print the output to the console. In the preceding example, the first variable value is denoted by a small f and the second by a capital F. The difference is that capital F is the uppercase version of small f, and Java is case-sensitive, which means that capital F and small f are treated as two different variables. But it is more common to use small f, since it is easier to type and takes up less space. Here are a few things to keep in mind when working with float values in Java. Float values are represented using fewer bits than double values, so they take up less space in memory. Float values have less precision than double values, which can lead to rounding errors when performing calculations. Float values are generally faster to process than double values on most modern computers because they take up less space in memory and the processor doesn't have to do as much work to manipulate them. The main difference between float and double is the range. Float has a lesser range than double. If we want to check the range, we simply use this line of code, as we discussed in the previous lecture on data types in Java. That is, system.out.print parentheses double quotation and write range of float, min range, plus float min underscore value plus to max range, plus float max underscore value parentheses. Now see the range of float here. Look at another example where we used expression. Now we've created a float variable and given it an expression. Now define this variable and press enter. As you can see, it's given an error that is incompatible types, possible lossy conversion from double to float. Why? Because we do not use f with the value. Without f, it treated as a double and assigned as a float. And double values have a larger range and more precision than float values. This means that when you try to assign a double value to a float variable, you may lose some precision in the process. So, we assign f to its value and press enter. Now see another example. In this example, we have a float variable named num is declared and initialized with the result of an arithmetic expression. The expression consists of three parts. In first part, it calculates the result of 4.0 divided by 2.0 and assigns the result to a float value. In second part, it calculates the result of 3.0 multiplied by 5.0 and assigns the result to a float value. And in last part, this adds the results of the two previous calculations together and assigns the result to the float variable num. The final value of num will be 17.0. Now come to double data type. In Java, the double data type is used to represent double precision floating point numbers. It is a 64-bit data type that is used to represent fractional values and is often used when a high level of precision is required. Double precision means it consists of 1 sign bit s, 11 exponent bits e, and 52 mantissa bits m as shown in figure. For example, we have a double variable named price is declared and initialized with the value 987.90d. The capital D or small d suffix is optional when initializing a double value, but it can be included to make it explicit that the value is a double and not a float. We already discussed explicit and implicit concepts in the type casting in Java lecture. Now take a slightly more complex calculation example. In the example, it calculates the total price of an item by adding the price of the item to the price of the tax. The result is stored in a double variable named total and printed to the console using the print method. The code starts by declaring a double variable named tax rate and initializing it with the values of 0.9. This represents the tax rate as a decimal value. Then, it declares a double variable named total and initializes it with the result of the expression price plus parentheses price multiply tax rate. We already initialized the price variable. This calculates the total price of the item by adding the price of the item to the price of the tax, which is calculated by multiplying the price by the tax rate. Finally, the code uses the print method to print the value of total to the console, along with the string total. The print method prints the string that is passed to it, followed by a new line character. So, if the value of price is 987.90D and the value of tax rate is 0.09, the output of this code is, total is, 1076.811. As you can see it, here are a few things to keep in mind when working with double values in Java. Double values are represented using 64 bits, which is twice as many bits as float values. This means that double values have a greater range and precision than float values. Double values are generally slower to process than float values on most modern computers, because they take up more space in memory and the processor has to do more work to manipulate them. Double values are often used in situations where a high level of precision is required, such as when working with very large or very small numbers or when performing a large number of calculations. The main difference between float and double is the range. Double has a higher range than float. If we want to check the range, we simply use this line of code that is system.out.print parentheses double quotation and write range of double, min range, plus double min underscore value plus to max range, plus double max underscore value parentheses. Now see the range of double here, in the final section of this lecture. In summary, we will compare float and double data types. Now, take a look at their differences. The first point defines the characteristics, the second point discusses floating, and the third point discusses doubles. Memory. Float occupies 4 bytes of memory, while double occupies 8 bytes of memory. Accuracy. Float accuracy is low, while double accuracy is high. Precision. Float follows single precision, while double follows double precision. Keyword used. The float keyword is used to define a float number, while the double keyword is used to define a double precision number. Default data type. Java does not use it as the default floating point number, while double is the default data type for floating point numbers. Data loss. There will be no data loss if we convert float to double, while there will be data loss if we convert double to float. Uses. Float should be used where less accuracy is required and storage is a constraint, while double is used where more accuracy is required and also requires more precision. Suffix. Float uses capital F or small f as a suffix. It is mandatory to add a suffix if you are declaring a float variable, while double uses small d or capital D as a suffix. It is optional to add a suffix if you are declaring a double variable. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Scientific notations in float and double. In this lecture, we will use scientific notations in float and double. First, we discuss about scientific notation. Scientific notation is a way of representing very large or very small numbers in a more convenient and compact form. It is commonly used in mathematics, science, and engineering. In scientific notation, a number is represented as a base number multiplied by a power of 10. The base number is always between 1 and 10 inclusive, and the power of 10 is expressed as an exponent. For example, the number 123,456,789 can be written in scientific notation as 1.23456,789 multiply 10 to the power 8. The base number is 1.23456,789, and the exponent 8 indicates that the number should be multiplied by 10 raised to the 8th power, or 10 to the power 8. Scientific notation is often used to represent very large or very small numbers in a more manageable form. For example, the distance from the Earth to the Sun is about 93 million miles, which can be written in scientific notation as 9.3 multiply 10 to the power 7 miles. In programming, scientific notation can be used to represent floating point numbers in certain programming languages, such as Java. Now we understand this concept with the help of some examples. For this OpenJ shell. Now look at the first example. If we store a large number in a double variable, then double store it in scientific notation. For example, we create a double variable and store a big value like this. Here you can see this, the value 2. And then some point values, and then E10 is a number in scientific notation, which is a way of representing very large or very small numbers in a more compact form. In scientific notation, a number is represented as a mantissa, a decimal number multiplied by the base 10 raised to an exponent. In this case, the mantissa is 2 and point values, and the exponent is 10, so the value of the number is 2 and point values multiplied 10 to power 10, or 2 and point values e10. The value of num would be equivalent to our given number. In the next example, we multiply two scientific notation numbers. For this, declares a variable num1 of type double and assigns it the result of the multiplication 4.56e10 multiplied by 5.89e9. The values 4.56e10 and 5.89e9 are numbers in scientific notation, which is a way of representing very large or very small numbers in a more compact form. In scientific notation, a number is represented as a mantissa, a decimal number multiplied by the base 10 rows to an exponent. In this case, the mantissas are 4.56 and 5.89, and the exponents are 10 and 9, respectively. The value of num1 would be the result of 4.56e10 multiplied by 5.89e9 is 2.68584e20. In the next example, we calculate the circumference of a circle in the radius. For this, we first declare a variable pi with double data type and assign it the value 3.14, which is a common approximation of the mathematical constant pi. It then declares a double variable radius and assigns it the value 5,000, which represents the radius of the circle. Next, we calculate the circumference of the circle using the formula 2 multiply pi multiply r, where pi is the value of pi and r is the radius of the circle. The result is stored in the double circumference variable. Finally, the code prints the value of the circumference variable to the console using the print method of the system.out object. The print method prints the value. In the next example, we will convert Celsius to Fahrenheit. To convert a temperature from Celsius to Fahrenheit, you can use this formula: Fahrenheit equals sign parentheses 9.0 divided by 5.0 multiply Celsius plus 32. For this, we declare a variable Celsius of type double and assign it the value 37.5, which represents a temperature in Celsius. Then declares a variable Fahrenheit of type double and assigns it the result of the conversion from Celsius to Fahrenheit. The formula for converting a temperature from Celsius to Fahrenheit, that is, double F equals sign parentheses 9 divided by 5 multiply Celsius plus 32, where F is the temperature in Fahrenheit and Celsius is the temperature in Celsius. Then calls the print method of the system.out object, which prints the value of the Fahrenheit variable to the console. The print method prints the value. The result of this code would be the temperature in Fahrenheit, which would be a double value, as you can see. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Char versus string. In this lecture, we will discuss in detail the comparison between the char and string primitive data types. First, we discuss the char primitive data type. A character is a unit of information that represents a single symbol in a written language. Characters can include letters, digits, punctuation marks, and other symbols used in written communication. In Java programming language, characters are represented using the char data type. The char data type is a single 16-bit Unicode character, and single quotes are used to denote a char literal, which allows for a range of 65,536, that is 210 to the power 16 unique characters, including most of the world's written languages as well as special characters and symbols. Characters are used in Java programming language to store and manipulate text data. To see an example, open JShell. Here we create char variable ch is being declared and initialized with the value a in single quote. Then, write system.out.print parentheses ch semicolon. The print method of the system.out object is being called to print the value of the ch variable to the console. Remember that in contrast, double quotes are used to denote a string literal. A string is a sequence of characters represented by a series of characters in double quotes, and we will discuss string later. Now come to the char again. So, there are several ways in which the char data type can be used in Java, like The char data type is well suited for storing and manipulating individual characters, such as letters, digits, and punctuation marks. For example, you might use a char variable to store a user's initial or a single character from a longer string. The char data type can be used to represent special characters in a string using escape sequences. An escape sequence is a combination of characters that represents a special character, such as a new line or a tab. For example, you can use the escape sequence \n to represent a new line character in a char literal. The char data type can be used to implement algorithms that operate on individual characters, such as character sorting. Now we will discuss Unicode because Java supports it for char values. What is Unicode? Java supports a Unicode value for characters, which you can use to set a char value. Unicode is an international encoding standard for use with different languages and scripts, by which each letter, digit, or symbol is assigned a unique numeric value that applies across different platforms and programs. In the English alphabet, only 26 characters are needed in total to represent the entire English alphabet. But other languages need more characters, and often a lot more. Unicode allows us to represent these languages. The way it works is that by using a combination of the 2 bytes that a chart takes up in memory, it can represent any one of 65,535 different types of characters. Let's swing over to the browser and look at a website called unicode-table.com. Here we can see there that we've got a lot of symbols on the screen, and if we scroll down you can see there's lots of different symbols, and these are all Unicode characters. And you can see there are many characters, and as I'm scrolling down, that's actually generating more. So I will go back up to the top again. Let's find the Unicode value for the capital letter C. There are actually different ways to get the value. The quickest way to get the values is to left-click on the letter of interest. A small pop-up will appear with 2 values. The first value that starts with U+ has the Unicode value after the U+, so we are interested in the values as in 4.3. Now that we have the code, how do we use it in Java? We will put the single quotes as we did before. But this time, because we're putting in a Unicode character, we need to put a \u and those 4 digits, all in single quotes. Now we use it in program. For this, we have the char variable Unicode as being declared and initialized with the Unicode value single quote \0043. The \u escape sequence is used to represent a Unicode character in a char literal. The 4-digit hexadecimal number 0043 and \u represents the Unicode code point for the character. The Unicode code point 0043 represents the character capital C. Therefore, the char variable Unicode will be initialized with the character capital C. Here we can see it stores character capital C. So, there are 3 ways to assign a value to a character: a literal character, a Unicode, and an integer. We already discussed literal characters in Unicode, but how is an integer possible? Because the range of the char data type includes all of the ASCII characters, which are the first 128 characters in the Unicode character set. For example, let's make a char variable called ASCII and give it the value 65. Decimal 65 have the character capital A in the ASCII table. So you can see it with a capital A here. Now come to string in Java. So, a string is a sequence of characters. In Java, string is not a primitive data type. It is a class in the Java library that represents a sequence of characters, and double quotes are used to denote a string literal. It is also called a non-primitive data type. We will discuss all non-primitive data types later. Why we discuss this here is because it is very important, because we start our first program with it, which is Hello World. And Hello World is a string that is a sequence of characters. For example, we have the string variable company is being declared and initialized with the value Java, programming with Nixware. The string literal is a series of characters in double quotes, and it represents the string value Java programming with Nixware. Now you can see it store Nixware as a string. Now, see another example. We have 3 string variables S1, S2, S3 are being declared and initialized with the values that are hello, world, and program, respectively. Then, write print method of the system.out object is being called one by one to print the values of the string variables to the console. The print methods print the given strings to the console. That is hello, world, and program. Now, see another example. Here we have three int variables num1, num2, and sum. Num1 and num2 are being declared and initialized with the values 100, 200. Then plus operator is being used to add the values of num1 and num2 and assign the result to the int variable sum. Then, write system.out.print parenthesis double quote sum is plus sum semicolon. Here the print method of the system.out object is being called to print the string the sum is and the value of the sum variable to the console. Here, the plus operator concatenates the value to the string that is sum is colon. Here is the output. Now, take a quick look at the summary of the difference between char and string. Char is a primitive data type, while string is a non-primitive data type. Char stored a single character, while string stored a sequence of characters. Char enclose in single quotation, while string enclose in double quotation. I hope you learned something useful in this lecture as well, and I will see you in the next one. In this lecture, we will talk about operators in Java. In Java, an operator is a symbol that performs a specific operation on 1, 2, or 3 operands and produces a result. There are many operators in Java. For example, d equals sign a plus b multiply c semicolon. In this statement, d is a variable and a, b, and c are also variables or values. The statement uses the assignment operator equal sign to assign the value of the expression a plus b multiply c to the variable d. First, the value of b multiply c is calculated, since the multiplication operator has higher precedence than the addition operator plus. Then, the value of a plus b multiply c is calculated as a plus parenthesis b multiply c. Finally, the value of the expression is assigned to the variable d. So the value of d will be the result of the addition of a and b multiply c. Now, we can see 3 operators here, equal, plus, and multiplication, and 4 operands that are a, b, c, and d. The term operand is used here. So, what exactly is operand? In Java, an operand is a quantity on which an operation is performed. An operator performs an operation on one or more operands to produce a result. For example, in the expression 5 plus 2, 5 and 2 are the operands, and plus is the operator. The operation performed is addition, and the result of the operation is 7. In this expression, 5 and 2 are both values also known as literals, but operands can also be variables. For example, in the expression x plus y, x and y are variables that represent values, and the operator plus performs the operation of addition on those values. Operands can be of various types, such as integers, floating point numbers, characters, and strings, depending on the operation being performed. For example, in the expression double quote hello plus double quote world, the operands are strings, and the operator plus concatenates or joins them to produce the result hello world. Now we define what an expression is. In Java, an expression is a combination of variables, literals, and operators that represents a single value or operation. Expressions are used to perform operations and to specify values in Java programs. An expression can be a simple value, such as a literal or a variable, or it can be a more complex combination of values and operators. For example, the expression 15 plus 12 represents the operation of adding the values 15 and 12. The result of this expression is 27. Expressions are often used in Java statements, such as assignment statements and control statements. For example, in the assignment statement x equals 15 plus 12, the expression 15 plus 12 is evaluated, and the result is assigned to the variable x. Now open JShell. We create a variable with value that is int sum equals sign 6 plus 7 semicolon, and the double slash notation indicates the start of a single line comment. Anything after the double slash on the same line is considered a comment and is ignored by the compiler. Here, the comment 6 plus 7 equals 13 is added to explain the purpose of the code. It does not have any effect on the execution of the program. Here int is a Java keyword that indicates that a variable of type integer is being declared. Sum is the name of the variable that is being declared and initialized. Equal sign is the assignment operator, which assigns a value to a variable. 6 plus 7 is the expression that is being evaluated and assigned to the variable sum. The expression 6 plus 7 consists of 6 and 7 are the operands. They are integer values, also known as literals. Plus is the operator. It performs the operation of addition on the operands 6 and 7. The result of the expression 6 plus 7 is 13, which is then assigned to the variable sum using the assignment operator equal sign. So after this statement is executed, the variable sum will have a value of 13. Now, we discuss comments in Java as we used them in the previous example. A comment is a piece of text in a program's source code that is not executed as part of the program. Comments are used to add explanatory notes to the code and to document how the code works. In Java, comments are used to explain the purpose of the code, how it works, and any important implementation details. Comments are ignored by the compiler and are not included in the final executable version of the program. They are intended for human readers of the code and are used to help make the code easier to understand. There are two types of comments in Java: single-line comments and multi-line comments. Single-line comments start with 2 forward slashes and continue until the end of the line. Multi-line comments start with a forward slash and an asterisk and end with an asterisk and a forward slash. They can span multiple lines. For example, we have a variable x of type int and initialize it with the value 10. The lines starting with double forward slash are comments and are ignored by the compiler. They are used to add explanatory notes to the code. Double forward slash declare a variable. This line is a comment that explains the purpose of the line of code. A forward slash and an asterisk initialize the variable. This is the start of a multi-line comment. Everything between the opening a forward slash and an asterisk and closing asterisk and a forward slash is considered a comment and is ignored by the compiler, with the value 10 asterisk and a forward. This line is part of the multi-line comment started on the previous line. It explains the purpose of the next line of code. X equals sign 10 semicolons. This line initializes the variable x with the value 10. System.out.print parenthesis x semicolon. This line prints the value of x to the console. Double forward slash print the value of x to the console. This line is a comment that explains the purpose of the next line of code. Now come to the operator again and see an example. We have two variables, first value and second value, are declared and initialized with the values a and b, respectively. The variables first value and second value are of type char, which represents a single character in Java. The line system.out.prints parentheses first value plus second value prints the sum of first value and second value to the console. Since first value and second value are of type char, their sum is actually the result of adding their ASCII values. For example, the ASCII value of A is 65, and the ASCII value of B is 66. Therefore, the expression first value plus second value evaluates to 65 plus 66, which is 131. Now, it prints 131 to the console. Remember that chars never concatenate here with the plus operator, unless we use string here like this. When we use the line system, .out.print parenthesis empty string plus first value plus second value prints the concatenation of first value and second value to the console. Since the empty string is added to the beginning of the expression, the result of the expression is a string. Here, it prints ab to the console. Now use another operator, which is subtraction. In Java, the subtract operator is used to perform subtraction. It can be used with numeric operands such as int and double to subtract one number from another. For example, we have three variables x, y, and z are declared and initialized. The variables x and y are initialized with the values 10 and 5, respectively. The variable z is then assigned the value of xy, which are 10 minus 5. Then print the z variable using the print method. Here is the output 5. Look another operator that is multiplication. In Java, the multiplication operator is used to perform multiplication. It can be used with numeric operands such as int and double to multiply one number by another. For example, we have variables x and y are declared and initialized with the values 10 and 5, respectively. The variable z is then assigned the value of x asterisk y, which is 10 asterisk 5, that is 50. Another example, write int r equals sign 10 semicolon. This line declares a variable r of type int and initializes it with the value 10. Then write int d equals sign r multiply r semicolon. This line declares a variable d of type int and assigns it the result of multiplying r by itself 3 times, which is 10 multiply 10 multiply 10, that is 1000. /d is assigned the value of 10 multiply 10 multiply 10, which is 1000. This line is a single line comment that explains the purpose of the previous line of code. Now we see another operator, that is modulus means remainder. In Java, the modulus operator is used to obtain the remainder of a division operation. It can be used with numeric operands such as int and double to divide one number by another and return the remainder. For example, we have 3 variables x, y, and z are declared and initialized. The variables x and y are initialized with the values 10 and 3, respectively. The variable z is then assigned the value of x modulus y, which is 10 modulus 3, that is 1. Why is the answer 1? Because 3 does not completely divide the 10. When we multiply 3 by 3, we get 9, which we subtract from 10, and 1 remaining. Similarly, if we divide 2 by 10, the remainder is 0. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Arithmetic operators with exercises. In this lecture, we will talk about arithmetic operators in Java. In Java, there are several types of operators, like arithmetic operators, relational operators, logical operators, assignment operators, conditional operators, bitwise operators, ternary operator, instance of operator. We will define all these in little bits and discuss them in detail in coming lectures. Here we will discuss only the arithmetic operator in detail. So, we take a look at all of these. Arithmetic operators. These are used to perform basic arithmetic operations such as addition, subtraction, multiplication, division, increment, and decrement. Relational operators. These are used to compare two values and determine their relationship, such as whether one value is greater than, less than, or equal to another value. Logical operators. These are used to combine two or more relational expressions and determine their overall truth value. Assignment operators. These are used to assign a value to a variable. Conditional operators. These are used to perform different actions based on the truth value of a condition. Bitwise operators. These are used to perform bit-level operations on integer values. Ternary operator. This is a conditional operator that takes 3 operands and evaluates a Boolean expression, returning one value if the expression is true and another value if it is false. Instance of operator. This is used to determine if an object is an instance of a particular class or an implementation of a particular interface. Now we will discuss arithmetic operators. In the previous lectures, we saw some example of arithmetic operators and also write multi-line example code in J shell using curly braces. For this, we first discuss what curly braces are and how we can use them in J shell. Curly braces are used to group statements together as a block. This is useful when you want to execute multiple statements as a single unit. Open J shell to look at an example. Now write, start curly brace for block of statements within the curly braces is executed. Then two integer variables, first variable and second variable, are declared and initialized with the values 2 and 3 respectively. Then, variables first variable and second variable are added together, and the result is stored in the sum variable. Then, the string result is, and the value of the sum variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Now we can see the output, that is, result is 5. Look at another example. Now write, start curly brace for block of statements within the curly braces is executed. Then, integer variable number is declared and initialized with the value 1. Then, value of number is incremented by 1, resulting in a new value of 2. Then, the string result is, and the value of the number variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. So, the output result is 2. The statement number is equal to number plus 1 is working as increment operator in Java. Now we discuss increment operator in Java. The increment operator is a unary operator that is used to increase the value of a variable by 1, that also known as ++. There are two increment operators in Java, the postfix increment operator and the prefix increment operator. The postfix increment operator increments the value of a variable by 1, but the increment occurs after the value of the variable has been used in the expression. For example, int x is equal to 5 semicolon. Int y is equal to x plus semicolon. First y is assigned the value of x, which is 5, and then x is incremented to 6. The prefix increment operator increment the value of a variable by 1, but the increment occurs before the value of the variable is used in the expression. For example, int x is equal to 5 semicolon. Int y is equal to plus x semicolon. First x is incremented to 6, and then y is assigned the value of x, which is 6. There is another way to increment value by 1 is compound assignment operator with the plus sign. In Java, the compound assignment operator with the plus sign is the plus is equal to operator. It is used to add the right operand to the left operand and assign the result to the left operand. For example, int x is equal to 10 semicolon. Int y is equal to 5 semicolon. X plus is equal to y semicolon. X is now 15. This is equivalent to writing x is equal to x plus y semicolon. The compound assignment operator with the plus sign can be used with any primitive type or with variables of type integer and atomic integer. The compound assignment operator with the plus sign is a shorthand way of adding a value to a variable and assigning the result to the same variable. It is often used in loops to accumulate the sum of a series of values or to perform some action repeatedly on the same variable. Look at another example of this. Open J shell. Now write, start curly brace for block of statements within the curly braces is executed. Then integer variable myNumber is declared and initialized with the value 10. The value of number is incremented by 1 using the postfix increment operator ++, resulting in a new value of 11. Then, the string result is, and the value of the myNumber variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output that is 11. Now edit the same example again, and change only statement with compound assignment operator with the plus sign that is myNumber plus is equal to 1 semicolon. Now press enter. The same result is shown here. Now look at another arithmetic operator that is decrement operator. In Java, there are two decrement operators, the postfix decrement operator --, and the prefix decrement operator --. The postfix decrement operator --, decrements the value of a variable by 1, but the decrement occurs after the value of the variable has been used in the expression. For example, int x is equal to 5 semicolon. Int y is equal to x minus semicolon. First y is assigned the value of x, which is 5, and then x is decremented to 4. The prefix decrement operator --, decrements the value of a variable by 1, but the decrement occurs before the value of the variable is used in the expression. For example, int x is equal to 5 semicolon. Int y is equal to -x semicolon. First x is decremented to 4, and then y is assigned the value of x, which is 4. Look at another example of this. Open J shell. Now write, start curly brace for block of statements within the curly braces is executed. Then integer variable myNumber is declared and initialized with the value 10. The value of number is decremented by 1 using the postfix decrement operator --, resulting in a new value of 9. Then, the string result is, and the value of the myNumber variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output that is 9. Now edit the same example again, and change only statement with compound assignment operator with the minus sign that is myNumber minus is equal to 1 semicolon. Now press enter. The same result is shown here. The compound assignment operator is used with the different arithmetic operator signs, like plus, minus, multiply, and division. We already practiced of the compound assignment operator with the plus sign and compound assignment operator with the minus sign. Now we look at the compound assignment operator with the multiply sign. For this OpenJ shell, now we have variables x and y are declared and initialized with the values 10 and 5 respectively. Then compound assignment operator multiply is equal to is used to multiply the value of x by the value of y and assign the result back to x. The value of x is now 50 and the value of y remains unchanged at 5. Then the string result is, and the value of the x variable is printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output that is 50. Now we look at the compound assignment operator with the division sign. Now edit same example, only change division sign here and press enter. Here we can see the output that is 2. Look another example using decimal number. Now write, start curly brace for block of statements within the curly braces is executed. We have declaring a variable point number of type double and initializing it with the value 5.5. Then, using the compound assignment operator plus is equal to add 4.5 to the value of point number and assign the result back to point number. After this operation, the value of point number becomes 10.0. Then, using the system.out.print method to print the string result is, followed by the value of point number. And last, close the curly brace to end the block and press enter. Here we can see the output that is 10.0. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to IDE. In this lecture, we will go over an introduction to IDE. In the previous lectures, we learned the basic concept of Java using the very basic tool JShell. Now we can move on to learn advanced Java concepts and write complete and comprehensive Java code. For this, we now will use an IDE. So, what is an IDE and why do we use it? Integrated Development Environment IDE is a software application that provides a comprehensive set of tools for software development. IDEs typically include a code editor, a compiler or interpreter, and a debugger, as well as many other features such as a source code management system, a version control system, and a build automation system. The main benefit of using an IDE is that it provides a single, unified interface for all the tasks involved in software development. This can save a lot of time and effort, as developers do not have to switch between different tools or environments for different stages of the development process. IDEs can also provide helpful features such as code completion, syntax highlighting, and error checking, which can make it easier and more efficient to write, debug, and maintain code. There are many different IDEs available for different programming languages and platforms. Some popular IDEs for Java include Eclipse, NetBeans, and IntelliJ IDE. We will now work on IntelliJ IDE because of a variety of reasons. IntelliJ IDE is a popular Java integrated development environment IDE developed by JetBrains. It is widely used by Java developers because of its rich set of features and functionality. Some of the benefits of using IntelliJ IDE include intelligent code completion. IntelliJ IDE provides intelligent code completion that suggests names of variables, methods, and classes as you type. This can help you write code more quickly and accurately. Advanced refactoring tools. IntelliJ IDE has advanced refactoring tools that can help you safely and easily change the structure of your code. Built-in debugger. IntelliJ IDE has a built-in debugger that allows you to step through your code, set breakpoints, and inspect variables. Integrated version control. IntelliJ IDE integrates with version control systems such as Git and Mercurial, allowing you to easily manage your codebase and collaborate with others. Customizable user interface. IntelliJ IDE has a customizable user interface, so you can tailor it to your specific needs and preferences. Great support for popular frameworks and libraries. IntelliJ IDE has excellent support for popular Java frameworks and libraries such as Spring, Hibernate, and Android. Regular updates and improvements. JetBrains is actively developing and improving IntelliJ IDE, releasing new versions on a regular basis. To summarize it, look at the difference between an IDE and a text editor. IDE typically includes a code editor, compiler or interpreter, and debugger. While text editor is a simple program for creating and editing plain text files. IDE provides a comprehensive set of tools for the full software development lifecycle. While text editor may have basic features such as syntax highlighting and code folding, IDE may have features such as code completion, syntax highlighting, and error checking. While text editor does not typically include a compiler or debugger. IDE may include tools for source code management, version control, and build automation. While text editor does not have as many tools and features as an IDE. IDE may be more feature-rich and have a steeper learning curve, while text editor may be simpler and easier to use. I hope now you can see why we are going to use an IDE rather than a text editor. So, in the next lecture, we will install the IntelliJ IDE on Windows and then on Linux. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about installing IntelliJ IDEA for Windows. In the previous lecture, we talked about IDEs, evaluated the differences between IDEs and text editors, and explored the reasons for using IntelliJ IDEA. Now we recap it, and then install it on Windows. We're going to work using IntelliJ IDEA and IDE. The tool for creating programs is called the Integrated Development Environment, or IDE. We need a text editor where we can enter our code in order to create functionalities. However, an IDE also executes and builds our programs for us. As you'll see, it also notifies us to programming mistakes before we execute the code. Our chosen IDE is called IntelliJ IDEA, and it was developed by a firm named JetBrains. There are additional options, and you are free to utilize any of them for this course. It's okay to continue using your existing IDE if you enjoy it and feel at ease doing so. Most current concepts provide equal or very similar features. I advise using IntelliJ IDEA if you've never utilized an IDE before. In this manner, your environments will operate as they would in the lecture. To be clear, this lecture is just for Windows users. Those of you who use Linux should check out the other lecture that is installing IntelliJ IDEA for Linux. Now, it's time to download and install IntelliJ IDEA, which we need to write Java programs. Open your browser and go to jetbrains.com. Click on Developer Tools at the top, and then click on IntelliJ IDEA. Then click on the Download button. Make sure Windows is selected here and choose the Community Edition of IntelliJ IDEA to download. The Ultimate Edition is a paid version of IntelliJ IDEA, which is not needed for this course. Now exe file is begin to download. After the exe file is downloaded, double-click on the exe file to open it for installation. When Installation Wizard appears, now click Next to accept the terms of the license agreement. Now choose the destination folder where you want to install IntelliJ IDEA and click Next. Now select the components that you want to install. For this, click on IntelliJ IDEA Community Edition and click Next. Then click Install to begin the installation process. This moment wait for the installation to complete. This may take a few minutes. Now click Finish to complete the installation. Now it's successfully installed on Windows. So, in the coming lectures, we will look at its functionality and start working on it. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about installing IntelliJ IDEA for CentOS Linux. We've already talked about IDEs and IntelliJ IDEA. Now, we're going to install IntelliJ IDEA on CentOS Linux. Check out the relevant lecture for your operating system if you use Windows. So let's start. I'm already setting up a virtual machine using VirtualBox on Windows, installing CentOS Linux as the operating system on the virtual machine, and connecting PuTTY software with CentOS Linux. So, PuTTY is available for Windows, macOS, and Linux operating systems, and it can be used to connect to any computer that has a supported network service running, such as an SSH server. You may use it by installing CentOS Linux or any other Linux flavor as a dual boot system or in a virtual machine. Now come to the installation. First, we run our machine as the root user and then given root password. To download IntelliJ IDEA from the CentOS terminal, you can follow these steps. To install IntelliJ IDEA on Linux, first we enable snaps on CentOS. For this, run the sudo yum install appel release command. It takes some time to install. Then, install the systemd. Unit that manages the main snap communication socket needs to be enabled. For this, run the sudo yum install snapt command. It takes some time to install. Now use the command sudo systemtool enable now snapt socket to enables and starts the snapped socket service. In last, enable classic snap support. Use sudo ln/var/lib/snapt/snap/snap command. If you already enable snaps on Linux, then you just directly download IntelliJ IDEA from your Linux terminal by using sudo snap install IntelliJ IDEA community classic command. If you see this error, that is, too early for operation, device not yet seeded or device model not acknowledged, just write again this command. Now, it takes some time to install. Now it's successfully installed on CentOS Linux. So, in the coming lectures, we will look at its functionality and start working on it. I hope you learned something useful in this lecture as well, and I'll see you in the next one. IntelliJ IDEA functionalities. In this lecture, we will go over an introduction to IntelliJ IDEA functionalities. In fact, we can begin writing some Java code. Whether you're using Windows or Linux, you may still benefit from this lecture. Therefore, we must first associate the JDK. To make them compatible, we installed IntelliJ IDE with Oracle's JDK 17. Basically, this means notifying IntelliJ of the presence or the absence of JDK on the system. In general, the JDK functions as a software development kit. It has the resources we need to develop programs. The Java development kit comes all the tools required for the computer to recognize and run our Java code. It also contains a debugger, which we will explore in more detail after we've developed a program to utilize it with. So, if we have not started IntelliJ IDEA already, do so now. The user agreement is the first thing we must acknowledge by checking the box, and then moving to the next step. However, it is recommended that we read this first. So, the next option is for exchanging data. Now click on Send on Anonymous Status button. So, IntelliJ IDEA is starting now. Here we are presented with a welcome screen that gives us the option to create a new project, open, and get from VCS. New project. This option allows us to create a new project from scratch. We can choose the type of project we want to create, such as a Java or Kotlin project, and configure various project settings. Open. This option allows us to open an existing project that we have already created or downloaded. We can navigate to the directory where the project is located and open it in IntelliJ IDEA. Get from VCS. This option allows us to check out a project from version control, such as Git or Subversion. We will need to provide the repository URL and any necessary authentication information to clone the project. Now, start by selecting New Project from the options. We will see that a JDK detection pop-up was shown by IntelliJ. It's looking for the JDK that we just installed a few lectures ago. You can notice that the numbers match the JDK that we previously downloaded if you look closely. 17.0.6 in my scenario. If we haven't installed the JDK, we should return to the JDK install lecture, install it, and then return here. The only other action we would do is to verify that Java and IntelliJ are chosen, which they already are, and which JDK is showing. This is the screen to use in IntelliJ to start a project, and we will be doing it a lot in the future. Now that I have returned to the main IntelliJ screen, I will click Cancel button, and this time I want to click Customize to change a few settings. Now click on All Settings. Here we can change the theme. Document is a nice background for programming as it's gentle on the eyes, and many people recommend it. Now, I am going to select, drop down, and choose IntelliJ Light, because the white background is better for us. So, keep in mind, you can come back here and change the setting at any time. Now click Editor and General now. We can see that I am expanding the available options. I am choosing a few options to simplify things for Java programmers who are just starting out. I will choose Auto Import. The Auto Import feature automatically adds missing import statements to our code when we complete a symbol, for example, a class or method name that cannot be resolved. This can be a convenient way to avoid having to manually add import statements for symbols that we use in our code. The Auto Import feature is turned on by default, but we can disable it if we prefer to add import statements manually. Now we check both, add unambiguous imports on the fly and also optimize imports on the fly. Add unambiguous imports on the fly refers to the ability of the IDE to automatically add import statements for symbols that are used in our code but do not have an import statement. This can be a convenient way to avoid having to manually add import statements for symbols that we use. While optimize imports on the fly refers to the ability of the IDE to automatically remove unnecessary import statements and reorder remaining import statements in an optimized way. This can help to keep our code clean and organized. Now, we will move on to code folding after that. I'm going to check a few things right now, since IntelliJ IDEA is a professional editor designed to shorten and simplify things for both inexperienced and expert developers. When we first start studying Java, it might be challenging, since some of these default parameters essentially hide some of the source code. I will come down here if we want to view all the code we are developing, then we are going to deselect imports and file headers. And also one line method will be deselected. Deselecting this closure, as well as generic constructor and method parameters. In other words, I am instructing IntelliJ to display as much code as possible for those items. We also need to go up for appearance right now. Make sure Show Line Numbers is checked in this area. The setting is now complete, and we may click OK. Click Projects here to return to the Projects page. Our completed projects will be listed for us in the main portion of this process, making it much simpler for us to access them once again. Obviously, none are present at this moment. We now have the New Project button on our screen. When we click it, it will be at a different location. Now that everything is set up, so we are ready to program. I will come over here and choose New Project. The next step is to provide IntelliJ with information about the project we wish to construct, including the project's name, location, and language. The JDK we wish to use, Java, will always be selected here and should automatically default to the JDK we previously defined. So name is the name of our new project, which I will change to my first program. My name can no longer include spaces. However, it's typically not a good IDEA to include spaces in file names or project names, since these names will eventually be used to identify the folder or location of the project, and various operating systems read spaces in these names differently. If you want to differentiate between these terms, I am going to advise you to always capitalize the first letter of each term, like I did with the my, capital M, and then first with capital F, and program with capital P here. This style of writing, known as camel case, allows words to be visually separated rather than by spaces. If we define camel case in more detail, there are two main types of camel case in Java: upper camel case, also called Pascal case, and lower camel case, also called just camel case. Upper camel case is a naming convention in which the first letter of each word in a compound word is capitalized, including the first word. For example, upper camel case is an example of upper camel case. Lower camel case is a naming convention in which the first letter of each subsequent word in a compound word is capitalized, except for the first word, which is written in lowercase. For example, lower camel case is an example of lower camel case. Both upper camel case and lower camel case are commonly used in Java to name variables, methods, and class names. Upper camel case is often used for naming constants, while lower camel case is more commonly used for naming variables and methods. It is generally a good IDEA to follow naming conventions in Java to make your code more readable and easier to understand. I think now you will understand the concept of the camel case. Now, the next thing we need to specify is a project location. IntelliJ use a default location. Use the folder named ~IDEA projects in Windows and Linux systems, and you may have used a different folder name. Here the tilde symbol represents your home directory, and IDEA projects is the name of the directory where your projects are stored. When you create a new project in IntelliJ IDEA, it is stored in the IDEA projects directory by default. You can change this location if you prefer to store your projects in a different directory. For example, if your username is John, the default location for your IntelliJ IDEA projects on Linux would be /home/John/IDEA projects. On Windows, the default location would be C/users/nixware/IDEA projects. Now I change it to my location. Now here is an option named sample code. If you select this option, IntelliJ IDEA will include a set of sample files and code in your project to help you get started. These sample files and code can be a useful resource for learning how to use IntelliJ IDEA and for understanding how to structure and organize your code. However, you might choose to uncheck the sample code option if you do not want these sample files and code to be included in your project. For example, you might want to start your project from scratch with an empty code base, or you might already have your own code and files that you want to use. So, in our case, we unchecked the sample code option, and now we will press the Create button. So next we get this little project, and on the left-hand side. To open or shut the folder, we may come over here and click on the little arrow icon. Therefore, below it, we have a folder labeled .idea, which contains functioning files, IntelliJ IDs, and this email file. None of these are currently a concern for us. Now, it's time to create our first Java class. For this, right-click on the SRC that is called Source Folder and select New, and then move here to click Java class and type in Hello World and press Enter. Now, the name Hello World is used by IntelliJ to produce some code for this. As you can see, IntelliJ wrote some code specifically for us, and that code is displayed in the user interface's right pane. The editor window appears here. The labeled Hello World with a small C in blue, which is IntelliJ's way of indicating that it's a class, can be seen in the left pane below the SRC folder. I will double-click this tab here to make it full screen. Now, I'm going to develop some code to print something out as my next step. Then I will hit Enter after advancing my cursor to the end of this line. To greatly reduce on typing, I will utilize an IntelliJ shortcut that is PSVM. Press the Tab key after selecting our preferred PSVM. The whole code is typed for us by IntelliJ, which also places the cursor in the appropriate place for the output statement that is system.out.println parenthesis double quote hello world semicolon. Hello world is printed by our regarding the system.out.println. Keep in mind that an IntelliJ line must end with a semicolon. How can we execute this code? By entering a command, we may read the code in J shell. We have many options in IntelliJ to execute this code, which is what you would think from an integrated development environment, which is meant to make life simpler for programmers. We currently have a few options for running the code. This green button up here on the right can be clicked at this time. A green arrow to the left may also be selected by clicking on one of them. Run as first classman is another option that can be chosen by right-clicking. All of them should to work for you, but I am going to choose that one. You can see that something is occurring in the lower right corner. The running pane is this. The Java Developer Kit's IntelliJ has therefore really built a Java program, which must be done before executing Java code, and afterwards presenting the output. The command that IntelliJ set to Java to run our application is in the first line of that section. Following the output of the program, Hello World, that was generated by our print line instruction. This procedure finishes with exit code 0, and what that means is everything's completed successfully. we have successfully executed our Hello World Java code in IntelliJ. I hope you learned something useful in this lecture as well, and I will see you in the next one. Conditional statement if-then with exercises. In this lecture, we will discuss conditional statements, which are if-then statements in Java. In Java, the if-then condition is used to control the flow of a program's execution. It allows developers to make decisions within the program based on certain conditions or circumstances. It is also known as conditional logic. So, conditional logic in Java refers to the use of if-then statements and related constructs to control the flow of a program's execution based on certain conditions. These statements allow a program to make decisions and take different actions depending on the current state or input. One common use of the if-then condition is to check the input values entered by the user to ensure they are valid before performing any further processing. For example, if an application prompts the user to enter a number between 1 and 10, the program can use an if condition to check that the number entered by the user is indeed within that range before proceeding. Another common use of the if condition is to make decisions based on the current state of the program. For example, a program may use an if condition to check if a variable has reached a certain threshold before taking a specific action. The syntax of an if-then statement is, the if keyword is used to start the statement, followed by a set of parentheses that contain the condition that is being evaluated. The condition can be any expression that returns a Boolean value true or false. If the condition inside the parentheses evaluates to true, then the code within the following curly braces is executed. These curly braces enclose the code block that will be executed if the condition is true. Any number of statements can be put inside the if block, but it should be noted that the code inside the if block is executed only if the condition inside the if statement is true. There are several advantages of using if conditions in Java, like conditional execution. If conditions allow for conditional execution of code, meaning that certain statements or blocks of code are executed only when a specific condition is true. This allows for a more efficient use of resources and can make a program more versatile and adaptive to different situations. Improved readability. If conditions can make the logic of a program more explicit and easy to understand. By using if conditions to separate the different branches of a program's logic, it becomes easier to see how the program is functioning and how it handles different input and scenarios. Better error handling. If conditions can be used to validate input and to check for error conditions that may arise during the execution of a program. This allows for better error handling, which can make a program more robust and less prone to crashing. Enhanced flexibility. By using if-else statements, developers can create more complex decision-making logic, allowing for the program to handle multiple conditions and scenarios. Reusability. If conditions can be used to create functions that can handle different conditions and inputs, and these functions can be reused in different parts of the program. This can save time and make the code more efficient. In short, if conditions are a powerful tool for controlling the flow of a program's execution, making it more versatile and adaptive, also improving the code readability and reusability, making it more robust to handle different scenarios and errors. Also, there are a few potential limitations to using if conditions in Java, like complexity. Using multiple if conditions in a program can make the code more complex and harder to understand, especially if the conditions are nested or involve multiple branches. This can make the program more difficult to debug and maintain. Performance. If a program has a large number of if conditions, the execution time may become a bottleneck and decrease the program performance. Especially if the conditions are complex, this can slow down the program's execution time. Repetitive code. Using too many if conditions can lead to repetitive code, making it harder to maintain and change the program. Readability. If the conditions and the code inside if statement are very complex, it can make the code less readable and harder for other developers to understand. Neglecting other options. If the code is heavily reliant on the if condition, it can lead to developers neglecting other options, like using different data structures or solving the problem in a different way. It's important to keep in mind that while if conditions are a powerful tool for controlling the flow of a program, they can also make the code more complex and harder to maintain if used excessively or in a disorganized manner. It's important to be mindful of the trade-offs when deciding to use if conditions and make the best decisions according to the context. Now we come to some practice for if statements. For this open IntelliJ, here we create a class file named conditions. After creating this class file, add a main method to this class as we discussed in the previous lectures. Now we make a simple example of using an if condition with a Boolean expression in Java. Now, we declare a variable named flag and assigns it the value of true. The next is the if statement, which checks the value of the variable flag. The condition inside the parentheses is simply the variable flag, which evaluates to true because it was previously assigned the value true. If the condition inside the if statement is true, then the code within the following curly braces is executed. In this case, the code within the if statement block is system.out.println parenthesis double quote, flag is true semicolon. This line of code calls the println method of the system.out object, which is used to output text to the console. The text that is output is flag is true. Therefore, when this code runs, it will output flag is true to the console because the variable flag is assigned the value true. And therefore, the if statement condition evaluates to true and the code within the if statement block is executed. Now you can see the output here. Now we see another example. For this, we create a new class file. This is a great practice for beginners as it makes the code easier to read and learn. So, write class name condition1. Same as previous example, first create a main method here. Now, we first declare a Boolean variable user and assign it the value of true. Then, the if statement checks if the value of the variable user is equal to true by using the comparison operator equal equal. The condition inside the parentheses is user equal equal true, which compares the value of user with the Boolean literal true. If the condition inside the if statement is true, then the code within the following curly braces is executed. In this case, the code within the if statement block is system.out.println parenthesis double quote, it's true semicolon. This line of code calls the println method of the system.out object, which is used to output text to the console. The text that is output is its true. Therefore, when this code runs, it will output its true to the console because the variable user is assigned the value true. And therefore, the if statement condition evaluates to true and the code within the if statement block is executed. Now you can see the output here. Now we see another example. For this, we create a new class file named condition2. Now, first we create a main method here. We first declare an integer variable x and assign it the value of 5. Then, the if statement checks if the value of the variable x is greater than 0 by using the comparison operator greater than. The condition inside the parentheses is x greater than 0, which compares the value of x with the integer literal 0. If the condition inside the if statement is true, then the code within the following curly braces is executed. In this case, the code within the if statement block is system.out.println parenthesis double quote, x is positive semicolon. This line of code calls the println method of the system.out object, which is used to output text to the console. The text that is output is x is positive. Therefore, when this code runs, it will output x is positive to the console because the variable x is assigned the value of 5 and is greater than 0. Therefore, the if statement condition evaluates to true and the code within the if statement block is executed. Now you can see the output here. It's important to note that if the condition inside the if statement is false, the code within the if block will not be executed and the program will continue executing the next statement after the if block. I hope you learned something useful in this lecture as well, and I will see you in the next one. Logical operators with exercises. In this lecture, we will discuss logical operators in Java. In the previous lecture, we discussed the if-then condition and used some operators to learn the concept of the if-then condition. Now, we learn about the logical operator and see how we can use it. In Java, logical operators are used to perform logical operations on Boolean expressions. They are used to combine multiple conditions in an if statement or a loop, or to negate a Boolean value. The logical operators that are available in Java are AND operator. This operator is used to check if both the conditions are true. If both conditions are true, then the entire expression returns true. Or operator. This operator is used to check if either of the conditions is true. If any one of the conditions is true, then the entire expression returns true. Not operator. This operator is used to negate a Boolean value. If a condition is true, then the not operator will make it false, and vice versa. Some other are working on bitwise logical operator like bitwise and bitwise or operator. In Java, bitwise logical operators are used to perform operations on individual bits of a binary number. These operators work on the binary representation of the numbers and allow you to manipulate the bits directly. Bitwise logical operators are typically used in low-level programming, such as working with hardware devices, or in performance-critical code, where manipulating the bits directly can be faster than using the higher-level operators. It's also used in some cases where the bit manipulation is needed, such as in encryption and compression algorithms. So, we will discuss bitwise logical operators later. Logical operators are important in Java because they allow you to create complex conditional statements and control the flow of execution of your program. They allow you to check multiple conditions and make decisions based on the result of those conditions. They can simplify complex expressions by breaking them down into smaller, more manageable parts. They also make your code more readable and maintainable. Logical operators are also useful for improving the performance of a program, as they allow you to evaluate multiple conditions in a single statement and avoid unnecessary computation. Furthermore, logical operators are versatile and can be used in a wide variety of situations, such as in if-else statements, while loops, and for loops. This makes them a powerful tool for programmers to use in many different types of applications. So, there are a few potential limitations of using logical operators in Java, like complexity. Logic operators can make code more complex and harder to understand, especially when multiple conditions are combined in a single expression. Error-prone. Logic operators can be difficult to use correctly, and using them incorrectly can lead to bugs and errors in your code. Performance. Using too many logical operators can slow down the performance of a program. Confusion. Logic operators can be confusing to new programmers, especially if they are not familiar with the rules of Boolean logic. Limited functionality. Logic operators are not able to perform all the logic manipulation. It only performs the basic logic manipulation, and other complex logic manipulation requires other techniques. Now we come to some practice for this Open IntelliJ. Here we create a class file named logical operators. Now, we declare an integer variable named age and assigns it the value of 18. Then uses if statement to check if the value of the variable age is greater than 18. The if statement starts with the keyword if followed by a condition in parentheses, in this case age greater than 18. This condition is checking if the value of age is greater than 18 using the greater than operator. If the condition is true, the code inside the curly braces will be executed. In this case, the code inside the if statement is a simple print statement that prints out condition is true to the console. If the condition is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. Next, we declare another string variable named gender and assigns it the value of male. The if statement starts with the if keyword followed by a condition in parentheses, in this case gender equal male. The condition is checking if the value of gender is equal to male using the equal operator. If the condition is true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out condition is true. In this case, since the value of gender is male, the if statement condition is met, so the code inside the if statement will be executed and the output will be condition is true. Now you can see the two outputs here. First for upper if statement and second for below if statement. Now we use the AND operator to combine these two conditions into one if statement. For example, if we want to check if the age is equal to 18 and the gender is equal to male, then output is given, and that is eligible. First, we will comment these print method statements because we want only the last generated output. So, we use already created variables from the above. which are age and gender. The if statement starts with the keyword if followed by a condition in parentheses. In this case, age greater than 18 and operator gender equal double quote male. The condition is checking if the value of age is greater than 18 and if the value of gender is equal to male using the greater than and equal operators respectively. The and operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out eligible to the console. If either of the conditions is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. See another example. For this, we create a class file named logicaloperators1. Now, we declares 4 integer variables, a, b, c, and d, and initializes them with the values 10, 20, 20, and 0 respectively. The if statement starts with a keyword if followed by a condition in parentheses. In our case, parentheses a less than b and operator parentheses b equal c. The condition is checking if the value of a is less than b and if the value of b is equal to c using the less than and equal operators respectively. The and operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement assigns the sum of the variables a, b, and c to the variable d, and prints out the sum is, along with the value of d. Then if statement will be executed because the values of a and b are 10 and 20, respectively, and b equal c, which is 20. So the result will be the sum is 50. Now you can see the output here. It's a simple example of how logical operator can be used to check multiple conditions in a single statement and perform different actions based on the outcome. It's also a good practice to initialize variables with meaningful values. This will help to improve the readability and maintainability of the code. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Or and not logical operators with exercises. In this lecture, we will discuss or and not logical operators in Java. In the previous lecture, we discussed the introduction of logical operators and saw examples of the and logical operator. Now, we will discuss or and not logical operators in Java and see examples of them. First, we will discuss the or logical operator and its examples, then we discuss the not logical operator. So, in Java, the or logical operator is used to test whether either or both of two conditions are true. It returns a Boolean value of true if at least one of the conditions being tested is true and returns false if both conditions are false. The or operator is represented by 2 vertical lines and is commonly used in control flow statements such as if-else and while loops to make decisions based on multiple conditions. Here we can see an example. In this piece of code, the variables x and y are assigned the values of 4 and 5 respectively. The if statement is then used to check if either x or y is greater than 4. The or operator is used in the condition of the if statement to check if either x greater than 4 or y greater than 4 is true. In this case, the value of y is greater than 4, so the if statement evaluates to true, and the code inside the if statement block is executed. The code inside the if statement block is a call to the system .out.println method, which outputs the string x or y is greater than 4 to the console. So the output will be x or y is greater than 4. It's important to note that in this case, the value of x is not greater than 4, but the or operator checks both conditions, and since one of them is true, the if statement is executed. The or logical operator has several advantages when used in Java, like concise and easy to read. The or operator allows you to check multiple conditions in a single line of code, making your program more readable and easier to understand. Flexibility. The or operator allows you to check multiple conditions and take action based on any of them being true. This allows for greater flexibility in your program's control flow. Improved performance. The or operator short circuits, which means that it stops evaluating further conditions as soon as one of them is found to be true. This can improve the performance of your program, especially when dealing with a large number of conditions. Error handling. The or operator can be used to check multiple conditions for errors in a single line of code. This can improve the readability and maintainability of your program. Multiple conditions check. The OR operator allows checking multiple conditions in a single line of code. This can save many lines of code and make it more readable, rather than writing multiple if-else statements. Combining multiple conditions. The OR operator allows you to combine multiple conditions in a single statement. This can make your code more efficient, as it will only execute the code block when one or more conditions are met. While the OR logical operator has many advantages, there are also some limitations to consider when using it in Java, like complex conditions. When using the OR operator to check multiple conditions, it can make the code more complex and harder to understand, especially when dealing with a large number of conditions. Inefficiency. If multiple conditions are independent from each other, checking them all with OR can lead to inefficiency, since it will check all conditions even if one is true. Reduced performance. When using the OR operator to check multiple conditions, it may not be as efficient as using multiple if-else statements. This can lead to a reduction in performance, especially when dealing with a large number of conditions. Lack of granularity. The OR operator only checks whether one or more conditions are true, and doesn't provide information about which conditions were true. This can make it difficult to take specific actions based on which condition was met. Incorrect results. If the conditions are not well defined, or if the logical operator is not properly used, the OR operator can lead to incorrect results. Risk of logical errors. Using the OR operator incorrectly can lead to logical errors, where the program behaves in unexpected ways or produces incorrect results. Therefore, it's important to understand the behavior of OR operator and use it correctly. Now we come to some practice. For this Open IntelliJ, here we create a class file named OR operator. Now, we declare a double variable named exam score, and then variable exam score is assigned the value of 85. The if statement is then used to check if the value of exam score is greater than or equal to 60 or less than or equal to 100. The condition of the if statement is exam score greater than equal to 60 or operator exam score less than equal to 100, which means that if the value of exam score is greater than or equal to 60 or less than or equal to 100, the if statement will evaluate to true and the code inside the if statement block will be executed. Here the less than or equal to operator and the greater than or equal to operator is a comparison operator that is used to determine if a value is less than or equal to or greater than or equal to another value. We will discuss comparison operators in detail later. In this case, the value of exam score is 85, which is greater than 60, so the first part of the condition exam score greater than equal to 60 is true, and the if statement will evaluate to true, and the code inside the if statement block is executed. The code inside the if statement block is a call to the system .out.println method, which outputs the string the student has passed the exam to the console. So the output is, the student has passed the exam, as you can see. Now see another example. In this example, we will show how the OR operator is used to check if a number is even or divisible by 3. It checks if the remainder of dividing num by 2 is equal to 0, or the remainder of dividing num by 3 is equal to 0. So, for this, we create a class file named OR operator1. Now, we declare a double variable named num, and then variable num is assigned the value of 6. The if statement is then used to check if the value of num is even or divisible by 3. The condition of the if statement is num module 2 = 0 or operator num module 3 = 0, which means that if the remainder of dividing num by 2 is equal to 0 or the remainder of dividing num by 3 is equal to 0, the if statement will evaluate to true and the code inside the if statement block will be executed. In this case, the value of num is 6. The remainder of 6 module 2 is 0. So the first part of the condition, num module 2 = 0 is true, and the if statement will evaluate to true, and the code inside the if statement block is executed. The code inside the if statement block is a call to the system .out.println method, which outputs the string the number is even or divisible by 3 to the console. So the output is, the number is even or divisible by 3 inches, as you can see. It's important to note that 6 is also divisible by 3, so if the program was checking both conditions independently, the output would be the same, but the OR operator allows to check both conditions in a single line of code. Now come to the NOT operator. In Java, the NOT logical operator is a unary operator that is used to negate the value of a Boolean expression. It is commonly used to invert the truth value of a Boolean variable or expression. The NOT operator is represented by an exclamation mark and is placed before the Boolean expression that is to be negated. Here we can see an example. In this piece of code, the value of the variable flag is true. The NOT operator is used to negate the value of flag, so the if statement evaluates to false. Therefore, the code inside the if statement block will not be executed. The NOT logical operator has several advantages when used in Java, like simplifies control flow. The NOT operator can be used to invert the value of a Boolean variable or expression, which can simplify the control flow of a program. Improved readability. The NOT operator can make code more readable by clearly indicating when a value is being negated. Error handling. The NOT operator can be used to check for errors in a program and to handle them in a specific way. Reusable code. The NOT operator can be used to create reusable code by inverting the results of a function that returns a Boolean value. Versatile. The NOT operator can be used in many different situations, such as negating the results of logical comparisons, negating the value of a Boolean variable, or negating the result of a function that returns a Boolean value. Condition inversion. The NOT operator is useful when you need to invert the conditions of your code, making it more readable and maintainable. Brevity. The NOT operator can make the code more brief, as it allows to negate a condition in a single line rather than writing multiple lines of code. It's a quick way to invert the value of a Boolean variable or expression, making it a powerful tool for controlling the flow of a program. While the NOT logical operator has many advantages, there are also some disadvantages to consider when using it in Java, like complexity. The NOT operator can make code more complex to read and understand, especially when used in combination with other logical operators. Confusing. The NOT operator can be confusing for new programmers who are not familiar with its use and behavior. Error-prone. The NOT operator can lead to errors in a program if it is not used correctly or if it is applied to a variable or expression that is not a Boolean. Risk of logical errors. Using the NOT operator incorrectly can lead to logical errors, where the program behaves in unexpected ways or produces incorrect results. Therefore, it's important to understand the behavior of NOT operator and use it correctly. Reduced performance. When using the NOT operator to negate a large number of conditions, it can lead to a reduction in performance, especially when dealing with a large number of conditions. It's a unary operator, meaning it only operates on one operand, so it can only negate a single Boolean value or expression, and it cannot be used in conjunction with other logical operations. Now we come to some practice. For this again, open IntelliJ. This example shows how the NOT operator is used to check if a number is odd. It negates the result. So if the result is false, meaning the number is odd, the if statement is executed. Now, we create a class file named NOT-operator. Now, we declare an integer variable named num, and then variable num is assigned the value of 7 if statement is then used to check if the value of num is odd. The condition of the if statement is not num module 2 = 0, which means that if the remainder of dividing num by 2 is not equal to 0, the if statement will evaluate to true and the code inside the if statement block will be executed. In this case, the value of num is 7. The remainder of 7 module 2 is 1, so the expression num module 2 = 0 is false, and the not operator negates this value, making the if statement true. Therefore, the code inside the if statement block is executed. The code inside the if statement block is a call to the system.out.println method, which outputs the string the number is odd to the console. So the output is the number is odd, as you see. It's important to note that the not operator is used to negate the result of the Boolean expression num module 2 = 0, so it's checking if the number is not even. I hope you learned something useful in this lecture as well, and I will see you in the next one. In this lecture, we will discuss assignment operators in Java. We already discussed some of assignment operator in our previous arithmetic operators lecture. We were using it in arithmetic operators as a compound assignment operator. Now we discuss it in detail and also see the difference between the equal sign and equals to operator. In Java, assignment operators are used to assign a value to a variable. The basic assignment operator is the equal to, which assigns the value on the right side of the operator to the variable on the left side. For example, int x equals sign 5 semicolon. It assigns the value 5 to the variable x. In Java, these are the common assignment operators like equal is basic assignment operator, which assigns the value on the right side of the operator to the variable on the left side. Plus equal is addition assignment, which adds the value on the right side of the operator to the variable on the left side, and assigns the result to the variable. Minus equal is subtraction assignment, which subtracts the value on the right side of the operator from the variable on the left side, and assigns the result to the variable. Multiply equal is multiplication assignment, which multiplies the value on the right side of the operator by the variable on the left side, and assigns the result to the variable. Divide equal is division assignment, which divides the variable on the left side by the value on the right side of the operator, and assigns the result to the variable. Modulus equal is remainder assignment, which calculates the remainder when the variable on the left side is divided by the value on the right side of the operator, and assigns the result to the variable. There are several advantages of using assignment operators in Java, like conciseness. Assignment operators allow you to perform an operation and assignment in a single step, which can make your code more concise and easier to read. Improved readability. Using shorthand assignment operators can make your code more readable by clearly indicating the intent of the operation. For example, the statement x plus equals sign 10 is more clear than x equals x plus 10. Increased efficiency. Assignment operators can increase the efficiency of your code by reducing the number of operations that need to be performed. Chaining. Assignment operators can be chained together to perform multiple operations on the same variable in a single line of code, which can also improve readability and conciseness. Reduced errors. Assignment operators can reduce the number of errors in your code by making it less likely that you'll accidentally use the wrong operator or forget to update a variable. Avoiding unnecessary variables. In some cases, the assignment operator can be used to avoid the need for additional variables, making the code more efficient and easier to read. Now we come to some practice for this Open IntelliJ. Here we create a class file named assignOperator. Now we declare a int variable named x, and then variable x is assigned the value of 10 using equal assignment operator. The statement x plus equals sign 5 semicolon uses the shorthand addition assignment operator to add the value of 5 to the current value of the variable x, and then assigns the result to the variable x. In this case, the original value of x is 10, and the operation x plus equals sign 5 semicolon is equivalent to x equals x plus 5 semicolon. So the value of x after this operation will be 15. So, we already discussed these entire assignment operator in our previous arithmetic operators lecture. Now we discuss the difference between equal sign and equal to operator. In Java, the assignment operator equal is used to assign a value to a variable, while the equals to operator equal sign is used to compare the values of two variables or expressions. For example, we are declaring two integer variables, x and y, and initializing them with the value of 5 using equal operator. Then use if statement and the equals to operator compares the values of two variables x and y and returns a Boolean value of true or false. This operator compares the values of the variables x and y on the left and right side of the operator. If the values are equal, the code inside the if statement will execute and print both are equal to the console. So, in this case, both x and y are assigned the value of 5 before the comparison, so the condition x equals sign y is true, and the code inside the if statement will execute, resulting in both are equal being printed to the console. Here is the output. Now, see another example. We are declaring a Boolean variable z and initializing it with the value of true. Then, we use an if statement to check if the variable z is equal true. It's assigning the value true to the variable z, and the assignment operator returns the value that is assigned, which is Boolean true in this case. So, the if statement will always evaluate to true, and the code inside the if statement will be executed. This will lead to the program printing anything to the console. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will discuss comparison operators in Java. In previous lectures, we used these sum of comparison operators like greater than t, less than, and also used and discussed the difference between equal assignment operator and equal to comparison operator. I think you are familiar with some of these comparison operators. So, now we discuss all comparison operators in detail. In Java, comparison operators are used to compare two values and return a Boolean value true or false, indicating the result of the comparison. These are the most commonly used comparison operators in Java. Equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. They are used in many different ways in Java, such as conditional statements. Comparison operators are often used in conditional statements such as if-else, switch case to make decisions based on the comparison result. Looping. Comparison operators are used to control the flow of loops, such as while, do while, and for loops. Searching and sorting. Comparison operators are used to search and sort data in arrays, lists, and other data structures. Comparison of objects. Comparison operators can be used to compare the properties of two objects and determine their relative order. Checking the type of an object. Instance of operator is used to check if an object is an instance of a class or an interface. Debugging and testing. Comparison operators are also used in debugging and testing to check the state of the program and ensure that it is working as expected. Comparison operators in Java have several advantages, some of which are simplicity. Comparison operators are simple to use and understand. They allow for easy and direct comparison of values, making the code more readable and maintainable. Flexibility. Comparison operators can be used with different data types such as integers, floating point numbers, strings, and objects, which make them very versatile. Conditional control flow. Comparison operators can be used to control the flow of a program by making decisions based on the comparison result. This allows for more dynamic and flexible code. Searching and sorting. Comparison operators are used to search and sort data in arrays, lists, and other data structures. This makes it easy to find and organize data efficiently. While comparison operators in Java have many advantages, there are also some potential limitations like limited functionality. Comparison operators are limited to making simple comparisons between values and cannot perform more complex operations. This can make the code more verbose and harder to read. Inconsistencies. Comparison operators may not always behave consistently across different data types. For example, comparing a string and a numeric value may not always produce the expected result. Overuse. Overusing comparison operators can make the code complex, hard to read and maintain. It is important to use them in moderation and to consider other options when appropriate. Inability to compare certain data types. Some data types, such as nan not a number or certain types of floating point numbers, may not be comparable in certain cases. Inability to compare certain properties of an object. When comparing two objects, we can only compare the properties that are exposed by the object. If the object doesn't expose certain properties, then we can't compare them. Not suitable for certain tasks. Comparison operators are not always the best choice for certain tasks. For example, if the task requires a more complex comparison, it may be better to use a different method. Now we come to some practice. For this open IntelliJ, here we create a class file named compoperator. Now, we declares three integer variables, x, y, and z, and assigns them initial values. The variable x is assigned the value of 5, variable y is assigned the value of 3, and variable z is assigned the value of 4. Then, the if statement checks if the condition x greater than y and operator x greater than z is true. This means that x should be greater than both y and z for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true, otherwise, the result is false. In this case, the first condition is x greater than y, and the second condition is x greater than z. If the condition x greater than y and operator x greater than z is true, meaning that x is indeed greater than both y and z, then the code inside the if statement will execute, and it will print x is the largest number. Here is the output. Now see another example. In this example, we use if statement that only evaluate as true if score is greater than or equal to 80 and smaller than or equal to 95. If score is greater than 95 or smaller than 80, the inside of the if statement won't execute. For this, we declare a variable score as an integer and assign it an initial value of 85, and another variable grade as a string. Then, the if statement checks if the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true. This means that score should be greater than or equal to 80 and less than or equal to 95 for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true. Otherwise, the result is false. In this case, the first condition is score greater than or equal to 80, and the second condition is score less than or equal to 95. If the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true, meaning that score is between 80 and 95, inclusive, then the code inside the if statement will execute, and it will assign it to the variable grade. And the print method outputs the grade variable result on the screen. Here you can see the output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Ternary operator with exercises. In this lecture, we will discuss ternary operator in Java. In previous lectures, we discussed if-then conditions and saw some of their examples. Now, we are going to look into a concept known as the ternary operator. The ternary operator in Java is a shorthand way of writing an if-else statement. An operator for ternary being the only operator in Java at the current with 3 operands, Java refers to it as the conditional operator with 3 operands. It has the syntax that is, condition question mark expression 1 colon expression 2. If the condition is true, the operator returns the value of expression 1. Otherwise, it returns the value of expression 2. There are several advantages of using the ternary operator in Java, like conciseness. The ternary operator can be used as a shorthand way of writing an if-else statement, making the code shorter and more concise. Readability. The ternary operator can make the code more readable, as it can be used to express the intent of the code in a more straightforward way. Efficiency. The ternary operator can improve the efficiency of the code by performing a single operation based on a condition, rather than executing multiple lines of code in an if-else statement. Nesting. Ternary operator can be nested in other ternary operator or inside a loop or a function which is not possible with if-else statements. Flexibility. The ternary operator can be used in a variety of situations, such as setting a variable's value, returning a value from a function, or as part of a larger expression. Readily understandable. As the ternary operator uses the conditional operator which is already familiar for most of the developers, it's easy to understand the intent of the code. While the ternary operator can have many advantages, there are also some potential limitations to consider, like complexity. The ternary operator can make the code more complex, especially if it is nested or used in complex expressions. This can make the code harder to understand and maintain. Limited functionality. The ternary operator can only be used for simple conditions and operations. For more complex logic, multiple ternary operators or an if-else statement may be needed. Overuse. Overuse of the ternary operator can lead to code that is hard to read, understand, and maintain. It is recommended to use it sparingly and only when it makes the code more readable. Error-prone. The ternary operator can be error-prone if not used correctly. It can be easy to accidentally reverse the true and false expressions or to forget to include the colon. Inefficient. The ternary operator can be less efficient than an if-else statement in certain situations, such as when the conditions being evaluated are expensive computations. Now we come to some practice. For this, open IntelliJ. Here we create a class file named ternary operator. Now, we declare a variable age with a value of 20. It then declares a variable status and assigns it a value using a ternary operator. The expression parenthesis age less than 18 is evaluated first. If it is true, then the value under age is assigned to the status variable. If it is false, then the value senior is assigned to the status variable. The ternary operator in this case is parenthesis age less than 18 question marks under age colon senior. This operator checks if age is less than 18. If it is true, it returns under age otherwise senior. Finally, the code prints the value of the status variable to the console using the system.out.print method. Here is the output. Now see another example. We declares a variable marks with a value of 50. It then declares a variable result and assigns it a value using a ternary operator. The ternary operator is a shorthand way of writing an if-else statement. The expression parenthesis marks greater than 40 is evaluated first. If it is true, then the value pass is assigned to the result variable. If it is false, then the value fail is assigned to the result variable. The ternary operator in this case is parenthesis marks greater than 40 question mark pass colon fail. This operator checks if marks are greater than 40. If it is true, it returns pass otherwise fail. Finally, the code prints a string U and the value of the result variable followed by the exam, using the system.out.print method. So the final output is, you pass the exam. See another example, declares a variable number with a value of 24. It then declares a variable result and assigns it a value using a ternary operator. The expression parenthesis number greater than 0 is evaluated first. If it is true, then the value positive number is assigned to the result variable. If it is false, then the value negative number is assigned to the result variable. The ternary operator in this case is parenthesis number greater than 0 question mark positive number colon negative number. This operator checks if number is greater than 0. If it is true, it returns positive number otherwise negative number. Finally, the code prints the value of the result variable to the console using the system.out.print method. So the final output is positive number. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Keywords and expressions. In this lecture, we will discuss keywords and expressions in Java. We will improve on expressions a little bit and discuss more about keywords, which, to some level, we have already explored in the previous. Starting with the keywords. Now, there are 51 reserved keywords in Java that are utilized as keywords in your programs, as you can see from these reserved keywords here. As you can see from the following list of Java keywords, each of the 51 reserved terms in the Java programming language has a specific meaning, like int, double, float, and so on. Don't worry, none of these are necessary to memorize since we will cover each and every one of them in the course. Java actually uses the terminology of character sequences to describe these keywords because, as of Java 9, the underscore by itself is a keyword. A character sequence refers to a specific sequence of characters that have a specific meaning in the Java programming language. These character sequences are reserved by the language and cannot be used as variable, method, or class names. For example, the keyword class is a character sequence that is reserved in Java. It cannot be used as the name of a variable, method, or class, as it has a specific meaning in the language related to defining classes. In addition to reserved keywords, in JDK 17, Java has 16 contextual keywords, which are only keywords in special situations. Let's open IntelliJ and talk about keywords a bit further. For the next series of lectures, I'll create a new project called Expressions and Statements. We will walk through the process of creating a new project one more time, and after that, the videos will just specify when a new project has been created. At the Welcome to IntelliJ idea screen, we select New Projects. For the reasons stated previously, we will name it Expressions and Statements in camel case. We will select Java as the language and accept all the other defaults. Finally, we will click the Create button, and we are in a new project. In this project, we will create a new class called Main by clicking on the src folder, selecting a new class, and then giving it the name Keywords. Now we have the code for the main class and the editor window. So we will also have the main method, as we have done before. The public static void, main, opening parentheses, string, opening and closing square brackets, args, closing parentheses, and opening curly brace and closing the curly brace. And you can see from this that IntelliJ is actually highlighting keywords in blue to show us that they actually are a keyword. Anything in blue that's in the IntelliJ editor is confirming to you that this is a reserved word. For example, we create a variable name using any of the keywords like == 2.0 semicolon. The IntelliJ is definitely trying to tell us that something is wrong with the red underscores, and if we hover over one of these red underscores, IntelliJ sends messages by the expected identifier. And that's because, as far as IntelliJ is concerned, second double is a reserved word, and it's actually a data type. We could not use it as the variable name. If we change this from double to =1, the error is removed because =1 is not a reserved keyword. So simply make sure you are not using a reserved keyword, and you can refer back to that list shown before. So if you get into word errors, just make sure that you're not using a reserved keyword. There are some words that are officially keywords but are specified. These two categories are true, false, and null. And although they are officially keywords, instead of literal values, we cannot use true or false or null to name any of our variables or other elements. Coding is related to writing documents. It is made up of unique hierarchical components that work as a whole. These are expression. So, an expression is a combination of one or more literals, variables, operators, and method calls that can be evaluated to a single value. Expressions can be used to perform calculations, assign values to variables, and control the flow of a program. In simple words, an expression, compute to a single value. Then statement. So, a statement is a single instruction that tells the program to perform a specific action. In simple words, statements are stand-alone units of work. And code blocks. A code block is a group of statements enclosed in curly braces. Code blocks are used to define the scope of variables and to group statements together. Let's start with expression. We already discussed a little bit about expression in our previous lectures. Here we see some of its example. Let's set some code to our main method. But first we will delete that first variable we created, since we don't need it for this next example, and now let's add some more interesting code. So, write $miles equals opening parentheses 70 multiplies 0.621371 closing parentheses semicolon. Here we are creating an expression to convert kilometers into miles using the conversion formula. 1 kilometer is equal to 0.621371 miles. In this code, we want to figure out what 70 kilometers are converted to miles. This entire line of code is a valid statement. For that line, the actual expression is this component of the entire line. The data type does not form part of an expression, but everything else on the line typically forms or is part of the expression. So the expression component can include variables, values, and operators. All of those are used in this case. We have got variable miles, and we have got values like 70, and of course operators, which in this case include the equals and multiplication symbols. So that's an expression. By including the data type and ending with a semicolon, we're now creating a valid Java statement. Let's look at some more examples of expressions. So, write a program that checks if the value of x is greater than 3. If the condition is true, increment the value of x by 10. So, we declares a variable called x and assigns it the value of 5. Then use if statement. It checks the condition inside the parentheses, which is x greater than 3. The expression inside the parentheses is x greater than 3, which is a relational operator that checks if the value of x is greater than 3. If the condition is true, the code inside the curly braces will be executed. In this case, it is a single line of code that increments the value of x by 10. The new value of x will be 15. You can see that x equals 5 is a valid expression, but the int data type and semicolon are not part of it. But by adding these, it becomes a statement. Same as the x greater than 3 is a valid expression, and if parentheses are statements. And in the calculation in the if statement code block, there are actually two expressions. First, the calculation by itself, 10 plus x, is one expression. Second, the entire line excluding the semicolon is an expression too. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Whitespace and indentation. In this lecture, we will discuss whitespace and indentation or code organization. Indentation and whitespace, what they are, and the reasons Java programs need them. In order to do this, I've created a new project in IntelliJ called Code Organization with the proper indenting and spacing, as well as a new class called whitespace with capital W. The public static void main function has also been introduced. Let's start with simply declare a variable simply within the main method. That is int number equals 100 semicolons. And if you remember from the previous lecture, when we spoke about expressions, you know that the expression is number variable equals 100. So what does the statement mean? Well, the statement is the entire line. So the entire line that reads number variable equals 100 semicolon. This is the statement within Java, so that is actually the complete line. In this case, a valid Java statement was produced by beginning our expression with the data type and ending it with a semicolon. Thus, Java statements may include assignment expressions like the one shown here, where we are giving the number variable the value 100. Next, system.out.print, opening parentheses, and double quotes and write a siring. This is the Nixware company, and its services include consulting. A semicolon after closing parentheses. Although a semicolon is often required to end a Java line and turn it into a statement, there are certain exceptions to this rule, which I will discuss further as we go through this course. Additionally, bear in mind that those sentences don't have to fit on a single line. A print statement could be started, and a plus sign could be added. And there's even more in the statement, it's said at another point. Therefore, there is no semicolon in the first half of system.out.println. This implies that, similarly to what we observed in J shell, the statement hasn't really come to an end. Here in IntelliJ, we may go on to the next line. Additionally, we may continue to break up the statement into separate lines and add more after the last semicolon. As a result, it essentially creates the line that you should be able to detect by adding all of this together. Java interprets a statement as a single line of code regardless of whether its components are spread over numerous lines or just one. So you'll see it written in Java code, and it's usually a good idea to do that to divide out your statement sections so they make more sense and are easier to understand. As long as you are not attempting to break the lines, Java doesn't care whether it's on one line or many. Therefore, Java will have trouble if you attempt to insert a semicolon there since it will now complain that there isn't any parenthesis there. And it's expecting parentheses because we placed a semicolon there, which, to put it another way, serves as a terminator to end the line. We will remove the semicolon once again and reintroduce the plus symbol. And if we execute it, we find the solution, indicating that everything is in order. Multiple statements may be included on a single line in IntelliJ as well, as you have previously seen with J shell. Let's have two statements on one line. Variable number 2 equals 200 semicolon. System.out.println opens parentheses, double quotes hello world, closes parentheses with a semicolon. So, as far as Java is concerned, that it's still valid because it's fair the semicolon between the statements that is a separator. Although this is entirely acceptable in Java, we advise against doing it generally since it may confuse code readers. They could miss certain things, and it does require a little extra work to determine if everything falls under the same category or not. In general, formatting your code is one technique to help with this since you want to make it extremely clear what your code is doing. Code may be made more readable by placing one statement per line, or by dividing a lengthy statement over multiple lines. This also raises the issue of whitespace. So, what is whitespace? In Java, whitespace refers to any characters that are used to separate words or tokens in the source code of a program. Examples of whitespace characters include spaces horizontal or vertical, tabs, and new line characters. These characters are used to format and structure the code, making it more readable for humans, but they are ignored by the Java compiler. If we talk about horizontal and vertical whitespace, in Java, horizontal whitespace refers to the spaces or characters that are used to separate words or tokens horizontally in the source code. Examples of horizontal whitespace include spaces and tabs. They are used to align and format the code, making it more readable. Vertical white space, on the other hand, refers to the spaces or characters that are used to separate lines of code vertically in the source code. Examples of vertical white space include newline characters and line breaks. They are used to separate lines of code and create new lines in the source code. Let's create some white space, then. Java doesn't care if we have a single space or many spaces. It'll just disregard this empty space. Even more harsh measures might be taken with something like this. You can see that it is obvious that this is not the way I would recommend you to code, and that it limits the statement's ability to be understood. However, if we execute that, Java is totally comfortable with that syntax, since what it is doing is internally looking at these white space and basically erasing them. And inside, it will be precisely the same as that there in that regard. You could thus generally do anything you want there given the available area. Java will happily operate despite the white space. IntelliJ has a little feature to reformat code, so I'm going to highlight that line of code. Go up to the code menu bar item, and find the reformat code and select it. Now you can say that IntelliJ did reformat that code for us. Observe that the system statement is on a different line, and that line one of number 2 variable equals 200. The equals symbol was surrounded by extra spaces. So you can utilize intellect to assist you use white space in code in a way that complies with standards. You'll most likely use the IntelliJ function pretty often. So let's go on to discussing the idea of indentation, which may help improve the readability of your code. I am thus considering the worst-case scenario. If we went back and modified this code, we could do it by highlighting the code and repeatedly pressing the Shift-Tab key combination until we had eliminated all leading indentation. If you look at that situation there, I believe it is a lot more difficult to interpret in order to try and determine where things are. If you wish to properly indent certain areas of the code, you may use the Tab key, or you can just select the full piece of code and utilize the code menu's Reformat Code option. Furthermore, this code is much easier to comprehend. As we begin code blocks at various levels in our code, IntelliJ will automatically fall into default for us. Therefore, the idea of indenting is to make it simple for us to understand the logical flow. I hope you learned something useful in this lecture as well, and I will see you in the next one. In this lecture, we will discuss if-then-else control statement. In the conditional statement, if-then lecture, we discussed the if-then conditional statements and saw some of their examples. In this lecture, we will see more about if-then conditional statements and add another term, else. So, now it will be if-then-else conditional statements and also see the one step higher that is latter if-else conditional statement. So, the if-then and if-then-else control statements in Java are used to make decisions in a program, but they are slightly different in how they handle the conditions being evaluated. The if statement is used when you want to execute a certain block of code only when a specific condition is true. The basic syntax for an if-then statement is begin with if keyword, open parenthesis, then condition, closing parenthesis, start curly braces to start the body of if-then condition. Here write any statements to be executed if condition is true, then closing curly brace. The if-else statement is used when you want to execute a certain block of code if a condition is true, and a different block of code if the condition is false. The basic syntax for an if-else statement is begin with if keyword, open parenthesis, then condition, closing parenthesis, start curly braces, to start the body of if-then condition. Here write any statements to be executed if condition is true. Then closing curly brace, then use else keyword, start curly braces, to start the body of if-then condition. Here write any statements to be executed if condition is false. Then closing curly brace. The main difference between if-then and if-then-else control statement is that if-then statement only execute the code block when the condition is true and it doesn't have any fallback code to execute. Whereas if-then-else statement provides a fallback code to execute when the condition is false. There are several advantages of using the if-else control statement in Java, like conditional execution. The if-else statement allows you to execute certain blocks of code only when certain conditions are met. This enables you to write more flexible and dynamic programs that can adapt to different inputs or situations. Improved readability. By using if-else statements, you can make your code more organized and easy to understand. The clear distinction between the code to be executed when a condition is true and when it is false makes it easier for other developers to read and understand your code. More control over program flow. With if-else statements, you can have more control over the flow of your program. For example, you can use multiple if-else statements to create complex decision-making structures that can handle a wide range of inputs and situations. Better error handling. The if-else statement can be used to handle errors or exceptions that might occur in your code. By using if-else statement to check for specific conditions, you can handle errors or exceptions in a more controlled and efficient way. Fallback code. The else part of the if-else statement provides a fallback code to execute when the condition is false. This allows you to handle situations that aren't covered by the original condition and make your code more robust. While the if-else control statement in Java has many advantages, there are also some potential limitations to consider, like complexity. If you use too many if-else statements in your code, it can make your program more complex and difficult to understand. This can lead to bugs and make it harder to maintain your code over time. Performance. Depending on the complexity of the conditions being evaluated, using if-else statements can have an impact on the performance of your program. This can be especially problematic if your program needs to process large amounts of data or make many decisions in a short period of time. Code duplication. If you use multiple if-else statements to handle similar conditions, it can lead to code duplication. This can make your code more difficult to maintain, and it can also increase the likelihood of bugs. Now we come to some practice. For this open IntelliJ, here we create a class file named IMf&x. Now see an example. In this example, we check if a number is positive or negative. For this, first, we create variable num and initialized with the value of -5. Then, an if-else control statement is used to check if the value of num is greater than 0. The condition being evaluated is num greater than 0. If this condition is true, it means the value stored in num is greater than 0 and hence it is positive. Hence, the code block inside the first set of curly braces is executed. The line system .out.println parenthesis double quote the number is positive semicolon is executed. If this condition is false, it means the value stored in num is less than or equal to 0 and hence it is negative. Hence, the code block inside the second set of curly braces is executed. The line system .out.println parenthesis double quote the number is negative semicolon is executed. In this case, since the value of num is -5, which is less than 0, the second block of code will be executed, and the message the number is negative will be printed to the console. Here is the output. Now see another example. For this, we create another class file named IMf&x1. So, in this example, we will check if a number is within a 10 to 100 range. For this, first, we create a variable num and initialized with the value of 10. Then, an if-else control statement is used to check if the value of num is greater than or equal to 1 and less than or equal to 10. The condition being evaluated is num greater than equals to 1 and operator, num less than equals to 10. If this condition is true, it means the value stored in num is within the range of 1 to 10 and hence the code block inside the first set of curly braces is executed. The line system .out.println parenthesis double quote the number is within the range semicolon is executed. If this condition is false, it means the value stored in num is not within the range of 1 to 10 and hence the code block inside the second set of curly braces is executed. The line system .out.println parenthesis double quote the number is not within the range semicolon is executed. In this case, since the value of num is 10 which is within the range of 1 to 10, the first block of code will be executed and the message, the number is within the range, will be printed to the console. Now see another example. For this, we create another class file named IMf&x2. So, in this example, we will check if a letter is a vowel or consonant. For this, first, we create a variable letter and initialized with the value of a. Then, an if-else control statement is used to check if the value of letter is a or e or I or o or u. The condition being evaluated is letter equals to operator A or operator letter equals to operator E or operator letter equals to operator I or operator letter equals to operator O or operator letter equals to operator U. If this condition is true, it means the value stored in letter is one of the vowels A, E, I, O, U, and hence the code block inside the first set of curly braces is executed. The line system .out.print in parenthesis double quote the letter is a vowel semicolon is executed. If this condition is false, it means the value stored in letter is not one of the vowels A, E, I, O, U, and hence the code block inside the second set of curly braces is executed. The line system .out.print in parenthesis double quote the letter is a consonant semicolon is executed. In this case, since the value of letter is a which is a vowel, the first block of code will be executed, and the message the letter is a vowel will be printed to the console. Here is output. Now, we will discuss ladder if-then-else conditional statement. A ladder if-else statement in Java is a type of decision-making structure that allows you to check multiple conditions in sequence. It is called a ladder because the conditions are evaluated one after the other, like a ladder. Here you can see the basic syntax of a ladder if-else statement. Each else-if block is evaluated in sequence, starting from the top. If a condition is found to be true, the code block associated with that condition is executed and the remaining conditions are not evaluated. If none of the conditions are true, the code block in the final else statement is executed. The main difference between a regular if-then-else statement and a ladder if-then-else statement in Java is the number of conditions being evaluated. A regular if-else statement is used to check a single condition and execute a specific code block based on whether that condition is true or false. A ladder if-else statement, on the other hand, is used to check multiple conditions in sequence. It allows you to evaluate multiple conditions one after the other and execute a specific code block based on the first condition that is found to be true. If none of the conditions are true, it will execute the code block inside the last else block. So, a regular if-else statement is used to check a single condition and takes two code blocks to execute, one for true and one for false. A ladder if-else statement is used to check multiple conditions and takes multiple code blocks to execute, one for each condition. It's also important to note that if any of the conditions inside the ladder if-else statement is true, the rest of the conditions will not be evaluated. Advantages of using ladder if-else statement in Java like conditional execution. A ladder if-else statement allows you to check multiple conditions in sequence and execute a specific code block based on the first condition that is found to be true. This enables you to write more flexible and dynamic programs that can adapt to different inputs or situations. Improved readability. By using ladder if-else statements, you can make your code more organized and easy to understand. The clear distinction between the code to be executed for each condition makes it easier for other developers to read and understand your code. More control over program flow. With ladder if-else statements, you can have more control over the flow of your program. For example, you can use ladder if-else statements to create complex decision-making structures that can handle a wide range of inputs and situations. Better error handling. The ladder if-else statement can be used to handle errors or exceptions that might occur in your code. By using ladder if-else statement to check for specific conditions, you can handle errors or exceptions in a more controlled and efficient way. Now we come to some practice. For this Open IntelliJ, here we create a class file named ladderifles. Now see an example that we will assign grades according to the score obtained. For this, we create a variable score and initialized with the value of 65. Then, a ladder if-else statement is used to check multiple conditions to determine the grade of the student. The conditions being evaluated are, if score greater than equals to 90, else if score greater than equals to 80, else if score greater than equals to 70, else if score greater than equals to 60. If any of the above conditions are true, the corresponding code block inside the curly braces is executed and the appropriate message is printed to the console. If none of the conditions are true, the code block inside the final else statement is executed. The line system .out.println parenthesis grade, F semicolon is executed. In this case, since the value of score is 65, which is greater than or equal to 60, but less than 70, The code block inside the else if score greater than equals to 60 is executed, and the output is grade D. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will discuss nested if-then-else concept. In the previous few lectures we discussed about if-then-else and ladder if-then-else conditional statements and also saw some of its examples. Now we will see the concept of nested if-then-else and ladder if-then-else. The term nested refers to the placement of one thing inside another. In the context of programming, it refers to the placement of one control flow statement, such as an if-then-else statement, within another control flow statement. In other words, one control flow statement is nested inside of another. When an if statement is nested inside another if statement, it is called a nested if statement. The inner if statement is executed only if the condition of the outer if statement is true. So, in Java, you can use if-then-else statements inside of other if-then-else statements to create a nested structure. This is known as a nested if-then-else. The inner if-then-else statement is executed only if the condition of the outer if-then-else statement is true. Here you can see the syntax. Here, the outer if statement has a condition 1, which is evaluated first. If condition 1 is true, then the code inside the first set of curly braces is executed. Inside of that code block, there is another if statement with a condition 2. This inner if statement is nested within the outer if statement. If condition 2 is true, then the code inside the second set of curly braces is executed. However, if condition 2 is false, the code inside the else block is executed. If the condition 1 is false, then the code inside the outer else block is executed. However, if condition 2 is false, the code inside the else block is executed. Now see an example for this. Open IntelliJ. Here we create a class file named nestedifs and create main method. Now see an example. So, in this example, we create a program to determine whether a number is both positive and even. For this, first we create a variable number is initialized with a value of 5. Then, we use a nested if-then-else statement to check the value of number in that way. Use an outer if statement to check if number is greater than 0. If it is, the code inside the first set of curly braces is executed. Inside of that code block, there we write an inner if statement that checks if number is even by using the modulus operator. The modulus operator returns the remainder when one number is divided by another, so if number %2 is 0, it means the number is even. If this inner if statement's condition is true, the code inside the second set of curly braces is executed, which prints out a message saying the number is positive and even. If the inner if statement's condition is false, the code inside the inner else block is executed, which prints out a message saying the number is positive, but not even. If the outer if statement's condition is false, the code inside the outer else block is executed, which prints out a message saying the number is not positive. In our example, since number is 5, the if statement, number greater than 0, will be true. The inner if statement number modulus 2 equals to operator 0 will be false, and the output is 5 is positive, but not even. Here is the output. There are several advantages to using nested if-then-else statements in Java, like flexibility. Nested if-then-else statements allow you to create complex control flow in your program by combining multiple conditions. This can be useful when you need to check multiple conditions before making a decision. Reusability. Nested if-then-else statements can be used to create reusable code blocks that can be used in multiple places in your program. This can save time and make it easier to maintain your code. More efficient. Using nested if-then-else statements can be more efficient than using multiple independent if-then-else statements. This is because nested if-then-else statements can check multiple conditions in a single statement, whereas multiple independent if-then-else statements would require multiple conditions to be checked. Better readability. Nested if-then-else statements can make the code more readable by providing a clear structure for the control flow of the program. By using indentation and comments, it's easier to understand the purpose and flow of the code. While nested if-then-else statements can be useful in certain situations, they also have some limitations in Java, like complexity. Nested if-then-else statements can make your code more complex and harder to read, understand, and maintain. As the number of conditions and nested levels increase, it can be difficult to keep track of what is happening in the code. Error-prone, as the code becomes more complex, it can be easier to introduce errors, such as logical errors or syntax errors, which can be difficult to detect and fix. Slow performance. Nested if-then-else statements can be slower than other control flow structures, especially when the number of conditions and nested levels increase. Unnecessary nesting. It's possible that the use of nested if-then-else statements is unnecessary, and another control flow structure or function call might be more appropriate and efficient. Harder to debug. Nested if-then-else statements can make it more difficult to debug your code, especially when there are multiple levels of nesting and multiple conditions that need to be checked. Now see an example for this. Open IntelliJ. Here we create a class file named nestedifels1 and create main method. Now see an example. So, in this example, we create a program that checks if a customer has made a purchase, and the store wants to offer a discount based on the purchase amount and membership status. For this, first we create two variables, purchase amount and isMember. The variable purchase amount is of type int and is assigned a value of 120. It represents the amount of money the customer has spent on the purchase. The variable isMember is of type string and is assigned a value of yes. It represents the membership status of the customer. Then use outer if statement checks if the purchase amount is greater than 100. If it is true, the code inside the first set of curly braces is executed. Inside of that code block, there is an inner if statement that checks if the customer is a member or not. Condition is isMember equals to yes. If the customer is a member, the inner if statement prints, you are eligible for a 10% discount, and if the customer is not a member, the inner else statement prints, you are eligible for a 5% discount. However, if the outer if statement's condition is false, the code inside the outer else block is executed, which prints, you are not eligible for a discount. In our example, the purchase amount is 120 and the customer is a member, so the output is, you are eligible for a 10% discount. Here you can see the output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to methods with exercises. In this lecture, we will discuss methods in Java. In the previous few lectures, we discussed about if-then, if-then-else, and ladder if-then-else conditional statements, and also saw some of its examples. Now we will see the concept of methods. We already use a method every time we write our code, and that is the main method. So, first, we will discuss what a method is, and then see our main method parts. A method in Java is a block of code that performs a specific task and can be invoked multiple times from other parts of the program. Methods can take parameters as input and return a value or not. They are defined within a class and typically have a name, return type, and a list of parameters. The syntax for defining a method in Java is modifiers return type method name parentheses parameter list open curly braces, method body and close curly brace. First is, modifiers are keywords such as public or private that control the access level of the method. They determine who can call or use the method. Return type is the data type of the value that the method returns. For example, if the method is returning an integer, the return type would be int. If the method does not return any value, the return type is void. Method name is the name of the method. It should be a descriptive name that explains what the method does. Parameter list is a list of input variables, also known as parameters that the method takes as input. The curly braces are where the actual code of the method is written. This is also known as the method body. Inside the method body, we can perform any kind of operation like calculation, I/O operation, etc. In simple words, this is a template of a method in Java. It has a name, it can take some inputs, and it can return some output. The code inside the curly braces is the actual code which the method will execute when it is called. So, here you can see the main method that is written as public static void main parentheses string square brackets args, then open curly braces and close curly brace. Here, public means that the method can be called from anywhere in the program. Static means that the method belongs to the class and not an individual object of the class. We will discuss method types in the coming lectures. Void means that the method does not return any value. Main is the name of the method. String square brackets args is an array of strings that can be passed to the main method when the program is run. Remember that there are a few standard conventions to follow when creating a method in Java, like method names should be written in camel case, with the first letter of the first word being lowercase and the first letter of any subsequent words being uppercase. Method names should be descriptive and indicate what the method does. For example, a method that calculates the area of a circle should be named calculateCircleArea rather than area. Method names should not include any special characters or spaces. Method parameters should be written in camel case, with the first letter of the first word being lowercase and the first letter of any subsequent words being uppercase. Method parameters should have descriptive names and be of the correct data type. The method's return type should be specified before its name, and the method name should be followed by parentheses, even if there are no parameters. The method body should be indented one level from the method declaration and should be enclosed in curly braces. Now, let's see some advantages of this method. So, there are several advantages to using methods in Java, like code reusability. Methods can be defined once and reused multiple times throughout a program, reducing the amount of code that needs to be written and making the code more organized and efficient. Modularity. Methods allow for the separation of concerns, meaning that different parts of the program can be written and tested independently of each other. Readability. Methods can make the code more readable by breaking it down into smaller, more manageable chunks. Debugging. Debugging is easier because when a bug is found in a method, it can be isolated and fixed without affecting the rest of the program. Flexibility. Methods can be overridden in subclasses, which allows for the implementation of polymorphism and the ability to change the behavior of a program at runtime. Code maintenance. Methods make it easier to maintain and update the code as it allows making changes to a specific part of the code without affecting other parts. In summary, methods in Java provide a way to organize and structure the code, making it more readable, maintainable, and reusable. It also helps to hide the complexity of the code and allows making changes to a specific part of the code without affecting other parts. There are a few potential disadvantages of using methods in Java, like increased memory usage. Each time a method is called, it creates a new stack frame on the call stack, which can increase the amount of memory used by the program. Increased processing time. Calling a method involves a certain amount of overhead, such as pushing arguments onto the stack and jumping to the method's location in memory. This can lead to increased processing time, particularly for methods that are called frequently or are computationally intensive. Overuse of methods. Overuse of methods can lead to a large number of small methods, which can make the code more difficult to understand and maintain. Nested methods calls. When methods call other methods and those call another, this can make the code more complex and harder to understand, especially when dealing with multiple return points. Complexity. When you have a lot of methods, it can be difficult to keep track of all of them and understand how they work together. Method calling can make the program slower, since the JVM need to push the current state of the program and jump to the new method. This will add some overhead in the program. This can make the program slower, especially when dealing with multiple nested calls. Now see an example for this, Open IntelliJ. Here we create a class file named myMethodClass and create main method. Remember that the main method is crucial for the execution of a Java program. It serves as the entry point of the program, and it tells the JVM where to start executing code, and it's the place where you put the code that you want to execute when the program runs. The purpose of creating the main method here is that we create a custom method after the main method and then call our custom method inside the main method, because as you saw earlier, the main method is the entry point. In general, a custom method cannot run without the main method in a standalone Java application. Now see our custom method. In Java, a custom method is a user-defined method that performs a specific task or set of tasks. Custom methods are also known as user-defined methods or user-created methods. Now, start creating it. Public static void print string parentheses open and close curly braces. Inside the body of method write print statement that is system.out.println parentheses double quote hello world semicolon. This is a custom method in Java named printString that has the public static void modifiers, indicating that it can be accessed from anywhere within the program. It belongs to the class, not an individual object of the class, and does not return any value. The method has no parameters as indicated by the empty parentheses. The method body contains a single statement system .out.println parentheses double quote hello world semicolon, which will print the string hello world to the console when the method is called. Now we call this method in the main method. For calling, we just write its name, and then parentheses and last write semicolon. Now run it. Here you can see the output. It's a simple way to create and run a method in Java. Now, we see various types of methods. In Java, there are several types of methods, but here we will see only 2 types based on parameters. Other types will be covered in future lectures. So, there are 2 types of methods based on whether they take parameters or not. So, that is non-parametric methods and parametric methods. Non-parametric methods. These methods do not take any parameters as input. They are defined with empty parentheses in the method signature. The preceding example is of a non-parametric method, where in the method parentheses there are no parameters defined. Next is parametric methods. These methods take 1 or more parameters as input, which are passed to the method when it is called. The parameters are defined in the method signature within parentheses, and the data type of each parameter is specified. Now see its example. For this, we create a class file named paramethod class and create main method. When we previously had empty parentheses after the method name, we now have method parameters in the declaration. There are no limits on the number of parameters, and the basic syntax is to declare first the data type followed by the parameter name. Multiple parameter declarations are separated by commas. This method still returns no data from the method parameters, and arguments are terms that are often used interchangeably by developers. But technically, a parameter is the definition in the method declaration, and the argument will be the value that's passed to the method when we call it. Now, the method starts with the public static void modifiers. Next, the method name myMethod is defined, followed by the parameter list in parentheses. Now create the first parameter that is an integer with named number, and the second parameter is a string named name. And inside the method body, there we create 2 print statements that print the value of the parameters passed to the method. The first statement will print, first parameter value is, followed by the value of the number parameter, and the second statement will print second parameter value is, followed by the value of the name parameter. Now I call it in the main method. Remember that, when calling a parametric method in Java, the values passed to the method are called arguments. The arguments are passed in the order they are declared in the method signature, and they are used to initialize the parameters of the method. Here, we have a method named myMethod that takes 2 parameters, an integer and a string. You can call the method and pass in 2 arguments like this. myMethod parentheses 1 comma double quote nixware semicolon. Here, the first argument passed is the integer value 1, which initializes the integer parameter of the method, and the second argument passed is the string nixware, which initializes the string parameter of the method. When the method is called, the values of the arguments are passed to the corresponding parameters of the method, and the method can use these values to perform its intended actions. Like here, that we print argument values. Now run it. Here you can see the output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Return statement with exercises. In this lecture, we will discuss how to use return statement in a method. In the previous lecture, we discussed the introduction of methods and also discussed 2 types of methods, parametric and non-parametric methods. Now we will see some of its examples and then see how a method returns its value. For this, open IntelliJ. Now, we create a class file named method_x and inside the class create a main method. Now we see an example that creates a method that takes in 2 numbers as parameters and some of those numbers and print them using print method. For this, we create a method using statement public static void and method named numbers that takes in 2 integer parameters, num1 and num2. So, the method addNumbers is a public static method in Java, which means it can be called from anywhere within the program without creating an instance of the class it belongs to. This method takes two integer parameters, num1 and num2. Inside the method, an integer variable sum is declared and assigned the value of the sum of num1 and num2 using the plus operator. Then, using the system.out.println method, the string sum is printed along with the value of the sum variable. Now call this method in the main method. For this, write method name and parenthesis, then given values. First we pass value 23 and second is 30 and last write semicolon. Remember that here both parameters are integer type. Now run it. Here you can see the output. Now see another example. For this, we create another class file named methodexamples1 and inside the class create a main method. Now, we write a program that creates a method to calculate the area of a circle. For this, we write public static method with name calculate area that takes in two double type parameters, radius and pi. Public means that the method can be accessed by any code outside the class it belongs to. Static means that the method can be called without creating an instance of the class it belongs to. Inside the method body, a variable result is declared and assigned the value of pi multiplied by the square of the radius using the multiply operator. Then, the system.out.println method is used to print a string area of circle is concatenated with the value of the result variable. Now call this method in the main method. For this, write method name and parenthesis, then given values. First we pass the radius value that is 10 and second is the pi value that is 3.14 and last write semicolon. Remember that here both parameters are double type and we must pass this value according to its order. Now run it. Here you can see the output. Now we will discuss return statement use and method. So, it's similar to declaring a variable with a type. We can declare a method to have a type. This declared type is placed just before the method name. In addition, a return statement is required in the code block, as shown, which returns the result from the method. In previous examples, we declared void, which has the special meaning that no data would be returned from the method. An example of a method declaration with a return type is shown here. In this case, the return type is an int. This method will return an integer when it finishes executing successfully. Being able to return a value from a method that's the calling code. Have a two-way conversation with the method code. So we can calculate something and send that value back to the code that called the method in the first place. Now see an example. If we take out the previous example, in this case, if you want to return something from our calculate area method, we need to first change the word void in the declaration to double, the data type of the information that we want to send back. This is going to be the entire thing. And once we do that, immediately IntelliJ is telling us there's a problem. We have an error. You can see that on the right-hand part of the screen, we have the little red icon with an exclamation mark. We could also say that IntelliJ has a red underscore under the method closing bracket. If we hover over that, IntelliJ tells us that the method is missing a return statement. Now see what a return statement is. Java states that a return statement returns control to the invoker of a method. The most common usage of the return statement is to return a value from a method. In a method that does not return anything, in other words, a method declared with void as the return type, a return statement is not required. But in methods that do return data, a return statement with a value is required. So we have defined a method that says it is going to return a double, but we haven't actually set that up yet. So what we need to do is add code to tell it to return that information. In the case of the calculate area method, we really want to return the result that was calculated. So how do we do that? As you would expect, there isn't just one way to do this. But since we've already got a variable in our method called result, we can return that from our method. The most common place for a return statement is right before the method closing brace, and that's what we'll do here. Return result semicolon. So next what we need to do is take out the print line there. And now we are going to change the code in the main method that calls calculate area. So first, let's create a new variable called area, and we will actually declare that right in front of it. Remember that we must declare the same data type variable that a method returns. If the method returns a double value, the receiving variable must have the same data type. So, assigned area variable to the value returned from the method call. Then we will print out that variable, system.out.println opening parentheses, double quotes the area is plus area variable closing parentheses, semicolon. Let's run that. You notice that we are only getting one line of output, as you can see. This is because, even though we are calling the calculate area method twice in the second instance, we don't assign the value that's returned to any variable, and we are not using it in any expression, so the return value is ignored by the calling code. You remember we also removed the system.app.println statement from inside the method, so nothing is in place to communicate the result variable to the console. This is not considered an error by the compiler or IntelliJ. Now see another example. For this, we create another class file named methodexamples3, and inside the class, create a main method. Now, we write a program that returns the sum of these two numbers. For this, we create a method named add that is declared as public and static, meaning it can be accessed by other parts of the program outside of the class it belongs to without creating an instance of the class it belongs to. The int in method returns an int value. This is indicated by the int keyword before the method name. The method takes in two integer parameters, a and b. Inside the method body, a simple arithmetic operation is performed a plus b, and the result is returned by the return statement. As previously stated, there are various methods for returning the value, which we also return as an expression like this. Now call this method in the main method. For this, write method name and parenthesis, then given values. First we pass the variable. Value that is 100 and second is the b variable value. That is 200 and last, write semicolon. Remember that here both parameters are int type, and we must pass this value according to its order. Now create an integer sum variable to store the return value of this method, and then use the print method to print the sum value. Now run it, and here is the output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Method overloading with exercises. In the previous lectures, we covered the concept of methods as well as how to utilize them in programming code. Method overloading will be covered in this lecture. Method overloading occurs when a class has many methods with the same name but differing parameter declarations. Therefore, we may call a method with a single name and execute it with several parameters. Based on the inputs given when the method is called, Java can decide which method it needs to run. Now discuss method signature. So, a method signature is made up of the name of the method and how each of its parameters is named. In other words, a signature is unique not just by the method name, but in combination with the number of parameters, their types, and the order in which they are declared. The method's return type is not part of the signature. A perimeter name is also not part of the signature. The type of order and number of parameters, in conjunction with the name, make a method signature unique. A unique method signature is the key for the Java compiler to determine if a method is overloaded correctly. The name of the parameter is not part of the signature, and therefore, from Java's point of view, it does not matter what we call our parameters. Here are some valid overload methods. So the first method has one parameter, a parameter of type int. In the next method, it still has one parameter, but the parameter is a float. This method has a unique signature because the parameter type is different from the first, and it's a valid overloaded method. In the third method, we have two parameters, and this is definitely different from the first two methods, so this is a valid overloaded method. In the fourth method, we have two parameters with the exact same types as the third method, but the order is different. So this is a valid overload method for the previous three. Parameter names are not important when determining if a method is overloaded. No return types are used when determining if a method is unique. In this example, both methods have the same number of parameters and same type, and therefore this is not a valid overloaded method. This will cause a compiler error. In the third method, we can have the same name and parameter, but a different return type. But the return type is not used in the determination of whether a method signature is unique, and so this method will also cause a compiler error when it's in the same class as the first and second. Method overloading is used a lot when programming in Java and in many other languages as well. So, overloading has numerous advantages, some of which are code reusability. Overloading methods enables code reuse as you can use the same method name for different tasks with different parameters. Readability. Overloading methods can improve code readability as it allows you to use the same name for similar tasks. Type safety. Overloading methods ensure type safety by allowing you to specify different implementations for different data types. Method signature uniqueness. Overloading methods ensure method signature uniqueness, as the method signature is defined by the number and type of parameters. Now see an example of overloading. For this, open IntelliJ. Here we create a class file named method overloading and create a main method inside this class. First we create a method using public, static, void, and its name is add, and then create two integer parameters a and b, and inside its body, the value of both parameters a and b is printed, and the string method with two parameters is concatenated. Then create another method using public, static, void, that's also have name add, but it takes three integer parameters a, b, and c, and the value of both parameters a and b and c printed, and the string method with three parameters is concatenated. Means it's overload the method add. Now we call these overloaded methods in the main method. First, write the method name add and give two arguments, 10 and 20. The Java compiler easily recognizes it and compiles the method with two parameters. That is the first method. Then we write the same name again, that is, add. Here we give the three arguments that are 100, 200, and 400. So, the Java compiler easily recognizes it and compiles the method with three parameters. That is the second method. Now run the program. Here you can see the output. First method output is method with two parameter, 10 and 20. Second method output is method with three parameter, 100, 200, and 400. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Switch statement. In this lecture, we will discuss about switch statement in Java. We already learned about if-then else, ladder if-then else, and nested if-then else conditions in detail, and also practiced some of their exercises in our previous lectures. I think you should now have a better idea of how to control the flow of a Java program. Now we come forward and discuss another important control statement, which is the switch statement, as I said earlier. So, the switch statement in Java is used as a control structure to execute one of several branches of code based on the value of an expression. It provides a way to handle multiple cases or conditions in a more efficient and readable way compared to using a series of if-else statements. The switch statement has gone through many enhancements since Java 8, but we'll be looking at the traditional switch statement to start. Now we see that the syntax for the switch statement. We start with the keyword switch. That's followed by the value we want to check in parentheses, followed by the opening curly brace, which starts to switch code blocks. And then there's the closing curly brace. Within the curly braces, there are some new keywords we haven't seen before. Case, break, and default. The case keyword is used with the switch statement for comparison. The switch value case essentially means in the case that value equals a, execute this code. If it doesn't, then move on to check the next case. The break keyword tells us which statement to terminate any further checks. The break statement is optional in switch, and we'll talk about it more shortly. So, here, the default keyword indicates that this code should be executed if none of the preceding conditions are met. Now we will see the comparison of switch and if-then-else statements. So, the if-then-else statement and the switch statement are both used to control the flow of execution in a Java program. But there are some key differences between the two, like expression type. The expression in an if-else statement can be of any type, including integer, float, double, or even an object, while the expression in a switch statement must be of a primitive data type, such as int, char, or short, or a wrapper class such as integer, character, or short. Multiple conditions. With an if-else statement, you can write multiple conditions to handle different cases, while with a switch statement, you can handle multiple cases, but only one expression is evaluated and compared to each of the case values. Readability. The switch statement can be more readable when handling multiple cases compared to a series of if-else statements, especially when dealing with a large number of cases. Performance. The performance of the switch statement is generally faster than an if-else statement, especially when dealing with a large number of cases. There are several advantages of using the switch statement in Java over the traditional if-else statement, like readability. Switch statements can make code more readable, especially when dealing with a large number of conditions, by grouping the conditions together in a clear and concise way. Cleaner code. Switch statements can help to make code more organized and easier to maintain by separating the conditions and their associated code blocks into distinct sections. Easy to use. The switch statement is easy to use and requires less typing compared to if-else statements. Better handling of multiple cases. The switch statement is especially useful when dealing with multiple cases, as it provides a simple and readable way to handle each case without the need for nested if-else statements. Better type safety. The switch statement only allows for certain data types as expressions, whereas if-else statements can accept any expression, which can lead to type mismatch errors. Better error handling. The switch statement provides the default case, which can be used to handle unexpected cases, providing a way to catch potential errors. Overall, the switch statement can greatly improve the readability, performance, and maintainability of your code, and it is especially useful when dealing with multiple cases. While the switch statement has several advantages, it also has some limitations, like limited data types. The switch statement only supports a limited number of data types as expressions, including byte, short, int, and char values. If you need to use a different data type, you will need to use a if-else statement instead. No range checks. The switch statement does not allow for range checks, which can be performed using if-else statements. If you need to check whether a value is within a certain range, you will need to use a if-else statement instead. No use of expressions. The switch statement does not allow for expressions to be used as cases, only constant values. This can limit its flexibility when compared to if-else statements, which can accept any expression. No support for null values. The switch statement does not support null values as expressions, which can cause issues if you need to handle null values in your code. Unpredictable behavior. The switch statement can have unpredictable behavior if a break statement is omitted from the end of a case block, causing execution to fall through to the next case. This can be a source of bugs and should be avoided. No short-circuit evaluation. The switch statement does not provide short-circuit evaluation, meaning that all cases are evaluated, even if a match is found. This can lead to a decrease in performance, especially when dealing with a large number of cases. I think now you understand basic syntax and also understand the compression between switch and if-then-else statements. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Switch statement exercises. In this lecture, we will practice some switch exercises. We already learned about the switch statement's basic syntax and the comparison between switch and if-then-else statements. Now we see one example using both if-then-else and switch statements. So, we write a program to determine the day of the week based on the value of day. If day is 1, the output should be Monday. If day is 2, the output should be Tuesday. If day is 3, the output should be Wednesday. If the value of day is not one of these 3 values, the output should be invalid day. Now, let's start creating this program. For this, open IntelliJ. Here we create a new project named switch. Then inside this project, create class file named misSwitchStatements. Then create a main method inside this misSwitchStatements class by right shortcut psvn. Now first we create this example using an if-then-else statement, and then we create the same example using a switch statement to see a clear picture of their differences. For this, we define an integer variable day with the value of 3. Then we write if parenthesis day equals to 1 open curly brace system dot out dot println parenthesis double quote Monday semicolon close curly brace. This line of code checks if the condition day equals to 1 is true. The code inside the curly braces will be executed and prints the string Monday to the console using the system.out.println statement. Then next write, Else if parenthesis day equals to 2 open curly brace system dot out dot println parenthesis double quote Tuesday semicolon close curly brace. It is used when the previous if condition is false and a new condition needs to be checked. In this case, the else if block checks if the value of the variable day is equal to 2. If the condition day equals to 2 is true, the code inside the curly braces will be executed and prints the string Tuesday to the console using the system .out.println statement. Then next write, else if parenthesis day equals to 3 open curly brace system .out.println parenthesis double quote Wednesday semicolon close curly brace. It is used when the previous else if condition is false and a new condition needs to be checked. In this case, the else if block checks if the value of the variable day is equal to 3. If the condition day equals to 3 is true, the code inside the curly braces will be executed and prints the string Wednesday to the console using the system .out.println statement. Then next write, else open curly brace. Inside this write, system.out.println parenthesis double quote invalid day semicolon close curly brace. It is used when catch all previous conditions are false. In this case, the code inside the curly braces of else condition will be executed and prints the string invalid day to the console using the system .out.println statement. Now run it. Here you can see the output that is Wednesday. Because the integer variable value is 3. As a result, the third condition, that day equals 3, became true. Now we create same example using switch statement. For this, we create separate class with name misSwitchStatements1 and create a main method inside this class by write shortcut psvm. Now, we declare an integer variable day with a value of 3. Then using switch statement that starts with the keyword switch followed by an expression in parentheses day variable. The expression day is evaluated and compared to each of the case values within the switch statement. Now we create first case by writing case 1 colon, then inside case write system .out.println parenthesis double quote Monday semicolon, then break statement and semicolon. So, the first case statement checks if the value of day is equal to 1. If the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is a call to the system .out.println method, which prints the string Monday to the console. Then break statement is used to exit the switch statement if the code for the matching case has been executed. Now we create second case by writing case 2 colon, then inside case write system .out.println parenthesis double quote Tuesday semicolon, then break statement and semicolon. So, the second case statement checks if the value of day is equal to 2. If the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is a call to the system .out.println method, which prints the string Tuesday to the console. Then break statement is used to exit the switch statement if the code for the matching case has been executed. Now we create third case by writing case 3 colon, then inside case write system .out.println parenthesis double quote Wednesday semicolon, then break statement and semicolon. So, the second case statement checks if the value of day is equal to 3. If the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is a call to the system .out.println method, which prints the string Wednesday to the console. Then break statement is used to exit the switch statement if the code for the matching case has been executed. Then we write default statement. So, the default is used as a catch-all case when none of the previous case conditions are true. The code inside the curly braces will be executed. The code inside the default statement is a call to the system's .out.println method, which prints the string invalid day to the console. Now run it. Here you can see the output that is Wednesday. Because the case 3 value is 3. As a result, the third case, that equals 3, became true. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Traditional versus enhanced switch statement. In this lecture, we'll see the difference between traditional and enhanced updating of switch statement. So, the switch statement has seen quite a few updates through the years. We're going to explore some of the new features of the switch statement. You may have noticed already that IntelliJ has been trying to get our attention. The switch keyword is highlighted. If we hover our mouse over that, IntelliJ tells us we can replace the switch statement with the enhanced switch. Let's do it. Let's select the replacement enhanced switch statement. So, the switch statement has been transformed by IntelliJ. Let's look at these statements side by side. We already introduced you to the switch statement and the syntax that's been used since Java's beginnings. This is shown on the left side of this slide. Since JDK 9, the switch has been undergoing enhancements, but to keep it backwards compatible, Java has introduced new syntax for this, which is shown on the right side of this slide. When we compare these two statements, the first thing we notice is that the colon after each case label has been replaced with the arrow token, as shown here. There are no breaks in the enhanced switch statement. The enhanced statement doesn't require them. Also notice that it's replaced the multiple case labels. We had case 48, case 49, and case 50 with a comma-delimited list of the values. If we see, in the traditional switch, we only declare the size variable and then inside the cases assign it values. But in the enhanced switch, the string size variable is assigned directly to the switch statement when any case runs, and then the string value inside the switch statement assigns a value to the size variable. Maybe you'll agree with me that this new switch code is easier to read and much more succinct. And for beginners, it comes with more controls in place to prevent coding errors. You'll see the traditional switch statement in code written before Java 14. So this is a fairly new feature in Java. For this reason, it's important to be familiar with both versions. Which one you use is really dependent on your development and production environments. If your code needs to be backwards compatible with earlier versions of Java, then stick to the traditional switch. So let's get back to the code. So, let's go over the traditional way of using a switch case statement in an expression, followed by the enhanced switch way. Prior to the enhanced statement, if you wanted the switch statement to return a value, you used a method that returned the value. So let's do that. The first thing we'll do is make a new method that takes a string as its single parameter and also returns a string. Let's do that. Public static string, getDays opening parentheses, string day name closing parentheses, and curly braces. So we have a new method called getDays, which takes a single string parameter called day name and returns a string value. This is going to be returned as a string. First 3 days of the week, Sunday, Monday, and Tuesday. Then return second 3 days of week for the Wednesday, Thursday and Friday, and then return string last day of week for the Saturday. So the idea is that this method will receive a day of the week and then return a string representing what part of the week that day is in. And we can use a switch statement to do that. And we can do it in a few ways. But let's look at the traditional way first. I'm going to type this code in, and then we'll talk about it afterwards. Now write switch parenthesis day name curly braces, case double quote Sunday colon, case double quote Monday colon, case double quote Tuesday colon, return double quote first 3 days of week semicolon, case double quote Wednesday colon, case double quote Thursday colon, case double quote Friday colon, return double quote second 3 days of week semicolon, case double quote Saturday colon. Return double quote last day of week semicolon. After closing switch curly brace, write return double quote nothing semicolon. Now, we're using a string for our switch and case values. The string was one of the few data types you can use with the switch statement. You can see those cases. We surround our test values in double quotes, indicating these are string values. What's really different here is that we're not using a break, but instead we're using a return statement. This works like a break since the code will exit out of both the switch statement and the method at this point. There's no chance to fall through the switch. We also don't need a default label in this instance, since if the day isn't found, the code will just fall through to the last statement. If we get string nothing back from this method, it means the day was invalid. Now let's go to the main method and call the getDays method. Here we create a string variable with value Tuesday. For this we write string day =, double quote Tuesday semicolon. Then we write system.out.println parenthesis day plus double quote is the plus getDays parenthesis day double parenthesis semicolon. Here we call a method named getDays and pass the day variable as an argument. and concatenate the day variable and the result of the getDays method with a string that describes their relationship. With string is the and print the concatenated string to the console using the system.out.println method. Now we run it. See the second output, that is Tuesday is the first 3 days of week. Now we will change the day variable to Saturday. Now we'll run that again, and here we get Saturday is the last day of week. Now the enhanced switch case statement gives us another option. First, let's change the switch case statement to an enhanced switch. We'll do what we did before, hovering over the switch keyword and selecting the option to replace with switch expression. As you can see, this performed a similar transformation on our code, but there is one notable difference. Notice that this code has the return keyword before the switch keyword. This enhancement was previewed in JDK 12 and 13, which experienced improvements due to the previews, and became standard in JDK 14, so it's pretty new. Here, it's very important to note that this switch statement is really an expression, meaning it resolves to a single value and can be assigned to a variable or, in this example, returned from the method. Let's consider this code side by side. There are some important differences. So again, we can see that the multiple case keywords have been removed in favor of a comma delimited list, and the colon is replaced with an arrow token. Look at the right side of the arrow token. It's just a string literal. This isn't a statement at all. This kind only compiles because we're using it as an expression, meaning we're using the result. In this case, we're simply returning the result from the method, but we could just as easily have assigned it to a local variable. The other important difference is this default label. When the enhanced switch is an expression, meaning it returns a value, and then a default label is required under most conditions. We'll be talking about the exception to this rule later. Now test these statements out in code. First, let's rerun our code with this newly formatted method. And, to their surprise, it still works. What happens if we leave out the default case? This is an interesting comment. IntelliJ doesn't give us a warning, but if we try to run that, we get an exception. The switch expression does not cover all possible input values, so you should always include a default label in the switch expression. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Enhanced switch statement exercises. In this lecture, we will practice some enhanced switch statement exercises. We already discussed comparisons between traditional and enhanced switch statements. Now we will develop an example using the enhanced switch statement. For this, we write a program to check a person's level, given an integer number, and then it returns the person's expertise level using a switch statement. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named EnhanceASwitch. Then create a main method inside this EnhanceASwitch class by right shortcut psvm. Now, we write string level string semicolon. Here, we declare a string variable named levelString. Then write int level equals sign 3 semicolon. Here, we declare an integer variable named level and initialize it with the value 3. We use the newer syntax for the switch because we want to assign the result of this switch to our levelString variable. Let's do this with writing levelString equals switch, opening parentheses, level, closing parentheses, and opening curly brace. Case 1, return type double quotes beginner semicolon, closing curly brace semicolon. So we've now handled case 1, which is beginner of the value of level 1. We're going to return beginner from this switch expression and assign it to the variable day of levelString. And because we are assigning this switch statement to a variable, we put a semicolon after the switch closing brace, as you can see here. And here we're using the error token instead of a colon, and simply putting the value that's supposed to be returned on the right side of that token. The enhanced switch doesn't have break statements, and if all we're doing is returning a value, we can do it without using curly braces around this code. Now creates other cases by writing case 2 return type double quotes intermediate semicolon. Case 3 return types double quotes expert semicolon. Now, let's add default case. We've said that anything that isn't 1, 2, or 3 should return failed to learn. So let's add default return type double quotes, failed to learn semicolon. Next, we'll print that information out in this method after the switch expression. system.out.println opening parentheses, day plus double quotes your level is colon, plus level string, closing parentheses, semicolon. Here we print out the level of the person, and then we print the text that came back from our switch expression. Now we run it. Here you can see the output, that is, your level is expert. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Nested switch statement. In this lecture, we will talk about nested switch statement in Java. In the previous lectures, we already discussed basic switch concepts and practiced some of their examples. Now we will see more advanced concept of it, that is nested switch. So, in simple words, a switch statement inside another switch statement is called a nested switch. We use nested switch statements in Java to handle complex situations where we need to check multiple conditions. A nested switch statement allows us to choose a specific case based on multiple conditions, which can simplify our code and make it more readable. Nested switch statements can be useful in situations where we need to evaluate different combinations of conditions. For example, if we want to calculate the grade for a student based on their score in 2 exams, we could use a nested switch statement to evaluate each possible combination of exam scores and assign a grade accordingly. This can be a much more efficient way than using a long series of if-then-else statements or multiple levels of nested if statements. Now we will see its syntax in Java. Here you can see its syntax. The outer switch statement starts with the keyword switch and is followed by an expression parenthesis expression 1 in this case inside the parentheses. The expression is evaluated to determine which case to execute. After the expression, there are multiple case statements. Each case statement has a value parenthesis value 1 and value 4 in this case that is compared to the expression. If the value matches, the code block following the case statement is executed. In the code block for the first case statement parenthesis value 1, there is another switch statement nested inside it. This second switch statement also has an expression parenthesis expression 2 and multiple case statements parenthesis value 2 and value 3, just like the outer switch statement. Depending on the value of the expression 2, one of the case statements parenthesis value 2 or value 3 is executed, and its corresponding code block is executed. If the value of expression 2 does not match any of the case statements, the default code block is executed. After the nested switch statement, there is a break statement that exits the code block for the first case statement parenthesis value 1. Without the break statement, execution would fall through to the next case statement. The remaining case statements parenthesis value 4 and parenthesis default follow the same syntax as the first case statement, and their corresponding code blocks are executed if their values match the expression or if no other cases match. There are many benefits to using nested switch statements in Java, such as improves readability. By breaking down complex logic into smaller, more manageable blocks, nested switch statements can make your code more readable and easier to understand. This can make it easier for other developers to maintain and extend your code. Simplifies complex logic. When you have complex logic that involves multiple conditions, nested switch statements can be an efficient way to simplify the code. By evaluating each condition separately, you can avoid writing long, complex if-else statements. Reduces code duplication. If you have multiple switch statements with some shared conditions, you can use a nested switch statement to avoid code duplication. This can make your code more efficient and easier to maintain. Improves performance. Switch statements are generally faster than if-else statements, and using nested switch statements can help you take advantage of this performance boost. By reducing the number of conditional checks that need to be performed, you can improve the speed and efficiency of your code. More modular code. By breaking down your code into smaller blocks, nested switch statements can make your code more modular and easier to maintain. This can help you make changes more easily and reduce the risk of introducing bugs. While the nested switch statement has several advantages, it also has some limitations, like can become difficult to read. While nested switch statements can help to simplify complex logic, if they are used excessively or improperly, they can make the code difficult to read and understand. This can make it harder for other developers to maintain and extend your code. Can lead to code duplication. While nested switch statements can help to reduce code duplication in some cases, they can also lead to additional code duplication if used improperly. This can make your code harder to maintain and can increase the risk of introducing bugs. May not be the most efficient approach. While switch statements can be faster than if-else statements, using nested switch statements may not always be the most efficient approach. In some cases, other approaches such as polymorphism or conditional expressions may be faster or more efficient. Limited to a single data type. Switch statements are limited to a single data type, which means that you cannot use them to evaluate complex or composite data types. This can limit their usefulness in certain situations. Limited to a small number of conditions. While switch statements can be useful for evaluating a small number of conditions, they can become unwieldy and difficult to manage if used to evaluate a large number of conditions. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Nested switch statement exercises. In this lecture, we will talk about nested switch statement in Java. We already discussed basic nested switch statement concepts in previous lectures, as well as their benefits and limitations. Now we will practice some examples using nested switch statements. Now start with simpler program. For this, we write a program to evaluate the values of two integer variables x and y using nested switch statements and print a message based on their values. If x is equal to 1, the code evaluates y and prints a message based on its value. If x is equal to 2, the code evaluates y and prints a message based on its value, and if y is not equal to either 2 or 3, it prints a default message. The code demonstrates the use of nested switch statements in Java. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named traditional switch example. Then create a main method inside this traditional switch example class by right shortcut psvm. Now, we write int x equals sign 2, y equals sign 3 semicolon. Here, declare two integer variables x and y and assign them the values 2 and 3, respectively. Then, write switch open parenthesis x close parenthesis curly brace. Here, we use a switch statement to evaluate the value of x. Then we create first case by writing case 1 colon. If value of x is 1, then this case executes. Then we use nested switch statement inside the case 1 by writing switch open parenthesis y close parenthesis curly brace. So, if x is equal to 1, execute the code inside the nested switch statement, which evaluates the value of y. Now, we create cases for nested switch statement. For this, we write case 2. System.out.println parenthesis double quote x is 1 and y is 2 semicolon, break semicolon. Case 3. System.out.println parenthesis double quote x is 1 and y is 3 semicolon, break semicolon. Here if x is equal to 1, the inner switch statement evaluates the value of y and checks whether it is equal to 2 or 3. If y is equal to 2, the code prints the message x is 1 and y is 2. If y is equal to 3, the code prints the message x is 1 and y is 3. Finally, this break statement is used to exit the inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create second case for the outer switch statement. For this, we write case 2 colon. Here, if value of x is 2, then this case executes. Then we use another nested switch statement inside the case 2 by writing switch open parenthesis y close parenthesis curly brace. So, if x is equal to 2, execute the code inside the nested switch statement, which evaluates the value of y. Now, we create cases for this nested switch statement. For this, we write case 2. System.out.println parenthesis double quote x is 1 and y is 2 semicolon, break semicolon. Case 3. System.out.println parenthesis double quote x is 2 and y is 3 semicolon, break semicolon. Here, if x is equal to 2, the inner switch statement evaluates the value of y and checks whether it is equal to 2 or 3. If y is equal to 2, the code prints the message x is 2 and y is 2. If y is equal to 3, The code prints the message x is 2 and y is 3. Finally, this break statement is used to exit the second inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. In this program, we use one outer and two nested switch statements. We already discussed the default case is optional, you may use or not, it depends on you or on program problem statement. Now run it. And here is the output after it has been successfully run. That is x is 2 and y is 3. Because here, x variable is equal to 2 and y is equal to 3. So, first, the variable x value successfully matches the case 2 of the outer switch. And then the variable y value successfully matches the case 3 inside the second nested switch. Now we will see another example. For this, we write a program that takes values for branch and year and prints the list of elective courses using switch statements. So, the first case is for the first year and it prints 2 courses, Advanced English and Algebra. The second case is for the second year, and depending on the value of branch, it prints different sets of elective courses. If the branch is CSE or CCE, it prints Machine Learning and Big Data. If the branch is S, it prints Antenna Engineering. If none of the cases match, it prints Optimization. Now, let's start creating this program. For this, we create a class file named Traditional Switch Example 2. Then create a main method inside this Traditional Switch Example 2 class by write shortcut PSVM. Now, write string branch equals sign double quote CSE semicolon. Here we initialize a string variable named branch to the value CSE. The value of branch is later used in a nested switch statement to determine which elective courses to print based on the student's branch of study. Then we write int year equals sign 2 semicolon. Here we initialize an integer variable named year to the value 2. The value of year is later used in a switch statement to determine which elective courses to print based on the year of study. So, here we evaluate 2 variables, a string variable branch and an integer variable year. The code prints the elective courses for each year of study based on the value of the variable year and the branch of study specified in the branch variable. Then, write switch open parenthesis year close parenthesis curly brace. Here, we use a switch statement to evaluate the value of year. Now we create first case by writing case 2 colon system dot out dot println parenthesis double quote elective courses colon advanced English comma algebra semicolon break semicolon. So, here the switch statement uses the value of the variable year to determine if the value of year is 1. Then the program will print the message elective courses, Advanced English, Algebra using the println method statement. After executing the println method statement, the break statement is used to exit the switch block and continue with the rest of the program. If the value of year is not 1, then the program will move on to the next case in the switch statement. So, now we create a second case by writing case 2. This case will run when the value of the year variable is 2. Now we create a nested switch and their cases inside this case. For this we write switch open parenthesis branch close parenthesis curly brace case double quote CSE colon case double quote CCE colon system dot out dot println parenthesis double quote elective courses colon machine learning comma big data semicolon break semicolon. So, the second case in the outer switch statement. It checks if the value of year is 2. The program will move to the inner switch statement to determine which elective courses to print based on the student's branch of study. In this case, the inner switch statement checks if the value of branch is either CSE or CCE. If the value of branch matches either of these 2 cases, then the program will print the message elective courses, Machine Learning, Big Data using the println statement. The break statement is used to exit the inner switch block and continue with the rest of the program. If the value of branch does not match either of these 2 cases, then the program will move on to the next case in the inner switch statement. Then we create other case for inner or nested switch statement. For this we write case double quotes colon system dot out dot println parenthesis double quote elective courses colon antenna engineering semicolon break semicolon. Here it checks if the value of year is 2, and then it checks if the value of branch is S. If the value of branch matches, Then the program will print the message elective courses, antenna engineering using the println statement. Then we add default case in the nested switch statement by writing default system .out.println parenthesis double quote elective courses optimization semicolon break semicolon. If none of the cases within the inner switch statement match the value of branch, then the program will execute the default case. In this case, the program will print the message elective courses, optimization using the println statement. The break statement is used to exit the inner switch block and continue with the rest of the program. Now run it. And here is the output after it has been successfully run. That is elective courses, machine learning, big data. Because here, branch variable is equal to CSE and year variable is equal to 2. So, first, the variable year value successfully matches the case 2 of the outer switch, and then the variable branch value successfully matches the case CSE inside the first case of nested switch. Now we will see another example. For this, we write a program to select the pizza based on its size and toppings. First select the size, and then select the toppings. So, the program takes in 2 characters, representing the size and toppings of the pizza, and uses nested switch statements to output the appropriate message based on the combination of size and toppings. If an invalid size or topping is entered, the program will output an error message. The program will use 3 sizes, S for small, M for medium, and L for large. And then we use 3 toppings, P for pepperoni topping, C for cheese topping, and V for vegetable topping. Now, let's start creating this program. For this, we create a class file named traditional switch example 3. Then create a main method inside this traditional switch example 3 class by write shortcut psvm. Now, write char size =, single quote L comma toppings =, single quote C semicolon. Here 2 character variables named size and toppings are declared and initialized with the values L and C, respectively. These variables will be used later in nested switch statements to determine the appropriate message to output based on the combination of pizza size and toppings. The character L represents a large pizza size, and C represents a cheese topping. Then, write switch open parenthesis size close parenthesis curly brace. Here, we use a switch statement to evaluate the value of size. Then we create first case by writing case single quotes colon. If value of size is S, then this case executes. Then we use nested switch statement inside the case S by writing switch open parenthesis toppings close parenthesis curly brace. So, if size is equal to S, execute the code inside the nested switch statement, which evaluates the value of toppings. Now, we create cases for nested switch statement. For this, we write case single quote p system .out.println parenthesis double quote small pizza with pepperoni topping semicolon break semicolon. Case single quote c system .out.println parenthesis double quote small pizza with cheese topping semicolon break semicolon. Case single quote v system .out.println parenthesis double quote small pizza with vegetable topping semicolon break semicolon. Here the outer switch statement is based on the value of the size variable, which is of type char. The inner switch statement is based on the value of the toppings variable, which is also of type char. When size is S, that is small pizza, the program will enter the inner switch statement and execute the code block corresponding to the value of toppings. In this case, if toppings are P, the program will output the message small pizza with pepperoni topping. If toppings are C, the program will output the message small pizza with cheese topping. If toppings are V, the program will output the message small pizza with vegetable topping. Now add default case by writing default curly braces system .out.println parenthesis double quote invalid topping semicolon break semicolon. So, if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create second case for the outer switch statement. For this, we write case single quote M colon. Here, if value of size is m, then this case executes. Then we use second nested switch statement inside the case m by writing switch open parenthesis toppings close parenthesis curly brace. So, if size is equal to s, execute the code inside the nested switch statement, which evaluates the value of toppings. Now, we create cases for second nested switch statement. For this, we write case single quote p colon system dot out dot println parenthesis double quote medium pizza with pepperoni topping semicolon break semicolon. Case single quote c colon system dot out dot println parenthesis double quote medium pizza with cheese topping semicolon break semicolon. Case single quote v colon system dot out dot println parenthesis double quote medium pizza with vegetable topping semicolon break semicolon. Now add default case by writing default colon curly braces system dot out dot println parenthesis double quote invalid topping semicolon break semicolon. So, if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the second inner switch statement. Then we write break outside of second nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create third case for the outer switch statement. For this, we write case single quote L colon. Here, if value of size is L, then this case executes. Then we use second nested switch statement inside the case L by writing switch open parenthesis toppings close parenthesis curly brace. So, if size is equal to S, execute the code inside the nested switch statement, which evaluates the value of toppings. Now, we create cases for third nested switch statement. For this, we write case single quote p colon system dot out dot println parenthesis double quote large pizza with pepperoni topping semicolons break semicolon. Case single quote c colon system dot out dot println parenthesis double quote large pizza with cheese topping semicolon break semicolon. Case single quote v colon system dot out dot println parenthesis double quote large pizza with vegetable topping semicolon break semicolon. Now add default case by writing default colon curly braces system dot out dot println parenthesis double quote invalid topping semicolon break semicolon. So, if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the third inner switch statement. Then we write break outside of third nested switch curly brace. This break statement is also used to exit the outer switch statement. Finally, we add default case for outer switch statement by writing default colon curly braces system dot out dot println parenthesis double quote invalid pizza size semicolon break semicolon. So, if pizza size is not S, M, or L, the program will execute the default case, which outputs the message invalid pizza size. The break statement is used to exit the outer switch statement. Now run it, and here is the output after it has been successfully run. That is large pizza with cheese topping. Because here, size variable is equal to L and toppings is equal to C. So, first, the variable size value successfully matches the third case L of the outer switch, and then the variable topping value successfully matches the case C inside the third nested switch. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to loops. In this lecture, we're going to move on now to talk about the introduction to loop statements in Java. Looping is a very common need in programming because it allows us to execute code multiple times. So there are several looping statements in Java. These statements will continue to execute a block of code repetitively until a condition or some set of conditions is met. In this section of the course, we'll be looking at 3 loop statements. These are for loop, while loop, do while loop. So, the for loop is probably the most common, and the one we'll look at first. The for loop is used when we know how many times we need to execute a block of code. It includes setup to initialize variables, checker loop expression, and update code, which often includes incrementing an iteration variable. Then while. The while that might seem simpler because it will just continue to execute code until its loop expression becomes false. So, The while loop is used when we don't know how many times we need to execute a block of code. It continues to execute until the condition becomes false. Then do while. So, do while loop is like the one loop, except that it will always execute the code once, regardless of whether the loop condition is true or false, and then continue looping until that expression is false. There are several advantages of using the loop statements in Java. Some of them are like reusability. Loops allow you to execute a block of code repeatedly without having to copy and paste the same code multiple times. This makes your code more efficient, organized, and easier to maintain. Efficiency. Loops help in reducing the amount of code that needs to be written and processed, which can result in better performance and faster execution time. Flexibility. Loops provide the flexibility to execute a block of code repeatedly based on different conditions, such as a fixed number of times or until a specific condition is met. This makes it easy to handle complex scenarios and implement complex algorithms. Scalability. Loops can be used to process large data sets, such as arrays and lists, in an efficient and scalable manner, which is important for developing applications that handle big data. Improved code readability. Loops can make your code more readable and easier to understand, as they can help to reduce the amount of code that needs to be written and increase the level of abstraction in your code. Loops are an important feature in Java and other programming languages, but they do have some potential limitations in Java, including performance. Depending on how they are implemented, loops can sometimes be less efficient than other approaches for solving a particular problem. This is because loops can require a lot of processing power and memory to execute, especially when dealing with large data sets. Infinite loops. If the condition specified in a loop is not set up correctly, it can result in an infinite loop, which can cause the program to hang or crash. This can be a major problem if the program is running on a critical system or processing large amounts of data. Complexity. Loops can make the code more complex and difficult to understand, especially if they are nested or used in conjunction with other control structures like if-else statements or switch statements. Maintenance. Loops can be difficult to maintain, especially if they are used in a large and complex program. Changes to the code can have unintended consequences, and it can be difficult to test and debug loops that are nested or have complex conditions. Code readability. While loops can improve code readability by reducing the amount of code that needs to be written, they can also make the code more difficult to read and understand if they are used excessively or inappropriately. Now we discuss for loop syntax. The for statement is also called the for loop because it loops something over and over again until the condition is met. When I say repeatedly loops, I mean it's processing a certain amount of code, a code block. In other words, the given number of times or until a particular condition is satisfied. The basic structure for statements and declarations is divided into 3 parts. These are declared in parentheses after the for keyword and are separated by semicolons. These parts are all optional and consist of initialization, condition, increment, or decrement. Initialization. This part is executed only once before the loop starts. It is used to initialize the loop counter variable to a starting value. Condition. This part is evaluated at the beginning of each iteration of the loop. If the condition is true, the loop will execute, otherwise, it will terminate. Increment-decrement. This part is executed at the end of each iteration of the loop. It is used to increment or decrement the loop counter variable by a fixed value. For example, if we want to display a count from 0 to 9 using for loop. For this we use for loop statement and in the parenthesis. The first part is initialization. Here, the loop counter variable I is initialized to 0 using the statement int I equals sign 0 semicolon. This statement is executed only once at the beginning of the loop. Then second part, condition. Here the loop will continue to execute as long as I is less than 10. The condition I less than 10 is evaluated at the beginning of each iteration of the loop. Then third part, increment or decrement. Here we use increment because the value incremented by 1 from 0 to less than 10. So, the loop counter variable I is incremented by 1 at the end of each iteration using the statement I++. To create block of loop, use the open and close curly braces. Inside the loop block, The system.out.println method is used to print the value of I at each iteration of the loop. The loop will execute 10 times, with the loop counter variable I taking on the values 0 through 9. Note that in Java, the curly braces that delimit the block of code inside a loop or any other control structure are not optional. However, there is an exception when there is only one statement inside the loop, in which case the curly braces can be omitted. However, if there is only one statement inside the loop block, the curly braces can be omitted. In our for loop example, the code prints the numbers 0 through 9, but with a loop block containing only a single statement, if the curly braces omitted from this loop block. This syntax is allowed in Java, but it can make the code less clear and harder to read, especially if the loop block contains more than one statement. In summary, while the curly braces that delimit the block of code inside a loop are generally required in Java, they can be omitted if there is only one statement inside the loop block. However, it is generally recommended to always include the curly braces to make the code clearer and easier to read. Now we discuss while loop syntax. The while loop has one part that is condition. So, the condition part of the while loop is a Boolean expression that is evaluated before each iteration of the loop. If the condition is true, the loop will execute, otherwise, it will terminate. The condition can be any expression that returns a Boolean value. Now, we use the same example as we used for the for loop. Here is the code. As previously stated, the while loop has only one component, which is the condition. So, the initiation is made before the while loop, as you can see. While loop statement and inside the parenthesis use condition that the loop will execute repeatedly as long as the condition I less than 10 is true. The code within the loop will execute repeatedly until the condition is false. The increment or decrement of the loop counter variable, that is I, is usually done within the loop. Now we discuss do while loop syntax. It is same as the while loop, but the main difference between while and do while loops in Java is that the while loop checks the loop condition at the beginning of the loop before executing the loop body, while the do while loop checks the loop condition at the end of the loop after executing the loop body at least once. So, the keyword do starts the do while loop block. The block of code that should be executed repeatedly is enclosed in curly braces. The keyword while is followed by a condition that is evaluated at the end of each iteration. If the condition is true, the loop will continue to execute the block of code, otherwise, the loop will terminate. And there is a semicolon at the end of loop syntax. Here you can see an example. In this code, the do while loop will execute at least once, because the loop condition is checked at the end of the loop. The loop body will print the value of I to the console, starting with 1, and then increment the value of I by 1. However, since the loop condition is I greater than 5, and I start with a value of 1, the loop condition is immediately false, and the loop terminates after executing the loop body only once. The loop terminates because I is not greater than 5. Therefore, the loop body is executed only once, and the value of I is never greater than 5. I hope you learned something useful in this lecture as well, and I'll see you in the next one. For loop with exercises. In the previous lecture, we discussed the introduction of loops and their types, and we also discussed their syntax. In this lecture, we will talk about for loop. So, the for loop is probably the most common and the one we'll look at first. The for loop is used when we know how many times we need to execute a block of code. It includes setup to initialize variables, checker loop expression, and update code, which often includes incrementing an iteration variable. The for statement is also called the for loop because it loops something over and over again until the condition is met. When I say repeatedly loops, I mean it's processing a certain amount of code, a code block. In other words, the given number of times or until a particular condition is satisfied. Now start with a simpler example using for loop. So, we write a program to print numbers from 1 to 5 using a for loop. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named for loop. Then create a main method inside this for loop class by right shortcut psvm. In the main method we write, for open parenthesis int I equals sign 1 semicolon, I less than equals to 5 semicolon, I plus plus close parenthesis curly braces. Then inside the loop body write system .out.println parenthesis I. So, loop starts with initializing a variable I to one that is int I equals sign 1. Then loop condition is checked. Since I is less than or equal to 5, the condition I less than or equal to 5 is true, and the loop body is executed. Then increment the value by 1 using I++. Then loop body consists of a single statement that prints the value of I to the console, using system.out.println parenthesis I. Now we run it. Here is the output after a successful run. That is 1 to 5. In this case, I is 1, so the first output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equal to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equal to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 4. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equal to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 4, so the output is 4. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 5. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equals to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 5, so the output is 5. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 6. Then loop condition is checked again. Since I is now greater than 5, the condition I less than or equal to 5 is false, and the loop exits. Now we see another example using the for loop. So, we write a program that iterates from 1 to 10 and prints each number to the console, except for 5. If the loop encounters the number 8, it should immediately exit. Now, let's start creating this program. Here we create another class file named forloop1. Then create a main method inside this forloop1 class by write shortcut psvm. In the main method we write, for open parenthesis int I equals sign 1 semicolon, I less than or equal to 10 semicolon, I plus plus close parenthesis curly braces. So, here, loop starts with initializing a variable I to one that is int I equals sign 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed. Then increment the value by 1 using I++. Then inside the loop body write if parenthesis I equals sign 5 curly braces continue semicolon. Here the if statement is checked to see if the condition is true. In this case, the condition is whether I is equal to 5. If the condition is true, the continue statement is executed, which immediately skips the rest of the current iteration of the loop and jumps to the next iteration. In other words, it bypasses any statements in the loop body that come after the continue statement. If the condition is false, the continue statement is not executed, and the program proceeds to the next statement after the if statement. So, continue statement allows the program to skip over certain iterations of a loop based on a specific condition. Then write else if parenthesis I equals sign 8 curly braces break semicolon. The else if statement is checked to see if the condition is true. In this case, the condition is whether I is equal to 8. If the condition is true, the break statement is executed, which immediately exits the loop, even if the loop condition has not yet been met. This means that the program will skip over any remaining iterations of the loop and continue with the next statement after the loop. If the condition is false, the else if statement is not executed, and the program proceeds to the next statement after the loop, or to the next statement in the loop body, if any. We already discussed break statement in switch statement lectures. Then outside of these conditions, we write system.out.println parenthesis I semicolon. Now we run it. Here is the output after a successful run. So, here you can see that 5, 9, and 10 numbers are not printed. Because in this example, when the loop runs first time, the variable I is initialized with 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console using the print statement. In this case, I is 1, so the output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. The loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Steps 4, 6, and 7 are repeated for each subsequent iteration of the loop, with the output being 4, 6, 7. But when I is equal to 5, the if statement is executed, and the continue statement is executed, which skip over remaining iterations of the loop and continue with the next statement after the loop. Same way when I is equal to 8, the else if statement is executed, and the break statement is executed, which immediately exits the loop. Then the loop is finished, and therefore the final output shows 1, 2, 3, 4, 6, and 7. Now we'll look at a slightly more complicated example that makes use of the for loop. So, we write a program to check whether the given number is prime or not. Now, first we discuss what prime number is and how to find them. So, prime numbers are a special type of whole numbers that have exactly 2 factors, 1 in themselves. This means that they cannot be divided evenly by any other positive integer except for 1 and the number itself. For example, 2 is a prime number because its only factors are 1 and 2. Similarly, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31 are prime numbers because they only have 2 factors. As you can see there, it lists the prime numbers of 1000. For instance, the number 7 cannot be divided by any number other than 1. That will produce a whole number, so it's a prime number. 7 divided by 1 is 7, and 7 divided 7 is 1, which are both whole numbers, but any other number will result in a decimal number. Whereas 9 can be divided by 3, which equals a whole number, and therefore it's not a prime number. The number 1 is not considered as a prime number, but the number 2 is. However, any other number divisible by 2 is not a prime number. That's a super simplified explanation for those of you who hate math. Don't worry, I'm not going to ask you to create the prime number method on your own. Prime numbers are used in computer science to generate random numbers and in various algorithms for optimization and search. Moreover, prime numbers are also used in various areas of mathematics, such as algebra, geometry, and calculus. For instance, prime numbers appear in the study of polynomial equations, elliptic curves, and number fields. I think now you better understand what a prime number is. Now we discuss how to find them. So, there are many ways to find a given number is prime or not. Divide the given number by 2. Take the first half of given number and start dividing it from 2 to last half number. If any one number divides the given number completely, then it's not prime number, otherwise it's prime number. Now let's create this program. First we create a class file named findPrimeNumbers, and then inside it create main method using shortcut PSVM. We're going to create is prime method before we do anything else. First, let's create the method using public static boolean is prime opening parentheses, int whole number closing parentheses curly braces. Return true semicolon. So it will be returning a boolean from this method. True if the number passed, which is the parameter, is a prime number, and false if it isn't. So the parameter name is whole number, and I've used this is prime as the method name. Because this method isn't really operable, we'll just return true. Let's next add some simple test cases to our main method. We'll test the number 0, and here's a decent opportunity to use the ternary operator. If the number is prime, the text will say a prime number, and if the number is not prime, the text will say not a prime number. I'm going to main method now. Write system.out.println, opening parentheses, double quotes. 0 is plus opening parentheses is prime opening parentheses 0 closing parentheses question mark double quotes colon double quotes, not closing parentheses, plus double quotes. A prime number closing parentheses, semicolon. So you can see we're calling the method here, asking at the number 0 in this line. And this is making the call to the isPrime method from the first operand of the ternary operator, which uses the question mark and colon. We concatenating an empty string. But if it's false, we'll slip in the word, not in the text. Because our prime method right now always returns true. When this code be run, it will indicate that all numbers are prime numbers. First, we'll check if the number is less than or equal to 2 with if-then statement. If it's less than or equal to 2, we want to return false if the number is negative, 0, or 1, because these are not prime numbers if the number is 2. However, we want to return true because 2 is a prime number. So we can do this by returning the value that will be returned from the Boolean expression whole number equals 2 using the double equals sign, here the equality operator. Now we write if opening parentheses whole number less than or equal to 2 closing parentheses, opening curly brace. Return opening parentheses, whole number equals to 2 closing parentheses semicolon. So, now let's see where we're at and run that with our test case. Here you can see the output that 0 isn't a prime number. So you remember to set up a for loop. We need a starting point, a condition to stop at, and a way to increment the variable that we're checking. So let's have this for loop. For open parentheses, int divisor equals 2 semicolon divisor, less than whole number semicolon divisor plus plus closing parentheses curly braces. We create a variable called divisor. This is the number we'll be dividing the whole number by. We'll keep flipping if the device is less than whole number. If we use less than or equal there instead of less than t, then would have the condition that whole number would be divided by itself at the end, and it would then say that the number was not prime, which would be wrong. So make sure this is just the less than symbol by itself, and then we'll increment by 1 each time. So the postfix operator will do the job for that. Now thinking about the number 8, that's the whole number. For example, we'll be looping from 2 to 7, incrementing by 1 each time, and what do we want to check each time? All we want to know if the whole number is evenly divisible by that loop variable, which we're calling divisor. What operator can we do this with? The remainder operator will modulus operator, whatever you like to call it. Let's add that code. If opening parentheses whole number modulus divisor equals 0, closing parentheses curly braces. Return false semicolon. Here we have an if statement that checks if the whole number is divisible by the loop parameter, which we're calling divisor. If our whole number can be evenly divisible by any number other than itself, so that is any number between 2 and 1 less than its value, then that means the whole number can't be a prime number. In other words, we've had a number that evenly divides into whole number, which means whole number isn't prime. We start with 2 because everything is divisible by 1. So starting with 1 would give us false positives. But notice that every even number will return a false on the first iteration of the loop. So that's pretty efficient. But it also said that we're just putting a return in that if code block. This will exit the loop at that moment when the condition is true, breaking out of the loop and exiting the entire method returning false. Now to test, we first add more cases. For this, we go into the main method and write system.out.println, opening parentheses, double quotes. 1 is plus opening parentheses is prime opening parentheses 1 closing parentheses question mark double quotes colon double quotes, not closing parentheses, plus double quotes. A prime number closing parentheses, semicolon. Now copy and paste this line many times and now change their values that are 2, 3, 8, 17, and 21. Now run it. Here you see the output that 0, 1, 8, and 21 are not prime numbers and 2, 3, and 17 are prime numbers. There are other ways we could program this, but this is a pretty easy way to get your answer and get out of the loop and subsequently the method. When you're using loops, it's a good idea to see if there are any ways to cut down on iterations, especially if the code block that's being executed is complex or creating a lot of variables. One minor thing we could do is change the code to iterate over fewer values. We could use the halfway mark for a number as the maximum value. Let's make those 2 minor changes, changing less than 2, less than or equal to the whole number, to whole number divided by 2. So think about why this is more efficient for a minute. And what should still work? Anything that is divisible by the smallest number 2 will also be divisible by that whole number divided by 2. So checking numbers greater than half the whole number is really just wasted effort. Now run it. Now you can see that gives us the same results. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Debugger. In this lecture, we will discuss the debugger, which is the most powerful component used in programming. So, first, we see what a debugger is and why it is important. So, a debugger is a software tool used by programmers to find and fix errors in their code. It allows developers to step through their program, inspect variables and memory, set breakpoints, and track the flow of execution. Debuggers are commonly used in software development to catch bugs, errors, and other issues that can affect the quality and performance of a program. They work by allowing developers to pause the execution of their code at specific points, examine the state of the program, and then resume execution. There are 2 main types of debuggers: source-level debuggers and machine-level debuggers. Source-level debuggers allow developers to debug code written in high-level programming languages, while machine-level debuggers allow developers to debug code at a lower level, such as assembly language. In addition to allowing developers to pause the execution of their code, debuggers also provide a number of other features that make it easier to identify and fix issues. These include breakpoints. Developers can set breakpoints in their code to pause execution at specific points. Stepping. Developers can step through their code line by line to see how it is executed. Inspecting variables. Developers can inspect the value of variables at any point during execution. Memory inspection. Developers can inspect the state of memory at any point during execution. Call stack inspection. Developers can inspect the call stack to see how functions are called and returned. Watch expressions. Developers can set up watch expressions to monitor the value of variables and expressions over time. Remember that debugger and debugging are 2 related but distinct concepts in software development. As we said, that debugger refers to a software tool or program that helps developers identify and diagnose errors in their code. Debugging, on the other hand, refers to the process of finding and fixing errors in code. Debugging involves a systematic approach to identifying the cause of the error, making changes to the code to fix the error, and then testing the code to ensure that the error has been resolved. Debugging is the process that the developer follows to identify and fix issues in their code, using tools such as a debugger. As a result, the debugger is a tool that developers use to assist in the process of debugging. Debugging is the process that developers follow to find and fix errors in their code. The debugger is just one of the many tools and techniques that can be used in the process of debugging. Now we see how the debugging process works. So, the process typically involves the steps that are reproduce the error. The first step in the debugging process is to reproduce the error or bug. The developer must be able to recreate the error in a controlled environment to understand its cause. Identify the cause. Once the error has been reproduced, the developer must analyze the code to identify the cause of the error. This may involve using debugging tools such as breakpoints, tracing, and logging to gain insight into the behavior of the code. Develop a fix. After identifying the cause of the error, the developer must develop a fix. This may involve modifying the code, adding new functionality, or reconfiguring the software. Test the fix. Once a fix has been developed, it must be tested to ensure that it addresses the original error and does not introduce new errors or issues. Deploy the fix. If the fix passes testing, it can be deployed to the production environment or distributed to end users. Monitor the fix. Finally, the developer must monitor the software to ensure that the fix is effective and does not introduce new errors or issues. Now we see what code mistakes call for debugging. There are many different types of coding errors that can require debugging. Some common examples include syntax errors. These are errors that occur when code violates the rules of the programming language, such as a missing semicolon or a misspelled keyword. Logical errors. These are errors that occur when the code is correct syntax-wise, but does not produce the expected results due to an incorrect sequence of statements or a mistake in the logic. Runtime errors. These are errors that occur during the execution of the program, such as an attempt to divide by 0 or accessing an invalid memory address. Memory leaks. These are errors that occur when a program does not release allocated memory after use, which can cause the program to slow down or crash. Deadlocks. These are errors that occur when two or more processes or threads are blocked, waiting for each other to release resources, resulting in a program that becomes unresponsive. Race conditions. These are errors that occur when the behavior of the program depends on the order of execution of multiple threads, which can cause unpredictable behavior. Input-output errors. These are errors that occur when the program cannot read or write data to a file or a network resource due to a permissions issue, network connectivity issues, or other external factors. While debuggers are useful tools for identifying and fixing errors in software code, there are also some potential limitations to using them. Over-reliance on the debugger. Developers who rely too heavily on the debugger may miss opportunities to improve their coding skills and understanding of the underlying software architecture. They may also become overly dependent on the tool, which can slow down their development process. Performance overhead. Debugging tools can introduce additional overhead into the program, slowing it down and making it less efficient. This can be especially problematic in performance-critical applications, such as video games or financial systems. Complexity. Debugging tools can be complex and difficult to use, especially for developers who are not familiar with the tool or the programming language. This can add to the overall complexity of the development process and make it more difficult to identify and fix errors. Incomplete or inaccurate information. Debugging tools may not always provide complete or accurate information about the state of the program, especially in cases where the error is caused by external factors such as network issues or user input. Security risks. Debugging tools can be used by attackers to identify vulnerabilities in software, making it easier to exploit them. This can be a particular concern in cases where the debugger is included in the production version of the software. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Debugger in IntelliJ IDEA. In this lecture, we will discuss how to use the debugger in IntelliJ IDEA using Java programming. So, first we will write a program, and then we will use the debugger on the program. So, for this, we write a program that creates a for statement using a range of numbers from 1 to 1500 inclusive. You want to save all the numbers when you're looping through that can be divided with both the number 7 and also with 11. In other words, that are found to be divisible by both 7 and also divisible by 11. You print out that number. You also want to break out of the loop once you find 4 numbers that meet those above conditions, and then finally, after breaking out of the loop, Print these 4 numbers you found that have met conditions. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named forloopexample. Then create a main method inside this forloopexample class by right shortcut psvm. In the main method we write int count equals $0 semicolon. Here we declare an integer variable named count and initialize it to 0. This variable will keep track of how many numbers we have found that meet the conditions. Then we write for open parentheses int I equals $1 semicolon, I less than or equal to 1500 semicolon, I plus plus open parentheses, curly braces. Here for is a keyword that starts the loop declaration. And int I equals $1 initializes an integer variable named I and sets its value to 1 at the beginning of the loop. This is the starting point for the loop counter. And I less than or equal to 1500 is the condition that must be true for the loop to continue iterating. The loop will continue as long as I is less than or equal to 1500. And I plus plus is the statement that is executed at the end of each iteration of the loop. It increments the value of I by 1. So, we use a for loop to iterate over the range of numbers from 1 to 1500 inclusive using an integer variable named I as the loop counter. Then we write if open parentheses I modulus 7 equals sign 0 and I modulus 11 equals sign so close parentheses, curly braces. So, if keyword that starts the conditional statement. Then inside it, I modulus 7 equals sign so checks whether the current value of I is divisible by 7. The modulus operator returns the remainder of the division of I by 7. If this remainder is 0, then I is divisible by 7. Then logical an operator requires both conditions to be true for the entire expression to be true. Then second condition, that is I modulus 11 equals sign so checks whether the current value of I is divisible by 11. The modulus operator returns the remainder of the division of I by 11. If this remainder is 0, then I is divisible by 11. Then inside the if condition write system.out.println parentheses double quote numbers divisible by 7 and 11 is colon. Plus I semicolon this statement prints the current value of I concatenate with text to the console. Then write count plus plus semicolon. This statement increments the value of the count variable by 1. So, when the condition in the if statement is true, the code block inside the if statement will execute. It prints the current value of I to the console using the print method and increments the count variable. This count variable is used to track the number of times the condition is true. When count is equal to 4, the loop will break out of the loop using the break statement, which stops the loop from continuing to iterate. So, in this if statement, we use a nested if statement to determine whether the count is equal to 4 or not. For this we write, if open parentheses count equals sign 4 close parentheses curly braces, break semicolon. So, here to check if count has reached the value of 4. If so, use the break statement to exit the loop. So, once the loop is completed, the program will have found 4 numbers that are divisible by both 7 and 11. The program will then print out those 4 numbers to the console. Now we run it. Here is the output after a successful run that are 77, 154, 231, and 308. So, 4 numbers that is divisible by both 7 and 11. Now come to the debugger in IntelliJ IDEA. IntelliJ IDEA provides a debugger for Java code. We don't have to include any plugin to use the debugger for Java. It's already all set up and ready for us to use. So, to use debugger we need to understand first the breakpoints. IntelliJ describes breakpoints as special markers that suspend program execution at a specific point. We can toggle breakpoints on at any line in our code, and then when we execute the code in debug mode, if the code reaches the breakpoint line of code, the process will suspend itself and the process will stay there, suspended indefinitely, until we tell it to rising in some way or we stop the debugging process. The suspended state lets us examine the internals of the code while it's still running. So, let's add some breakpoints. The easiest way to do this is to find the lines of code you're interested in pausing it. For us for this code, I think one logical place to put a breakpoint is where the loop will start, iterate and test the loop condition, and to set a breakpoint. You can simply click here in the gray area to the right of the line number, and you can see that now displays a red circle. That's the indication that we've set a breakpoint. Now that we have a breakpoint, there are several ways to run this code in debug mode. We can right-click on the editor pane, and instead of selecting Run, we can pick Debug right under it. We could simply use that debug icon in the right top part of the IDE window. It's to the right of the right icon. We could click on the Run icon to the left of the main method in the editor window, and this also gives us the option to debug, and there's also a shortcut for it. For me using Windows, that's Shift F9. So whatever way you choose to debug the code, let's just start the debugger. When we do start it, you'll notice that we have a debug tool window displayed now. There should be 3 separate windows. If you don't see the third one on the right, come over here to this icon and click on it. Then you come down here and click on Separate Watches. So, our code started running them, was suspended, and here you can see line 4. This is the location of our first breakpoint, and that's where the code has been suspended. In the center, the debug window has our method arguments and our local variable displayed. Because we are sitting at line 4, we haven't yet started to execute our loop, so count variable is still 0. We haven't started the loop, so we definitely haven't matched any criteria yet. On the right, we can add variables or expressions that we're interested in watching. I think this would be a good place to add the criteria we set up, so let's do that. Where it says Evaluate Expression, I'm going to type in the first part of our criteria IMf&x. Then I'm going to hit this plus icon. This has this expression to what's called the watch list. This means as we progress through the code, we'll see these watched expression change values. You'll note here that we actually have an error with this expression. To start with, cannot find local variable I, and that's because we haven't actually started the loop yet. And that variable doesn't even get created until we start the loop. So right now that variable doesn't exist in the JVM, but we can still have this expression, and I want to add the other part of our condition. So let me do that now. Add IMf&x this time and click the plus icon. Let's actually move forward now. We can do this in a couple of ways. Now see on the left, there are several icons vertically here, and if we hover over those, we see Return for loop example, Modify run configuration, Resume program, Pause program, Stop for loop example, and so on. The 2 we care about right now are Resume program and Stop for loop example. Recent will actually start executing the code from where we paused it. Stop or terminate the debugging session. Some other options we have are the icons shown above these panels. And if we hover over them, we'll see Show Execution Point, Step Over, Step Into, Force Step Into, Step Out, and so on. Now, the one we care about here is Step Over. These icons let us step through the code, we'll execute it line by line, instead of just running it to the next breakpoint or to the end. It is why there is so many options and is relevant when we start executing methods from other methods. Since in this code we're not executing any methods other than main, we can just use the Step Over icon. Let's click that, and you can see IntelliJ first of all is indicating in the main editor window what line of code will be executed next. So now the debugger is sitting at line 5, which is where we'll be testing our criteria, and we're in the loop now. You can see this because I is now showing up as a variable in the middle pane of the debug window, and its value is 1, and look over here to the right where we set our watched expressions, the 2 parts of our condition. These expressions have been evaluated, and their values are shown here. Both cases we can see that I which has the value of 1 has a remainder of 1. This means they have conditioned criteria will be false, because we're testing if these values are equal to 0. In fact, we can add those as expressions too. Let me quickly do that. So what I'm basically doing is adding the 2 sides of our logical and expression that we're testing on line 5. I'm going to add IMf&x equals sign 0. That's the one expression, and IMf&x equals sign 0. That's the second one. Then after we do that, we can see that they're both false, so that means our condition will be false. You can see that the editor window has a lot more information on it in debug mode. So for each line you step through, you can see some of the data on the editor pane as well, which is really pretty neat, and if we step over again, then we're back at the start of the loop and hitting step over here again. You can see we can go through the code line by line. Both IntelliJ editor window and the debugger panel here are telling us the values of the variables. We are now in the second increment of our loop, I is 2. Now watched variables have changed, and we can see remainder is 2 in both cases, and the 2 of our conditional expression are still both false. So now let's change our breakpoint. First of all, toggle line 4 off. Then we'll add a breakpoint on line 5. Their code will pause right before it checks this condition. Instead of stepping through it this time, we'll hit this resume program button, and now the code executes until it hits the breakpoint in the next iteration. Now we hit the resume program button until the I value became 7. Now you can see one of our conditions is true, but not both when I has the value of 7. I'm a Julo 7, and therefore the expression here with equals 0 is true. So again, we'll change our breakpoint because we're only really interested in the numbers that match our criteria. Let's remove the breakpoint from line 5 and edit that line 7. Then when the code gets to that breakpoint, we'll be in this code where we found a match, and now hitting the resume button. We can see that the code is paused now at line 7. I is 77, meaning we're on our 77th iteration of this loop. It took 77 iterations to find the first match. So now let's step through the next couple of lines of code line by line. We do this with the step over icon, and now you can see after stepping over the line, we've increment for the first time count to 1. It also executed our print line statement. We can see this output if we select the console tab here. We could see our output from that line numbers divisible by 7 and 11 is 77. So let's select the debugger tab again, and now we'll hit resume button again, and this will suspend execution when it finds another match. And so then we found another matching number, a number that matches our criteria, and that number is 154, which is the value in I, and if we step through our code line by line after the first step, we see that count gets set to 2 because we've found our second match in step again. I hope you can see how watching the debugger and using some combination of breakpoints, and using the resume and stepping into features to walk through the code can help you understand what the code is doing and where it might be going wrong. There's a lot you can do with this debugger, and I want to encourage you to explore it. I could see after these 2 matches that our code is working correctly. So now we want to change our breakpoint again. I'm going to toggle the breakpoint on line 7, and this time set 1 on line 9. So now if I resume this code, the code will only suspend now at the point where we finally found our 4th match. After finish all iterations, and if we look at the console. And here we can see our 4 matches printed there, 77, 154, 231, and 308. Now our code completes successfully. I hope you learned something useful in this lecture as well, and I'll see you in the next one. The while statements with exercises. In this lecture, we will discuss about while statement in Java. So, the while loop that might seem simpler because it will just continue to execute code until its loop expression becomes false. So, the while loop is used when we don't know how many times we need to execute a block of code. It continues to execute until the condition becomes false. So, the initiation is made before the while loop. Then while loop statement and inside the parenthesis use condition that the loop will execute repeatedly as long as the condition is true. The code within the loop will execute repeatedly until the condition is false. The increment or decrement of the loop is done within the loop. Now start with a simpler example using for loop. So, we write a program to print numbers from 10 to 1 using a while loop. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named whileLoop. Then create a main method inside this whileLoop class by right shortcut PSVN. In the main method we write int number equals sign 10 semicolon. Here we are declaring a new variable named number of type int and initializing it with the value 10. This means that number is assigned the value 10 at the start of the program, and this value will be used as the starting point for the loop. As the loop executes, the value of number will be decremented by 1 until it reaches 1, and each value of number will be printed to the console. Then write while open parentheses number greater than equals to 1 close parenthesis curly braces. In this statement, We are defining a while loop that will execute the code inside the curly braces repeatedly as long as the condition number greater than equals to 1 is true. The condition number greater than equals to be a Boolean expression that is evaluated at the beginning of each iteration of the loop. If the condition is true, the code inside the curly braces is executed. If the condition is false, the loop is exited and execution continues with the next statement after the while loop. In this case, the condition greater than equals to means that the loop will continue to execute as long as the value of number is greater than or equal to 1. The loop will exit when the value of number becomes less than 1. Then write system.out.println parentheses number semicolon. Number minus semicolon. Inside the loop, we first print the value of number to the console using the println method. Then we decrement the value of number by 1 using the number minus statement. The loop will continue to execute as long as the value of number is greater than or equal to 1. On each iteration, the value of number will be printed to the console, starting from the initial value of number and counting down by 1 on each iteration. The loop will exit when the value of number becomes less than 1. Now run this. Here is the output after successfully running, which is a number from 10 to 1. So, when we run this program first at the beginning of the loop, number variable is initialized to 10. Then loop condition number greater than equals to 1 is evaluated and found to be true because number is currently equal to 10. Println statement prints the value of number, which is 10, to the console. Then decrements the value of number by 1, so it now has a value of 9. Then condition is evaluated again and found to be true because number is still greater than or equal to 1 and prints the value of number, which is 9, to the console. And decrements the value of number by 1, so it now has a value of 8. Steps repeat until number has a value of 1 and its printed number variable values 8, 7, 6, 5, 4, 3, and 2. Now it's became 1. So, it now prints the value of number, which is now 1, to the console. Then decrements the value of number by 1, so it now has a value of 0. Then condition is evaluated again and found to be false because number is now less than 1, which terminates the while loop. Now we change the while condition from number greater than or equal to 1 to a Boolean value that is true. If we run it at this movement, the loop runs infinitely because the loop condition is always true and prints numbers from 10 to minus infinite value, and it creates an exception, as you can see. Now stop it by pressing stop button in IntelliJ. So to handle this, we use an if statement and check if the value of the number is less than 1, at which point the loop will immediately terminate. For this we write if open parentheses number less than 1 close parentheses curly braces break semicolon. Here the if statement checks if the value of the number variable is less than 1. If this condition evaluates to true, the break statement is executed. Then break statement. It is a control statement that is used to terminate the enclosing loop or switch statement immediately. In this case, if the value of number is less than 1, the break statement will cause the while loop to terminate immediately. Now run this. Here is the output after successfully running, which is same as previous. Now we see another example. So, we write a program to find even and odd numbers within a given range using a custom method checkevented. Now, let's start creating this program. Now we create another class file named whileLoop1. Then create a main method inside this whileLoop1 class by right shortcut psvm. Now we create a method first. For this we write public static void checkevenod open parentheses int num close parentheses curly braces. Here the checkevenod method takes an integer argument num and will checks whether it is even or odd. So, then we write if open parentheses num modulus 2 equals sign zo close parentheses curly braces system dot out dot print ln open parentheses num plus double quote is even close parentheses semicolon. Then write else curly braces system dot out dot print ln open parentheses num plus double quote is odd close parentheses semicolon. First we use if statement, and inside it we use condition that is a Boolean expression that checks whether a given number num is even or odd. So, here the modulus operator which calculates the remainder of num divided by 2. If the remainder is 0, then num is evenly divisible by 2, which means that num is an even number. Therefore, if num modulus 2 is equal to 0, then the entire expression num modulus 2 equals sign 0 evaluates to true, which means that num is even, and inside it we print the message num is even. If num modulus 2 is not equal to 0, then the entire expression num modulus 2 equals sign 0 evaluates to false, which means that num is odd, and inside it we print the message num is odd. Now go into main method to call this method and find even and odd numbers. So, first we write int start equals sign 5, end equals sign 11 semicolon. Here we declare two integer variables named start and end, and initialize them to 5 and 11, respectively, and the purpose of these variables is to set our range. Then write while open parentheses start equals sign end close parentheses curly braces check even odd open parentheses start semicolon start plus semicolon. Here we use while loop, and inside it we use the condition start less than equals to end is a Boolean expression that evaluates to true if the value of the variable start is less than or equal to the value of the variable end, and false otherwise. During each iteration of the loop, the condition start less than equals to end is checked. If the condition is true, the code inside the curly braces is executed. So, checkavinod is a method call that passes the current value of start as an argument to the checkavinod method. This method determines whether the number is even or odd, and prints a message to the console indicating which it is. Then start plus is a shorthand notation for start equals sign start plus 1. Which increments the value of start by 1 on each iteration of the loop. Now run it. Here is the output as you can see after successfully run. Here 6, 8, 10 are even numbers and 5, 7, 9, 11 are odd numbers. Now we see another example. So, write a program which creates a method named sumOfDigits with one parameter of type int called number. The method needs to find the first and the last digit of the parameter number passed to the method, using a loop, and return the sum of the first and the last digit of that number. If the number is negative, then the method needs to return -1 to indicate an invalid value. Now, let's start creating this program. For this, we create another class file named whileLoop2. Then create a main method inside this whileLoop2 class by right shortcut psvn. Now we create a custom method by writing public static int sumOfDigits open parentheses int number close parentheses curly braces. Then inside it we write if open parentheses number less than 0 close parentheses curly braces return -1 semicolon. So here, the sumOfDigits method takes an integer parameter number and will returns the sum of the first and the last digit of that number. If the number is negative, it returns -1 to indicate an invalid value. This check for negative numbers is done using an if statement with a condition number less than 0. If the condition is true, the method immediately returns -1, indicating that the input number is invalid. This is important because the calculation of the first and last digits is only possible for non-negative numbers. Then we write int last digit equals sign number modulus 10 semicolon, int first digit equals sign number semicolon. After checking for negative numbers, the method first calculates the last digit of the input number using the modulus operator. This is done by taking the input number and computing its remainder when divided by 10. For example, if the input number is 1234, then the last digit will be 4. Next, the method calculates the first digit of the input number. For this, the first digit is initialized to number variable. Then we write while open parentheses first digit greater than equals to 10 close parentheses curly braces first digit divided by equals sign 10 semicolon. Here a while loop is used to repeatedly divide it by 10 until it becomes less than 10. At each iteration, the result of the division is assigned back to first digit. For example, if the input number is 1234, the while loop will divide it by 10 3 times, resulting in first digit being assigned the value 1. The right return first digit plus last digit semicolon. Finally, the method returns the sum of the first and the last digit, which is computed by adding the values of first digit and last digit. For example, if the input number is 1234, the sum of the first and last digit will be 1 plus 4 equals 5. Now go into main method to call this method and find sum of first and last digit. For this, first we write int number equals sign 1, 2, 3, 4, 5, 6 semicolon. Int sum equals sign open parentheses sum of digits number close parentheses semicolon. Here we creates an integer variable number and assigns it the value 1, 2, 3, 4, 5, 6. And then calls the sum of digits method with number as the argument, and assigns the returned value to an integer variable sum. Then we write system.out.println open parentheses double quote sum of first and last digit of plus number plus double quote is plus sum open parentheses semicolon. Here, we use the println method to print a message to the console. Here, sum of first and last digit of is a string literal that describes the purpose of the message, and number is a variable that contains the number for which the sum of first and last digit is computed, and is another string literal that separates the message from the computed sum, and sum is a variable that contains the computed sum of the first and last digits of the number. Here, the plus operator is used to concatenate these different parts into a single string. Then we write number equals sign minus 123 semicolon. Sum equals sign open parentheses sum of digits number close parentheses semicolon. Write system.out.println open parentheses double quote sum of first and last digit of plus number plus double quote is plus sum open parentheses semicolon. Here we assigns minus 123 to number and repeats the same process, calling the sum of digits method and printing the computed sum to the console, but this time we use a negative value. Now run this. Here is the output after successfully running, which is sum of first and last digit of 1, 2, 3, 4, 5, 6 is 7. Sum of first and last digit of minus 123 is minus 1. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Do-while statements with exercises. In this lecture, we will discuss about do-while statement in Java. Do-while loop is like the while loop, except that it will always execute the code once, regardless of whether the loop condition is true or false, and then continue looping until that expression is false. The do-while loop in Java is commonly used in situations where you need to execute a code block at least once, and then continue to execute it as long as a certain condition is true. Some common use cases for do-while loops include reading user input. When reading user input, you may want to ensure that the user enters valid data before continuing. A do-while loop can be used to repeatedly prompt the user for input until valid input is provided. File or database processing. When reading data from a file or database, a do-while loop can be used to read each record until the end of the file or database is reached. The code block would contain the code to read each record, and the loop condition would check whether there are more records to read. Performing calculations. A do-while loop can be used to perform calculations until a certain condition is met, such as reaching a certain value or achieving a certain level of accuracy. Iterating through collections. When iterating through collections, you may want to execute a block of code for each element in the collection. A do-while loop can be used to ensure that the code is executed at least once, even if the collection is empty. Implementing game logic. In game development, a do-while loop can be used to implement game logic that repeats until a certain condition is met, such as the player completing a level or achieving a certain score. Now start with a simpler example using do-while loop. For this, open IntelliJ. Here we create a class file named whileloop5. Then create a main method inside this whileloop5 class by right shortcut psvm. In the main method we write int I equals sign 6 semicolon. Here we declare a variable named I of type int and initialize it with the value 6. The purpose of declaring I as a variable is to use it in the do-while loop. Now we write keyword do then curly braces, and inside this curly braces we write system.out.println parentheses I semicolon. I plus plus semicolon. Then outside of the close curly brace we write while open parentheses I less than 5 close parentheses semicolon. The loop starts with the do keyword, which indicates the beginning of the loop. The code inside the loop will be executed at least once, regardless of the condition specified in the while statement. The code inside the loop consists of two statements. Print method. This statement prints the current value of the variable I to the console. I plus plus. This statement increments the value of the variable I by 1. Then condition in the while statement is I less than 5, which is false when I is equal to or greater than 5. This means that the loop will continue to execute as long as I is less than 5. However, since the initial value of I is 6, the loop condition is already false, so the loop will execute at once and only 6 printed to the console. Now run it. Here is the output after successfully run, that is 6. Now we will see another example. So, we write a program calculates the sum of integers from a given range, using a do-while loop. Now start creating program. For this, we create a class file named whileLoop6, then create a main method inside this whileLoop6 class by write shortcut psvm. In the main method we write int x equals sign 21 comma sum equals sign zo semicolon. Here we initializes two variables, x and sum. So, x is being initialized to the value 21, and sum is being initialized to the value 0. This means that x will be used as the starting point for the summation loop, and sum will be used to accumulate the total sum of values. Then we write do curly braces sum plus equals sign x semicolon x minus minus semicolon. Then write outside the curly braces while open parentheses x greater than 10 close parentheses. Here we use do keyword to start the do while loop. Inside the curly braces, the statement sum plus equals sign x adds the current value of x to the sum variable. The statement x minus minus decrements the value of x by 1. This means that the next time the loop executes, it will add the new value of x to sum. The loop condition x greater than 10 is evaluated at the end of each loop iteration. If the condition is true, the loop continues executing. If the condition is false, the loop exits. So, the loop continues to execute as long as x is greater than 10. Since x is initially set to 21, the loop will execute 11 times once for each value of x from 21 down to 11. During each iteration of the loop, the value of x decreases by 1, and the current value of x are added to sum. When x becomes 10 or less, the loop condition x greater than 10 is no longer true, and the loop exits. At this point, the program has calculated the sum of integers from 21 down to 11, which is stored in the sum variable. Then we write below the while, system.out.println open parentheses double quote summation, plus sum close parentheses semicolon. The line of output includes a string literal summation, and the value of the sum variable concatenated together using the plus operator. This is called string concatenation, and it combines the two values into a single string that is printed to the console. So, the output of this line of code will be a message that includes the string summation, followed by the value of the sum variable. Now we run it. Here is the output after successfully run, that is summation, 176. Now we review this program. So, first initializes two variables, x with a value of 21, and sum with a value of 0. The code then enters a do while loop. The body of the loop first adds the current value of x to sum, and then decrements x by 1. This process continues as long as the value of x is greater than 10. So the loop will execute 11 times from x equals sign 21 to x equals sign 10. And in each iteration, the value of x is added to the variable sum. Thus, the final value of sum will be the sum of all integers from 21 down to 11, inclusive. The result of the program is outputted using system.out.println, which prints the string summation, followed by the value of sum. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Nested loop with exercises. In this lecture, we're going to move on now to talk about the introduction to nested loop. Nested loops are loops that are defined inside other loops. They are used when you need to repeat a set of instructions multiple times, where each repetition requires another loop. Here is the basic structure of a nested loop using for loop. Here the outer for loop is initialized with an integer variable I and a starting value of 0. The loop condition I less than outer limit is checked before each iteration of the loop. If the condition is true, the loop body is executed. Otherwise, the loop exits. The loop body consists of the code inside the curly braces. This code will be executed once for each value of I that satisfies the loop condition. Inside the loop body, There is another for loop, called the inner loop. This loop is also initialized with an integer variable j and a starting value of 0. The loop condition j less than inner limit are checked before each iteration of the inner loop. If the condition is true, the inner loop body is executed. Otherwise, the inner loop exits and control returns to the outer loop. The inner loop body consists of the code inside the curly braces. This code will be executed once for each value of j that satisfies the loop condition. After the inner loop body finishes executing, the control returns to the inner loop condition, which is checked again. If the condition is true, the inner loop body is executed again. Otherwise, the inner loop exits and control returns to the outer loop. The outer loop continues to iterate until the loop condition I less than outer limit is no longer true. At that point, the entire nested loop construct exits. Note that the variables I and j can be replaced with any valid Java variable name, and the starting values and loop conditions can be adjusted as needed to suit the specific task being performed with the nested loop. Now we start nested loop with a simple program. So, we write a program of a nested for loop that prints a multiplication table from 1 to 10. Let's start creating program. For this, open IntelliJ. Here we create a class file named nestedloop. Then create a main method inside this nested loop class by write shortcut psvm. Inside the main method, we write for open parentheses int I equals sign 1 semicolon, I less than equals to 10 semicolon. I plus plus close parentheses curly braces. Here the outer for loop is initialized with an integer variable I and a starting value of 1. The loop condition I less than equals to 10 is checked before each iteration of the loop. If the condition is true, the loop body is executed. Otherwise, the loop exits. Then we write inside the body of outer loop. For open parentheses in j equals sign 1 semicolon, j less than equals to 10 semicolon, j plus plus close parentheses curly braces, system.out.print open parentheses, I multiply by j plus double quote backslash t close parentheses semicolon. Here inside the loop body, there is another for loop, called the inner loop, which is also initialized with an integer variable j and a starting value of 1. The loop condition j less than equals to 10 is checked before each iteration of the inner loop. If the condition is true, the inner loop body is executed. Otherwise, the inner loop exits and control returns to the outer loop. The inner loop body consists of the code inside the curly braces. This code will be executed once for each value of j that satisfies the loop condition. Inside the inner loop body, we use the system.out.print method to print the product of I and j, followed by a tab character \t. This will print each value of the multiplication table on the same line, separated by tabs. After the inner loop finishes iterating through all the values of j, a new line is printed out to start a new row in the output. For this, we write system.out.println parentheses. This is used to separate the output of each row of the multiplication table. After the inner loop has printed the values of I multiply by j for all values of j for a given value of I, print method is called to move the cursor to the next line and start a new row of output. Without this statement, all the values of I multiply by j would be printed on the same line, making the output difficult to read. Now we run it. Here is the output after successfully run that prints tables from 1 to 10 using nested for loop. Here, the first row is the table of 1, the second row is the table of 2, and so up to the last row, which is the table of 10. When the program runs, in the first iteration of the outer loop, I equals sign 1. The inner loop runs 10 times, with j equals sign 1, j equals sign 2, and j equals sign 3, up to j equals sign 10 respectively. For each value of j, the product I multiply by j is printed, separated by a tab character. So the output for this iteration is 1, 2, 3 up to 10. In the second iteration of the outer loop, I equals sign 2. The inner loop runs 10 times again, with j equals sign 1, j equals sign 2, and j equals sign 3, up to j equals sign 10 respectively. For each value of j, the product I multiply by j is printed, separated by a tab character. So the output for this iteration is 2, 4, 6, 8 up to 20. In the third iteration of the outer loop, I equals sign 3. The inner loop runs 10 times again, with j equals sign 1, j equals sign 2, and j equals sign 3, up to j equals sign 10 respectively. For each value of j, the product I multiply by j is printed, separated by a tab character. So the output for this iteration is 3, 6, 9, up to 30. Similarly, this process continues with the changes in the value of I that increment with every iteration. So, in the 10th iteration of the outer loop, I equals sign 10. The inner loop runs 10 times again, with j equals sign 1, j equals sign 2, and j equals sign 3, up to j equals sign 10 respectively. For each value of j, the product I multiply by j is printed, separated by a tab character. So the output for this iteration is 10, 20, 30, 40, up to 100. In the 11th iteration of the outer loop, I equals sign 11. When the condition was checked, it became false. So the inner loop is already complete, and the outer loop condition is now false. So it's time to exit the outer loop, and program execution is complete. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Local variables. In this lecture, we will talk about local variables and its scope. In the past couple of lectures, we have looked at many of Java's flow statements, the switch statement, for statement, the while statement, as well as the do while statement. All of these statements may and probably will have their own code blocks. We have talked about code blocks quite a bit, but we haven't really talked about variables declared locally to many of these code blocks. A local variable is called local because it is available for use by the code block in which it was declared. It is also available to code blocks that are contained by declaring block. In other words, in Java, a local variable is a variable that is declared within a block of code, such as a method, loop, or conditional statement, and its scope is limited to that block of code. This means that the variable can only be accessed within the block where it was declared, and once the block is exited, the variable is no longer accessible. Local variables are commonly used to store temporary data or intermediate results within a method. They are also used to pass arguments to a method, where the value of the argument is assigned to a local variable within the method. In the example, we have two variables declared at the start of a code block. We use the first number variable in an if-then statement expression that could print the second number variable inside of the if statement block. If block is contained by the method block and has access to the method block's variables, as this demonstrates. This accessibility is also known as variable scope. Scope describes the accessibility of a variable. It means the variable can be used by an executing block or any nested blocks. Out of scope means the variable is no longer available. Local variables are always in scope in the block they are declared. They are also in scope for any nested blocks or blocks contained within the outer block. So for example, a method block can declare local variables, and any flow statements contained in the method block will have access to the method's local variables. This is also true for the method parameters. Any code in the method and any nested blocks have access to the parameters. There's no limit to how deep can this code blocks, but generally for readability and maintainability, consider replacing deeply nested blocks with method calls. Local variables are always out of scope for out of blocks or the containing blocks they are declared in. Let's look at an example. In this example, we have declared a local variable called newNumber inside the block. This means newNumber will be able to scope for any containing blocks. The method block is the containing block in this instance. You can see that the systemout.print statement outside of the block can't use a variable declared inside they have block. This line of code will cause a compiler error. IntelliJ shows this error with cannot resolve symbol by newNumber. There are some best practices when declaring variables in different blocks, which we'll briefly discuss now. To declare and initialize variables in the same place, if possible, and to declare variables in the narrow scope possible. It is much clearer to declare and initialize a variable, if possible, in a single statement. There are times when this is not always feasible, but when it is, you should do this. Declaring variables in the narrow scope simply means if your variable are only used in a nested block, declare it there. Another example that we have seen if you're using a variable only in the loop code block, like the iteration variable, and won't be using it outside of the loop block, declare it in the loop code or in the for loop initialization block. Obviously, this is a practice we can implement with a for loop because of its special declaration support for initialization, but this is harder to do with a while loop. Let's revisit the for statement and look at local variables. In this for statement, as part of the declaration, there is an initialization part as we have described. In this case, we declared a variable I that is inaccessible outside of the loop. This is because any variables declared in the intersection are local to the loop, meaning they exist and are accessible in memory only while the loop is executing and only to the loop code block. This is also true for most flow statements, for example the if statement. Local variables declared in an if statement block and not accessible outside of that block. This also includes other parts of the if statement like the else if block or the else block. If you try the code on this slide in the method, you would get an error on the 2 lines indicated. The variable is only in scope for the block declared in the first part of the statement. However, the switch statement is different from the if-else statement blocks. Consider the code below. In the left and right braces are optional in a switch statement. The code block is whatever is after one case label and before the next case label, including the break statement. However, the case block has different access for local variables than the if-else block. In a switch statement, a variable declared in one case label code block can be accessed in another case label code block, but only if that block is after the declaration and initialization of the variable. As you can see in the example here, in the default code block we had access to the variable I, and this did not cause an error. Let's look at another example of code blocks and local variables in the switch statement. In the first case label block, the code is trying to use the old variable, but it's not declared until the case 2 block. So we get an error when we try to use it in the case 1 block. However, as previously shown, we don't get an error in box declared below the case 2 block. But again, we get an error if we try to use the local variable by outside of the switch block altogether. So that's it for local variables in scope. In addition to local variables, we could set up data to be defined and used as part of a class or an object. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Class and object. In this lecture, we will talk about class and object. First, we discuss attributes of classes. After that, we discuss the ways to store data. Second, I want to introduce you to some static methods on the wrapper classes, which are classes we previously looked at, but we have not used any methods on these classes yet. These methods will help pass strings into numeric values. And finally, I want to introduce you to a special class for reading input, which we will be using in the last part of this section to create an interactive program. Before you use that class, it will help if we understand some very basic concepts with classes. The class can be described as a custom data type, a special code block that contains methods. We have already talked about the class a little, both as a custom data type and a special code block that contains methods related to the class. What we have not talked about is the class's unique role in creating objects in memory. The class is like an empty form. It describes information, or placeholders, for data that will be filled in when that form is given to a unique individual. The class may have a field for name. The object will have a value in the name field which will be unique to the object. The class may have a field for address. The object will have values for the address field, and so on. The process of copying that empty form and then delivering it to some process or person to fill in the blanks is a loose analogy to what happens when you create an object. The empty form, the class, is the template for the data to be collected. The populated form, the object, may be completely different each time because of the values used to fill in the data. But the data being collected each time is determined by the class or the form in this analogy. An object is called an instance of a particular class. In this course, we will often use the word instance interchangeably with object. This means an object is created by instantiating a class. There are multiple ways to do that, and we will be talking about that more in a bit. This shows a class that has 5 objects or instances created from it. We called the creation of the object instantiation or instantiating a class. We can use the term object or instance interchangeably. There is no limit to the number of objects you can create from a class. The class is sometimes compared to a cookie cutter, and the cookies are your objects. The class provides a shape or framework that describes the object being created. A template is another word you'll hear used when trying to describe a class as relationship to an object. We are going to cover some very simple basics about classes right now. The most common way to create an object is to use the new keyword. The new keyword creates an instance, and you can sometimes pass data when creating an instance to set data on that object. The string is special because we can create a string just by using a literal, which we have seen. But we could also use new. Like other data types, you can assign this object's memory location, also called a reference to a local variable, as we have done with this string. We have assigned to the local variable company name and instance of string, or manipulation of the object's data and methods are then done using the local variable name. In both of these statements, we are creating a new object of type string and initializing it with the text nixware and assigning it to a string variable named. The second statement makes this a bit clearer. When we create an object, we can pass initial data to be associated with it in parentheses. We have stated previously that the class can be thought of as a special data type. This is because you can create variables on classes. These are called fields or attributes on the class or object. There are two ways to create fields on classes. What is with the static keyword and what is without the static keyword? When the static keyword is used, it's called a static field on the class. This means the value of that field always stays with the class. It's stored in a special memory location for values that are changing constantly, unlike local variables and objects. In our form analogy, this would be a field that is pre-populated on the form and would not change for any of the copied forms. But unlike the form, this type of field in a class does not really get copied down to the object. It maintains a single value on the master. Copy the class. The field in memory is accessed differently because we can access that field using the class name with dot notation, and we have done that already. When the static keyword is not used, it's called an instance field. Until the class is instantiated and an object created, the instance field has no place in memory. These instance fields can have different values for every instance created. This field is accessed using the variable name for the object and the dot notation used with the field name. In the same way that there are static fields and instance fields, there are static methods and instance methods. Again, the static keyword is used to differentiate these two kinds of methods. A static method can be called directly using the class name and dot notation. In other words, you don't need an instance to use this method. An instance method requires an instance exists first and the method be called on that instance. In the example shown here, I am showing you that a string literal with a value nixware is really an object of type string. The string class has many instance methods defined on it, which we can use to manipulate strings. One of these is the toUpperCase methods, which simply returns a string with all uppercase letters. So the result of this call would be a new string with the value nixware all in capital letters. The most important difference to remember right now is that to use an instance method, you have to create an instance or object first. We have seen lots of examples of static methods, since that's all we have used so far in the course. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Parsing values and user input with exercises. In this lecture, we will talk about how to parse data and also discuss how to get user input. Now, first we open IntelliJ and create a class file named parseValues, and inside this calls create a main method using shortcut PSVM. We'll create two variables which will emulate data coming in from a user, either from an input file, a console, or even some user interface. These variables are the current year and the birth year. For this, we write inside the main method string current year equals sign double quote 2023 semicolon. String birth year equals sign double quote 1992 semicolon. So now let's say we want to get the person's total age from this data. So to get a person's age, we just subtract the birth year from the current year and would be relatively close to their age in years. Let's add a print statement that will print out the total age, And we'll just put the equation system .out.println opening parentheses double quotes total age equals plus opening parentheses current year minus birth year close double parentheses semicolon. So now we have a problem. And if we hover over the IntelliJ, that we find out that the operator minus cannot be applied to string and string. Let's try the plus operator. Since the operators we just looked at indicated that the plus sign was a valid operator for strings. And the good news is that this compiles. Let's run this code, and you can see we get a number that doesn't look like. Actually, this isn't a number at all, but a string, and what happened was the two strings uses, birth year and current year, were not added together, they were concatenated together. The solution to this is to parse the value from a string into integer values. In Java, parse typically refers to the process of converting a string representation of a value into an actual value of a particular data type. Parsing values in Java is necessary when you need to convert data from one format to another. For example, if you are reading input from a user or a file, the data is often in the form of strings, but you may need to perform calculations or comparisons using numerical values or other data types. By using parsing methods in Java, you can convert the string representation of a value into an actual value of the desired data type. This allows you to perform operations on the value as needed. Additionally, parsing can be useful for error checking and validation, as it allows you to verify that the input is in the expected format before attempting to use it. So, parsing values in Java is an important tool for working with different data types and formats, and it allows you to manipulate and transform data as needed in your Java programs. Here are some common parse methods in Java for converting string values to different data types, like integer.parseInt parentheses string str converts a string to an int value. Double.parseDouble converts a string to a double value. Float.parseFloat converts a string to a float value. Long.parseLong converts a string to a long value. Short.parseShort converts a string to a short value. Byte.parseByte converts a string to a byte value. Boolean.parseBoolean converts a string to a Boolean value. Character.toString converts a char value to a string value. Wrapper classes and wrapper methods in Java are related to parsing in that they provide a way to convert between primitive data types and their object-oriented counterparts. When parsing a string value into a primitive data type, you can use the appropriate wrapper class to perform the conversion. For example, to parse a string value into an int, you can use the integer.parseInt method, which takes a string parameter and returns an int value. This method uses the integer wrapper class to perform the conversion. Similarly, the double.parseDouble method uses the double wrapper class to convert a string value to a double, and the boolean.parseBoolean method uses the boolean wrapper class to convert a string value to a boolean. Wrapper classes and wrapper methods can also be used for formatting and manipulating values of primitive data types. For example, the integer.toString method can be used to convert an int value to a string value, and the double.value of method can be used to convert a double value to a double object. Now we use these methods in our code to parse the string value to integer value. First, we change string to int of current year variable data type and remove the double quote around the value 2023. For this, we write int my birth year equals sign integer dot parse int open parentheses birth year close parentheses semicolon. Then we'll change the expression in the system println statement. We'll change plus to minus, and we'll change the variable from birth year to my birth year, which is now an integer. So, what's this code doing? It's converting a string with a value of 1992 and returning an integer with the value 1992. But what is this really? Well, we know what to choose a class. It's not an object. In this class, there's a static method called ascent that takes a string and returns an integer. And we just saw to access static methods on the class, we have to use the class name and the dot notation and the name of the method. So in other words, what we're really doing is we're calling a method on the class named integer. We can only call static methods this way, so passing is a static method on the class integer. Let's run this code. And then we have a result that looks right. Parse_double is very similar. Now let's talk about input data. So, where that input might come from. This is often either in the form of an input file, a console, or some kind of user interface? Well, this lecture and the ones immediately following, we're going to be soliciting input from the console. When reading data from the console, we have some different options. Like system.out, Java provides system in which can read input from the console or terminal. It's not easy to use for beginners, and lots of code has been built around it to make it easier. System.console is Java's solution for easy support for reading a single line and prompting the user for information. Although this is easy to use, it doesn't work with IDs because these environments disable it. Command line arguments can be passed in when we execute a Java program from a command line or terminal, and we can specify data directly in that call. This is very commonly used, but doesn't let us create an interactive application in a loop in Java. The scanner class was built to be a common way to read input, either using system.in or file. For beginners, it's much easier to understand than the bare-bones system.in. Let's get back to our code. We'll delete everything here. First, we'll be looking at system.console, and I'll show you a way to run the code using IntelliJ terminal. So next I'm going to set up a method. So, we'll use system.console. So, we write public static void from console, parentheses, curly braces. And inside this method, we write string name equals sign system.console parentheses dot read line open parentheses double quote what is your name? Close parentheses semicolon. System.out.println open parentheses double quote your name is, plus name close parentheses semicolon. This method uses the system.console method to access the console and read input from the user. The readLine method prompts the user with the message, "What is your name?" and waits for the user to input a response. The user's input is stored in a string variable called name. After the user enters their name, the method prints a message to the console that includes the user's name. The message is constructed using the concatenation operator plus to combine the string your name is with the user's input stored in the name variable. Now we call this method in the main method. For this we write from console parentheses semicolon. Now we run it. So, when the first time we run this, we see we get an error. Why? Because system console can't be used in IntelliJ. Because IntelliJ is disabled the console. So this area is expected. Instead, we'll have to either run this from a command line or terminal session. And because IntelliJ enables us to have a terminal session inside of its application, we can use that in IntelliJ. You should see at the bottom of the screen where your output is printed that there are other tabs. We want to select terminal, and then we'll type in Java src parsevalues.java. Parsevalues.java is the name of our source files, and then we'll hit enter. Now the terminal window is prompting us to enter data. And I'll talk in John and press enter. And now the code completes with the message that your name is John. Now our code is complete. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Scanner with exercises. In this lecture, we will talk about Introduction to Scanner. So, the Scanner class is a class in Java's standard library that allows for reading user input or other types of input, such as files or strings. It provides methods for parsing and interpreting different types of input, including integers, floating point numbers, characters, and strings. The Scanner class can be used to read input from various sources, such as the console or a file. It can be instantiated with various constructor methods depending on the source of input. Once instantiated, the Scanner class provides various methods for reading input. So, there are some of the commonly used methods of the Scanner class in Java, like next parentheses. This method reads the next token from the input stream as a string and returns it. The token is delimited by whitespace by default. Next int parentheses. This method reads the next token from the input stream as an int and returns it. It throws an exception if the next token cannot be parsed as an integer. Next line parentheses. This method reads the next line of input from the input stream as a string and returns it. It reads until it encounters a new line character or end of input. Have next parentheses. This method returns true if there is another token available in the input stream. It returns false otherwise. Use delimiter parentheses. This method sets the delimiter pattern for the scanner. The default delimiter pattern is whitespace has nextInt parentheses. This method returns true if the next token in the input stream can be parsed as an int. It returns false otherwise. Next double parentheses. This method reads the next token from the input stream as a double and returns it. It throws an exception if the next token cannot be parsed as a double. Next boolean parentheses returns the next token from the input stream as a boolean. Next byte parentheses returns the next token from the input stream as a byte. Next short parentheses returns the next token from the input stream as a short. Next long parentheses returns the next token from the input stream as a long. Close parentheses closes the scanner and releases any system resources associated with it. So, the scanner class is described as a simple text scanner which can pass primitive types and strings. To use the scanner class, we have to create an instance of scanner. You remember this means we're creating an object of type scanner. We will use the keyword new to do it. The new keyword is used in what Java calls a class instance creation expression. In its simplest form, it's the word new followed by the class name and empty parentheses. And often in many cases, we can pass parameters in the parentheses, as we saw with methods. And we saw that we could do this with the string class, passing the text in the parentheses. For reading input from the console or terminal, we instantiate a scanner object using new followed by the scanner class name and passing in system.in in the parentheses. For reading input from a file, we instantiate a scanner object using new, again with the scanner class name, but pass in a file object in the parentheses. Follows another class provided by Java for reading and writing files. We will talk about file input later. We have not talked about the import statement yet, but this statement lets us use classes from other people's code. In this case, Java provides a library of code, which includes the scanner class in a library called java.util. Go back. When we configured IntelliJ with a number of different settings, I recommend that you enable these two options in the auto import menu. Add an ambiguous imports on the fly and optimize imports on the family. If you enable these options, then IntelliJ will automatically add and will remove import statements as required. Now we see an example. For this, write a Java program that takes user input for their name and age, and then displays their name. The program should prompt the user to enter their name and age, read the input using a scanner object, and then print out the user's name. Specifically, the program should do: create a scanner object to read input from the user. Prompt the user to enter their name. Read the user's name input from the command line using the next line method of the scanner object. Print out the user's name using system.out.println. Close the scanner object to release any system resources associated with it. Let's start to create this program. For this, open IntelliJ, and then create a class file named scannerExample, and inside this class create a main method using shortcut psvm. First, we need to use the scanner class. So, we need to import it at the beginning of our Java program using the import statement like import java.util.scanner . Now inside the main method, we write scanner equals new scanner open parentheses system dot in close parentheses semicolon. Here we create a new scanner object named scanner that is associated with the standard input stream that is the command line. The system.in argument passed to the scanner indicates that we want to read input from the command line. Here scanner is the name of the class we are using to read input. This scanner is the name of the scanner object we are creating. You can name it anything you like. New is used to create a new object. Scanner system.in. This call creates the new scanner object. The system.in argument tells the scanner object to read input from the command line. Then we write system.out.print open parentheses double quote enter your name, close parentheses semicolon. String name equals scanner.nextLine parentheses semicolon. Here println method is used to display a message to the user. It does not add a new line after the message, so any subsequent output will be displayed on the same line. Enter your name. This is the message that is displayed to the user. It prompts them to enter their name. String name. This declares a new variable named name that will store the user's name input. Scanner.nextLine. This method reads a line of input from the user using the scanner object named scanner. It waits for the user to enter input and press the enter key. The input is returned as a string object. After these lines of code execute, the name variable will contain the user's name input, which we can then use in our program as needed. Then we write system.out.print open parentheses double quote enter your age, close parentheses semicolon. Int age equals scanner.nextInt parentheses semicolon. Here print method displays a message to the user, asking them to enter their age. The message is displayed on the console, or wherever the output stream of the program is directed to. Then the nextInt method of the scanner object to read an integer input from the user. The input is read as an int value and is stored in the age variable. Then we write system.out.println open parentheses double quote your name is plus name plus double quote, and you are plus age plus double quote years old close parentheses semicolon. Here print method is used to display a message to the user. It adds a new line after the message, so any subsequent output will be displayed on a new line. Your name is. This is the first part of the message that is displayed to the user. It tells them that we are going to display their name. Name. This part of the message includes the user's name. The plus operator is used to concatenate the string literal your name is with the value of the name variable. The result is a new string that includes the user's name. And you are. This is the second part of the message that is displayed to the user. It tells them that we are going to display their age. Plus age plus years old. This part of the message includes the user's age. The plus operator is used to concatenate the string literal and you are with the value of the age variable, and then concatenate the resulting string with the string literal years old. The final result is a new string that includes the user's age. Then finally write scanner.close parentheses semicolon. This line of code calls the close method on the scanner object named scanner. This is used to release any resources that the scanner object is using, such as file handles or network connections. It's generally a good practice to close any resources that your program opens or uses to prevent memory leaks and ensure that resources are released in a timely manner. In this case, closing the scanner object is not strictly necessary, since we are only reading input from the console and the scanner object is not holding any significant resources. However, it's still a good practice to close it. Now run it. First display message that enter your name. Now we write John and press enter. After that it displays another message that is enter your age. Now we write 31 and press enter. Finally, it displays that your name is John and you are 31 years old. Now see another example. So, write a program that have a method named shared digit with two parameters of type int. Each number should be within the range of 10 inclusive to 99 inclusive. If one of the numbers is not within the range, the method should return false. The method should return true if there is a digit that appears in both numbers, such as 2 and 12 and 23. Otherwise, the method should return false. Let's start to create this program. For this, we create another class file named scannerExample1. Now first we need to use the scanner class. So we need to import it at the beginning of our Java program using the import statement like import java.util.scanner semicolon. Now we create a custom static method by writing public static boolean shared digit open parentheses int num1 comma int num2 close parentheses curly braces. Here, we create shared digit that takes two integer parameters num1 and num2. The method is defined with the public static modifiers, which means it can be accessed from outside the class and can be called without creating an instance of the class. The method returns a boolean value of true or false. Then inside this method, we write if double open parentheses num1 less than 10 or num1 greater than 99 close parentheses or open parentheses, num2 less than 10 or num2 greater than 99 double close parentheses curly braces. Return false semicolon. Here inside the method, we use if statement that checks whether num1 and num2 are within the range of 10 to 99 inclusive. If either num1 is less than 10 or greater than 99, or num2 is less than 10 or greater than 99, then the method returns false because at least one of the two numbers is outside the valid range. The operator is a logical or operator, which means that if either the left or right condition is true, the entire expression will evaluate to true. In this case, if either num1 or num2 is outside the valid range, the entire expression will evaluate to true, causing the method to immediately return false. If both numbers are within the valid range, the code will continue to check for a shared digit. Then we write in digit 1 equals num1 modulus 10, int digit 2 equals num1 divided by 10 semicolon, int digit 3 equals num2 modulus 10 semicolon, int digit 4 equals num2 divided by 10 semicolon. Here, if both numbers num1 and num2 are within the range, the method extracts the 1s and 10s digits of each number using the modulus and integer division operators, and stores them in digit 1, digit 2, digit 3, and digit 4 variables. So, here num1 modulus 10 gets the remainder of num1 divided by 10, which gives us the 1s digit of num1. For example, if num1 is 23, then num1 modulus 10 will give us 3. Num1 divided by 10 gets the integer quotient of num1 divided by 10, which gives us the 10s digit of num1. For example, if num1 is 23, then num1 divided by 10 will give us 2. Similarly, num2 modulus 10 and num2 divided by 10 give us the 1s and 10s digits of num2, respectively. The extracted digits are then assigned to the variables digit 1, digit 2, digit 3, and digit 4, respectively. By extracting the individual digits of the input numbers, we can compare them against each other to check if there is any shared digit between them. Then we write return open parentheses digit 1 equals digit 3 or digit 1 equals digit 4 or digit 2 equals digit 3 or digit 2 equals digit 4 close parentheses semicolon. This line of code is checking whether there is a shared digit between num1 and num2. It does so by checking if digit 1, which represents the 1s digit of num1, is equal to digit 3, the 1s digit of num2, or if digit 1 is equal to digit 4, the 10s digit of num2. If either of these conditions is true, then there is a shared digit between num1 and num2. Similarly, it checks if digit 2, which represents the 10s digit of num1, is equal to digit 3 or digit 4. If either of these conditions is true, then there is a shared digit between num1 and num2. The operator is a logical or operator, which means that if any of the conditions are true, the entire expression will evaluate to true. Therefore, if any of the 4 conditions in the return statement are true, the method will return true, indicating that there is a shared digit between the two numbers. Otherwise, it will return false. Now we create a main method by using shortcut PSVM. Inside this method, we write scanner equals new scanner open parentheses system dot in close parentheses semicolon. Here a new instance of the scanner class is created and assigned to the variable scanner. The argument system dot in indicates that the scanner will read input from the standard input stream, which is usually the keyboard. Then write system.out.println open parentheses double quote enter the first number open parentheses between 10 to 99 close parentheses colon close parentheses semicolon. Int set num1 equals scanner dot nextInt parentheses semicolon. System.out.println open parentheses double quote enter the second number open parentheses between 10 to 99 close parentheses colon close parentheses semicolon. Int set num2 equals scanner dot nextInt parentheses semicolon. Scanner dot close parentheses semicolon. Here print statement is used to print a message to the console or standard output stream without moving the cursor to the next line. In this code, the message enter the first number between 10 to 99 is printed to the console. Scanner.nextInt is used to read an integer value from the standard input stream. It waits for the user to enter a value and press enter, and then returns the integer value entered by the user. In the code int set num1 equals scanner.nextInt, the program waits for the user to enter an integer value and press enter. The entered value is stored in the variable set num1. Similarly, in the code int set num2 equals scanner.nextInt, the program waits for the user to enter another integer value and press enter, and the entered value is stored in the variable set num2. Scanner.close is used to close the scanner object and release any system resources associated with it. It is good practice to close the scanner object when it is no longer needed to prevent resource leaks. Then we write if open parentheses shared digit open parentheses set num1 comma set num2 double close parentheses curly braces. System.out.println open parentheses double quote, there is a shared digit between plus set num1 plus double quote and plus set num2 close parentheses semicolon. Here the if statement checks the return value of the shared digit method with the set num1 and set num2 values as input parameters. If the method returns true, it means that there is a shared digit between the two numbers, and the message there is a shared digit between value 1 and value 1 is printed to the console using the println statement. The values of set num1 and set num2 are concatenated to the string message using the plus operator. Then we write else curly braces system.out.println open parentheses double quote, there is no shared digit between plus set num1 plus double quote and plus set num2 close parentheses semicolon. Here the else statement is executed when the shared digit method returns false, indicating that there is no shared digit between set num1 and set num2. In this case, the message there is no shared digit between value 1 and value 1 is printed to the console using the println statement. The values of set num1 and set num2 are concatenated to the string message using the plus operator. Now we run it. So, first it prints message, enter the first number between 10 to 99. Now we write 12 and press enter. After that it displays another message that is enter the second number between 10 to 99. This time we write 23 and press enter. Finally, it displays that there is a shared digit between 12 and 23. Now we change the value for this, we run this program again. Now we enter 13 and 26. Here you can see the result that there is no shared digit between 13 and 26. Now we see the quick summary of this program. So, this program checks whether two integers in the range of 1099 have at least one shared digit. The program first defines a method called sharedDigit that takes two integer arguments num1 and num2. This method first checks if both integers are within the range of 1099 and returns false if they are not. The method then extracts the ones digit and tens digit of each number using the modulus and division operators and checks if any of these digits are the same in both numbers. If there is at least one shared digit, the method returns true, otherwise it returns false. The main method of the program creates a new scanner object to read input from the user. It prompts the user to enter two integers in the range of 10 to 99, reads the input values using the nextInt method of the scanner object, and then closes the scanner object. It then calls the sharedDigit method with the two input integers and prints out a message indicating whether or not there is a shared digit between the two integers, based on the Boolean value returned by the sharedDigit method. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will discuss about classes and objects with exercises. Now we're going to start talking about object-oriented programming. What is object-oriented programming? Object-oriented programming is a way to model real-world objects as software objects which contain both data and code. OOP is a common acronym for object-oriented programming, and in particular we'll be talking about classes, which is a fundamental component of object-oriented programming in Java, and other languages for that matter. It's sometimes called class-based programming. Class-based programming starts with classes which become the blueprints for objects. But what does this really mean? To start, we need to understand what objects are. So really the key to understanding this object-oriented terminology. What I'd like you to do is just have a look around in the area you're sitting in right now. And if you do that, you'll find that there are many examples of real-world objects. For example, I'm sitting here and I can see a computer. I can see a keyboard. I can see a microphone. I can see shelves on the wall. I can see a door. All of these are examples of real-world objects. Now, real-world objects have two major components: state and behavior. The state in terms of a computer object might be the amount of RAM it has, the operating system it's running, the hard drive size, and the size of the monitor. These are characteristics about the item that can describe it. We can also describe animate objects like people or animals or even insects. The state might be the number of legs, the conscious state, whether the event is sleeping. In addition to state, objects may also have behavior or actions that can be performed by the object or upon the object. Behavior for a computer might be things like shutting down, beeping or outputting some form of sound, drawing something on the screen, and so on. All of this could be described as behaviors for a computer. So modeling real-world objects or software objects is a fundamental part of object-oriented programming. Now, the software object stores its state in fields, which can also be called variables or attributes. Objects expose their behavior with methods. Well, think of a class as a template or a blueprint for creating objects. Let's take a look at the class. The class describes the data fields and the behavior methods that are relevant to the real-world object we want to describe. These are called class members. A class member could be a field, or a method, or some other type of dependent element. If a field is static, there is only one copy in memory, and this value is associated with the class or template itself. If a field is not static, it's called an instance field, and each object may have a different value stored for this field. The static method can't be dependent on any one object state, so can't reference any instance members. In other words, any method that operates on instance fields needs to be non-static. These class or member fields can be thought of as variables, though it's more common to call them fields or attributes. In this lecture, we'll be looking at instance fields to describe our objects. We'll be describing static members in greater detail later in this section's lecture. So as it turns out, you've been using classes all along. Now come to practice and open IntelliJ. Here we create a new project first with name classes and object, and now we create a class file named central class. So, for this we right-click on src folder, and then new then click on class option, here given its name and press enter. Now inside it we create a main method using shortcut psvn. So a question that might come up at this point is what do we need to bother about classes? Or what benefit do classes give us in our everyday programming? Well, think back to the basic data types that we've worked on, the primitive data types that we've explored so far, such as int, short, and those types of things. They're all basic data types, but they're fairly limiting. There's only so much you can do with them. So a case could be made here that a class could be thought of as a powerful user-defined data type. That's not really correct in the true meaning, but it gives you an idea of what classes are. They're really enabling you to have sort of a powerful user-defined type, like a regular data type. So to take this a little bit further, let's create our first real class. As you can see on the screen, every time we create a new project, and here we've created a project called classes and object, we've been creating a new class, usually one called central class with capital C, and we generally had a method called main. So now let's create another class. So we'll click down where it's got src for source. Click on that and right-click. And we kind of create a class with the name of pen, making sure the first letter is capitalized as we've recommended previously. When you're creating classes in Java, the first letter should be an uppercase letter. First thing what I want you to notice is this public class pen. That's actually the statement to create a new class with the name pen. Now the public keyword is an access modifier. This lets us determine what access others will have to this new class that we're creating. We haven't talked about how classes are organized, so let's just look at that briefly before we talk about access. Classes can be organized into logical groupings, which are called packages. He declared package name in the class using the package statement. If you don't declare a package, the class implicitly belongs to the default package. The default package is all we've used so far because we haven't yet introduced the package statement. We're not going to get too deep into packages just yet. There's more on them later in this section. But you do need to understand that classes are grouped into packages to understand access modifiers. A class is said to be a top-level class if it is defined in the source code file and not enclosed in the code block of another class type or method. A top-level class has only two valid access modifier options, public or none. So the word public gives a restricted access to a class. Any code anywhere has access. When we get to Java modules, you'll see that we can refine this further, but for now, public means any code can access this class. Now, usually, at least initially anyway, we're going to be using the public modifier on the classes we create. And when there is no modifier specified at all, Java by default implicitly allows package private access. This means that classes grouped into the same package can access the class. So that's our class defined. But at the moment, it's not very useful because it doesn't actually do anything. Literally, we've created a show. It's like creating a new blueprint. So remember that the class is a blueprint for an object that we're going to be creating. And in this case, it's like virtually starting out on a brand new blueprint and we haven't done anything yet. We've called the blueprint pen, but we haven't described anything else about what we're building at this stage. So what we need to do is create some variables that are part of this class. Now the data you've seen variables used inside a method or code block. And these were called local variables because they were local to or actually belong to that method or code block. But we couldn't access those local variables outside of the method or block we declared them. Classes allow us to create variables that can be seen or accessible by any code block within that class. But we can also allow access from outside the class itself. When we're designing our class, there are some things we want the public to know, and some things that are necessary for the public to know. We can have a public interface. This is only the information the outside board needs to know to use our class. But we'll also have a non-public interface. This is information we may want to share, but not always and not with everyone. We may need to share some information with our own company and other departments, while other data might need to be shared with our manufacturers and dealers, but not with the public. Java gives us the ability to have this kind of control by specifying different access modifiers for each member in the class. An access modifier at the member level allows granular control over class members. The valid access modifiers are shown in this table, from the least restrictive to the most restrictive. Here you can see that public is still an option for class members like it was for the class, and this means there is a restricted access to the member. We also still have no modifier, which means package or package private by default, so that any class in the same package can access this member. We could also use private, which is basically the opposite of public, and that's where no code outside the class can use this field or method. And finally, there's the protected modifier. This one also allows package access, but it also permits subclasses to access this member. As a general rule, all your fields should be private, unlike the class where we usually use public. So what we want to make all the fields on the class private. Doesn't this mean that nobody can access them? This practice has a name encapsulation, and it's a key fundamental rule of object-oriented programming. Encapsulation in object-oriented programming usually has two meanings. What is the bundling of behavior and attributes on a single object? The other is the practice of hiding fields and some methods from public access. In general, when we talk about encapsulation, we're talking about information hiding, or hiding the internal workings of a particular object. When we make our attributes private, we can then create methods to access the data, each with different degrees of access allowed as needed. So what we're going to do first is we're going to create some fields for our class. This is going to look familiar to you. It is a lot like the way we've created local variables previously. Well, that's some fields which are characteristics of the pen. So what kind of things might you are interested in when describing a pen? Maybe things like the manufacturer, its color, its type. Let's set these fields, and then we'll talk a little about them. Well, that's some fields which are characteristics of the pen. So, we write private string manufacturer semicolon, private string color semicolon, private string type semicolon. So here we've created three fields. There's a fields because they are defined in the class's code block or the body of the class, and not in the method. When we create an object from this class, then the values we assign to these fields represent the state of the object. And like local variables, class variables should have some type of access modifier declared for. If you don't declare one, Java declares the default one package private implicitly. So here we've set the access modifier to be private in all cases, which we've said will help us encapsulate this class. We want to control access to these fields, and this starts by making them private. Later, we'll let the methods to access them. The other thing you might have noticed is that we're not actually assigning any values yet. This is because at this point we don't know what these values might be, and they'll likely be different for each instance anyway. If we were creating a real application, we'd likely have a lot more fields, but we'll keep this simple to start with. Let's set a method now that will print out this information about the pen object. We'll call this method describePen and make the method public. This method is not static because we're accessing instance fields on the class. Methods, unlike fields, will often be public because we want to give users a way to interact with the object. Public void describePen opening and closing parentheses, opening curly brace. System.out.println open parentheses, manufacturer plus double quotes, manufacturer plus, color plus, double quotes plus, type plus double quotes plus, closing curly braces. So we've created our first rule template class called pen, and we've set up some attributes on pen. So the next thing we need to do is we need to create an object from this class. Because if you recall, the class is just the template. We need to create an object which will sort of take that blueprint, that definition that we've defined in the class, and instantiate or create an object that we can then start using. So to do that, what we need to do is go back to the central class. We started out with, and I'll just click the tab that says Central Class Java. And what we can do in here is we can actually build an object and base it on that pen class. So what we now need to do is create that object. So how do we do that? Did you guess that you'd use the new keyword? So let's do that. First, we'll declare a variable of type pen, calling the variable simply pen, and then we'll assign it a new instance of the pen class. Now we write pen equals new pen opening and closing parentheses semicolon. Then we write pen.describePen opening, closing parentheses, semicolon. So now what happens, and if we run that, we get null, manufacturer, null. So what's happening here? When do we get now when we were expecting manufacturer, color, and type? Notice a special keyword in Java, meaning the variable or attribute has a type, but no reference to an object. This means that no instance or object is assigned to the variable field. Fields with primitive data types are never null. So, what is the manufacturer, color, and type? All of these fields were declared with the string data type, and we haven't assigned values to them. We know from previous lectures that strings are really objects, not primitive data types. So Java assigned each and null reference. The other thing I want you to notice about the output we got was that manufacturer was printed with the value null here. So how is that possible? We didn't set manufacturer to any values in our class, but we didn't get any errors when running this code. And now we're seeing another difference between local variables and fields declared on a class. And this is that a field with the primitive data type will get assigned a default value by Java. Field some classes and assign default values intrinsically by Java if not assigned explicitly. So because we didn't assign any values to our fields, Java assigned some values for us by default. Java will set any numeric primitive type to a 0. For double S and floats, the numeric literal which is implicitly assigned is the decimal numbers in 0.0. The building field is assigned false by default, and any other type will be null. So, now let's assign some of our own default values to these attributes. So, go into the pen class, and here we assign Edison to the manufacturer, blue to the color, and gel to the type of pen attributes. This means that every object that's instantiated will get assigned the default values we declared here, instead of Java's implicit values. And now running our code in centralclass.java. Now we can see the output that is Edison, manufacturer, blue, and gel. So every pen object we create will have these values by default. But that's not what we really want either. How do we can set the manufacturer, color, and type of our pen each time we create a pen object? Since we made these fields private, we can't use the dot notation with the variable name to set the value. Let me show you what I mean. Let's try accessing these fields directly in the main method. Now we write pen.manufacturer equals double quotes Garwood semicolon. Pen.color equals double quotes black semicolon. Pen.type equals double quotes fountain semicolon. You can see when we try this, we get errors on all three of those lines. We've defined these fields as private on the pen class, and because of that we can't set the values on any pen object we create this way. So let's comment this code out for a moment. We also can't access those values directly in an expression. For example, we just print that data out in the main method of this central class. So, we write system.out.println opening parentheses, double quotes manufacturer equals plus pen dot manufacturer closing parentheses semicolon. System.out.println opening parentheses, double quotes, color equals plus pen dot color closing parentheses semicolon. System.out.println opening parentheses, double quotes, color equals plus pen dot color closing parentheses semicolon. Again, we get compiler errors saying that these fields have private access and our central class isn't allowed to access them. Over that describe pen method, how does outside code get access to this data? We could make all of these fields public or package, but we've set this as bad practice, so we're not going to do that. What we're going to do is allow access to this data. Either to set it, we'll get it through methods on this class. These are a special set of methods called getters and setters. So what getters and setters? The getter is a method on a class that retrieves the value of a private field and returns. The setters are a method on a class that sets the value of a private field. The purpose of these methods is to control and protect access to private fields. Another important aspect is that the getter and setter method signatures are part of pen public interface, but the attribute names and types are. This means that we can change things internally, like the name or type of an attribute, but as long as we use the same getter and setter method, these changes should have no effect on code that uses our class. Our internal changes are hidden from our users. Beginner method usually just returns the value of a private attribute. It's usual to name a getter method with the get prefix followed by the field name in lower camel case, but this is not required. You could have getter methods 3 attributes that are not really declared on your class, but that are derived in some way. A setter method may simply just assign the argument passed to the attribute, but it often contains code to validate data, check additional security requirements, ensure immutability of the field value, or any other code required to protect and validate an object state. It's usual to name a setter method with the set prefix followed by the field name in lower camel case, but again, this is a matter of 3. There may be many cases where we won't have any set of methods for some of our private fields. Maybe this is data only needed within the class itself and doesn't need to be exposed to the outside world. So, let's first start again a method. Going back to the pen class, we'll add a method which will get manufacturer on using a method. Public string get manufacturer opening and closing parentheses opening curly braces. Return manufacturer semicolon. So this method is public, but notices we don't use the word static here. When writing methods that use non-static fields, your method can't be declared static. We just return the field name manufacturer, even though manufacturer is declared on the class. To create the other kind of methods, we could copy and paste this code 2 times and change the name and the attribute returned in each instance. But in general, you won't really be manually typing in the code for you getting methods. IntelliJ has features to generate code for you, including one to create a setter, getter methods. Let's do that for the next 2 attributes. I set my cursor under that first getter method, and then I'll select the code menu item, and then generate, and if you click on that, you'll see there's a lot of options. We'll select getter. Numbers of attributes are listed here that don't already have getters. So select the remaining 2 by holding Shift and pressing the down arrow key. And then we have 2 new public methods, getColor and getType. So let's use these getters in our main method. In each println statement, I'll change the code to use the corresponding getter method. When I delete the field name, I can pick to get a method from the list displayed. And you can see we've eliminated our errors in the main method. Let's run this now. And you can see we can now use the manufacturer, color, and type in our own output string. We also still calling the describe pen method that gives us all the information. So, in this lecture we've talked about encapsulation, getters and setters, and we added getters for our 3 private fields, both manually as well as using IntelliJ as generation feature. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Using getter and setters with exercises. In this lecture, we will discuss about using getter and setters with exercises. So in the last lecture, we set up getter methods for all of the private attributes on our pen class. We talked about best practices for fields that in general fields on classes should be private, and again, a method should be created to access those fields. This provides encapsulation of the internals of our class that supports maintenance of a public interface that does not have to change even though our class might. In this lecture, we are going to be setting up and talking about setter methods which set data on the objects. Well, in this lecture by creating more objects out of the pen class and talking more about the process. We will be using the code from the last lecture where we ended it with the central class and pen classes and the classes and objects project. So now let's set a setter method in the pen class. So, we write public void set manufacturer opening parentheses, string manufacturer closing parentheses curly braces, manufacturer equals manufacturer semicolon. So, we have a public method that does not return anything. It's void because remember, the setter methods set data, they don't retrieve it. And the parameter is going to be string, because that's what we are setting. The field's manufacturer is string, and we will use string as our parameter type. And what we want to do is assign the field on our object, manufacturer this case to the value passed as an argument to the method. But what this is doing? You will notice that IntelliJ has underlined manufacturer in every instance here. If we hover over each of these, IntelliJ is giving us a different warning. Hovering over the parameter, we get reassigned parameter. Hovering over the first manufacturer, we get the warning the value manufacturer signed to manufacturer is never used. And finally, hovering over the second, making that statement, we get yet another warning message. Variable manufacturer is assigned to itself. That introduces another problem. Now the problem here is we have got two different types of variables. If you think about it, we have got the field named manufacturer that we have defined up here. But we have also got another one in here called manufacturer. Now obviously this one here is a parameter that's been passed to this method. In the code as we have written it, we are not really setting the field named manufacturer to the parameter named manufacturer. What we are really doing here is assigning the parameter manufacturer to itself. So how do we distinguish between the two? Because as far as IntelliJ for Java is concerned, we need to be specific to say which one we want to update. What we want to do here is we want to actually update this field private string manufacturer with the contents of the parameter that was passed to us and updated in here. So how do we do that? Well, it turns out there is a way to do that, and that's where the keyword we have not yet seen before called this. This is a special keyword in Java. What it really refers to is the instance that was created when the object was instantiated. So this is a special reference name for the object or instance which it can use to describe itself. And we can use this to access fields on the class. So, because we are trying to set manufacturer, the field here on the left side of the assignment operator, we want to specify that the manufacturer field we want to use to assign a value to is to manufacturer field on the object and not to manufacturer method parameter. So let's set the keyword this to our code. So, we write this dot manufacturer equals manufacturer semicolon. And now all the warnings are gone. So what that's done now is it said update this variable. Here private string manufacturer with the contents of the parameter manufacturer that was passed to us. So, that's the way of updating the manufacturer attribute on pen using a method instead of trying to access it directly. We will go back to the main method and replace that first commented line with code that calls this new setter method on pen. Pen.setManufacturer opening parentheses, double quotes, Garwood closing parentheses, and semicolon. And now if we run this, we can see that our pen is not using the default manufacturer, but is using the manufacturer. We set it to Garwood in both of these cases. So again, we don't really want to manually code all of these setters like we did this first one. We will use IntelliJ code generation to create the rest of the setters for us. We will set our cursor after the last method setManufacturer, but before the describe pen method, and then select code from the toolbar items, then generate, then we will select setters. Now we could pick our two remaining attributes as we did previously with the getters. And now IntelliJ has added two new methods to our class setColor and setType. So, just to show you how that would work, we will go back to our main class again. I am going to delete the two lines of code that are commented out, and we will get calls to these new setters. We will call the setter method by writing pen.setColor opening parentheses, double quotes, black closing parentheses, semicolon. Pen.setType opening parentheses, double quotes, fountain closing parentheses, semicolon. and running that. Then we get the values we set on the pen and not the defaults. So let's talk about the concept of why we want to use getters and setters. So what we are doing is set make. What is the advantage of that? What that means by using the set manufacturer, what we could do is, for example, we could go back to our pen.java. We can have a look at this set manufacturer method our setter, and we could do some validation. Let's add some validation to this method. If opening parentheses manufacturer equals null, closing parentheses manufacturer equals double quotes unknown semicolon. String lowercase manufacturer equals manufacturer dot to lowercase opening and closing parentheses semicolon. Switch opening parentheses lowercase manufacturer closing parentheses curly braces. Case double quotes Franklin comma double quotes scan comma double quotes noodler return type this dot manufacturer equals to manufacturer semicolon. Default returns type curly braces. This dot manufacturer equals double quotes unsupported semicolon. So, first, in this code we check if the argument being passed is null. If it is, we set the manufacturer to unknown. Next, we are using a method on string to test the argument being passed. So now this expression should not be completely unfamiliar to you. We know that the manufacturer parameter is a string, or more correctly, it's an object of type string. And because of that we have access to many methods on instances of string. One of these methods is this one to lowercase, which returns a new string that's all lowercase. We use the switch statement on this variable and test if it's one of the three makes we support. There's a Franklin, scan, and noodler. If they make matches one of those, we will set to make field to the argument passed. But if it does not, we use the default case. It's set to manufacturer field to unsupported. So now we have built a rule that we are supporting only 3 manufacturers. And we'll enforce that rule so that if anything else is passed, we set back to unsupported. But if the argument is null, we set it to unknown. So, let's test this. Go back to centralclass.java. We will change the make from Garwood to Conklin. And running that, we see that make becomes unsupported and not necessarily. So you can see how it's very useful to have this type of functionality, the validation. So what you can do with a set of methods is you can set up all the rules related to that class, what is valid and what is not valid. You can have all that functionality set up within the pen class itself so that these rules are in place as we are creating the object. What that means is the code that's creating objects cannot make invalid objects, so to speak. In other words, you can't assign a manufacturer that we have not defined as being valid in our pen class. So that's the reason. And that's really the whole concept of encapsulation, is that we are not allowing people to access the field directly. We force them to go through a controlled way of setting up the data on the object. Using a set of method, we can really make sure that the data in our objects is valid data. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will see the introduction to constructors. A constructor is used in the creation of an object that's an instance of a class. It is a special type of code block that has a specific name and parameters, much like a method. It has the same name as the class itself, and it doesn't return any values. You never include a return type from a constructor, not even void. You can and should specify the appropriate access modifier to control who should be able to create new instances of the class. So what you can do with a constructor is you can essentially do all the statements we've done here to set the initial parameters or the initial values of the fields. And you can include any other initialization code you want to perform in the constructor. In other words, in Java, a constructor is a special method that is used to initialize objects of a class. It has the same name as the class and is called when an object of the class is created. The main purpose of a constructor is to initialize the variables of the object with some default values. A constructor can have parameters, which are used to pass arguments to the constructor when creating an object. These parameters are used to initialize the variables of the object. In Java, there are 2 types of constructors: default constructors and parameterized constructors. A default constructor is a constructor that has no parameters, while a parameterized constructor is a constructor that has 1 or more parameters. When an object is created, the constructor is called automatically. The constructor initializes the variables of the object and sets its initial state. Once the object is created, the constructor is not called again. Constructors in Java have several advantages. Object initialization. The main purpose of constructors is to initialize the instance variables of an object to some initial values. This ensures that the object is in a consistent state and ready to be used. Encapsulation. Constructors can be used to set the initial state of an object and ensure that the object is encapsulated. Encapsulation means that the object state is hidden from the outside world and can only be accessed through its public methods. Default values. If no constructor is provided in a class, Java provides a default constructor that initializes the instance variables to default values, for example, 0 for integer variables, null for object references. This ensures that an object is always in a valid state. Method overloading. Constructors can be overloaded, just like any other method in Java. This means that you can have multiple constructors with different parameter lists. This is useful when you want to create objects with different initial states. Inheritance. Constructors are also inherited from the parent class to the child class. This means that if a parent class has a constructor, the child class can use that constructor to initialize its instance variables. If no constructor is provided in the child class, Java will call the default constructor of the parent class. We will discuss the inheritance concept in upcoming lecture. There are not many limitations of constructors in Java. However, there are a few things to keep in mind. Overuse. Constructors should only be used for initializing object state. Overusing constructors can lead to code that is difficult to maintain and understand. For example, if you have a complex object that requires a lot of initialization, it may be better to use a factory method instead of a constructor. Coupling. Constructors can lead to tight coupling between classes. If a class has a constructor with many parameters, it may be difficult to change the constructor signature without affecting other classes that use that constructor. Performance. Constructors can have an impact on performance if they are doing a lot of work to initialize object state. If this initialization work is computationally expensive, it may be better to delay the initialization until later. Inheritance. When a subclass is created, the constructor of the superclass is automatically called. This can sometimes lead to unexpected behavior if the constructor of the superclass has side effects or performs actions that are not appropriate for the subclass. Now we discuss types of constructor. So, for this we discuss default constructor. So, the term default constructor can refer to two different things in Java. Constructor with no arguments and an implicit constructor. So, a constructor with no arguments. In this context, a default constructor is a constructor that takes no arguments. If a class does not define any constructors, the compiler will generate a default constructor that takes no arguments. This default constructor initializes all instance variables to their default values. Here is an example of a default constructor with no arguments. In this example, the person class has a default constructor with no arguments. This means that the constructor takes no parameters when it is called. The constructor initializes the instance variables name and age to null and 0, respectively. The private access modifier is used to restrict access to the instance variables name and age to within the person class only. This means that they cannot be accessed directly from outside the class. The default constructor is defined using the constructor declaration public person parentheses. The public access modifier is used to allow the constructor to be accessed from outside the person class. Inside the constructor, the instance variable name is assigned the value null, which is the default value for the string data type. The instance variable age is assigned the value 0, which is the default value for the int data type. A default constructor with no arguments is useful in situations where a class does not require any specific initialization behavior. It is also useful when a class has other constructors that take arguments, as it provides a fallback option if no arguments are provided. An implicit constructor. In this context, a default constructor is a constructor that is implicitly declared by the compiler, if no constructor declarations are provided in the class. This constructor is also known as a no-arguments constructor or zero-argument constructor. The implicit default constructor takes no arguments and initializes all instance variables to their default values. In other words, a no-arguments method or constructor has an empty parameter list. Here is an example of a no-arguments constructor. In this example, the person class does not have any constructor declarations provided, so the compiler generates an implicit default constructor for the class. Here you can see the we create a object of person class. In this line of code, an instance of the person class is being created using the new keyword and stored in a variable named person. The new keyword is used to allocate memory for the new person object on the heap and returns a reference to the object. The reference is then assigned to the person variable. In this case, the person parentheses is a constructor with no arguments is being called to create the new person object. This constructor initializes the name and age instance variables to their default values of null and 0, respectively. Then next is parameterized constructor. So, a parameterized constructor is a constructor that takes one or more parameters when an object is created. Unlike a default constructor, which takes no arguments and initializes instance variables to default values, a parameterized constructor allows the programmer to initialize instance variables with specific values provided as arguments. The syntax for defining a parameterized constructor is similar to that of a default constructor, except that it takes one or more parameters inside the parentheses. Here is an example of a parameterized constructor with two arguments. In this example, the person class has a parameterized constructor that takes two parameters, name of type string and age of type int. This keyword is used to refer to the instance variables of the class and assign the parameter values to them. To create a new person object using the parameterized constructor, you need to provide the appropriate arguments when calling the constructor. Person equals sign new person opening parentheses double quote John, 30 closing parentheses semicolon. In this example, the person object is created with the name John and age 30. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will practice some examples using constructor. For this, we write a program that have a class called library with three private instance variables, name a string, numbooks an integer, and address a string. The class has a constructor that takes in values for each instance variable and initializes them. The class also has getter and setter methods for each instance variable, allowing the user to access and modify the values of the instance variables. Then the main class creates an instance of the library class, sets its initial values, and then prints them using the getter methods. It then modifies the values using the setter methods and prints them again using the getter methods. Let's start creating this program. For this, we create a new project named Object-Oriented Constructor. Now we create a class file named main class, and inside it we create a main method using shortcut PSVM. Now we create another class file named library. Now inside this class we write private string name semicolon, private int numbooks semicolon, private string address semicolon. Here we define three private instance variables, name with string, numbooks with integer, and address with string. The name variable is of type string and represents the name of the library. The numbooks variable is of type int and represents the number of books in the library. The address variable is of type string and represents the physical address of the library. By making these variables private, the code ensures that they can only be accessed and modified through the public getter and setter methods provided in the library class. This helps to control access to the variables and ensures that they are modified only in a controlled and safe way. Then we write public library opening parentheses string name, int numbooks, string address closing parentheses curly braces, this dot name equals sign name semicolon. This dot numbooks equals sign numbooks semicolon. This dot address equals sign address semicolon. Here we create a constructor for the library class. A constructor is a special method that is used to create and initialize objects of a class. In this case, the constructor takes in three parameters, name, numbooks, and address. These parameters represent the initial values for the three private instance variables of the library class. This keyword refers to the current instance of the library class, and is used here to distinguish between the parameter variables and the instance variables with the same name. So, within the constructor, the values of the parameter variables name, numbooks, and address are assigned to the instance variables this name, this.numbooks, and this.address, respectively. This means that when a new library object is created using this constructor, the name, numbooks, and address instance variables will be initialized to the values passed in as parameters. Then we write public string getName parentheses curly braces return name semicolon. Public string getNumbooks parentheses curly braces return numbooks semicolon. Public string getAddress parentheses curly braces return address semicolon. These are getter methods for the name, numbooks, and address instance variables of the library class. In this case, getName, getNumbooks, and getAddress are getter methods for the name, numbooks, and address instance variables, respectively. These methods simply return the value of their corresponding instance variables. Then we write public void setName opening parentheses string name closing parentheses curly braces. This dot name equals sign name semicolon. Public void setNumbooks opening parentheses int numbooks closing parentheses curly braces. This dot numbooks equals sign numbooks semicolon. Public void setAddress opening parentheses string address closing parentheses curly braces. This dot address equals sign address semicolon. Here these three methods are the setters for the three private instance variables of the library class, name, numbooks, and address. The setName method takes a string argument name and sets the name instance variable to the value of name. The setNumbooks method takes an int argument numbooks and sets the numbooks instance variable to the value of numbooks. The setAddress method takes a string argument address and sets the address instance variable to the value of address. By using these setter methods, we can modify the values of the private instance variables of a library object after it has been instantiated. Now go into the main class.java file. Here we write inside the main method library myLibrary equals sign new library opening parentheses double quote central library comma 5000 comma double quote 123 Main Street closing parentheses semicolon. Here we create a new library object called myLibrary and initializes its name, numbooks, and address instance variables with the values central library, 5000, and 123 Main Street, respectively. The new keyword creates a new instance of the library class, and the arguments in parentheses are passed to the library constructor, which initializes the instance variables of the new object with the given values. Now we write system.out.println opening parentheses myLibrary.getName parentheses closing parentheses semicolon. System.out.println opening parentheses myLibrary.getNumbooks parentheses closing parentheses semicolon. System.out.println opening parentheses myLibrary.getAddress parentheses closing parentheses semicolon. These lines of code are using the getter methods of the myLibrary object to access and print the values that we set with the help of constructor of its private instance variables. So, these lines of code are essentially printing out the initial values of the name, numbooks, and address variables of the myLibrary object. Then we write myLibrary.setName opening parentheses double quote downtown library closing parentheses semicolon. myLibrary.setNumbooks opening parentheses 10,000 closing parentheses semicolon. myLibrary.setAddress opening parentheses double quote 456 Elm Street closing parentheses semicolon. These lines of code are modifying the instance variables of the myLibrary object using the setter methods provided in the library class. First, the setName method is called with the argument downtown library, which sets the name instance variable of myLibrary to downtown library. Next, the setNumbooks method is called with the argument 10,000, which sets the numbooks instance variable of myLibrary to 10,000. Finally, the setAddress method is called with the argument 456 Elm Street, which sets the address instance variable of myLibrary to 456 Elm Street. Then we write system.out.println opening parentheses myLibrary.getName parentheses closing parentheses semicolon. System.out.println opening parentheses myLibrary.getNumbooks parentheses closing parentheses semicolon. System.out.println opening parentheses myLibrary.getAddress parentheses closing parentheses semicolon. These lines of code are accessing the modified instance variables of the myLibrary object using getter methods after setting new values using the corresponding setter methods. Specifically, println method mylibrary.getName prints the updated name of the library, which was set to downtown library using mylibrary.setName. Println method mylibrary.getNumBooks prints the updated number of books in the library, which was set to 10,000 using mylibrary.setNumBooks. Println method mylibrary.mylibrary.getAddress prints the updated address of the library, which was set to 456 Elm Street using mylibrary.setAddress. Now we run it. Here is the output after successfully run, that is Central Library, 5,000, 123 Main Street, Downtown Library, 10,000, 456 Elm Street. The first three values are those that we set with the help of the constructor, and the last three values are those that we modified with setter methods. For this, we write a program that have a class called car that has private fields for make, model, and year, and uses getter and setter methods to access and modify these fields. It also includes a constructor to set initial values for these fields. The main class includes a main method that creates an instance of the car class, initializes it with some values, and then uses the getter and setter methods to retrieve and update the car's year field. The program prints out the car's make, model, and year before and after the year is updated. Let's start creating this program. For this, we create a new project named Object-Oriented Constructor 1. Now we create a class file named MainClass, and inside it we create a main method using shortcut PSVN. Now we create another class file named car. Now inside this class we write private string make semicolon, private string model semicolon, private int year semicolon. Here the variable make represents the brand or manufacturer of the car, such as Toyota or Ford. The variable model represents the specific model of the car within that brand, such as Corolla. The variable year represents the year the car was manufactured. It is an integer value that represents the model year of the car, such as 25 or 2022. Together, these variables provide important information about a car's make, model, and year of manufacture. Then we write public car opening parentheses, string make comma string model comma int year closing parentheses curly braces, this dot make equal sign make semicolon. This dot model equals sign model semicolon. This dot year equals sign year semicolon. This is a constructor for a class called car, which takes three parameters, make, model, and year. The public keyword means that this constructor can be accessed from outside the class. Inside the constructor, this keyword refers to the current instance of the car class, which is being created by the constructor. The constructor assigns the values of the make, model, and year parameters to the respective instance variables fields of the car class. Then we write public string getMake parentheses curly braces return make semicolon. Public string getModel parentheses curly braces return model semicolon. Public string getYear parentheses curly braces return year semicolon. These are getter methods for the private fields make, model, and year of a car class. Getter methods are used to retrieve the values of private fields from outside the class. Inside the method, the return keyword is used to return the value of the make, model, and year fields. Then we write public void setMake opening parentheses, string make closing parentheses curly braces, this dot make equal sign make semicolon. Public void setModel opening parentheses, string model closing parentheses curly braces, this dot model equals sign model semicolon. Public void setYear opening parentheses, string year closing parentheses curly braces, this dot year equals sign year semicolon. Here these are setter methods for the private fields make, model, and year of a car class. Setter methods are used to set or modify the values of private fields from outside the class. Each method takes one parameter, which is the new value to be assigned to the corresponding field. Inside the method, this keyword refers to the current instance of the car class, and the parameter value is assigned to the corresponding private field. Now go into the main class.java. First, we need to use the scanner class. So, we need to import it at the beginning of our Java program using the import statement like import java.util.scanner semicolon. Then inside the main method, we write scanner equals sign new scanner opening parentheses system dot enclosing parentheses semicolon. As creates a new scanner object named scanner that reads input from the standard input stream usually the keyboard using the system.in parameter. Here, the scanner class provides a way to read input from different sources, such as a file or a string. The system.in parameter passed to the scanner constructor indicates that the input will be read from the standard input stream, which is usually the keyboard. Once we have created a scanner object, we can use its methods, such as nextInt and nextLine, to read user input from the standard input stream. Then we write system.out.println opening parentheses double quote enter the car's make, closing parentheses semicolon. String make equal sign scanner dot nextLine parentheses semicolon. System.out.println opening parentheses double quote enter the car's model, closing parentheses semicolon. String model equal sign scanner dot nextLine parentheses semicolon. System.out.println opening parentheses double quote enter the car's year, closing parentheses semicolon. Int year equal sign scanner dot nextInt parentheses semicolon. Here these lines of code prompt the user to enter the make, model, and year of a car, and then use the scanner object to read in the user input. The first line uses the print method to display the message enter the car's make on the console, prompting the user to enter the make of the car. The second line creates a new string variable named make and uses the print method to read in the user input as a string. The third and fourth lines do the same thing for the model and year of the car, respectively, with the print method used to display the appropriate message, and the scanner.nextLine or scanner.nextInt method used to read in the user input. It's worth noting that the scanner.nextLine method is used to read in the make and model input, while the scanner.nextInt method is used to read in the year input. This is because the nextInt method reads in only the next integer value from the input stream, whereas the nextLine method reads in the entire line of input, including any spaces or other characters. Then we write car mycar equal sign new car opening parentheses make comma model comma year closing parentheses semicolon. Here we create a new car object using the car class constructor, passing in the make, model, and year values that were previously read in from user input. The new keyword is used to create a new instance of the car class, and the car keyword followed by parentheses refers to the class constructor that takes 3 arguments of type string, and int, respectively. The make, model, and year values are passed into the constructor as arguments using the variable names that were used to store the user input earlier. Once the car object is created, it is assigned to the mycar variable, which is of type car. This variable can now be used to reference the newly created car object and access its methods and fields. Then we write system.out.println opening parentheses double quote make plus mycar.getMake parentheses closing parentheses semicolon. System.out.println opening parentheses double quote model plus mycar.getModel parentheses closing parentheses semicolon. System.out.println opening parentheses double quote year plus mycar.getYear parentheses closing parentheses semicolon. Here these lines of code use the car object referenced by the mycar variable to print out the make, model, and year of the car to the console. The print method is used to output a string to the console, followed by the value returned by the respective getter method of the car object. For example, the first line of code outputs the string make, followed by the value returned by the getMake method of the car object, which represents the make of the car. Similarly, the second line of code outputs the string model, followed by the value returned by the getModel method of the car object, which represents the model of the car. Finally, the third line of code outputs the string year, followed by the value returned by the getYear method of the car object, which represents the year of the car. Then we write system.out.println opening parentheses double quote enter the updated year, closing parentheses semicolon. Int updated year equals sign scanner dot nextInt parentheses semicolon. Here this line of code prompts the user to enter a new value for the year of the car by printing the message enter the updated year to the console. The print method is used to display the message, which is followed by the user input being read in from the console using the scanner.nextInt method. The scanner.nextInt method reads in the next integer value entered by the user and assigns it to the updated year variable, which is of type int. After this line of code executes, the program has a new value for the year of the car, which can be used to update the car object by calling its setYear method, like so. myCar.setYear opening parentheses updated year closing parentheses semicolon. Then we write system.out.println opening parentheses double quote updated year, plus myCar.getYear parentheses closing parentheses semicolon. Here this line of code outputs the updated year value of the car object referenced by the myCar variable to the console. The print method is used to display the message updated year, followed by the current value of the year stored in the car object returned by the getYear method. The getYear method is a getter method defined in the car class that returns the current value of the year field in the car object. By using this method to access the updated year value of the car object, the program can output the new value to the console, allowing the user to see that the year value has been successfully updated. Now we run it. So, first message displayed that says enter the car's make. Now we write Toyota and press enter. Then second message displayed that says enter the car's model. Now we write Corolla and press enter. Then third message displayed that says enter the car's year. Now we write 2022 and press enter. Here it displays the result that are make, Toyota, model, Corolla, year 2022. Then again displays a message enter the updated year. Now we write 2023 and press enter. Now it displays final message that is updated year, 2023. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Clear understanding of reference, object, instance, and class. In this lecture, we are going to go over and discuss references, objects, and instances in an effort to clear up any misunderstandings. By now, you've probably noticed that we use the words reference, object, instance, and class quite a lot when talking about Java code. These new concepts may well be confusing at first. So, in this lecture, I'm going to try and go through the process and show you exactly what each of these words means in the context of Java programming. You might remember in earlier lectures of the course that we use object and instance interchangeably, and that we create an instance or object using a class. These new concepts may well be confusing at first, so let's talk about them. Let's use the analogy of build an office to understand classes. Now, class is basically a blueprint for the office. Do you think the blueprint? We can build as much office as we like based on those plans. So thinking back to the physical world, we use the plans for the office to build many offices that have the same full plan. Each office we build. In other words, going back to programming terms, each office us instantiate using the new operator is an object. This object can also be known as an instance. Often we'll say it's an instance of the class. So we would have an instance of office in this example. Getting back to the physical world, each office we build has an address. It's built at a physical location. In other words, if we tell someone where we work, we give them our address, perhaps written on a piece of paper. So that piece of paper with the address on it. This is known as a reference. Then we can copy that reference as many times as we like, but there is still just one office that we are referring to. In other words, we are copying the paper that has the address on it, not the office itself. Or we are writing that address on another piece of paper. Now back to programming terms. We could pass references as parameters to constructors and methods. Let's not just go a bit deeper to make this clearer. So, we have got some code on the screen now. Now on the left-hand side, we have got the class office with instance variable, also known as a field called name. Now on the right-hand side, we have the main class with the main method. Now this code in the main method is creating instances of the office class, changing the name and printing out the result. So, let's actually go through line by line and see what happens when this code is executed. So, looking at this first line that I have got highlighted in red on the right-hand side. Office my office equals new my office opening parentheses and double quotes nixware closing parentheses semicolon. This code creates a new instance of the office class. So, remember, office is a blueprint, and we are assigning it to the my office variable. So in other words, it's a reference to the object in memory. Then you can see that hopefully on the left-hand side, and then it makes a bit more sense there. My office is the variable. We are creating a new instance of the office class and assigning it the name nixware. So this next line, then I have got highlighted, has another office equals my office. Well, that creates another reference to the same object in memory. So what we have got now is two references pointing to the same object in memory. So there is still one office, but two references to that one object. So in other words, we have got two pieces of paper with the physical address of where the office is built written down if we came back to a real-world example to make that clearer. So next, on the right-hand side, I have got two print statements highlighted. So they print the value of the name variable for my office and also another office. Now, in this scenario, both will actually print IMf&x, and that's because, again, we have got two references to the same object. And again, you can see that on the left-hand side there. Hopefully, that image showing both references to the same office, which is IMf&x, makes that clearer as to how this is actually working. Alright, so this next line I have highlighted here another office, .setName IMf&x Consulting Company. Well, that's calling the method setName and setting the name to IMf&x Consulting Company. Now to the left you can see that both my office and another office now have the same name. So why is that? I'll remember that we have got two references that point to the same object in memory. Now once we change the name of one, both references still point to the same object. So consequently, they both got the same value of IMf&x Consulting Company in this example. Alright, so we have got a couple more print statements here, which I have highlighted. So these two print statements are printing the same name. Both are printing IMf&x Consulting Company because, again, we have got two references that point to the same object in memory. And again, you can see that defined with the arrow on the left-hand side of the image when instance pointed to by two objects. So moving on. What we are doing now is with that next line that's highlighted on this slide, office new office equals sign new office. We are creating another new instance of the house class, this time with the name set to again IMf&x. So now we have got two objects in memory, but we have got three references. And those references are my office, another office, and our new office. Now the variable or reference new office points to a different object in memory, and that's the one we just instantiated using the new keyword here. The my office and another office point to the same object in memory, the previous office we created at this point. So I have highlighted this statement. Another office equals my office. So what we are doing here is we are assigning my office to another office. So in other words, we're really dereferencing another office, and it will now point to a different object in memory. Previously, that was pointing to an office that had the IMf&x Consulting Company name, but now it's pointing to an office that's got the again IMf&x name. So, this scenario, we still have three references and two objects in memory, but my office points to one object while another office in my office. Now, point to the same object which has the again IMf&x name in memory. And finally, we have got those last three print line statements. The first will print IMf&x Consulting Company since the my office variable or reference points to the object in memory that has the IMf&x Consulting Company name. The next two lines will print again IMf&x, and that's because another office and new office point to the same object in memory. So keep in mind that in Java you always have a reference to an object in memory. There's no way to access an object directly. Everything is done using that reference. Now we see a quick summary. So, reference. A reference is a variable that points to an object or an instance of a class. When you declare a variable of a particular type, such as string or class, you are creating a reference variable. The reference variable holds the memory address of the object or instance of the class, and not the object itself. Object. An object is an instance of a class that is created at runtime. It is a concrete entity that occupies memory space and has state and behavior. An object is created using the new keyword followed by the class name. Instance. An instance is a single occurrence of an object. Every time you create an object using the new keyword, you are creating a new instance of that object. So, as a result, a reference is a variable that holds the memory address of an object or instance. An object is a concrete entity that has state and behavior. And an instance is a single occurrence of an object created using the new keyword. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about static versus instance variables and methods. First, we discuss differences between static variables and instance variables. So firstly, the static variable is declared by using the keyword static. Static variables are also known as static member variables. Every instance of the class shares the same static variable. So if changes are made to that variable, all other instances of that class will see the effect of that change. It is considered best practice to use the class name and not a reference variable to access a static variable. This makes it clear that the variable is associated with the class and therefore shared, and the value is not stored with the instance. In instances that required to exist to access the value of a static variable. Static variables aren't used very often, but can sometimes be very useful. Static variables are useful in many situations where you need to maintain a value or a counter across multiple function calls or instances of a class. Some common scenarios where static variables are useful include counting function calls. If you want to count the number of times a function has been called, you can use a static variable to maintain the count across multiple function calls. Sharing data across instances. If you have a class that has multiple instances and you want to share some data across all instances, you can use a static variable to store the data. Cache data. If you have a function that performs an expensive calculation and the result is the same for the same input, you can use a static variable to cache the result so that it can be reused on subsequent calls with the same input. Managing resources. If you need to manage limited resources, such as database connections or file handles, you can use a static variable to keep track of the number of available resources. Here you can see this example. In this example, we've got a class called cat, and it's got a static variable called name. Now there's a constructor that sets the static variable to the parameter value passed to the constructor. And we've got a method there called printName, which is in static. So, that's a pretty simple class. And inside main, we're creating two instances of the cat class with the line cat main_coon equals new main_coon. We're creating an instance of the cat class, and then we're passing the string main_coon as a parameter, and that'll be the name of the cat. In the next line, we've got a similar situation, just passing the parameter which will be used as the name ragdoll. So let me call the printName method on both of the instances. So they're just regular instance methods because they are defined using static. So both method calls will print ragdoll. You might be wondering, why is that the case? Won't both methods here print ragdoll? Well, remember that static variables are shared between instances. So in other words, once we change the static variable, all instances will see that change we made. So when we call the constructor with parameter ragdoll, it modifies the static variable name because both instances are sharing that variable. That's why ragdoll twice. So you could also say that all cat have the same name, but that's logically incorrect. So hopefully you can see how static variables can be used inappropriately sometimes, as in this example. Probably you were assuming that the cat name would be associated with each instance of the cat, and therefore would be different for each one. One cat would be named ragdoll, and the other would be main_coon. So this is a scenario where using a static variable probably wouldn't be a good idea, and using a regular instance variable would make a lot more sense in this particular example. So let's move on now to instance variables. So firstly, they don't use the static keyword when you're defining them. They're also known as fields or member variables. Unlike a static variable, instance variables belong to a specific instance of a class. Each instance has its own copy of an instance variable. Every instance can have a different value. Instance variables represent the state of a specific instance of a class. Let's see an example using instance variables. So this example, we've again got very similar code to what we looked at earlier example of static variable, but this time the variable name in the class is not a static. So it's just a regular instance variable. So once again, the constructor is setting the value from the parameter passed to that instance variable. But now the code will print main_coon and on the next line ragdoll, and that's because we're using instance variables. Each instance of the class has its own state or its own values for any variables that have been defined. So in other words, every cat has got its own copy of the name field. We can also say that it's basically not shared like it was before in the earlier example, which was using a static variable. So most cases you'd probably want to use instance variables, but there will be scenarios when it can be useful to use a static variable like in the early example. Let's move on to the next concept, that is differences between static methods and instance methods. So firstly, static methods. Static methods are declared using a static modifier. Static methods cannot access instance methods and instant variables directly. They're usually used for operations that don't require any data from an instance of the class. From this, in other words, if you remember that this keyword is the current instance of a class, so inside a static method, we can't use for this keyword. Whenever you see a method that doesn't use instance variables, that method should probably be declared as a static method. For example, main is a static method, and it's called by the Java virtual machine when it starts the Java application. Here you can see an example. So, in this example, we've got a class called mycompany with a static method called mycompany. And it just prints the company name and its location using two string variables. Then we've got the main class with two static methods, main and print hello. Now inside main, we're calling the method print sum from the mycompany class. So, as you can see, to call the mycompany method, we just need to type the class name, in this case mycompany, and then the method name mycompany. Or the second example, in the case of print hello, we can just type the method name of parentheses, which will automatically call the print hello static method because it's being invoked from a static method itself. So, static methods don't require an instance to be created. We can just top the class name and use the dot notation with the method name to access them. Let's move on now to instance methods. Instance methods belong to an instance, a specific instance of a class. To use an instance method, we have to instantiate the class first, usually by using the new keyword. Instance methods can access instance methods and instance variables directly. Instance methods can also access static methods and static variables directly. What I mean by directly is that we don't usually have to use the keyword this with the dot notation to use them. And we don't have to use the class name of the dot notation to access static variables. That can help with clarity. Now we see an example. So this example, we've again got very similar code to what we looked at earlier example of static method. But this time, the method company name in the class is not a static. So it's just a regular instance method. So, in this example, we've got a class called mycompany with a method company name. So notice here how the method company name is not using the static keyword this time. So in other words, that method is just a standard instance method. Then we've got our main class with a method main. Now inside main, we first need to create an instance of the mycompany class, and that's done with the line mycompany comapny equals new mycompany. As you can see, we're using the new keyword to create an instance of that class. After we've got the instance, we can call the instance method company name, in this case by typing company.company_name. So, the hard part here could be deciding where to create an instance or where to create a static method. So, let's see some basic rules that should help you decide. So here we decide whether we need an instance or a static method. When deciding whether to use a static method or an instance method in Java, you need to consider the purpose of the method and the data it operates on. Here are some guidelines to help you decide whether to use a static method or an instance method. If the method does not depend on the state of any particular object, and can be called independently of any instance of the class, consider making it a static method. If the method operates on the data of a specific instance of a class, and depends on the state of that instance, make it an instance method. If the method needs to access both the static data and the instance data of a class, consider making it a static method that takes an instance of the class as a parameter. In general, it is better to make methods static whenever possible, as this can improve performance and reduce memory usage. However, if a method needs to access and modify the state of a particular object, it should be an instance method. I hope you learned something useful in this lecture as well, and I'll see you in the next one. The plain old Java object with exercises. In this lecture, we will talk about the plain old Java object. We already discussed the inheritance concept and saw some of its examples. We will see inheritance and other concept later. First, we will see the POJO concept, and then we will come back to inheritance. So, plain old Java object in short called POJO. It is a Java class that is used to encapsulate data and business logic. A POJO is not bound by any restrictions that come with Enterprise JavaBeans EJBs, such as implementing interfaces or inheriting from framework-specific classes. A POJO typically contains private member variables with public getter and setter methods to access and modify the data. It also has a default constructor and can optionally have additional constructors. POJO class is a normal, simple, and ordinary Java classes without any special specialties. The Java class that is not extending or implementing any framework or technology, API classes and interfaces respectively. These classes are also said to be POJO class. POJO class is not against of expending any class and implementation any interface. It is against of extending or implementing any other framework or technology API classes and interfaces beside JDK. Generally, POJO classes are compiled by using JDK libraries only. It does not need any third-party library jar files of other technology or framework in the class path. Now we see some of its examples. Here you can see a public class test. We can simply compile this class using only JDK, and libraries are not required to compile this. So, this type of class is called POJO class. In the next example, we see public class test extends thread. We already discussed that POJO class is not against of expending any class and implementation any interface, but it is against of extending or implementing any other framework or technology API classes and interfaces beside JDK. Here the thread class is the JDK class. So, in this example, test extends thread is a POJO class. In the next example, we see public class test implements Runable. Here Runable is an interface of JDK. So, the text class implements this Runable interface. So, test implements Runable is a POJO class. We will discuss all these classes and interface in upcoming lectures. In the next example, we see public class demo implements javax.serverlet.serverlet. Here javax.serverlet.serverlet is an interface of serverlet API. So, serverlet API is an external API. That is not the part of JDK. So, demo implements javax.serverlet.serverlet is not a POJO class. Now we see another example that is public class myapp extends demo. Here we see that demo class extends with myapp class. But the demo class in the previous example implements javax.serverlet.serverlet interface. And serverlet is an external API. So, public class myapp extends demo is also not a POJO class. Because of demo class implements serverlet interface, and it's become the parent-child relation. Demo class become parent class of myapp class. Now we see one of the exceptional cases of POJO class. Here is the example that is public class myJDBC curly braces. Inside this class, we use a method that is void some JDBC method parentheses curly braces. In this case, myJDBC is a POJO class because it's not extends or implements any external API. But the code inside it need JDBC library to compile it. So, in this exception case where class is POJO but code inside it need any other external library to compile it. In addition, a plain old Java object whose acronym is POJO is a class that generally only has instance fields. It's used to house data and pass data between functional classes. It usually has few, if any, methods other than getters and setters. Many database frameworks use POJO to read data from or to write data to databases, files, or streams. You remember I've said several times that a class can be thought of as a superdata type. POJO is really just that. It lets you extend and combine your definition of data types. A POJO also might be called a bean or a Java bean. Maybe you have heard the term Java bean. A Java bean is just a POJO with some extra rules applied to it. These rules are in place so that Java frameworks have a standard way to manipulate and manage these objects. A POJO is sometimes called an entity because it mirrors database entities. Another acronym is DTO for Data Transfer Object. It's a description of an object that can be modeled as just data. There are many generation tools that will turn a data model into generated POJO or Java beans. You have seen an example of similar code generation in IntelliJ, which allowed us to generate getters, setters, and constructors in a uniform way based on our class fields. Let's look at an example by POJO. So, open IntelliJ, and here created a project called POJO Concept Project, and created the usual main class with the main method. Now let's say we want to read data out of a database that has a table of employee records. So we can see from this that we need 4 fields: ID, name, date of birth, and company name. We're going to make all of these strings for this exercise. Now we will create a new class, and we will call it employee. Now we create 4 fields by writing private string ID semicolon, private string name semicolon, private string date of birth semicolon, private string company name semicolon. So now let's make this a plain old Java object. A POJO in its simplest form requires a way to populate data, and we can do this with a constructor. We will use IntelliJ code generation tool to create a constructor first with all of these fields. Now select code from menu. So this class, even without getters and setters, let's just create and populate employee objects using just this constructor. And let's really do that now in the main method of the main class. Let's have some other practice and put some of the Java skills we have learned to work. We'll create 5 employee in the loop. We use the loop variable to create a unique ID. At first, we will have code the name as Bob as well as set date of birth and company name to some literal values. So, we write for parentheses int I equals sign 1 semicolon, I less than or equal to 5 semicolon, I plus plus closing parentheses, curly braces, employee E equals new employee opening parentheses, double quotes EN plus I comma, double quotes, Bob comma, double quotes the 7th of January 1980 comma, double quotes, Nixware closing parentheses, semicolon. So, here we create 5 employee objects. We pass an ID that starts with this EN, then appends the loop index I. So each employee has a different IDs, and the rest of the values are literals. That's never place Bob. We're going to put a switch expression that will give us a different name based on the value of the loop index I. Switch open parentheses, I closing parentheses, curly braces. Case 1 return type double quotes Bob semicolon. Case 2 return type double quotes John semicolon. Case 3 return type double quotes Imran semicolon. Case 4 return type double quotes Kashif semicolon. Case 5 return type double quotes Anderson semicolon. Default return type double quotes anonymous semicolon closing curly brace comma. So we're using a switch expression as a parameter to a constructor, which is pretty neat, you have to admit. Maybe you noticed that I have a default case label defined, although in this loop it won't ever be true. This is actually a requirement for the switch expression when it's used with the numeric switch value. It requires that all possible values be resolved, and with the numeric switch value. The only way to really do this is to use a default label like we did here. The last 2 parameters are simply hard-coded to the same birth date and the company name. Now we use toString method to print out data. We already discussed toString method in the previous lectures. Now, back to our employee POJO class. Put your cursor before the last closing brace of the class. We will pick code and generate, and now look for the option that says toString and select that. And the method called toString, which will print out all the attributes in our class in a nicely formatted way. So the toString method is a special method in Java. We can implement this method in any class we create, and doing this lets us print out the current state of our object. IntelliJ, when it generates this code as a special statement, as you can see here, it override displayed above the method. Now come back to the main class and main method. We can simply print out each one of our employee objects using the system.out.println statement. So, we write system.out.println, opening parentheses, E, closing parentheses, and semicolon. You might notice that we didn't actually even call toString method on the employee, this variable in this loop in the system.out.println statement. We did not have to. This is another built-in feature from Java. Every object, when passed to system.out.println, will have the district method implicitly executed if you have created such a method on your class. Now running this code, we get output. And we can see the data in our 5 employee objects or records. That's another pretty heavy code generation tool to know we can use. So this was a contrived example, but you can imagine if you were reading data from a database or a comma-delimited file, how you could create a whole set of POJO to collect all the data elements in all your records. On CE, you have all this information in the POJO. You could pass these objects to whatever code would process it that would need to do something with it, perhaps generate a mailing list or whatever. So, now we will discuss new features of Java that is called the record, which officially became part of Java in JDK 16. We will talk about the record now. In summary, we talked about the plain old Java object, and we showed you how it comes with a lot of what we call boilerplate code. It's kind that's repetitive and follows certain rules. In our case, we had a constructor with parameters for every field on our class, as well as getters and setters for each field. We also set up a toString method on this class, so we could print out all the fields on our class in a nicely formatted way. This is code that's repeated over and over for every POJO or for every Java bean if you're using Java beans to leverage Java frameworks that use them. What's created this code is really looked at or modified. In fact, there are tools that will just regenerate all of this code if your underlying data or domain model changes. Even better, though, Java introduced a new type, the record, which became part of the official language in JDK 16. The record was introduced in JDK 14 and became officially part of Java and JDK 16. Its purpose is to replace the boilerplate code of the POJO, but to be more restrictive. Java calls them plain data carries. The word carry is an important term because it means the record has more rules built in than a POJO would. The record is a special class that contains data that's not meant to be altered. In other words, it seeks to achieve immutability for the data in its members. It contains only the most fundamental methods, such as constructors and setters or getters. Either developer don't have to write or generate any of this code. We are back in our record project. In previous, we created an employee class with a constructor and some getters and setters that we used to form look to create 5 employees. Now I will expand the project panel and highlight RC because I want to add a new Java class. But this time I'm going to pick record instead of the default class we have been using all along until now. You will see there are others like interface, enum and annotation, but don't worry, we will be talking about those eventually. Right now we care about the record type, and I will give it a name. They will NC employee. They will NC stands for my own company name, Nixware Consulting, and then employee. You can see this looks a lot like a class. It starts with a public access modifier, but instead of the class keyword, it's using the record keyword. You will notice that in this code, there are a set of parentheses after the name of this record. There will be an employee. Similar to a constructor, we could set up some parameters within those parentheses. So let's set some up so let the parameters are the same as our employee class parameters. In fact, let me just copy that parameter list from the employee class constructor. I will pop over to employee.java. Copy the parameter list I've set up in that first constructor. Then I will come back over to our ncemployee.java and paste those parameters into parentheses. And that's it. We're ready to use this record now in our code. It's really that simple. Let's go to mainclass.java and show you. Before we make any changes, let's run the main code as it is. And you will remember we get the output from the toString method which generated in the employee class. Now let's use our new record. I'm simply going to use ncemployee in place of employee in the code here, where I had student unmodified to be ncemployee the name of our record. That's the variable or reference NCE type, and on that same line, I will use ncemployee after the new keyword instead of employee. This code compiles, and if we run it, we get output that's very similar to the output we got before. The bracket top is different. Let's look at these two source files side by side. We have replaced the 56 lines of code that we have in student Java with these 2 lines of code in ncemployee.java. Now the truth is the record ncemployee doesn't have or support set of methods, but the other functionality, Calling the constructor with 4 parameters and printing the data out is implicitly part of the record. What's really happening here? What does Java tell us about what is implicitly created when we declare record as we did in this code? First, it's important to understand that the part that's in parentheses, this entire part, is called the record header. The record had a consistent record. Components are comma-delimited list of components. For each component in the header, Java generates. I feel that's the same name and declared type as the record component. So for example, it sets up fields for us as we have them in the parentheses. These become the fields of the record. The field is declared private and final. We will be talking about final more later, but simply put, it means the field can't be modified. The field is sometimes referred to as a component field. Java generates such a string method that prints out each attribute in a formatted string. In addition to creating a private final field for each component, Java generates a public assessor method for each component. This method has the same name and type of the component, but it doesn't have any kind of special prefix. The accessor method for ID in this example is simply ID open and close parentheses. This is easy to show you in the code. First, I will drag ncemployee.java back over into the other window and get rid of that side-by-side view, and I will open the main class.java code. Now let's get some extra code after our for loop. Let's create 2 employees when we use our POJO class, and 1 we will use our record. Let me set that up. Employee POJO employee equals new employee opening parentheses double quotes it's EN20 comma, double quotes Dave comma, double quotes the 10th of December 1975 comma, double quotes Nixware, closing parentheses, and semicolon. NC employee record employee equals new NC employee. Opening parentheses, double quotes, that's EN24 comma, double quotes Ivan comma, double quotes the 11th of February 1982 comma, double quotes Nixware, closing parentheses, semicolon. So, now let's print some information out about each of these employees. System.out.println, opening parentheses, POJO employee, closing parentheses, semicolon. System.out.println, opening parentheses, record employee, closing parentheses, semicolon. And if we run that, we can see our 2 new employee at the end of the output and notice the minor differences in the output. This shows us that like IntelliJ generated method to string the record is printing information out similarly, though it doesn't include single quotes around strings and the brackets are different. I hope you learned something useful in this lecture as well, and I will see you in the next one. Introduction to java.lang.object with exercises. In this lecture, we will talk about java.lang.object class. Now it's time to come back to inheritance. So, in the last couple of lectures, we introduced you to inheritance and how it works with the class hierarchy. We talked about the base class, also called the superclass and subclasses. We demonstrated overriding methods, and we gave you a quick look at how inheritance plays into polymorphism in Java. Well, it turns out in Java we have been using inheritance all along without even knowing it. This is because every class you create in Java intrinsically extends a special Java class. This class is named Object, and it's in the java.lang package. That's confusing a class called Object. Let's see what Java has to say about this class. We used to link to Java Application Programming Interface API for this class. This is a class called Object. Class object is the root of the class hierarchy. Every class has object that's a superclass. Objects, including arrays, implement the methods of this class. Whether you knew it or not, your classes were extending this class object. They all inherit from object. And what that means is all of your classes have functionality built in that you can use or override the minute you create them. Let's explore the methods on java.lang.object. And here you can see some of the methods on object by clone and equals. And also here is one we just showed in the last couple of videos, that toString method. Every class we create or use is automatically inheriting from this Java-supplied class called the object class. Let's see an example. For this open IntelliJ. Now we create a project named Java Lang Object. Now create a class named main class, and inside this class create a main method using shortcut PSVM. We have said every class inherits from object, and this actually includes the main class. We can use the code generation tools, and you can see that by opening up your generate command if you go to override methods. You can see when I've done that select methods to override or to implement. Then you can see these are all methods. The M stands for method. And these are all methods that are inherited from java.lang.object, which is a classic classes you create automatically extend. That's equivalent essentially to topping extends object java.lang.object class. So, let's do that in our main class. Extends java.lang.object. We could also just submit the package name java.lang and just say a class extends object. We will talk about packages later. For now, I will just say that Java has a way of implicitly doing things that make our jobs easier. One of these is to include all objects from its core libraries automatically, so we can refer to them like we do here as simply object, for example. The other is to implicitly have all classes extend this object class that does not explicitly extend from another class. Now let's double-click object in the code and right-click the mouse to bring up options. We could select Go to and then Declarations and Usage. This is the Control-B key combination for Windows users. This displays the actual source code of the class, in this case object Java, which is inherited automatically when you create any class. You can see as we scroll down that we will go through some of these methods. We see hash code, and the equals method which compares one type of object to another. This has a lot of detail about the implementation of each of these methods. There's also a string, which it says is just a way to return a string representation of a specific object. Let's explore the string a little more using main Java. We will close object.java first. Let's add a new class in main class Java itself, and we will call it employee. Remember, any one class in a Java source file can be public, and since we have already made public, we won't make employee public. Class employee curly braces. Private string name semicolon. Private int age semicolon. That's a simple code named employee with a name and an age. Let's set a constructor so we can quickly pass data to the class when we create it. Employee opening parentheses, string name, comma, int age, closing parentheses, curly braces. This dot name equals name semicolon. This dot age equals age semicolon. Now let's create an instance of employee in our main method and print employee. Employee equals new employee opening parentheses, double quotes, John comma, 30 closing parentheses, semicolon. System.out.println, opening parentheses, employee.toString, opening and closing parentheses, semicolon. And running the code. We get employee at the rate 1b28cdfa. You might get something different, but that's fine and I will explain it soon. What is that? Well, the kind of the toString method in the object class prints out the class name, which in our case is employee, followed by that sign, then the hash code of the object. A hash code is an integer that is unique to an instance in the currently executing code. When an instance is created, it's assigned the hash code, and that hash code is what can tell us if our multiple references are pointing to a single instance. It's a mechanism for comparison. Anyway, this is not what we want printed out. We really want to print out the name and each of our employee. And we have done this before, but now I hope it's becoming clear what we are doing. We are overwriting the toString method on object. Let's do that on employee. First, let's just type public and then to in lowercase and notice IntelliJ has popped up choices we could select. Let's pick that first option. And then we have a toString method that simply calls super.toString. Do you think that does anything different? Maybe you will remember we have said that calling a method on super like this without doing anything else is kind of redundant. Let's confirm that by running the code. Then we get the same result. We have really just explicitly called the code that Java would have implicitly done for us. Let's comment that code out and try the other option next. Then again we'll public, and to then pick the second option which is generated Fire Wizard in it. And this should look familiar. This brings up IntelliJ code generation window for the toString method. Then we will select both fields and press OK. We have done this before. We have simply specifying for this class what we want to print out. Running this code gives us the employee class name still, but now in brackets we can see this object has name equals to John and age equals to 30. Let's change this and just simplify it. We don't really care that the class name is employee. We will comment out the default generated code and simply return the employee name and say how old they are. Then write return name plus double quotes or plus age semicolon. And now if we run that, we get John is 30. You make this could be whatever you want it to be when the toString method is called on your class. You may also remember that I've told you Java implicitly calls the toString method on an object if you simply pass your object to system.println. Let's confirm that by changing system.out.println and removing the dot to string. Here we simply pass the employee object to the println method on system.out. And if we run that, we can confirm that this code is really calling the toString method on employee and John is 30 is still printed out. Then what happens if we now have another class that extends employee? Let's create an experienced employee class, which would be an employee who is aged 40 to 60. For example, in the company, this employee will have an employee ID associated with it. So, we will build experienced employee, which will inherit from employee. Let's add this new class. We write class experienced employee extends employee curly braces. Private string employee ID semicolon. Experienced employee, opening parentheses, string name, comma, int age, comma, string employee ID, closing parentheses, curly braces, super open parentheses name, comma, age, closing parentheses, and semicolon. This dot employee ID equals employee ID semicolon. Hopefully you understand what we are doing here with this code. We have created an experienced employee class that extends employee. We have added an attribute specific to experienced employee and called it employee ID. And we have set up a constructor with 3 fields. The 2 fields we have for employees name and age, and now employee ID as well. We call super with name and age parentheses to employee constructor. And we set the employee ID. Let's create an experienced employee in the main class. Name is Anderson, and his employee ID will be EN109. So, we write experienced employee experienced equals new experienced employee opening parentheses double quotes Anderson, comma 45, comma, double quotes, EN109 closing parentheses, semicolon, system.out.println opening parentheses, experienced closing parentheses, semicolon, and running that. We see that Anderson is 45 as the output for this code. This code inherited employee toString method code. And then we can override toString again, this time on experienced employee. Here we will return the employee ID and then call the toString method on employee with the super keyword. For this we go into the experienced employee class again and create toString method and remove these and write in it, return employee ID plus double quotes, experienced employee plus super dot toString parentheses semicolon. And when we run that, we get the output EN109 experienced employee Anderson is 45. In this case, super.string did not call objects toString method, it called employee. But it still inherits objects' other functionality indirectly through employee. Java only supports one class and extends class. For example, we couldn't type employee then object. This is a compile error. The inheritance tree is cumulative, meaning that experienced employee inherits both employee members and object members. Object members are accessible as long as employee doesn't override them. Because employee override toString, we no longer can simply call the toString implementation on object from experienced employee. Let's revert that last change. In summary, in this lecture, we will learn that all classes which do not explicitly extend another class will implicitly extend a class named object. Object is the base class or RIP class of every class in Java, which means all classes can use or override objects' methods. I hope you learned something useful in this lecture as well, and I will see you in the next one. Introduction to Text Block with Exercises. In this lecture, we will talk about text block. Let's take a look at a fairly new feature in Java, that is the text block. The text block is just a special format for multi-line string literals. It's simply a string with a new representation in the source code. It became part of the official languages of JDK 15. It can be used to represent any type of string. It reduces any accidental errors or complexities in writing multi-line string literals, as well as it improves the expressiveness and readability. Now see an example. For this Open IntelliJ, now create a new project named Formatting. Inside this project, create a main class and a main method using shortcut PSVM. This example uses the pre-JDK15 way of handling multiple lines of text. So we write string right arrow equal sign double quotes, welcome to our colon plus, double quotes backslash U279E company plus, double quotes backslash U279E Nixware semicolons, system.out. println, opening parentheses, right arrow, closing parentheses, semicolon. So, this code is using the concatenation operator, the plus sign to add several strings together. And we're using the Unicode character backslash U279E to include a right arrow character on these two lines. Now we run it. That if we print that out, we get a single line of text printer, welcome to our company and Nixware. That's not what I really wanted because I wanted some formatting and these strings on multiple lines. I can do this with some special combinations of characters called escape sequences. An escape sequence starts with a backslash. Java has several, but the most common ones, the ones you're most likely to use, are shown here. These could insert a tab, a new line, a double quote character, or a backslash character if you need it in your text. Let's set some of these characters to our multi-line string in this code. Well, that's some new lines after each of the first two lines, and we'll also add some tabs before the right arrows. We want one tap before the right arrow and two tabs before the second right arrow. And although that code is pretty ugly if we run it, we get a formatted right arrow list. That looks pretty good. Now let's use a text block to reproduce this output. String text block equals triple quotes. Welcome to our colon. Press double tab, backslash U279E company. Press triple tab, backslash U279E Nixware triple quotes, semicolon. System.out.println, opening parentheses, text block, closing parentheses, semicolon. You can see right at the start we're creating a string variable and assigning it string. This is the new format called a text block for creating a multi-line formatted string. You'll notice that we start with 3 double quotes there. This is required and they must be on their own line. The text that follows is the text that's part of the string. And we end with another 3 quotes which close or complete the text block. Everything between the 2 sets of triple quotes is the text block itself. And you can see we didn't include any additional quotes or plus signs. And we also got rid of the tab and new line escape sequences. The text block lets us format text in the source code the same way we want to see it in the output. Let's run this and see what we get. You can see we get the exact same output as we did when we concatenated several strings and used escape sequences. That's really it. The text block makes outputting many lines of text using indents and new lines a lot easier, as I hope you can see. We've looked at formatting text over multiple lines in 2 different ways. So, text blocks in Java have several advantages over traditional string literals or concatenation. Here are some of the key benefits. Improved readability. Text blocks make it much easier to read and write code that includes long, multi-line strings. The text block syntax makes it clear which parts of the text are included and how they are formatted. Reduced code noise. With text blocks, you no longer need to use escape characters or concatenation to represent multi-line strings. This reduces the amount of noise in your code and makes it more concise and easier to read. Preserves whitespace. Text blocks preserve whitespace, including leading or trailing whitespace and line breaks, so you can easily format your text without worrying about the impact on your code. Easy to embed. Text blocks are easy to embed within other Java code, making it simple to create complex text-based data structures or code generation templates. Interpolates variables. Java's text block feature also supports variable interpolation, which allows you to include variables directly within the text block without needing to concatenate them manually. While text blocks in Java provide many benefits, there are also some limitations to consider that are limited backward compatibility. Text blocks were introduced in Java 15, so if you are working with an older version of Java, you will not be able to use them. This may limit the applicability of text blocks in some contexts. Increased memory consumption. Text blocks are stored in memory as multi-line strings, which can increase memory consumption for large strings or when many text blocks are used in the same program. Limited performance benefits. While text blocks may make code more readable and easier to write, they do not provide significant performance benefits over traditional string literals or concatenation. Potential code obfuscation. The syntax for text blocks can be confusing or unfamiliar to developers who are not familiar with the feature. This could lead to code that is more difficult to understand or maintain. Limited formatting control. While text blocks preserve whitespace, they do not offer the same level of formatting control as some other text-based formats. This can make it more difficult to create complex formatted text within a text block. Next, let's look at formatting numbers in text that will output. There are several ways to do this. Up until now, we've used system.out.println and system.out.print, but there are two other methods we haven't yet discussed. There are system.out.printf and system.out.format. These methods behave the same. So for our examples, we'll just use system.out.printf. But be aware you can change printf to format with the same results. Let's start with a simple example, and then we'll explain how this works. So, we write int number equals 100 semicolon. System.out.printf opening parentheses double quotes. Your number is colon space %d comma number closing parentheses semicolon. You'll notice we're using printf in place of print or println on systemout.printf is like print in that it doesn't end with a new line character. But this method has multiple arguments. The first is a string, which will be printed to the console, and the following arguments are values that will be used in the string. First, you'll notice our string contains %d in it. This is a special indicator called a format specifier. This is a placeholder for other data which should replace this specifier in the text. In this example, we're going to replace %d with number, and that's why we pass at just the second argument to this method. Now running this code. We see we get the output. Your number is 100. Let's try another example. This time we'll pass add a new number and find the sum. Before we do that, we'll first add an escape sequence in the first string so we have a new line printed between statements. So, we write int sum equals number plus 40 semicolon. System.out.printf opening parentheses double quotes number equals %d comma, sum equals %d comma number variable comma, sum variable closing parentheses semicolon. In this statement, we have two instances of %d, so we should pass two arguments, number and sum. And running that we see the result. Number equals sign 100, sum equals sign 140. Let's take a moment and look more closely at this format specifier, %d. But they're most complex format specifiers. So, go to this link shown here. Let's start with the %sign, and then with the conversion symbol, and have lots of options in between. We've looked at one conversion type, d, which is the symbol used for a decimal integer value. Let's go to Java API documentation for a class called formatter, which is the basis for many of the formatting methods we'll be talking about. So if we scroll down, we can see the conversion symbols shown in this table. But once you'll be using the most of those for the two different numeric types d and f. D formats a decimal integer as we've said, and would be used for any of Java's whole number primitive types like short, int, and long. If formats are decimal number, so it can be used for floating point numbers, a double or float. But you can see there are many others for different types of numbers, dates and time, as well as general specifiers. And look at the last one, the letter N called the line separator. So this would print a new line character. The difference between these escape sequence \n and this format specifier %then is that % in outputs to platform-specific line separator, so it's preferred. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about comparison between string and string builder class. So, both string and string builder are classes in Java that are used to represent a sequence of characters. However, there are some key differences between the two. Immutability. String objects are immutable, which means that once a string object is created, its value cannot be changed. Any operation that appears to modify a string object actually creates a new string object with the modified value. String builder objects, on the other hand, are mutable, meaning that you can modify the value of the object directly without creating a new object. Performance. Because string objects are immutable, modifying a string object involves creating a new object with the modified value. This can be slow if you need to perform a lot of modifications. String builder objects are designed to be more efficient when making a large number of modifications to a string, because you can modify the same object repeatedly without creating new objects. In other words, because string is immutable, each method call returns a new instance of a string. As an alternative, Java provides a mutable class that lets us change its text value or character sequence. This is the string builder class. We've already talked about creating strings and a preferred way. The most efficient way is simply to assign a literal or concatenated literals to a variable. We show this on the left here. Let's compare that to the string builder, which has 4 overloaded constructors. These are shown on the right side here. There are 4 ways to create a new string builder object using the new keyword. Pass a string. Pass no arguments at all. Pass an integer value. Pass some other type of character sequence like string builder. Now see an example of compare the string and string builder class. I'm starting out with a string options project with the usual main class and main method. First, we'll create a couple of overloaded methods, one that will take a string and the other will take a string builder. Both of these will print the argument that's passed, and both will call the length method, which is a method on both string and string builder. So, we write public static void print info, opening parentheses, string my string, closing parentheses, curly braces, system.out.println, opening parentheses, double quotes, string equals plus mistring, closing parentheses, semicolon, system.out.println, opening parentheses, double quotes, length equals plus mistring.length, opening and closing parentheses, semicolon. Here we're printing out the string and the length of the string passed us the argument. Next, we overloaded this method by writing public static void printinfo, opening parentheses, string builder my builder, closing parentheses, curly braces, system.out.println, opening parentheses, double quotes, string builder equals plus my builder, closing parentheses, semicolon, system.out.println, opening parentheses, double quotes, length equals plus my builder.length, opening and closing parentheses, closing parentheses, semicolon. Here we changed the parameter type and name changing string to string builder and the string parameter name to builder. We have to change that in both statements in the method as well. So now in the main method, let's create some objects. String message equals double quotes, I love plus double quotes programming semicolon. String builder message builder equals double quotes, I love plus double quotes programming semicolon. What I wanted to show you with this code, this second statement doesn't compile. This is an important difference between the string and the string builder. You can't assign a string literal to a string builder variable. We have to use one of the constructors, so let's do that. We'll remove that assignment to I love programming. Instead, we'll create a new string builder and pass I love programming to the constructor. We've created 2 types of objects which have the same set of characters in them. Let's make a call to our printinfo methods for each of these objects. So, we write printinfo, opening parentheses, message, closing parentheses, semicolon. Printinfo, opening parentheses, message builder, closing parentheses, semicolon. And if we run that, we see that the sequences have the same length as you'd expect, since the values are the same. So now let's examine what we mean when we say the string builder's text value is mutable, but the string's isn't. First, we use the concat method on string, which is a lot like using the plus operator on string. The result is a new string object with the argument value concatenated to existing text. For string builder, a similar method is called append, so we'll use that. Message.concat, opening parentheses, double quotes in Java closing parentheses, semicolon. Message builder.append opening parentheses, double quotes in Java closing parentheses, semicolon, then running the code. Now look carefully at the results. String is still I love programming, but string builder is I love programming and in Java, and its length has increased. Let's talk about what happened. When we passed the string literal and in Java to the concat method, this created an object in memory for that literal and in Java. It also created the result of the concat method, the object, the string that has the value love programming and in Java. It's important to remember to assign the result of any string manipulation method you call on a string to a variable. These methods don't change the internals of the existing string object. The string referenced by the message variable never changed. Instead of new string was created by the method call. Now let's compare that to what happened with the string builder. We still have the objects in memory that represent the string literals that were passed to the string builder. In this case, message. But you can see that after the call to the append method, we still only have one string builder object. The variable message builder is still referencing the same object, but the value of that object changed. This is important because it means the character sequence in the string builder changed. And this time we didn't have to assign the result to another variable to access the result. String methods create a new object in memory and return a reference to this new object. String builder methods also return a string builder reference, but it's really a self-reference or a reference to the same object. Unlike strings, we can call methods on string builder without the need to assign the results to intermediate variables, as we saw with strings. String builder methods return this self-reference to support chaining methods together. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will discuss about composition in object-oriented programming in Java. Composition is another component of object-oriented programming. So, in Java, composition is a way to make new, more complex objects by putting smaller objects inside of them. So, before we go into detail about composition, we will first talk about inheritance. So, inheritance is a relationship. For example, a building is a house, which means a house is a type of building and building inherits with the house. This type of relationship is called inheritance. In other words, inheritance allows a subclass to inherit properties and methods from a superclass, creating is a relationship between them. This means that the subclass is a specialized version of the superclass and can access and use the properties and methods of the superclass. So, if we see the building and house example, the composition in this example is that a house has a kitchen. That is a composition, because house and kitchen has a relation between them. Now we see another example. For example, we have a car, and its manufacturer company is Honda. So, we say that Honda is a car, means car and Honda is a relation between them that is called inheritance, and then we say that Honda has an engine in it. So, Honda and engine has a relation between them that is called composition. I think you will understand the composition concept. Now we will see its practical example. For this, open IntelliJ. So, we write a program that have a person class with name and address fields, and then creating two subclasses, student and professor, which inherit from the person class and have additional fields of roll number and salary, respectively, along with an address class that is composed within the person class. We also create a main class and main method to instantiate objects of the student, and professor classes and demonstrate the use of inheritance, and composition in accessing their respective fields and the address fields from the address class. Let's start creating this program. For this, we create a new project named composition. Now we create a class file named main class, and inside it we create a main method using shortcut PSVM. Now we create another class file named person. Now we write private string name semicolon, private string street semicolon, private string city semicolon, private string state semicolon. These are private instance variables declared in a Java class. Here name represents the name of a person. Street represents the street name of the address of a person. City represents the city of the address of a person. State represents the state of the address of a person. Now we'll generate the constructor. So selecting code generate, then constructor. Now we select all these attribute and press OK. Now constructor is created. Here the person class constructor takes 4 parameters: name, street, city, and state, which are used to initialize the private member variables of the class with the values passed as arguments. This constructor sets the name, street, city, and state member variables of the person class to the values passed in the constructor parameters. Here this keyword is used to refer to the current instance of the person class and to distinguish between the local parameter variables and the instance variables. Then we create getters, so selecting code generate, then getters. Now we select all these attribute and press OK. Now getters are created. So, these getter methods are used to retrieve the values of private fields from outside the class. Here the getName method returns the name of the person. The getStreet method returns the street address. The getCity method returns the city. And the getState method returns the state of the person. Now we have our base class, and next let's create a couple of the subclasses. We'll let them all in the same Java source file as the person.java file. Remember, only one class can be public, so we'll omit the access modifier for these classes. We'll start with student class. So, we write class student extends person curly braces. Here the student class is a subclass of the person class. This means that the student class inherits the properties and methods of the person class. In other words, the student class has all the properties like name, street, city, state, and methods like getters for name, street, city, state of the person class. This establishes an is a relationship between student and person, where a student is a type of person. So, this is called inheritance because if it is a relation. Then inside this class, we write private string roll number semicolon. Here roll number is a private instance variable of the student class. It is used to store the roll number of a student. Now we'll generate the constructor, so selecting code generate, then constructor. Now we select this attribute and press OK. Now constructor is created. So, this is the constructor for the student class, which takes in 5 parameters: name, street, city, state, and roll number. The constructor calls the constructor of its parent class person using the super keyword, which passes the first 4 parameters to the parent constructor to set the name, street, city, and state fields of the person class. The roll number parameter is used to set the roll number field of the student class using this keyword. Then we create getter, so selecting code generates, then getters. Now we this attribute and press OK. Now getter is created. So, this getter method returns the roll number of the student. The roll number is a private variable of the student class, so it cannot be accessed directly from outside the class. To access the roll number, this method is used, which returns the value of the private variable roll number. Now we create another subclass called professor. So, we write class professor extends person curly braces. Here the professor class is a subclass of the person class. It inherits all the properties and methods of the person class and can also have its own additional properties and methods. This is an example of inheritance, because this establishes an is a relationship between professor and person, where a professor is a type of person. In this case, the professor class has an additional property salary that the person class does not have. This means that the professor class has all the properties and methods of the person class, and also has its own additional property. Now we write inside this class private string salary semicolon. Here we create a private instance variable that represents the salary of the professor class. This instance variable is specific to the professor class and not present in the person class, which means that only professor objects will have this variable associated with them. Now we'll generate the constructor, so selecting code generate, then constructor. Now we select this attribute and press OK. Now constructor is created. So, this is the constructor of the professor class, which takes 5 parameters: name, street, city, state, and salary. The first 4 parameters are passed to the superclass person's constructor using the super keyword. This initializes the inherited name, street, city, and state fields of the professor object with the values passed to the constructor. The last parameter salary is used to initialize the salary field that is specific to the professor class. This keyword is used to refer to the salary field of the professor object being constructed. Then we create getter, so selecting code generates, then getters. Now we this attribute and press OK. Now getter is created. So, the getSalary method is a getter method for the salary attribute of the professor class. It returns the value of the salary attribute, which is a string representing the salary of the professor. This method allows other classes to access the salary attribute of a professor object without modifying it directly. Now go into the main class.java. Here we write student equals sign new student opening parentheses double quote John Doe comma, double quote 5th Ave 32nd floor comma, double quote New York comma, double quote United States comma, double quote a 201 closing parentheses semicolon. Here we create a new instance of the student class and assigns it to a variable called student. The constructor of the student class is called with the arguments John Doe for the student's name, 5th Ave 32nd floor for the student's street address, New York for the student's city, United States for the student's state, and a 201 for the student's roll number. These values are then used to initialize the corresponding instance variables of the student class. The we write system.out.println opening parentheses double quote student roll no plus student.get roll number parentheses plus double quote \n name plus student.get name parentheses plus double quote \n city plus student.get city parentheses plus double quote \n street plus student.get street parentheses plus double quote \n state plus student.get state parentheses closing parentheses semicolon. This line of code prints out the details of the student object created earlier. Here student.get roll number retrieves the roll number of the student object, and student.get name retrieves the name of the student object. Similarly, student.get city, student.get street, and student.get state retrieve the city, street, and state of the student object respectively. The details retrieved from the student object are then concatenated with strings and printed out using print method. Then we write system.out.println opening parentheses double quote multiple hyphen sign closing parentheses semicolon. This line of code simply prints a line of dashes to the console, which can serve as a visual separator between the previous and the upcoming outputs. It is used here to separate the output for the student object from that of the professor object. Then we write professor equals sign new professor opening parentheses double quote Anderson comma, double quote 5th Ave 32nd floor comma, double quote New York comma, double quote America comma, double quote then $1,000 closing parentheses semicolon. Here we create a new instance of the professor class and initializes it with the given values. The professor class has a constructor that takes 5 arguments, which are the name, street, city, state, and salary of the professor. The we write system.out.println opening parentheses double quote professor salary plus professor.get salary parentheses plus double quote \n name plus professor.get name parentheses plus double quote \n city plus professor.get city parentheses plus double quote \n street plus professor.get street parentheses plus double quote \n state plus professor.get state parentheses closing parentheses semicolon. Here professor.getSalary retrieves the salary of the professor object and professor.getName retrieves the name of the professor object. Similarly, professor.getCity, professor.getStreet, and professor.getState retrieve the city, street, and state of the professor object respectively. The details retrieved from the student object are then concatenated with strings and printed out using print method. Now we run it. Here is the output. First is the student object, and after the separator, the second is the output of the professor object. It's an example of an is a relationship or inheritance. Now we create a has a relation, which means we use the concept of composition. You saw that we use address variables like street, city, and state every time in the constructor of the student and professor classes. Here the address have the has a relationship of professor and student class, and professor and student have a is a relationship with the person class. For this we create a new class file named address. Now inside this class we write private string street semicolon, private string city semicolon, private string state semicolon. And then we create a constructor using IntelliJ functionality. So here address class constructor created. After that, we create getters using IntelliJ functionality. Here these 3 getters are created. So, The purpose of the address class is to model an address with its different components, namely street, city, and state. It provides a constructor that takes these components as parameters and initializes the corresponding instance variables. It also provides getter methods to access the values of these variables. This class can be used in other classes to represent an address for a person, a company, or any other entity that needs an address. Now go into the person.java file, and first we remove these three variables street, city, and state. And then here we write private address semicolon. It is a declaration of a private instance variable named address of type address within a class. This variable is an object of the address class, which encapsulates the details of a physical address such as street, city, and state. By declaring an address instance variable within a class, we can use it to store and retrieve the details of an address for objects of that class. This can be useful in situations where multiple objects within the same class require the same address information, and it can help to avoid code duplication by centralizing the address data in a separate class. Then we remove these parameters from the constructor and write address space address and add a statement inside this constructor that is this dot address equals sign address semicolon. Then remove all these getters of address variables. Similarly, go into the student class. Remove these variables and add address as parameter in its constructor and also in the super statement. Same process repeat in the professor class. Now go into the main class.java file. Now in the first line we write address equals sign new address opening double quote parentheses 5th Ave 32nd floor comma, double quote New York comma, double quote United States closing parentheses semicolon. Here we create a new object of the address class with the given values for the street, city, and state. The object is then assigned to the address variable. Now we remove the values of city, state, and street from the student object constructor and write the address object here. Then we replace the student.getCity, student.getStreet, and student.getState with address.getCity, address.getStreet, and address.getState, because these getters are called from the address class. So, therefore, the address object calls them. Similarly, we create another object for address with named address1 and give them same values. Then we remove the values of city, state, and street from the professor object constructor and write the address object here. Then we replace the professor.getCity, professor.getStreet, and professor.getState with address.getCity, address.getStreet, and address.getState, because these getters are called from the address class. So, therefore, the address object calls them. Now run it. The result is the same as when we used simple inheritance, but this time we use the composition concept. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Encapsulation with Exercises. In this lecture, we're going to talk about another fundamental object-oriented programming concept, which is encapsulation. We've already talked about it briefly when we first introduced getter methods. In Java, encapsulation means hiding things by making them private or inaccessible. What we hide things in Java. To make the interface simpler, we might want to hide unnecessary details. To protect the integrity of data on an object, we may hide or restrict access to some of the data and operations. To decouple the published interface from the internal details of the class, we may hide actual names and types of class members. This gives us more flexibility if we have to change the class in the future. When we talk about the class's public or published interface, we're really talking about the class members that are exposed to or can be accessed by the calling code. Everything else in the class is internal or private to it. An application programming interface or API is the public contract that tells others how to use the class. Now we will see an example. For this, we program defines a class marks calculation with 4 instance variables math marks, science marks, percentage, and grade. It has 2 methods calculate percentage and calculate grade that calculate the percentage and grade based on the marks obtained in the 2 subjects. Create another class named main class, and inside this class, create an object of marks calculation is created, and the marks in math and science subjects are assigned. The calculate percentage and calculate grade methods are called to calculate the percentage and grade based on the assigned marks. The percentage and grade are printed to the console using print method. Let's start creating this program. For this, open IntelliJ. Now we create a project named encapsulation. Now we create a class named main class, and inside it we create a main method by using shortcut PSVM. So, what we're going to do is create a class that doesn't use encapsulation to show why this feature is important. We're going to start up with the class that doesn't use it, and then we will create another enhanced class that does use it. We will start with the non-encapsulated class called marks calculation. To do this, we will create new Java class and call it marks calculation. Now let's set the variables or fields, and we've set these are the math marks, science marks, percentage, and grade. So, we write public int math marks semicolon, public int science marks semicolon, public float percentage semicolon, public string grade semicolon. So, these are the fields or instance variables of the marks calculation class. Math marks is an integer field that holds the marks obtained by the student in math subject. Science marks is an integer field that holds the marks obtained by the student in science subject. Percentage is an float field that holds the calculated percentage marks of the student, which is calculated by averaging the marks obtained in the two subjects. Grade is a string field that holds the calculated grade of the student, which is determined based on the total marks obtained by the student in the two subjects. Now what I want you to notice is that here we've actually used a public access modifier. We've discussed this before, and we've said it's usually a good idea to use private. But we're using Puppet for a reason here, and that'll become clear shortly. We're not actually going to create a constructor for this class, but we will create our two methods next. So, we write public int calculate percentage parentheses curly braces return double opening parentheses math marks plus science marks closing parentheses divided by 200. 0f closing parentheses multiply by 100. 0f semicolon. Here we calculate the percentage based on the math marks and science marks variables by dividing their sum by 200, which are the total maximum marks for both subjects combined. The division is done using the float value 200. 0f to ensure that the result of the division is a floating point number rather than an integer. The result is then multiplied by 100. 0f to convert it into a percentage value. By using the float values for division and multiplication, the result of the calculation is automatically promoted to a float, which allows for decimal places to be included in the result. If the calculation were done using only integers, then the result would be truncated to an integer value, which would result in incorrect percentage values for cases where the sum of the marks is not evenly divisible by 200. Then we write public void calculate grade parentheses curly braces. If opening parentheses percentage greater than equals to 90 and percentage less than equals to 100 closing parentheses curly braces grade is equal to double quota semicolon. Else if opening parentheses percentage greater than equals to 80 and percentage less than equals to 89 closing parentheses curly braces grade is equal to double quote B semicolon. Else if opening parentheses percentage greater than equals to 70 and percentage less than equals to 79 closing parentheses curly braces grade is equal to double quote C semicolon. Else if opening parentheses percentage greater than equals to 60 and percentage less than equals to 69 closing parentheses curly braces grade is equal to double quote D semicolon. Else curly braces grade is equal to double quote F semicolon. Here we create a calculate grade method that is used to calculate the grade of the student based on the total marks obtained in the two subjects, math and science. In this method, the total mark variable is calculated by adding the math marks and science marks. Then, an if-else ladder is used to determine the grade based on the percentage obtained. The grade is assigned to the grade field, which holds the grade value. The grading system used in this method is a simple one where the grades are assigned based on the total mark. For this we use ladder if-else statements. So, if the total mark obtained is greater than or equal to 180, the grade assigned is a. If the total mark obtained is greater than or equal to 160, the grade assigned is B. If the total mark obtained is greater than or equal to 140, the grade assigned is C. If the total mark obtained is greater than or equal to 120, the grade assigned is D. Otherwise, the grade assigned is F, which means the student has failed. Once the grade has been determined, it is assigned to the grade field, which can be accessed later to display the grade. The marks calculation class is done. Now we can go back to our main class, and we will create a new marks calculation object. For this, we write marks calculation is equal to new marks calculation parentheses semicolon. We didn't create a constructor in the marks calculation class, but if you recall, a default constructor with no parameters gets created for us by Java. In other words, we don't now have a constructor to pass marks calculation data. This means the calling code needs to manually set the data in these fields. Now we set it manually. So, we write calculation.mathMarks is equal to 80 semicolon. Calculation.ScienceMarks is equal to 90 semicolon. That's the way we need to initialize those fields. And of course, as you can see, even though we're not in that class, we can access those fields directly. That's because we set the access to be public for those fields. If we'd sites to private, we wouldn't be able to do this. Next, let's test the methods on the marks calculation class. So, we write calculation.calculate percentage parentheses semicolon. Calculation.calculate grade parentheses semicolon. Now print these results. For this, we write system.out.println opening parentheses double quote percentage plus calculation.percentage closing parentheses semicolon. System.out.println opening parentheses double quote grade plus calculation.grade closing parentheses semicolon. Looking at this code, here the marks calculation object named calculation is created, and its math marks and science marks fields are set to 80 and 90 respectively using the dot notation. Then, the calculate percentage method is called on the calculation object, which calculates the percentage of marks obtained by the student in the two subjects. After that, the calculate grade method is called on the calculation object, which calculates the grade of the student based on the total marks obtained in the two subjects. Finally, the results are printed to the console using the print method. The percentage and grade fields of the calculation object are accessed using the dot notation and printed to the console. Now run it. Here is the output that is percentage 85, grade B. We've created a method in here, calculate percentage, which is the code that should manage the calculation of percentage of student. This is where we want to put in all our formulas for making sure that we're calculating percentage correctly. But what happens if the calling code decides to just access the calculation of percentage directly anytime it wants? Now we change here and write calculation.mathMarks is equal to 150 semicolon. Calculation.ScienceMarks is equal to 190 semicolon. Now here the main method has kind of gone rogue because it's setting the student percentage manually outside of the normal calculate percentage method calls. This code actually takes control away from the marks calculation class for managing the student percentage. It didn't call the restore calculate percentage, which has the additional control in place that calculate percentage can never exceed 100. This is an example of the first problem with a class that's not encapsulated properly. Allowing direct access to data on an object can potentially bypass checks and additional processing. Your class has in place to manage the data. By being able to access fields directly like this, we really potentially opening up our application to be accessed in ways that it shouldn't be. Maybe we don't ever want the code to be able to change the calculate percentage that because we really wanted to restore percentage to be called and the right set of conditions to be set. But because these fields are public to everyone, we can't control when they get accessed. But there's also another issue. If we go back to our marks calculation class again, and let's just say we've decided that we want to change the field for the name of our subject. Maybe now we think name isn't descriptive enough, and we want to be a bit clearer. We're going to change math marks to linear algebra marks, and that's going to be the variable name that we want to use from this point on. This is really just an internal change to the marks calculation class, and in theory, it shouldn't really affect any other class. We should be able to call class variables anything we want and be able to change them if we want to. But if we go back to the main class now, suddenly we've got an error. And it's quite rightly saying that it can't find that field anymore, because we're trying to access these fields directly. We've got an error here. Now this might not seem like the end of the world. But what it means is that in a time that we change this field's name, we have to also make the change here in the main class. And in a small application like this, of course it's not going to be a problem. It's quite a quick change. But when you're talking about big applications, it does become a problem. Because the first thing here, looking at the main class, you have to figure out what's the new correct name of the field. This means you need to go back into the code and have a look and see what the new name is. And maybe this isn't really a problem as much when it's your own code, but if you're deploying this kind of code in a library, for example, you're setting yourself up for a lot of problems. Allow direct access to fields means calling code would need to change when you edit any of the fields. The third issue with this approach is we're manually initializing our object with these calls at the start. This means the calling code is responsible for making all the right method calls to initialize marks at the beginning. That the code might actually forget to initialize this altogether. And consequently, when the class is called for the first time, the subject marks may be starting out with 0. In other words, we're not guaranteeing or ensuring that to access the marks calculation class. We can only access it when the data is valid. Then we can do that with a constructor. We can actually make sure that the data is valid and that the object is valid before the calculation starts. But when you are allowing people to manually access the fields, there's no real way to guarantee that the marks are set. Omitting a constructor that would accept initialization data may mean the calling code is responsible for setting up this data on the new object. And this is what encapsulation actually does for us, and what we don't code like this. We want the ability to ensure certain conditions are met before calculation, and that access to the calculation data is controlled and protected. Now revert these changes in the marks calculation class. At this point, we showed you a class that had no encapsulation principles. And we saw this created several problems. Allowing direct access to data on an object can bypass checks and operations. It encourages an interdependency or coupling between the calling code and the class. This interdependency makes it hard to change the class without impacting the calling code. Now let's create a new class that actually has got proper encapsulation and show you the right way of doing it. Open the project panel, right-clicks on the src folder. Select New Java Class and enter Encapsulate Calculation. The difference here is we're going to create our fields as private. So, we write private int math score semicolon, private int science score semicolon, private float percentage semicolon, private string grade semicolon. These fields are marked as private, which means they can only be accessed by methods within the same class. This is a form of encapsulation, which is a way of hiding the implementation details of a class from other parts of the program, and only exposing the necessary methods and variables for use. Next, we do want to create a constructor. Placing the cursor below those fields will first create a constructor with these parameters, so select Code Generate, Constructor, and pick Math Marks and Science Marks. Now constructor is created. And what we're going to do is use this constructor to make sure the marks field stays in the range of 0 to 100 within the field statement. Then inside this constructor, we write if opening parentheses math marks less than 0 closing parentheses curly braces, this dot math marks is equal to 0 semicolon. Then write else if opening parentheses science marks less than 0 closing parentheses curly braces, this dot science marks is equal to 0 semicolon. Then write else if opening parentheses math marks greater than 100 closing parentheses curly braces, this dot math marks is equal to 100 semicolon. Then write else if opening parentheses science marks greater than 100 closing parentheses curly braces, this dot science marks is equal to 100 semicolon. Else curly braces, this dot science marks is equal to science marks semicolon. This dot math marks is equal to math marks semicolon. Here we first check if math marks is less than 0. It sets the value of math marks to 0. If science marks is less than 0, it sets the value of science marks to 0. If math marks is greater than 100, it sets the value of math marks to 100. If science marks is greater than 100, it sets the value of science marks to 100. Otherwise, it sets the values of math marks and science marks to the values of the corresponding arguments passed to the constructor. This ensures that the values of math marks and science marks are always within the valid range of 0 to 100, preventing any potential errors or unexpected behavior when calculating the percentage and grade. Then we write private float, calculate percentage parentheses, curly braces, return double opening parentheses, this dot math marks plus this dot science marks closing parentheses divided by 200. 0f closing parentheses multiply by 100. 0f semicolon. This is a private method that calculates the percentage based on the math and science marks. The method uses percentage formula to calculate the percentage. Here, math marks and science marks are instance variables that have been set through the constructor. By making the method private, it can only be accessed within the class, which helps to ensure that the calculation of percentage is performed correctly and not modified or accessed from outside the class. The method returns the calculated percentage value, which is then used to calculate the grade using another public method, calculate grade of the same class. Now we copy calculate grade method from marks calculation class. So here we can make change that we change void to string return type of method, and then we write it first line in the method that is this dot percentage is equal to calculate percentage parentheses semicolon. So it assigns the value returned by the calculate percentage method to the percentage instance variable that called the calculate grade method. The calculate percentage method calculates the percentage of marks obtained in math and science subjects and returns it as a float value. The calculate grade method uses the value returned by the calculate percentage method to determine the grade and assigns the grade to the grade instance variable. Before that, it also stores the calculated percentage in the percentage instance variable. Now in the last line of this method, we write return double quote percentage plus this dot percentage plus double quote / n grade plus this dot grade semicolon. Here we returning a string that includes the calculated percentage and the corresponding grade. The percentage and grade values are obtained by calling the calculate percentage and calculate grade methods, respectively. The resulting string is formatted using string concatenation and includes a line break to separate the two values on separate lines when printed to the console. The resulting string is then returned to the calling method. Now go into the main class.java file. Now first we comment all these code of marks calculation object. Then we write encapsulate calculation EC is equal to new encapsulate calculation opening parentheses 70, 80, closing parentheses semicolon. Here we create an object of the encapsulate calculation class and initializes it with the constructor that takes two integer arguments 70 and 80. These two arguments represent the math and science marks respectively. The constructor initializes the private variables math marks and science marks with the values passed as arguments while also ensuring that they are within the range of 0 to 100. If the values are less than 0, it sets them to 0, and if they are greater than 100, it sets them to 100. Then write string result is equal to ec.calculate grade parentheses semicolon. systemout.println parentheses result semicolon. As here, we are calling the calculate grade method on the encapsulate calculation instance EC that we created in the previous line. The calculate grade method first calculates the percentage based on the math marks and science marks values stored in EC. It then determines the grade based on the percentage using a series of if-else statements and stores the grade in the grade variable. The method then returns a string that contains the percentage and grade information. This string is stored in the result variable. Finally, we print the result string to the console using the println method. This prints the percentage and grade information to the console. Now run it. Here is the output that is percentage, 75.0 and grade, C. Now we change the value in the constructor to 85 and 76 and run it. The output is percentage, 85.0 grade, B. Hopefully you can see straight away we've got more control. There's no other way for the calling code to change the math marks and science marks except to use constructor method to do it. This gives all the control back to the encapsulate calculation class. And just to be clear, this is encapsulation. This is what we're doing. By making our fields private, we're making sure that the fields within the class aren't accessible to any classes that are outside. And now let's say I wanted to change the field we used for the marks, changing it from math marks to English marks. But this time I want to show you another feature of IntelliJ that's really cool and enables you to do a quick rename. If you actually click on math marks in this case and right-click, go to Refactor and choose Rename. And now if I go back and change this, the part that's in blue, I change that to English marks. You see it turns pink. Before hitting the Enter key, we can English marks and see every instance of math marks has been replaced with English marks. And if we press Enter, we're going to pop up that asks us if we want to change the parameter names of the constructors. And this really is up to you. But this time I'll select All and press OK. And it changes the math marks to English marks in their code. So this is another cool feature of encapsulation, which is we can make all these changes to this encapsulate calculation class. We can create private fields and private functions that we don't want to be exposed to any other class. And we can change those names at any time in this code without affecting any other code. That's really one of the huge benefits of encapsulation, is that you're not actually affecting any other code. It's sort of like a black box in many ways. This is why we want to use encapsulation. We really want to protect access to our object's data. We protect the members of the class and some methods from external access. This prevents calling code from bypassing the rules and constraints we've built into the class. In this case, as I said, we're using it to make sure that the encapsulate calculation, when we create a new instance, it's initialized with valid data. But likewise, we're also making sure that there's no direct access to the fields. That's why you always use encapsulation. It's something that you should really get used to. To create an encapsulated class, you want to create constructors for object initialization, which enforces that only objects with valid data will get created. Use the private access modifier for your fields. You set it and get a method sparingly and only as needed. These access modifiers that are private only for the methods that their calling code needs to use. You definitely don't want to be creating code like the player class when you're creating public fields. In the majority of cases, you don't want to give access to other classes because, as you saw, it's more work to make those changes when you create, or when you change a field name or something of that nature. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we're going to talk about another fundamental object-oriented programming concept, which is polymorphism. So, polymorphism is a concept in object-oriented programming that refers to the ability of different objects to respond to the same message or method in different ways. In other words, it allows objects of different classes to be treated as if they were objects of the same class, enabling them to share a common interface. Polymorphism can take different forms, such as method overloading, where different methods with the same name but different parameters are defined in a class, or method overriding, where a subclass provides a different implementation of a method that is already defined in its superclass. Polymorphism is a powerful feature of object-oriented programming that allows for more flexible and extensible code, making it easier to write and maintain complex software systems. In simple words, polymorphism means many forms. And you might be wondering, how does this apply to code? Full polymorphism lets us write code to call a method, but at runtime this method's behavior can be different for different objects. This means the behavior that occurs while the program is executing depends on the runtime type of the object. And the runtime talk might be different from the declared type in the code. The declared type has to have some kind of relationship to the runtime type, and inheritance is one way to establish this relationship. There are other ways, but in this lecture we'll talk about how to use inheritance to support polymorphism. We've given you a taste of this in the inheritance lecture, but this time we're going to look at polymorphism specifically. Hopefully by now you're getting more comfortable with class diagrams. This time we're going to look at a polymorphism example using fruit. We'll have a base class of fruit which has the name of the fruit, and we'll have one method, isRipe. We'll have two subclasses, each a different kind of fruit. We'll have an orange fruit and a banana fruit. These are the different categories, so we'll use these as the subclasses. All of these will override and implement unique behavior for the fruit method. Now we will see an example. For this first we create a project named polymorphism. Then we create a class named mainClass, and inside this class we create a main method using shortcut PSVM. Then we create another class named fruit, and then we write private string name semicolon. The next we'll generate a constructor, placing our cursor under that field and select code generate constructor. And pick name. And we get the constructor. And now let's add isRipeFruit method. This is the public method that's going to be called from the outside world or the calling code. And this is the method that we'll be using to demonstrate polymorphism. So we write public void isRipe parentheses string check curly braces string instance type equals sign. This dot get class parentheses dot get simple name parentheses semicolon. Systemout.println opening parentheses name plus double quote is a plus instance type plus double quote and plus check closing parentheses semicolon. Now here on the first line of this method is something new. You've seen the use of the keyword this before, which refers to the current instance, and now we're calling a method on that called getClass. The method getClass is on java.lang.object, which we've talked about. This method returns class type information about the runtime instance on which this method is executing. And from that we can get the name of the class using the getSimpleName method. And here again, we're just using method chaining for convenience. This prints out the class, which will be fruit. If we execute this method on a runtime fruit object, but when we implement the subclasses and run this method, the runtime object could be an instance of one of those classes. Next, in this code, we print out the title of the fruit and the type of the fruit runtime instance, and that's the fruit class. In other words, the purpose of this method is to print out a message indicating that the fruit is ripe. The message includes the name of the fruit, as well as the type of the fruit, which is obtained using the getClass.getSimpleName method. So, the getClass.getSimpleName method returns a string containing the simple name of the class of the current object. For example, if the current object is an instance of the orange class, then getClass.getSimpleName would return the string type orange type. If the current object is an instance of the banana class, then getClass.getSimpleName would return the string type banana type. By including the name of the fruit and its type in the output message, this method allows for different types of fruits to be handled in a polymorphic manner. For example, if we have an array of fruit objects that includes both orange and banana objects, we can call isRipe method on each object in the array, and the appropriate message will be printed for each fruit. Let's go to the main method on main class and test out the isRipeFruit method. So, we write fruit equals new fruit, opening parentheses, double quotes, orange, closing parentheses, semicolon. Fruit.isRipe parentheses double quote ripped semicolon. And running this, we get the output that is orange is a fruit and ripped, and that's because the runtime instance of the fruit variable is the fruit class. It's the object we created here in the main method, and we did new fruit, which means it's really an instance of a fruit. Here, we've created the object using the new fruit statement and passed it the name orange. And then we signed our fruit instance to a fruit reference variable, and here we just called it isRipe. What we'll do next is add some subclasses of fruit that represent different fruit or classifications of fruit. So, we'll start with the apple fruit type. Well, add this class to the fruit.java source file, and we won't give it an access modifier, meaning it has package or default access. But we can have it extend fruit. So, we write class apple extends fruit curly braces. This doesn't compile yet because we need to add a constructor. Placing the cursor before the closing brackets select code generate constructor. And we get the generated constructor which uses fruit field name as a parameter and makes a call to super using that argument. Then we've got the constructor and an apple fruit. We'll get created with just the name of the fruit. Next we want to implement or override the isRipe method. When you overriding a method, it's a pretty good idea to start with IntelliJ's override generation tool. This ensures that your method signature is right. So let's do that for this class. Placing the cursor below the constructor, select code, override methods, and select the isRipe method on fruit. And that gives us the IntelliJ is default generated code, which includes the override annotation which we've seen before. And this method simply calls the method on the fruit class, which is the super or base class for apple. We want to do that, but we include extra functionality that's specific to the apple class. So, we write systemout.println opening parentheses check plus double quote apples may lower your risk for cancer, diabetes, and heart disease closing parentheses semicolon. This line of code is added to the isRipe method in the apple class. to provide additional information about the health benefits of apples when the isRipe method is called on an instance of the apple class. When the isRipe method is called on an instance of the apple class, this line of code will be executed after the message from the fruit class is printed. Because the apple class overrides the isRipe method of the fruit class and calls super.isRipe to execute the parent implementation of the method first. Now let's go back to the main method and test that the isRipe fruit method on an apple object this time. And what we can do here is simply replace this new fruit statement with new apple. And also change the constructor value from orange to fruit. We don't have to change the type of the fruit variable, because stays fruit. And this is because apple is really a type of fruit, a subclass. So we can assign an apple object to a fruit variable. We can run it. And then look what happened. The code and isRipe method on the apple class. That's because at runtime, the method that gets run is determined by the Java virtual machine based on the runtime object and not this variable type. And there's our first taste of polymorphism in this code. We've declared a variable of type fruit and assigned it an object that's really an apple type of fruit. And when we called isRipe on that, the behavior was the apple fruit behavior. It wasn't just the base class's behavior. Now, the method that's on the apple class first calls fruit method, which is why we see that first statement. That is, fruit is an apple and ripped. But this time we get the text that ripped apple may lower your risk for cancer, diabetes, and heart disease. And this is the actual type of the object at runtime. That's a really simple example of polymorphism. Now we create another class named banana. So, we write class banana extends fruit curly braces. This doesn't compile yet because we need to add a constructor. Placing the cursor before the closing bracket select code generate constructor. And we get the generated constructor which uses fruit field name as a parameter and makes a call to super using that argument. Then we've got the constructor and an apple fruit. We'll get created with just the name of the fruit. Next we want to implement or override the isRipe method. When you overriding a method, it's a pretty good idea to start with IntelliJ's override generation tool. This ensures that your method signature is right. This method simply calls the method on the fruit class, which is the super or base class for banana. We want to do that, but we include extra functionality that's specific to the banana class. So, we write systemout.println opening parentheses check plus double quote banana may support digestive health closing parentheses semicolon. This line of code is added to the isRipe method in the banana class to provide additional information about the health benefits of banana when the isRipe method is called on an instance of the banana class. When the isRipe method is called on an instance of the banana class, this line of code will be executed after the message from the fruit class is printed. Because the banana class overrides the isRipe method of the fruit class and calls super.isRipe to execute the parent implementation of the method first. Now let's go back to the main method and test that the isRipe fruit method on banana object this time. And what we can do here is simply replace this new fruit statement with new banana. We don't have to change the type of the fruit variable, because stays fruit. And this is because banana is really a type of fruit, a subclass. So, we can assign banana object to a fruit variable. We can run it. Now same process repeat, but this time for banana class. Now I want to show you something a little different. Up until now, we've always had the main method or calling code create instances of the object. But this time we'll create a method on the fruit class that the calling code can execute that will return a fruit instance for us. We'll make this method public and static, which means anybody can call this method to get a fruit instance based on the parameter type being passed in and the name. Let's type this method. Public static fruit, get fruit, opening parentheses, string type, comma, string name, closing parentheses, curly braces. Return switch opening parentheses, type dot uppercase parentheses, dot char at opening parentheses 0, close both parentheses, curly braces. Default return type, new fruit, opening parentheses, main, closing parentheses, semicolon. Semicolon at closing curly brace. In this code, the parameters of this method are the type of the fruit and the name. And we got to return an instance of the fruit class, or a subclass of a fruit. And this gets returned by the switch expression. But what are we really doing here with the switch expression? Well, we're taking whatever was passed to us, making it uppercase, then just getting the first letter. In our case, each of our subclasses has a unique letter for its class name. Now let's go back to the main method and test that out. We'll call the static method using fruit class object. First we remove this line. Then we write fruit equals fruit.getFruit, opening parentheses, double quotes, apple comma, double quotes, Honeycrisp, closing parentheses, semicolon. Now notice if we run this. It works, but we're still not really getting an apple fruit. The output is just Honeycrisp is a fruit and ripped. That's because we haven't really completed the getFruit method. Now going back to the fruit class, we want to add the code to return the different subclasses based on the type argument. So we write case, single quotes a return type, new apple, opening parentheses, name, closing parentheses, semicolon. Case, single quotes, B return type, new banana, opening parentheses, name, closing parentheses, semicolon. Here our switch expression is really evaluating a char, a single character. We get this character from the string method char that we're using in the switch expression. That's going to give us the first letter of the type. It affects to a. We'll return a new apple instance. If it's B, we'll return a banana. If it's not an A or B, then we'll just return the base class and instance of fruit. By providing this method the code in the main method, the calling code doesn't really need to know anything about any of fruit subclasses. It can just pass in the type and get a different type of fruit subclass. This kind of method that returns a new instance object is known as a factory method in software programming design patterns. Factory methods give us a way to get an object without having to know the details of how to create a new one or specify the exact class we want. Actually, if we run this code now from the main method, we see that we really do get an apple object back because you can see apple fruit there on the first line. To get fruit method returned an instance which we maybe didn't know what it was, and maybe we don't really care. But because the runtime object was an instance of the apple class, the method on that class was executed. And then we can see the output for an apple instance with the name Honeycrisp, that it's an apple fruit. So, this keeps all the information about moving, and its subclasses in the control of the fruit class, and simplifies the work that needs to be done by the calling code. That sounds like a good encapsulation technique. Now we'll use polymorphism. This time we'll make the code interactive using the scanner class we've seen before. We'll let the user enter the type of fruit, and then the name of the fruit they want to print. First of all, comment out the first 2 lines of code, then at the code for a new scanner. We write scanner_sc equals new scanner, opening parentheses, system dot and closing parentheses, semicolon. Next we'll create a loop, so we'll keep getting information from the user until they quit out of the loop. We write while parentheses true, closing parentheses, curly braces. System.out.print and opening parentheses, double quotes, enter type, opening parentheses, A for apple, comma, B for banana, or Q to quit. Closing parentheses, colon, closing parentheses, semicolon. String type equals sc dot next line, opening and closing parentheses, semicolon. In this code, we're using a while loop with a condition that's always true. That's really an infinite loop, and you definitely don't want to run this code yet. But first, we'll prompt the user for the type of fruit. Enter for apple, or for banana. After that, we'll get the user's response using nextLine method on scanner. We want to get all the data they entered up to and including the new line. The nextLine method gets the type of the fruit. But we're not doing anything with it yet except assigning it to type. If we run this now, we'd be stuck in an infinite loop. We need to add the code to break out of the loop. We write next if opening parentheses double quotes, QQ dot contains opening parentheses. Type closes both parentheses curly braces, break semicolon. What is this code doing? This statement uses contains method on a string. Here we use contains. So, it is a method in Java that checks whether a string contains a specified sequence of characters or not. Then we have a string literal that has an uppercase and lowercase q in it, and we're using containers to test what the user entered. This means if the user enters a single character, either an uppercase or lowercase q, then the code will break out of the loop. That contains method will determine If it contains the single letter Q, then it returns true. Now that we can get out of the loop, we next run the code to get the name of the fruit. And after that we use the factory method on the fruit class to get the right kind of instance. So, we write system.out.print opening parentheses, double quotes, enter the fruit name colon, closing parentheses, semicolon. String name equals this dot next line, opening and closing parentheses, semicolon. Fruit equals fruit dot get fruit opening parentheses, type, comma, name, closing parentheses, semicolon. Here again, we prompt the user to enter the fruit name, and we'll read that in using the next line method on scanner. After that we can call fruit.getFruit to get an instance of a fruit, passing the type and name that the user entered. And regardless of what comes back from this method, we go to assign it to a variable with a type that we've set as fruit. So as long as whatever is being returned from the getFruit method, there's a fruit or a subclass of fruit, we can assign it to a fruit variable. And because it's a fruit variable, we can call any of fruit methods on it. And that method is ripe. So we write fruit.isRipe opening and closing parentheses, semicolon, and running this code. Now we get prompted to enter the type. So let's just enter an A for apple and press enter. And now we'll put in the name and I'll type in Crips, but you can enter anything you want there. And look at the output. This code called the method isRipe using a fruit reference variable. But at runtime, the fruit wasn't really a fruit. It was an instance of the subclass, the apple class. And it was the method isRipe that's actually declared on the apple class that really got executed. This is polymorphism in action. Our compiled code in the main method of the main class never knew anything about the apple class or any of the other subclasses. But at runtime, we've got an object of type apple back from the factory method. And when the method isRipe was called on that, it called isRipe on the apple class. That's pretty neat code using polymorphism. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will see an introduction to Java packages. As the course proceeds, we'll use more and more of Java's libraries, and our program will get more advanced. Now seems like a good moment to go into more detail regarding the package and import statements. We briefly discussed import statements when we used the scanner class, and we also brought up packages when we discussed access modifiers. I want to focus on what a package is in this session, how to access classes in various packages, and what we'll be switching to using packages for moving forward. And discussing of Oracle Java documentation. A set of related types are grouped in a namespace called a package. A package typically refers to a directory or folder on the operating system, but this is not a requirement. We don't need to be worried about the file system storage of packages and classes while using an IDE like IntelliJ. The package structure is hierarchical, meaning a group types in a tree fashion. You can use any legal Java identifier for your package names, but common practice has package names is all lowercase. The period separates the hierarchical level of the package. By now you're familiar with two of Java packages, java.lang and java.util. Here we show these two packages with some of the classes we've used to date, or will use shortly shown within these packages. You might remember when we used the scanner class, or the random class, we were required to use an import statement. We show you an example of using the scanner class in this code. The import statement has to be declared before any class or type declarations, but after any package statement. In this code, we don't have a package statement, so the import statement must be the first statement in the code. There is no limit to the number of import statements you can have. This code shows two import statements, one for the random class and one for the scanner class. Alternately, we could use a wildcard with the asterisk character with the import statement. In the following code, we're telling Java to import all classes from the java.util package with the use of the asterisks after the java.util package reference. Packages let us reuse common class names across different libraries or applications and provide a way to identify the correct class, either with an import statement or a qualifying name. For example, you might have a package for utility classes that can provide common functionality for all of your classes to access. Packages let us organize our classes by functionality or relationships. Packages also let us encapsulate our classes from classes and other packages. So you might have a package of tightly coupled classes that should only be accessed by each other, but not by the outside world. As an example, we've seen that Java starts their package names with Java in some of the examples we've looked at. However, it is common practice to use the reverse domain name to start your own package naming conventions. If your company's nixwarecompany.com, for example, your package prefixes would be com.nixwarecompany. The package name hierarchy is separated by periods. The package statement needs to be the first statement in the code, with the exception of comments. The package statement comes before any import statements. There could be only one package statement because a class or top can only be in a single package. In this code, we created a class called main class. A class is fully qualified class name. FQCM consists of the package name and the class name. So this class's fully qualified name is Nixware Consulting Package. It's unlikely this class with its fully qualified name will have a naming conflict with a main class in another package. That's another example. The fully qualified class name of the scanner class in this code is java.util.scanner. You can use the fully qualified class name instead of the import statement as we show you here. This code does not use the import statement, but instead with the scanner class is referenced. The fully qualified class name is used. You can imagine this could get tedious if you have to use the type often in your code. Later in the course, we'll talk about using a combination of the import statement and the fully qualified class name to resolve conflicts. Let's jump into IntelliJ and see how to create some packages there. In IntelliJ, I've created a project called Packages, but hasn't done anything else. I have the project panel open. You can create the packages first by right-clicking on the SRC folder, selecting New, then Package. And here I'm going to type in nixware.consulting, which will be the base package. You can see IntelliJ created a folder system with nixware.consulting under the SRC folder. If you'd rather see the individual folders, click on the gear tree appearance and then uncheck Compact Middle Packages. And then we can create a class under the consulting folder by right-clicking it, New Java Class, and entering Main Class. Now you can see that IntelliJ includes a package statement at the start of this new class. You can create your package structure this way, and it classes under the relevant packages. An alternate way to do this is to simply include the full package structure in your new class name, but you have to be careful where you're creating the new class. Let's create a new class, but this time we'll include the package structure com.nixware.first.product. And now you see IntelliJ has both created the package folders and created a class called course at the same time listed in the right folder. Again, the package statement was added to the source file for us. Those are the different ways to create packages in IntelliJ. That's real quick at a field to this class and a constructor. So, we write private string course semicolon. Public product opening parentheses, string course, closing parentheses, curly braces. This dot course equals course semicolon. Then we'll add it a string method real quick. I'll use generate to create it and place it just below the constructor. So now we're going to use this class from our nixware.consulting main class. Into that class, let's create a main method with the PSVM shortcut in IntelliJ. Then we want to create a product. When I'm typing product, and what I want you to notice is that IntelliJ is displaying all the classes that it knows about that start with the word course. And at the top is our com.nixware.first. If we select that first class, IntelliJ adds the import statement for us, and we can continue to create an instance of course. So we write product equals new product, opening parentheses, double quotes, Java, closing parentheses, semicolon. System.out.println, opening parentheses, product, closing parentheses, semicolon. Now we can run the main method using this product class from the com.nixware first product, and if we run that we could see the output course equals to Java. Now you can imagine that item as a class name might be used in a lot of applications. So the import statement lets us tell the compiler which product class this really is. We'll be going into this in a lot more detail in a future lecture. I've said that you could use a fully qualified name instead of an import statement, so let me just show that to you next. I'm going to retype the first statement using the fully qualified class name. Because we have those auto import settings configured, you will want to do this. The import statement will disappear. So, we remove this line and write com.nixware.first.product =new com.nixware.first.product opening parentheses double quote Java closing parentheses semicolon. So that's another way to use a class from another package. But you can imagine that if we have to reference that class name more than a couple of times, this could get really fast. Let's revert that code back to the way we had it. When I do that, the import will reappear, but then we'll make one minor change. In the import statement, let's replace product with an asterisk. And this code still compiles if we use an asterisk. Remember, an asterisk is a wild card which says import all classes from this package. If we run it, we get same result as we see. We only have one class in this package and are only using that one class, so the asterisk doesn't buy us much in this example. In truth, with the introduction of an IDE, the use of the asterisk is less commonplace because it's more descriptive to include an import statement for every class, but you may still see it used in some code. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Arrays. In this lecture, we will see an introduction to arrays. Welcome to the new section on arrays. By now, you have likely gained a great deal of confidence in writing Java code, and we are excited to introduce you to this powerful tool for storing multiple values of the same type. In previous sections, we saw how to create classes with multiple data elements. But what if we want to store many values of the same type, such as a list of temperatures or an array of names? This is where arrays come in handy. They allow us to store and access multiple values in a single data structure, and provide us with a more efficient and flexible way of handling this type of data. As an example, imagine that we are building a game that requires us to keep track of the scores of multiple players. Instead of creating separate variables for each player, we can use an array to store their scores in a single data structure. This not only makes our code more concise and easier to manage, but also allows us to perform operations on all the scores at once, such as calculating the average or finding the highest score. Throughout this section, we will explore the syntax and functionality of arrays, including how to declare, initialize, and manipulate them. We will also cover important topics such as multi-dimensional arrays and array algorithms, so get ready to dive into the world of Java arrays and take your coding skills to the next level. Let's now begin with an array. Let's examine how to manipulate and store several values of the same type. Using an array is the most typical approach to accomplish this in Java. Moreover, there are data structures called arrays that let you store a series of similarly typed values. Any primitive type, such as int, double, booleans, or any of the others we've learned about, can have its own type. Moreover, you might hold a type for any class. Elements in an array are indexed starting at 0. If we have an array storing 4 names, conceptually it looks as shown here. The first element is at index 0 and is Anderson. The last element in this array is at index 3 and has the string value John. We must clear up an array. The type of the elements you want in the array must first be specified. You must use square brackets in the declaration after that because Java needs them to recognize the variable as an array. As seen in the first 2 cases, the square brackets might come after the type. This is a lot more common. And this is the way the code will be changed to reflect arrays. As seen in the last array, the brackets may also come after the variable name. This might be found in some code you examine. In the actual declaration of the array, size is not specified. Remember, the declaration is usually to the left of an equals or assignment operator, but not always. One way to instantiate the array is with a new keyword, much as we've seen with most of the classes we've used to date, with the exception of string. Here we have an array declaration on the left of the equal side, and then on the right creation expression on the right side. For comparison, I'm showing you a typical array variable declaration and a class instance or object creation expression using the string builder class. They look pretty similar, but there are 2 major differences. Square brackets are required when using the new keyword, and a size is specified between them. So in this example, there will be 5 elements in the array. And the right initiation doesn't have a set of parentheses, meaning we can't pass data to a constructor for an array. In fact, using parentheses with an array instantiation gives you a compiler error because invalid array creation and compile error because of parentheses. Now we discuss types of array as overview. So, in Java, there are two main types of arrays: single-dimensional arrays and multi-dimensional arrays. A single-dimensional array is a type of array in Java that allows you to store a sequence of values of the same data type in a single row. It is a collection of variables of the same type, referred to by a common name. Each element in the array is assigned an index starting from 0, which represents its position within the array. These are the example of a single-dimensional array, as we discussed earlier. Second is a multi-dimensional array. So, it is a type of array in Java that allows you to store a sequence of values of the same data type in multiple rows and columns. It is a collection of variables of the same type, referred to by a common name. Each element in the array is assigned a pair of indexes that represent its position within the array. This is the syntax. Here, data type is the data type of the elements that the array can hold, and array name is the name of the array. In the second example here, rows and columns specify the number of rows and columns in the array. This creates an array with rows and columns, each containing a default value of 0, and assigns it to the array variable. We will discuss multi-arrays in upcoming lectures. So, arrays are an essential part of Java programming, and they offer several advantages that make them a popular choice for storing and manipulating multiple values of the same data type. Here are some of the key advantages of using arrays in Java, like efficient memory management. Arrays provide a simple and efficient way to manage memory in Java. They allow you to allocate a fixed amount of memory to store a sequence of values, and you can access individual elements of the array using an index. Easy data manipulation. Arrays provide a convenient way to manipulate data in Java. You can easily add, remove, or modify elements of an array, and you can use loops to perform operations on each element in the array. Quick access to elements. With arrays, you can quickly access any element in the collection using its index. This makes it easy to perform operations on specific elements of the array or retrieve data from the array. Multidimensional arrays. In Java, you can create multidimensional arrays, which allow you to store data in multiple dimensions, such as rows and columns. This makes it easy to work with complex data structures and perform operations on large datasets. Compatibility with other data structures. Arrays can easily be used in conjunction with other data structures in Java, such as lists, queues, and stacks. This provides developers with greater flexibility and the ability to choose the best data structure for their particular needs. Although arrays are useful for storing and manipulating multiple values of the same data type, they do have some limitations in Java, like fixed size. Once an array is created, its size cannot be changed. This means that if you need to add or remove elements from an array, you will need to create a new array with a different size and copy the elements from the old array into the new one. Inefficient for dynamic data. Arrays are not ideal for storing and manipulating dynamic data structures, such as linked lists or trees, because they have a fixed size and cannot easily be resized to accommodate changing data. Can only store one data type. An array can only hold values of a single data type. If you need to store values of different data types, you will need to create separate arrays for each type. No built-in methods. Unlike other data structures in Java, such as lists or sets, arrays do not have built-in methods for adding, removing, or searching for elements. You must manually implement these operations using loops or other constructs. Can lead to memory leaks. If you do not properly manage the memory used by arrays, they can lead to memory leaks, where memory is allocated but never released, leading to performance issues and potentially crashes. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Arrays exercise. In this lecture, we will practice some examples using array. Now let's start. For this, open IntelliJ. Then create a new project named Arrays, and then right-click on the src folder and create a package named nixware.consulting. Now we will use this package in our programs. Then right-click on the consulting folder, creates a Java class named main class, and press enter. Here you can see the Nixware .consulting package we created. Now in the main class, we will create a main method using the shortcut PSVM. I will create an int array called number array and set it to have 5 elements. Like we do when we create any new object, we use the new keyword. A Java array is just a specialized class, so the new keyword here creates a new array. And then we again need to specify the type, similar to the way we specify the class when creating a new instance. But this time we specify the type that all the array elements will be, so this will be int here. And next we include the brackets again, but with a number the size of the array in the brackets. This is the number of slots, or in this case of separate integers, that we want in this array. And it's important to know that an array is not resizable. The size of an array was created as fixed. In this case, integer array will have 5 elements. You cannot change the size of an array after the array is instantiated. We cannot add or delete elements. We can only assign values to one of the 5 elements in this array. Now in our code, let's see how we go about accessing the array elements. I will set element 2 of number array to the in value 30. This statement assigns the value 30 to one of the array elements. You might assume that this code is assigning 30 to element 2. The reason for this is that's with all arrays in Java, indexing starts with position 0. And for the last element, you would actually use index 4 in this case. Instead of starting from 1 and finishing on 5 for this array, you start from 0 and finish on 4. This might be confusing at first, but you will soon get used to it. Arrays can be any primitive type, so we could create an array to contain double. Let's do that next. Double opening and closing square brackets. Decimal array equals new double opening square bracket 4 closing square bracket semicolons. Decimal array square bracket 1 is equal to 11.5 semicolon. Then I will set the second element of my double array to the value 11.5. And here we are creating an array called decimal array with 4 double. And we set the second element in that array to a floating point number, a decimal number 11.5. Remember that any decimal number literal like we are using here is really a double in Java. Retrieving a value from the array is done in the same way, using the position of the element in the array. Let's print out the second element of the double array we just created. System.out.println, opening parentheses, decimal array, opening square bracket, 1 closing square bracket, closing parentheses, semicolon. Now run it and we call it the second element, but we use index 1 because Java starts counting at 0 for arrays. And we get 11.5 printed out. Like any variable, whatever type you define the variable to be, that's the type of data that can be assigned to that array. You cannot put a double into an integer array, in much the same way you cannot assign a double value to an integer variable. Now let's assign some more data to the first 2 elements of the integer array. So, set the first element of number array to double value 7.5 and set the second element to string literal 12. In this code, I've purposely created a couple of errors. I declared this array to store integers and here, I'm trying to assign other types of values to the array elements. You can see we have compiler errors here because Java doesn't allow this. In the first case, we have a double, and that cannot be assigned to an element. In the second case, we are trying to assign a string literal to an int variable, which is what each array element really is. Let's fix those. And that compiles, so that's good. But imagine assigning values this way, one at a time, like this for the other 2 elements. You can see this gets tedious really fast. Java provides another shortcut for creating an array. If we know the values for all the elements at the time we create the array, we can use an array initializer. An initializer makes the job of instantiating and initializing a small array much easier. In this example, you can see we still use the new keyword and have it with the square brackets. But here we specify the values we want the array to be initialized to in a comma delimited list in curly braces. Because these values are specified, the length of the array can be determined, so we don't specify the size in the square brackets. Actually, Java provides an even simpler way to do this. Java allows us to drop new int with brackets from the expression as we show here. This is known as an anonymous array. He was showing examples for both an int array as well as a string array. An anonymous array initializer can only be used in a declaration statement. Let's create a new integer array. This time we use an array initializer to create an array with the values 1 through 6 in it. I will tell Java it's an integer array called 6number, and assign the values 1 through 6 in curly braces. Then print first number in array using println statement. Let's find 6 number lengths using a new variable array length. Then print it out using println. So now I've created a new integer array, and I've actually defined the numbers we want in that array. The fact is there are actually 6 elements in there, 1 through 6. Java looks at that and initializes an integer array with 6 elements. The Java assigns each value in this list to an array element in the order we specify here. Element 0 gets assigned the value 1 and element 5 of the array will get the value 6. To confirm that, I'm printing out the first element in this code, and then we access a field on the array called length that tells us the length of the array. Here we assign it to a local variable called array_length and print that out. If we run this code, you can see we've got first equals 1 and length of array equals 6. But what happens if you want to get the last element of an array? Let's add another line of code to get the last element using the length of the array. I will print the element. But if we run this though, we get an exception. This is an array index out of bounds exception, and you can see the message index 6 out of bounds for length 6. This is a very common error to make. We've been taught to think starting with 1, not 0, so it's easy to forget that Java starts indexing with 0. Because it starts with 0, all indices are shifted by 1. The last element in an array that has 10 elements is at index 5. We need to subtract 1 from the length to get the last index. Let's fix that. I also hope you notice that we can use variables and expressions in the square brackets to access an array element, as we are showing here. The expression or variable needs to evaluate to an integer value. Then running that, we get last equals 6. Now set this to right. Initializer can only be used in declaration assignments or method arguments, so let's review what that means for a moment. So, we write int opening and closing square brackets, another array semicolon. So, I will attempt to set the values 1 to 4 as an array initializer. And now with this code, we've got a compiler error. Here we see that array initializer is not allowed here. This means you cannot use the anonymous version of the array initializer in a statement outside of a declaration statement, but we can use the longer form. So I will change that now including newint with square brackets before the values in curly braces. And this code compiles. Once you have an array, you can look through the elements, retrieving each value with the loop index. We can do this with the traditional for loop. So, we write for opening parentheses, int I is equal to 0, semicolon, I less than another array, dot length semicolon, I plus plus closing parentheses, curly braces. Then use print statement and inside it another array element I and add a space after that. What we are doing here is we are living through each element starting from element 0. We start with our equals 0, incrementing by 1 while I is less than another array length. Let me print out each element using the loop index to get the current element. We are just printing all of those on a single line with a space between each orson. So, when the loop variable I starts with 0 and is incremented by 1 in each iteration until it reaches the length of another array, which is 4. In each iteration, the loop body executes the statement systemout.println opening parentheses another array square brackets I plus double quote space closing parentheses semicolon, which prints the value at the ith index of another array followed by a space. In the first iteration, I is 0 and another array into I is 1. In the second iteration, I is 1 and another array into I is 2. In the third iteration, I is 2 and another array into I is 3. In the fourth iteration, I is 3 and another array into I is 4. After the loop completes execution, the output on the console would be 1, 2, 3, 4. Now we run it. We could see all the elements in the array get printed. Now go next. So, Java has another for loop statement. They call it the enhanced for loop, but it's also sometimes known as the for each loop. This loop was designed to walk through elements in an array or some other type of collection. It processes one element at a time when the first element to the last. Here I will show you the syntax for the two types of for loop statements. The enhanced for loop only has two components, versus three defined in the parentheses after the for keyword. It's important to notice that the separator character between components is a colon and not a semicolon for the enhanced for loop. The first part is a declaration expression which includes the type and a variable name. This is usually a local variable with the same type as an element in the array. And the second component is the array or some other collection variable. Let's see this for loop in code. The last for loop did in our code, which was to loop through each element in the array and print each value out. But this time I will use the for each or enhanced for loop to do it. Here we use the separator to separate from the upper loop. Then we write for opening parentheses, int element, colon, another array, closing parentheses, curly braces and print out element using print with a space after it. As an enhanced for loop, also known as a for each loop, is used to iterate through each element of the array another array. The loop variable element is declared as an integer and takes the value of each element in another array in each iteration of the loop. In each iteration, the loop body executes the statement system out.println opening parentheses element plus double quote space closing parentheses semicolon, which prints the value of element followed by a space. So, this code will print the horizontal line of dashes first, and then print each element of another array on a single line, separated by spaces, using for each loop. Now run it. Here you can see the output. We get the exact same output. The values 1 through 4 is printed out. That's rather nice thing, because you don't have to deal with the array index position. The enhanced for loop gives you a simpler if you need to do is process the elements from start to finish, and you aren't trying to set, swap, or sort elements. I hope you learned something useful in this lecture as well, and I will see you in the next one. Introduction to Java Utility Arrays class. In this lecture, we will talk about Java Utility Arrays class. Some common behavior for an array would be sorting, initializing values, copying the array, and finding an element. Toward the right, this behavior isn't on the array instance itself, but it's provided on a helper class, java.util.arrays. So, the java.util.arrays class is a utility class in Java that provides various static methods to work with arrays. Some of the methods in this class are binary search, sort, fill, copy of, equals to string. Now we will discuss them a little bit about the sort, copy, and fill methods. So, we start with sort method first. So, the sort method of the java.util.arrays class is used to sort the elements of an array in ascending order. The method sorts the array in place, which means that the original array is modified and the sorted array is returned. There are several overloaded versions of the sort method, depending on the type of the elements in the array, like sort parentheses int square brackets a. This sort method sorts the elements of the given int array in ascending order. Sort parentheses long square brackets a. This sort method sorts the elements of the given long array in ascending order. Sort parentheses float square brackets a. This sort method sorts the elements of the given float array in ascending order. Sort parentheses double square brackets a. This sort method sorts the elements of the given double array in ascending order. Sort parentheses object square brackets a. This sort method sorts the elements of the given object array in ascending order, using the natural ordering of the elements. Here's an example of how to use the sort method to sort an array of integers. In this example, we first create an integer array named r with 5 elements, 5, 3, 9, 1, 7. We then call the arrays.sort method, passing in the r array as the argument. This method sorts the elements of the r array in ascending order using a modified version of the quick sort algorithm. After the sort method completes, the elements of the r array will be rearranged in ascending order, so that it becomes 1, 3, 5, 7, 9. Finally, we call the arrays.toString method and pass in the r array as an argument to print out the contents of the sorted array. The method returns a string representation of the array, with each element separated by a comma and enclosed in square brackets. The output of the print statement is square brackets 1, 3, 5, 7, 9. It's important to note that the sort method sorts the elements of the array in place, which means that the original array is modified. If you want to preserve the original order of the array, you should create a copy of the array before sorting it. So, the next method is copy of. So, the copy of method in the java.util.arrays class is used to create a copy of an array with a specified length. The method takes two arguments, the original array and the length of the new array. If the length of the new array is greater than the length of the original array, the new array will be padded with default values that are 0 for numeric types, false for Boolean, and null for reference types. If the length of the new array is less than the length of the original array, the new array will contain only the first length elements of the original array. Here's an example of how to use the copy of method. In this example, we are first initializing an integer array called original with 5 elements. Then, we are calling the arrays.copy of method to create a new integer array copy, which is a copy of the first 3 elements of the original array. The first argument to the arrays.copy of method is the array to be copied, which is original in this case. The second argument specifies the length of the new array, which is 3. Therefore, the copy array contains the first 3 elements of original, which are 1, 2, 3. After that, we use the arrays.toString method to convert the arrays to strings and print them using the print statements. The first print statement prints the entire original array, which is 1, 2, 3, 4, and 5. The second print statement prints the copy array, which contains only the first 3 elements of original, which are 1, 2, and 3. Therefore, this is the output. So, the next method is fill. So, the fill method in the java.util.arrays class is used to fill an array with a specified value. The method takes 2 arguments, the array to be filled and the value to fill the array with. Here's an example of how to use the fill method. In this example, we first create a new integer array r with a length of 5. This means that r has 5 elements, but all of them are initially set to the default value for int, which is 0. We then call the arrays.fill method and pass r as the first argument and 0 as the second argument. This means that we want to fill r with the value 0, replacing all the initial 0 values. After that, we use the arrays.toString method to convert the r array to a string and print it using the print statement. This prints the contents of the r array as a string, since we filled r with the value 0. So, the output is here. This means that the r array has been successfully filled with 0 using the arrays.fill method. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Java.util.arrays class method exercise. In this lecture, we will practice some examples using Java.util.arrays class methods. Now we start with a simple program that sort an array in ascending order without using sort method of Java.util.arrays class. So, we write a program that sort numeric array in ascending order without using sort method. For this, we first create a class file named ArraySort without sort method in the Nixware and Consulting package. Then create a main method using PSVM. Now inside this main method, we write in square brackets myArray is equal to opening curly brace 13, 7, 6, 45, 21, 9, 101, 102 closing curly brace semicolon. Here we create an array of integers named myArray and initializes it with the integer values with length 8 that is indexed from 0 to 7. Then write int temp is equal to 0 semicolon. Here we create an integer variable named temp and initializes it with the value 0. In sorting algorithms, it is common to use a temporary variable to hold the value of an element during swapping operations. When 2 elements are swapped, their values are temporarily stored in a third variable, typically named temp, before being reassigned to their new positions. So, in the context of a sorting, int temp is equal to 0 initializes the temp variable to 0, which can be later used to hold the value of an element temporarily during swapping operations. Then write systemout.println opening parentheses double quote before sorting closing parentheses semicolon. Here we use print method that prints the string before sorting to the standard output stream, followed by a new line character. In this particular case, This statement is used to provide a visual indication to the user that the array is being printed before it is sorted. It is a common practice to print the original unsorted array before applying any sorting algorithm to it. This helps the user to better understand the behavior of the sorting algorithm and to compare the original and sorted arrays. Then we write for opening parentheses int I is equal to 0 semicolon. I less than my array dot length semicolon. I plus plus closing parentheses curly braces. System out dot print ln opening parentheses my array square brackets I plus double quote space closing parentheses semicolon. This for loop iterates over the elements of the integer array myArray, printing each element to the console on a single line separated by a space. First, the print method prints the statement before sorting, and then this for loop prints the original value that are before sorting values. Then we write for opening parentheses int I is equal to 0 semicolon. I less than my array dot length semicolon. I plus plus closing parentheses curly braces. For opening parentheses int j is equal to I plus 1 semicolon. J less than my array dot length semicolon. J plus plus closing parentheses curly braces. Here we use two for loops upper and nested. In the upper loop int I is equal to 0 initializes a loop counter variable I to 0, which represents the index of the first element in the array. Then I less than my array dot length sets a condition for the outer loop to continue executing as long as I is less than the length of my array. This ensures that the outer loop iterates over each element of the array exactly once. Then I plus plus increments the outer loop counter variable I by 1 after each iteration of the outer loop. This ensures that the outer loop progresses through the elements of the array from beginning to end. In the nested loop int j is equal to I plus 1 initializes a second loop counter variable j to the next index after I, which ensures that the inner loop only iterates over the remaining elements of the array that come after the current element myArray square brackets I. This is because the inner loop is used to compare the current element with all the subsequent elements in the array. J less than myArray dot length sets a condition for the inner loop to continue executing as long as j is less than the length of myArray. This ensures that the inner loop only iterates over the remaining elements of the array that come after the current element myArray square brackets I. J plus plus increments the inner loop counter variable j by 1 after each iteration of the inner loop. This ensures that the inner loop progresses through the elements of the array from beginning to end, starting from the current index I plus 1. The inner loop body can be used to compare and manipulate the current element myArray square brackets I with all the subsequent elements myArray square brackets j in the array. So, this nested for loop is used to compare the elements of myArray with each other in pairs, starting with the first element and comparing it with all subsequent elements. Then inside the nested array, we write if opening parentheses myArray square brackets I greater than myArray square brackets j closing parentheses curly braces. Temp is equal to myArray square brackets I semicolon. MyArray square brackets I is equal to myArray square brackets j semicolon. MyArray square brackets j is equal to temp semicolon. Here we use if statement that checks if the current element myArray square brackets I is greater than the subsequent element myArray square brackets j in the array. If this condition is true, it means that the current element is out of order and needs to be swapped with the subsequent elements to sort the array in ascending order. Temp is equal to myArray square brackets I stores the value of the current element myArray square brackets I in a temporary variable temp. This is done to avoid losing the value of the current element when it is overwritten during the swap. MyArray square brackets I is equal to myArray square brackets j assigns the value of the subsequent element myArray square brackets j to the current element myArray square brackets I, effectively swapping their values. MyArray square brackets j is equal to temp assigns the value of the temporary variable temp to the subsequent element myArray square brackets j, effectively restoring the original value of the current element that was stored in temp. After this conditional block of code executes, the array elements at indices I and j will have been swapped if necessary to sort the array in ascending order. Then we write systemout.print ln opening parentheses double quote backslash n after sorting closing parentheses semicolon. Here we use print statement that prints the message after sorting to the console output on a new line. This statement is typically used in conjunction with the subsequent loop that prints the sorted array to the console output. Then we write for opening parentheses int I is equal to 0 semicolon. I less than my array dot length semicolon. I plus plus closing parentheses curly braces. System out dot println opening parentheses my array square brackets. I plus double quote space closing parentheses semicolon. First print method print statement after sorting, and then subsequent for loop prints the sorted my array to the console output. Now run it. Here is the output that is. Before sorting, 13, 7, 6, 45, 21, 9, 101, and 102. After sorting, 6, 7, 9, 13, 21, 45, 101, and 102. So, when the program runs. First, the program creates an integer array myArray with 8 elements containing the values 13, 7, 6, 45, 21, 9, 101, 102. Then program declares an integer variable temp and initializes it to 0. This variable will be used later to temporarily store array elements during the sorting process. Then program prints the message before sorting to the console output, followed by a space-separated list of the original array elements using for loop. Then program uses 2 nested for loops to compare adjacent elements of my array and swap them if they are out of order. This is the main part of the program. So, here we will see how both upper and nested loops work together to sort the array. First, the outer loop starts at index I is equal to 0 and iterates through each element of the array myArray, up to the last element at index myArray dot length -1. For each value of I, the inner loop is executed. Then inner loop starts at index j is equal to I plus 1 and iterates through each remaining element of the array myArray, up to the last element at index myArray dot length .1. For each value of j, then if statement is executed. Then if statement compares the values of myArray square brackets I and myArray square brackets j. If myArray square brackets I is greater than myArray square brackets j, it means that the 2 elements are out of order and need to be swapped. Then temporary variable temp is used to temporarily store the value of myArray square brackets I, so that it can be replaced with the value of myArray square brackets j. Then myArray square brackets j is assigned the value of temp, which is the original value of myArray square brackets I. Once the inner loop has completed iterating through all remaining elements of myArray, the outer loop moves on to the next element at index I is equal to I plus 1. This process repeats until the outer loop has completed iterating through all elements of the array. If we give a closer look at how nested loops work together for the first 2 iterations. So, in the first iteration, I is equal to 0, j is equal to 1. myArray square brackets 0 is equal to 13, myArray square brackets 1 is equal to 7. myArray square brackets 0 are greater than myArray square brackets 1, so they need to be swapped. Temp is equal to myArray square brackets 0 that is temporarily store the value of myArray square brackets 0, which is 13. myArray square brackets 0 is equal to myArray square brackets 1 replace the value of myArray square brackets 0 with the value of myArray square brackets 1, which is 7. myArray square brackets 1 is equal to temp that is replace the value of myArray square brackets 1 with the value of temp, which is 13. The array now looks like this. Opening curly brace 7, 13, 6, 45, 21, 9, 101, 102 closing curly brace. Second iteration, I is equal to 0, j is equal to 2. myArray square brackets 0 is equal to 7. myArray square brackets 2 is equal to 6. myArray square brackets 0 are greater than myArray square brackets 2, so they need to be swapped. Temp is equal to myArray square brackets 0 that is temporarily store the value of myArray square brackets 0, which is 7. myArray square brackets 0 is equal to myArray square brackets 2 that is replace the value of myArray square brackets 0 with the value of myArray square brackets 2, which is 6. myArray square brackets 2 is equal to temp, that is, replace the value of myArray square brackets 2 with the value of temp, which is 7. The array now looks like this. Opening curly brace 6, 13, 7, 45, 21, 9, 101, 102 closing curly brace. This process continues for each pair of adjacent elements in the array until the entire array is sorted in ascending order. Finally, the program prints the message after sorting to the console output, followed by a space-separated list of the sorted array elements using another for loop. Now we saw how to sort array in ascending order without using sort method of java.util.arrays class. As the size of the array and the value of its elements increase, the number of iterations required to sort the array increases dramatically, making this approach very time-consuming. So it is not an efficient way to sort an array. Now we will write this program using sort method of java.util.arrays class. For this, we create another class file named arraysort with sort method in the Nixware and consulting package. Then create a main method using psvm. Now inside this main method, we write int square brackets myArray is equal to opening curly brace 13, 7, 6, 45, 21, 9, 101, 102 closing curly brace semicolon. Here we create integer array named myArray with same value that we used in the previous program. Then we write systemout.println opening parentheses double quote before sorting plus arrays dot to string parentheses myArray closing parentheses semicolon. As we write arrays dot to string, the IntelliJ auto import the java.util.arrays class file, because class arrays is the part of this class. So here we use print statement that printing the message before sorting, along with the elements of myArray in a human readable format. And here arrays.toString is a method that calls to string method of the arrays class in the java.util package. This method takes an array as an argument and returns a string representation of its contents. In this case, myArray is passed as an argument to arrays.toString, which returns a string that represents the elements of the array in a human readable format. The resulting string is then concatenated with a message before sorting, using the plus operator, and the entire string is printed to the console using print statement. Then write arrays.sort parentheses myArray semicolon. Here we use this method to sort an array in ascending order. It takes the array as its argument and sorts it in place. The method uses a variation of the quick sort algorithm and is highly efficient for large arrays. Once the method returns, the array is sorted in ascending order. Then we write systemout.println opening parentheses double quote after sorting, plus arrays.toString parentheses myArray closing parentheses semicolon. This statement is same as above statement, but this time it prints the sorted array with the string after sorting. Now run it. Here is the output, that is. Before sorting, square brackets 13, 7, 6, 45, 21, 9, 101, and 102. After sorting, square brackets 6, 7, 9, 13, 21, 45, 101, and 102. So, the program then prints out both the original array and the sorted array using the print method, along with the arrays.toString method to format the arrays into a string representation. I hope you learned something useful in this lecture as well, and I'll see you in the next one. References and value types. In this lecture, we will talk about the references and value types using an array. As in Java, variables can hold either a value type or a reference type. A value type variable stores the actual value of the variable, while a reference type variable stores a reference to an object. When working with arrays in Java, the type of the array determines whether it is a value type or a reference type. For example, an array of primitive types such as int, double, or boolean is a value type, and the array variable holds the actual values. Any changes made to the array variable do not affect other variables that refer to the same array. On the other hand, an array of objects, such as string or object, is a reference type. The array variable holds a reference to the object, and any changes made to the array variable are reflected in other variables that refer to the same object. Here is an example of an array of primitive type int, which is a value type. In this example, the variable values holds the actual values of the array, and the variable copy holds a copy of the reference to the same array. When we modify the value at index 0 of values, it does not affect the value of copy. Here is an example of an array of objects type string, which is a reference type. In this example, the variable names holds a reference to the array of strings, and the variable copy holds a copy of the same reference. When we modify the value at index 0 of names, it is reflected in the value of copy as well, since they both refer to the same object. It's important to keep in mind the distinction between value types and reference types when working with arrays in Java, as it can affect how changes to an array are propagated to other variable. Furthermore, when you assign an object to a variable, the variable becomes a reference to that object. This is true of an array, but the array has yet another level of indirection if it's an array of objects. This means every array element is also a reference. Let's start by looking at this in code. For this, open IntelliJ. Now create a new class called referencesValue in the Nixware consulting package, and create a main method using PSVM. Then create a new simple array in the main method. For this, write int opening and closing square brackets. Array1 equals new int opening square bracket 5 closing square bracket semicolon. This array has 5 elements, and we have a variable, or in other words, a reference array1. This means that reference is an address to the object in memory, but not the object itself. Stated differently, the variable array1 holds a reference or address to an array in memory, and we use a reference to access and control the object in memory. For now, let's create a second reference variable, an integer array. Int opening and closing square brackets array2 equals array1 semicolon. Here I'm declaring another reference to the same array in memory. So now we've got 2 references pointing to the same array in memory. In other words, both array1 and array2 hold the same address. One way to know it's a reference type is the new operator, because that creates a new object in memory, and we're using the new operator, where we created an array of 5 elements. Basically, new means new object. On the second line, we haven't used a new keyword. We've just used the equal sign, which means we're assigning one reference to another. Let's print these array references out. I'll use arrays to string for array1 and print the value returned. The same thing for array2. I'll just run that. Then you can see that it's nicely printed out the values. We've got all zeros because all we've done is initialize the array with the size and the default values. Let's actually see what happens if we make a change to array2. Array2 square brackets 0 equal 1 semicolon. Now we're printing out both reference variables again after we make that change. What do you think is going to happen at this point? Will it change just array2? Or will it in fact change both arrays? Let's run this and see what happens. And you can see what's happened with those last 2 output statements. Both variables are referencing the same array in memory, so there's only one copy of the array. When you use one reference variable to make changes to the object in memory, it's like making that change with the other variable. It's because reference types represent the address of the variable rather than the data itself. In our case, again, both variables represent the address pointing to the same array in memory. So in effect, we've only got one array in memory that both variables are pointing to. Let's check out those. Here we've got the same code from IntelliJ. When the int array1 equals sign new int 5 executes, this creates a new array in memory with 5 elements that initializes all elements to 0. And that's because by default you make arrays are initialized to 0, because they have type int in this case. Now we've got a reference that points to the array address in memory. And you can see an arrow from the reference pointing to the array in memory. On the next line, we're creating another reference to the same array. Notice on the slide we've still only got the one array, but we've now got 2 references that point to that same array in memory. In other words, pointing to that same address in memory. Each reference or variable has a different name, but that doesn't mean there's 2 different arrays. We've got 2 references, but both, as you can see, clearly point to the same array. The next 2 lines are just printing out the array to the console. We're printing the same array again. Because there's only the one array in memory, every element has the value 0, And that's exactly what's printed out. Here array 2 element 0 equals sign 1. We're assigning the value of 1 to the first element of the array. That puts the value 1 into the element at index 0. In other words, we're setting the element at index 0 to hold the value 1. Now, since array 2 and array 1 is two references pointing to the same array, we could say that both references can see that change. In other words, we've got one array in memory, so whichever reference to the array we use, the other references are still pointing to the same address, and we're getting the same output back as a result of making that change. We're printing out the last two lines now, and again, since we're printing the same array out, since we changed the rate element at index 0 to 1, we see the change for both lines. For the first element in element 0, they're showing the value 1 instead of 0, so both references. We can see the change that we made, and we get 1 as the first element in the array. The same behavior happens when we pass reference types to methods. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Runtime arguments. In this lecture, we will talk about the runtime arguments. In Java, the main method is the entry point of a program, and it can take command line arguments as input. These arguments are passed to the main method as an array of strings. The syntax for the main method with command line arguments is: here the args parameter is an array of strings that contains the command line arguments passed to the program. The length of the array is equal to the number of command line arguments, and each element of the array contains one argument. Here is an example of how to use command line arguments in the main method. In this example, the my class has a single method, main, which takes an array of strings args as a parameter. This array represents the command line arguments passed to the program when it is executed. The first line of the main method prints the number of command line arguments passed to the program using the args.length property. The second part of the code is a for loop that iterates over the args array and prints each argument and its index using the println method. The loop runs from 0 to args.length -1, which is the index of the last element in the array. If the program is run with these commands, Java my class arg1, arg2, arg3. To run the program with command line arguments, you can pass the arguments after the name of the Java class file in the command prompt or terminal. Then the output will be number of arguments, 3. Argument 0, arg1, argument 1, arg2, argument 2, arg3. So, this program shows how to access and use command line arguments in a Java program. Now we will revisit the main method. Bear with me, there is a good reason for this. You probably have the structure of the main method memorized by now. Notice here, if you haven't noticed before, that the parameter to the main method is an array of string. This means we could pass an array of strings to this method with its called. Or if we use this method as the entry point to our application, we can pass data on the command line to this method. Up until now, I've only shown you this particular method signature. But this signature can be written in a slightly different way. We can replace the brackets after the string type, which we now tell us this method will take an array of string. And we can instead replace that with 3 periods. This is a special designation for Java. That means Java will take 0, one or many strings as arguments to this method, and create an array with which to process them in the method. The arrival will be called out and be of type string. So what's the difference then? The difference is minor within the method body, but significant to the code that caused the method. Now come to practice. For this, open IntelliJ. Then we create a class file named arguments in the Nixware consulting package. Then create a main method by using shortcut psvm. Now I'm going to change that main method to use the varargs version for the parameter. And let's just print something out and confirm that works. I'll print the string literal hello Nixware, and running that. Everything works as before, so this change isn't really evident to us using the main method as the entry point to the application. So, Java allows you to use an alternative syntax for the main method signature. Instead of using the traditional string square brackets array syntax, you can use the varargs syntax by replacing string square brackets with string 3 dots. So, the varargs syntax allows you to declare a method with a variable number of arguments of the same type. The syntax for varargs is to use the ellipsis after the type name of the argument in the method declaration. Now we create another method by writing public static void print values opening parentheses string ellipsis values closing parentheses curly braces. Here we define a method named printValues that accepts a variable number of arguments of type string. This is achieved by using the varargs syntax, which is denoted by the ellipsis after the type name string. When you call the printValues method with one or more string arguments, the arguments are automatically packed into an array and passed to the method. Within the method, the values parameter is treated as an array of string, and you can access each individual argument using an index, just like you would with a regular array. Then inside this method, we write for opening parentheses string value colon values closing parentheses curly braces. Systemout.println opening parentheses value closing parentheses semicolon. Here we for each loop that iterates over each element in the values array, which is a variable number of string arguments passed to the method. This loop assigns each string argument in the values array to the value variable, and then prints it to the console using the println method. For example, if you call the printValues method with 3 string arguments world, width, and piece, the for each loop will execute 3 times, with value set to world on the first iteration, width on the second iteration, and piece on the third iteration. The loop will print each of these string values to the console, 1 per line. Now we go into the main method and write printValues opening parentheses double quote world comma, double quote with comma, double quote piece closing parentheses semicolon. Here we call printValues method passing 3 string arguments, world, width, and piece. Since the printValues method is defined with the varargs syntax string ellipsis values, the 3 string arguments passed to the method are automatically packed into an array and passed as the values parameter. Inside the printValues method, the for each loop iterates over the values array, which now contains the 3 string arguments passed to the method, and prints each argument to the console on a separate line. Now we run it. Here is the output. Note that you can also call the printValues method with any number of string arguments, including 0 arguments, by simply passing the desired arguments separated by commas. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Two-Dimensional Arrays. In this lecture, we will see the introduction to two-dimensional arrays. So, arrays are data structures that can hold multiple values of the same data type in a contiguous block of memory. The major types of arrays are one-dimensional arrays in short 1D and multi-dimensional arrays, which can include two-dimensional and short 2D arrays, three-dimensional and short 3D arrays, and so on. We already discussed 1D array, and we start with two-dimensional arrays. If we recall the concept of matrix that we studied in math, we studied that a matrix can be defined as an m cross n, where m represents the number of rows, and n represents the number of columns. Here we see a 3 by 5 matrix, which means it has 3 rows and 5 columns. And rows start from 1 to 3, and columns start from 1 to 5 numbers. And we store some data in these boxes, which are called cells. So, we add 12, 17, 19, 22, 26, 32, 10, 14, and so on. If we get the location of this particular cell, then we write it in parentheses with a row, comma, and column. If its row is 2, then its location becomes 2, 3, because the particular location column is 3. Using this method, we find this value that is 14. If we put this structure of matrix in the Java programming language, this structure is called 2D array in the Java programming. If we define 2D array, we says that a 2D array, also known as a two-dimensional array, is a data structure consisting of a collection of elements, where each element is identified by a pair of indices. It is a type of array that represents data in a table-like format with rows and columns. A 2D array can be thought of as a matrix or a grid of values, where each cell in the matrix corresponds to a unique pair of indices. The first index identifies the row, and the second index identifies the column. Furthermore, first of all, the basic form of declaring two-dimensional arrays. You have to specify the data type and the name of the array. And then within these square brackets you have to specify the sizes. X and Y here represent the size. Now let's address our first question, that is how to visualize two-dimensional arrays. So, please recall how to declare a 1D array. We can declare 1D array using this statement. You have to specify the data type, the name of the array, and just a single size. You have to mention and how we can visualize a 1D array. This is the usual way of visualization. We imagine a 1D array as a single row which consists of multiple blocks, and the number of blocks is basically equals to the size that we have mentioned. If it is 5, then there are 5 blocks. This is the way how we can visualize a 1D array. Now if we add one more dimension here, then it becomes a 2D arrays in that, but how we can visualize it? This simply means we require 4 such 1D arrays, which consist of 5 blocks. They're quite far away, isn't that? So let's see what happens when we combine them together. It forms up a matrix, and the size of this matrix is 4 cross 5. It consists of 4 rows and 5 columns. Isn't that so? So we can say their two-dimensional array is basically a matrix right here. In this case, it is 4 cross 5 matrix because it consists of 4 rows and 5 columns. This is the way we can visualize a two-dimensional array. And how many elements does this array consist of? It consists of 4 into 5 elements. That means 20 elements. So what is the conclusion? This post size means the number of rows, and this means the number of columns. And in order to multiply the size of any two-dimensional array, we have to multiply the number of rows by number of columns. In this case, we will multiply 4 by 5, which gives me 20. This array is capable of storing 20 elements, and if you want to calculate the size in bytes, we will simply multiply 20 by 4. I'm assuming here that the size of one element is 4 bytes. Therefore, I will multiply this 20 by 4, and it gives me 80 bytes. So the size of this array in bytes is 80. Let's see how we can initialize two-dimensional arrays. In order to initialize two-dimensional arrays, there are 2 methods that I'm going to discuss. First method is, this we can initialize two-dimensional arrays by simply mentioning the elements inside these curly brackets. And this array consists of 2 rows and 3 columns. So let me draw them over here. And please note down that index always starts from 0. When I'm saying 2 rows, the index starts from 0 and ends at 1. And when I'm saying it consists of 3 columns, that means index starts from 0 and ends at 2. And how the elements are stored in this array. The first element stores at this particular location, second element stores at this location, third element stores at this location, fourth element stored at this location, fifth element stored at this location, and sixth element finally will get stored in this location. All the elements here will store in a consecutive fashion, but sometimes it is confusing. There is one better method initialization, which I'm going to discuss next. And here is this method. This will also initialize this array in this form that we have seen previously. But the beauty of this initialization is we can visualize it properly. This depicts the row 1, and this depicts the row 2. Now, after having a discussion on initialization, let's talk about how we can access 2D array elements using row index and column index. We can access 2D array elements. For example, we can access elements stored in first row and second column of this array like this. We have to specify the index, that is row index must be 0 that depicts the first row, and column index must be 1 that depicts the second column. In order to access the first row, second column element, that is this element, we have to specify the row index as 0 and column index as 1. Now, after having a discussion on how to access 2D array elements, let's learn how to print 2D array elements. We can print 1D array elements using single for loop, isn't that so? Like suppose you have this array, which is a single-dimensional array. We can access the elements of this array by using a single for loop, which is very easy to write by initializing I to 0 and specifying the condition as I less than 5, because in this case, the number of elements is 5. And then this increment statement, and inside this for loop, we will use printf function. Print all the array elements. Now, in order to print 2D array elements, we will simply use 2 nested for loops. That is the basic idea. That is, if you have a 2D array like this, then we can print all the elements of this array by using these 2 nested for loops. Let's see how we can print all the elements of 2D. Array using 2 for loops. Please recall that the example consists of 2 rows and 3 columns, right? That is, in the conditions, there is a need of writing 2 here and 3 over here. Initially, we will initialize this I by 0, and then we will check this condition is I less than 2 or not. Yes, I is less than 2 because I is 0 therefore. We will come inside this power loop and we will initialize j to 0. After initializing j to 0, we'll check this condition is j is less than 3. Yes, 0 is less than 3, right? Again, the condition is satisfied. Therefore we land at this point and we will print aij. This means we will print a 0 because I is also. U and j is also a 0. 0 means we are accessing the 0th row and 0th column, that is this element. Therefore this element will get printed on the screen, and then after that will land at this point. That is, we will increment the value of jj now becomes 1. Now we will check this condition is 1 less than 3 or not. Yes, 1 is less than 3. Therefore condition is again satisfied. We will come. At this point we will print a 0. 1 that is 0 the row and first column. This element we will print on the screen. After this, again we will increment the value of j. They now becomes 2. 2 is less than 3. Again the condition is satisfied. Therefore we will print the element stored at 0th row and second column, that is this element. This element will get printed on the screen. After that again we will increment the value of j now becomes 3. 3 is not less than 3. Condition is not satisfied. Therefore we will come outside of this for loop at this point. After this follow, we won't find anything. Therefore we will increment the value of I next I now becomes 1. 1 is less than 2. Isn't that so? Condition is satisfied. Therefore again we will go inside this for loop and again we will find the for loop. This means the j will again get initialized by 0. Please note that I is 1 in this case and j will again get initialized by 0. Again, we will check the condition is 0 is less than 3, yes. 0 is less than 3. Condition is satisfied. Therefore, we will print the value stored at row index 1 and column index 0. That is this element. This element will get printed on the screen. After that, we will again increment the value of j. J now becomes 1. 1 is less than 3 condition is satisfied, and therefore we will print the values stored at row index 1 and column index 1. Row index 1, column index 1. That means this element 5 will get printed on the screen. After that we will increment the value of j again and j now becomes 2. 2 is less than 3 condition is satisfied. We'll go inside and print the value stored at row index 1 and column index 2, that is this particular element. This will get printed on the screen. J now becomes 3. 3 is not less than 3, right? Condition is not satisfied and hence will come outside of this for loop. That is again we will increment the value of I. I now become 2 because previously the value of I was 1. Now it becomes 2. 2 is not less than 2. Condition is not satisfied. Therefore we will come outside of this power loop and hence the program finishes its execution. Therefore, the final output is 1, 2, 3, 4, 5, 6, that is all the elements which are stored in this 2D array. This means that this nested for loop structure helps us in printing all the elements of this array. What we have learned so far, we have learned that how to declare and define two-dimensional array. Then we learned how to visualize two-dimensional arrays. Then we learned how to initialize two-dimensional arrays. Then we have learned how to access two-dimensional array elements. Then finally we learned how to print two-dimensional array elements. Now we will discuss advantages of 2D array. There are many advantages of using a 2D array in Java, like representing tabular data. 2D arrays are commonly used to represent data in a table-like format, such as spreadsheets or game boards. They provide a convenient way to organize and store data that can be accessed using row and column indices. Efficient memory management. 2D arrays in Java are stored in contiguous memory locations, which make accessing their elements faster and more efficient than using nested collections like lists of lists. Easy to iterate over. 2D arrays can be easily iterated over using nested for loops. This makes it easy to perform operations on all the elements in the array or to extract specific subsets of the data. Flexible sizing. In Java, the size of a 2D array can be easily modified during runtime. This allows for greater flexibility in handling data that may grow or shrink over time. Type safety. Java provides strong type safety, which means that the data type of each element in the 2D array is checked at compile time. This helps prevent errors that could arise from incompatible data types being used in the array. There are also some limitations of using a 2D array in Java, like fixed size. Once the size of a 2D array is set, it cannot be easily changed without creating a new array and copying the elements over. This can lead to inefficiencies in memory usage if the array is larger than needed or errors if it is too small. High memory usage. 2D arrays can require a large amount of memory, especially if they contain a large number of elements or if the elements themselves are large. Limited flexibility. 2D arrays in Java are limited in terms of the types of operations that can be performed on them. For example, it can be difficult to insert or remove rows or columns, or to sort or search the data in the array. Indexing complexity. Working with the indices of a 2D array can be more complex than with a 1D array, as you need to keep track of both the row and column indices. This can lead to errors if the indices are not handled correctly. Now we will see comparisons between 1D and 2D arrays in Java. So, structure. 1D array is a linear collection of elements, while 2D arrays have a tabular structure, with rows and columns. Accessing elements. In a 1D array, elements are accessed using a single index, while in a 2D array, elements are accessed using two indices, one for the row and one for the column. Memory usage. 2D arrays can use more memory than 1D arrays, especially if the arrays are large or the elements themselves are large. Flexibility. 1D arrays can be resized easily, while 2D arrays are fixed in size once they are created. Code complexity. Code for manipulating 2D arrays can be more complex than code for manipulating 1D arrays, as it requires nested loops to access and manipulate the elements. Representation of data. 1D arrays are suitable for representing simple lists of data, while 2D arrays are better suited for representing data in a table-like format, such as matrices, spreadsheets, or game boards. Type safety. Both 1D and 2D arrays provide strong type safety, which means that the data type of each element in the array is checked at compile time. In summary, 1D arrays are better suited for representing linear collections of data, while 2D arrays are better suited for representing tabular data. Both 1D and 2D arrays provide strong type safety and efficient memory usage, but 2D arrays can be more complex to work with and may use more memory than 1D array. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Two-dimensional arrays exercise. In this lecture, we will practice some example of two-dimensional arrays. So, open IntelliJ. Now we create a new class file named 2DArray in the Nixware consulting package, and then create a main method using shortcut PSVM. Now we write in double square brackets numbers equal sign double opening curly brace 1 comma, 2 comma, 3 comma, 4 closing curly brace comma opening curly brace 5 comma, 6 comma, 7 comma, 8 closing curly brace semicolon. Here we create a 2D array of integers with 2 rows and 4 columns. So, in this 2D array, the first row has 4 cells with the values 1, 2, 3, and 4, and the second row has 4 cells with the values 5, 6, 7, and 8. This means that the 2D array has a total of 8 cells, with each cell storing a specific integer value. Then we system out .print opening parentheses numbers square bracket 0, plus double quote space closing parentheses semicolon. System out .println opening parentheses numbers square bracket 0, square bracket 3, closing parentheses semicolon. System out .print opening parentheses numbers square bracket 1, plus double quote space closing parentheses semicolon. System.out.println opening parentheses numbers square bracket 1, square bracket 2, closing parentheses semicolon. Here we will print out the values of 4 specific elements in the numbers 2D array. Here the first line prints out the value at the first row and first column of the numbers array, which is 1. It also adds a space character after the number. Then second line prints out the value at the first row and fourth column of the numbers array, which is 4. It then moves to the next line. Then third line prints out the value at the second row and second column of the numbers array, which is 6. It also adds a space character after the number. Then fourth line prints out the value at the second row and third column of the numbers array, which is 7. It then moves to the next line. Now we run it. Here is the output. 1, 4, and 6, 7. Here the values of numbers index 0, 0 and numbers index 0, 3 are printed on the same line with a space in between, and the values of numbers index 1, 1 and numbers index 1, 2 are printed on the same line with a space in between. Now we display the values of the 2D array using a for loop. So, we write for opening parentheses into I equals sign 0 semicolon, I less than numbers dot length semicolon, I plus plus closing parentheses curly braces. For opening parentheses in J equals sign 0 semicolon, J less than numbers square brackets I dot length semicolon, J plus plus closing parentheses curly braces system dot out dot print opening parentheses numbers square brackets I square brackets J plus double quote space closing parentheses semicolon. Then right outside the nested for loop system out dot print ln parentheses semicolon. Here we use outer and nested loop to traverse through all the elements of the numbers 2D array and print them out. So, the outer for loop uses the variable I to iterate through each row of the numbers array. It starts at 0 and goes up to the value of numbers dot length minus 1, which is 1 in this case, since there are 2 rows in the array. The inner for loop uses the variable j to iterate through each column of the current row of the numbers array. It starts at 0 and goes up to the value of numbers square brackets I dot length minus 1, which is 3 for the first row and 3 for the second row in this case, since there are 4 columns in each row. Inside the inner for loop, the code uses print method to print out the value at the current row and column of the numbers array. It also adds a space character after the number. After the inner for loop has printed out all the values in the current row of the numbers array, the code uses empty print method to move to the next line. So when this code is executed, it will print out all the values in the numbers 2D array in row major order, with each row on a separate line. Before we run it, we first comment these 4 print methods. Now we run it. Here is the output. Here first prints out the values of the first row 1, 2, 3, 4, followed by a new line, and then prints out the values of the second row 5, 6, 7, 8, followed by another new line. Now we will write more complex program. For this, we write a program that implements Conway's game of life, a cellular automaton simulation. The program should initialize a 20 by 20 grid with random values of either 0 or 1. Then, for each generation of the simulation, the program should update the grid based on the following rules. Any live cell with fewer than 2 live neighbors dies, as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies, as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. The program should print out the grid after each generation, using the asterisk character to represent live cells and the dot character to represent dead cells. The simulation should run for 10 generations. Before we start creating this game, we first see what Conway's game of life is. Conway's game of life is a cellular automaton created by mathematician John Conway in 1970. It is a 0-player game, meaning that its evolution is determined by its initial state, requiring no further input from a player. The game is played on a 2-dimensional grid of cells, where each cell can be either alive or dead. The game progresses through generations, with the state of each cell in a new generation determined by a set of rules based on the state of its 8 neighbors in the previous generation. The rules are simple, but can lead to complex and interesting patterns. The game of life has been of interest to computer scientists, mathematicians, and physicists, as well as to enthusiasts of complex systems and emergent behavior. Let's start creating program. For this, we first create a class file named Game of Life in the Nixware and Consulting package. Inside this class, we write private static int rows equals sign 20 semicolon. Private static int calls equals sign 20 semicolon. Here we define the number of rows and columns in the grid for Conway's game of life simulation. In this case, the grid will have 20 rows and 20 columns. Then write private static int double square brackets neighbor underscore offsets equals sign double opening square brackets -1 comma, -1 closing square bracket comma, opening square bracket -1 comma, 0 closing square bracket comma, opening square bracket -1 comma, 1 closing square bracket comma, opening square bracket 0 comma, -1 closing square bracket comma, opening square bracket 6 comma, 1 closing square bracket comma, opening square bracket 1 comma, -1 closing square bracket comma, opening square bracket 1 comma, 0 closing square bracket comma, opening square bracket 1 comma, 1 double closing square bracket semicolon. Here we initialize as a 2D array neighbor underscore offsets with 8 rows and 2 columns. Each row represents the coordinates of a cell's 8 neighbors in a 2D grid. The first column represents the offset in the row direction, and the second column represents the offset in the column direction. For example, the first row -1 comma, -1 represents the top left neighbor of a cell. The second row -1 comma, 0 represents the neighbor directly above the cell, and so on. These offsets will be used to determine the coordinates of a cell's neighbors when updating the game of life grid. Then we write private int double square brackets grid semicolon. Here grid is a 2D integer array that represents the state of the cells in the game of life. Each element in the array represents the state of a cell, where a value of 1 indicates a live cell and a value of 0 indicates a dead cell. The size of the array is determined by the constants rows and cols, which are set to 20 in this code. The grid is used to update the state of the cells in each iteration of the game of life. Then we write private random semicolon. Here random is a Java class that provides a way to generate random numbers. In the game of life class, a random object is used to generate random numbers that determine whether each cell in the grid is initially alive or dead. Then write public game of life parentheses curly braces. Grid equals sign new int square brackets rows square brackets calls semicolon. Random equals sign new random parentheses semicolon. Initialize grid parentheses semicolon. Here we create constructor of the game of life class, which initializes the grid and random variables. The grid variable is initialized as a 2-dimensional integer array with rows and cols columns. This is the grid on which the game of life simulation will take place. The random variable is initialized as a new random object, which is used to generate random values for the cells in the grid. Finally, the initialize grid method is called to randomly initialize the cells in the grid. Then write private void initialize grid parentheses curly braces. Here we create initialize grid method. So, the purpose of this is to create an initial state for the game of life simulation. In the game of life, the cells in the grid represent the organisms, which can be either alive represented by a value of 1 or dead represented by a value of 0. The initial state of the grid is important because it sets the starting configuration of the organisms, which will then evolve over time according to the rules of the game. By randomly initializing the grid, the simulation can start from a variety of different initial configurations, allowing for different outcomes and patterns to emerge. Then write for opening parentheses int row equals sign zo semicolon. Row less than rows semicolon. Row plus closing parentheses curly braces. For opening parentheses int call equals sign zo semicolon. Call less than calls semicolon. Call plus closing parentheses curly braces. Grid square brackets row square brackets call equals sign random dot next int parentheses 2 semicolon. Here we initialize the grid with randomly generated values of either 0 or 1. The nested for loops iterate through each cell in the grid, and for each cell, the random.nextInt method generates a random integer that is either 0 or 1, which is then assigned to the corresponding cell in the grid. This initialization step is important because it sets up the initial state of the game board, which is necessary for the simulation to start. Here we go into the constructor, and call the initializeGrid method to randomly initialize the cells in the grid. Then we write private int count live neighbors opening parentheses int row comma, int call closing parentheses curly braces. Here we create count live neighbors method. So, this method is used to count the number of live or on neighboring cells around a given cell in the grid. This method takes two arguments, row and call, which represent the row and column indices of the cell for which we want to count the live neighbors. The method uses the neighbor underscore offsets array to iterate over the 8 neighboring cells around the given cell and counts the number of cells that are live. It then returns the count of live neighbors. Then we write int live neighbors equals sign zo semicolon. So, live neighbors is an integer variable initialized to 0. Its purpose is to count the number of live neighbors of a given cell in the game of life grid. The count of live neighbors will be used to determine the new state of the cell in the next generation. Then we write for opening parentheses int square brackets offset colon neighbor underscore offsets closing parentheses curly braces int neighbor row equals sign row plus offset square brackets 0 semicolon. Int neighbor call equals sign call plus offset square brackets 1 semicolon. Here for each loop is iterating over the array neighbor underscore offsets, which contains pairs of numbers that represent the relative positions of the neighboring cells of the current cell being examined. For each pair of numbers which is stored in the variable offset, the code calculates the row and column of the neighboring cell by adding the current cell's row and column to the corresponding numbers in the offset array. These values are stored in the variables neighbor row and neighbor call, respectively. This allows the code to examine the state of each of the neighboring cells in order to count the number of live cells around the current cell. If we see what offset is. So, in the context of the game of life simulation, an offset is a two-element integer array that describes the relative position of a neighboring cell with respect to a given cell. For example, the offset 1, 0 represents a cell that is one row below the current cell and in the same column, while the offset -1, 1 represents a cell that is one row above and one column to the right of the current cell. Then write if opening parentheses neighbor row greater than equals to 0 and neighbor row less than rows and neighbor call greater than equals to 0 and neighbor call less than calls and grid square brackets, neighbor row square brackets, neighbor call equals sign 1 closing parentheses curly braces live neighbors plus semicolon. Here if statement checks if the current neighbor identified by the neighbor row and neighbor call variables are within the bounds of the grid. That is whether the neighbor is on the board, and whether the neighbor is alive. That is the value of grid square brackets, neighbor row square brackets, neighbor call is equal to 1. If both of these conditions are satisfied, then live neighbors is incremented by 1, since this neighbor is alive. In other words, this code is counting the number of live neighbors of the current cell. Then write return live neighbors semicolon in the last line of method. Here count live neighbors method returns the number of live neighbors for a given cell in the grid. After iterating through all the neighbor offsets and checking if each neighbor is valid and alive, live neighbors variable would have been updated to reflect the number of live neighbors. This variable is then returned to the calling method. Then write public void update parentheses curly braces. Here we create update method. So, the update method is responsible for updating the grid based on the rules of the game of life. Specifically, for each cell in the grid, the method counts the number of live neighbors and applies these rules. If the cell is alive and has fewer than 2 live neighbors or more than 3 live neighbors, it dies becomes 0. If the cell is alive and has 2 or 3 live neighbors, it stays alive remains 1. If the cell is dead and has exactly 3 live neighbors, it comes to life becomes 1. The updated grid is then stored back in the grid instance variable. Then write in double square brackets new grid equals sign new int square brackets rows square brackets calls semicolon. So, in the update method, a new 2D integer array new grid is created with the same dimensions as the original grid. This new grid will be used to calculate the updated state of the cells in the game of life. By creating a new grid, we can ensure that the updates are applied to a separate copy of the grid, so that the updates don't interfere with each other. After all the updates are complete, the original grid will be replaced with the updated new grid. Then write for opening parentheses int row equals sign zo semicolon, row less than rows semicolon, row plus closing parentheses curly braces. For opening parentheses int call equals sign zo semicolon. Call less than call semicolon. Call plus plus closing parentheses curly braces. Int live neighbors equals sign count live neighbors opening parentheses row comma, call closing parentheses semicolon. Here the outer loop iterates over each row in the grid, and the inner loop iterates over each column in the grid. For each cell in the grid specified by the current row and column, it calls the count live neighbors method to calculate the number of live neighbors. The result is stored in the live neighbors variable. Then write if opening parentheses grid square brackets row square brackets call equal sign 1 closing parentheses curly braces. If opening parentheses live neighbors less than 2 or live neighbors greater than 3 closing parentheses curly braces. New grid square brackets row square brackets call equal sign zo semicolon. Then write else curly braces new grid square brackets row square brackets call equal sign 1 semicolon. Then write else curly braces if opening parentheses live neighbors equal sign 3 closing parentheses curly braces. New grid square brackets row square brackets call equal sign 1 semicolon. Then write else curly braces new grid square brackets row square brackets call equal sign zo semicolon. Here is the logic that determines whether a cell should be alive or dead in the next generation of the game of life. Here the first if statement checks if the current cell is alive, that is its value in the current grid is 1. If it is alive, the next if statement checks if the cell has less than 2 live neighbors or more than 3 live neighbors. If either of these conditions is true, the cell will die in the next generation, so the corresponding element in the new grid is set to 0 dead. Otherwise, the cell will continue to live, so the corresponding element in the new grid is set to 1 alive. If the current cell is dead, that is its value in the current grid is 0. The second if statement checks if it has exactly 3 live neighbors. If it does, the cell will come to life in the next generation, so the corresponding element in the new grid is set to 1 alive. Otherwise, the cell will remain dead in the next generation, so the corresponding element in the new grid is set to 0 dead. Then write grid equals sign new grid semicolon last line of this method. Here we assign the new grid generated by the update method to the instance variable grid. It replaces the old state of the grid with the new state, reflecting the changes made based on the rules of the game of life. Now we create another method by writing public void print grid parentheses curly braces. So, here we create print grid method. The purpose of this method is to print the current state of the grid to the console in a human-readable format. This allows the user to see the current state of the game of life and observe the changes that occur as the game progresses. The method iterates over the rows and columns of the grid array and prints a asterisk character for each live cell and a dot character for each dead cell. The output is formatted to show a grid-like structure with rows and columns separated by vertical and horizontal lines. Then we write for opening parentheses int row equals sign 0 semicolon. Row less than rows semicolon. Row plus plus closing parentheses curly braces. For opening parentheses int call equals sign 0 semicolon. Call less than calls semicolon. Call plus plus closing parentheses curly braces. If opening parentheses grid square brackets row square brackets call equals sign 1 closing parentheses curly braces. Systemout.println opening parentheses double quote asterisk closing parentheses semicolon. Then write else curly braces. Systemout.println opening parentheses double quote dot closing parentheses semicolon. Then outside the inner loop write systemout.println parentheses semicolon. Here the outer loop iterates through all the rows in the grid, from the first row index 0 to the last row index rows -1. The inner loop iterates through all the columns in the grid, from the first column index 0 to the last column index calls -1. For each cell in the grid, the if-else statement checks if the value is 1 or 0. If the value is 1, then the cell is alive and an asterisk is printed to the console. If the value is 0, then the cell is dead and a dot is printed to the console. Once all the cells in a row are printed, a new line character is printed to move to the next row. This continues until all the cells in the grid have been printed. Now we create a main method by writing shortcut PSVM. Now inside this method, we write game of life game equals sign new game of life parentheses semicolon. Here we creates a new instance of the game of life class and assigns it to a variable named game. Once the game of life object is created, its constructor is called, which initializes the grid and random instance variables and calls the initializeGrid method to randomly initialize the grid with live and dead cells. The game object can then be used to update the state of the grid and print it out using the update and print grid methods, respectively. Then we write for opening parentheses int I equals sign 0 semicolon, I less than 10 semicolon, I plus plus closing parentheses curly braces, game.print grid parentheses semicolon, game.update parentheses semicolon. Here this for runs for 10 iterations, where in each iteration it first calls the print grid method of the game object, which prints the current state of the grid on the console. After that, it calls the update method of the game object, which updates the state of the grid based on the rules of the game of life. This loop will repeat for 10 times, and in each iteration, the grid will be updated based on the previous state and printed on the console. At the end of the loop, the final state of the grid will be printed on the console. Now we run it. Here is the output after successfully run. So, the output appears to be a visual representation of the state of the game's grid at each update iteration. In this specific case, it shows the grid evolving over 10 generations. Each asterisk represents a live cell, and each dot represents a dead cell. The pattern of cells seems to be random and unpredictable, since it depends on the initial state of the grid, which is determined by the initializeGrid method. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Multi-dimensional arrays. In this lecture, we will talk about multi-dimensional arrays. So, let's start with how to visualize a multi-dimensional array. If I want to visualize a two-dimensional array, I can visualize it in this way. This two-dimensional array consists of 3 rows and 3 columns. It is just a simple matrix. But what happens if I add one more dimension here? Then it becomes a 3-dimensional arrays, and that's... So what does this statement says? It says that I want 2 such two-dimensional arrays which consist of 3 rows and 3 columns. That means something like this too. 2-dimensional arrays which consist of 3 rows and 3 columns. Now I want to access the element in the first row and third column of the first 2D array. In order to do that, I have to specify something like this. Here 0 indicates the first 2D array. This 0 indicates the first row, and this 2 indicates the third column. That means finally I would be able to access this particular element. Now, after understanding this, let's try to understand how we can initialize the 3-dimensional array. If you want to initialize the 3-dimensional array, there are basically 2 methods, and here is method number 1, which says that if you want to initialize a 3-dimensional array, then simply specify all the elements in a sequence. Then these elements will get stored in a contiguous fashion in this array. But obviously this is not a best matter because we won't be able to visualize all these elements will get stored in this 3D array. In order to visualize that, there is another method. In this method, as we can see, these curly brackets indicate that this is our first 2D array, and these curly brackets indicate that this is our second 2D array. This is the first row of this first 2D array, and this is the second row of the first 2D array. Similarly, this is the first row of the second 2D array, and this is the second row of the second 2D array. This is obviously the better method. Now, after understanding how we can initialize the 3-dimensional array, let's try to understand how we can print the elements of the 3D array. Recall that in order to print the elements of one-dimensional array, we have to use a single for loop. That means something like this. A single for loop helps us in printing all the elements of one-dimensional array. And if you want to print all the elements of a 2-dimensional array, then we can print that with the help of 2 for loops. Now you can guess that in order to print the elements of a 3-dimensional array, we require 3 for loops. And now my target is to print all the elements which are stored in this particular array. Please note down that here we are having 2 two-dimensional arrays, which consist of 2 rows and 3 columns. Here I indicate the 2D array index. J indicates the row index, and K indicates the column index. Now let me simulate the whole process so that we can better understand how these elements will get printed on the screen. As I is initialized to 0, that means we want to access the first 2D array first, and we can check that 0 is less than 2. Therefore, condition is satisfied. Therefore, we will come inside this for loop, and in this for loop, we are initializing j to 0. That means we want to access the first row of this first 2D array. J is less than 2, that is 0 is less than 2 conditions is satisfied. We'll come inside this for loop, and here we will encounter another for loop, which is containing k. K indicates the column index, and k is also initialized to 0. That means we want to access this particular element. 0 is less than 3, right condition is satisfied. Therefore, we can print k, which means we can print this particular element on the screen. After printing this element, this k will get incremented. Now, k becomes 1. 1 is less than 3, condition is satisfied. Therefore, this time we will print this element. Please note down that I is 0 and j is also 0 while printing this element. That means we are still in the first 2D array, and the first row. But k will get incremented, that means column is incremented. That means we are jumping from this position to this position. Simple, isn't that? So now the k will get incremented again. K now becomes 2. 2 is less than 3 condition is satisfied. Therefore, we will jump to this particular location because we are still at first row of this first 2D array. Only the k will get incremented. Therefore, this element will get printed on the screen. After that, k will again get incremented. But this time k is now 3. 3 is not less than 3, condition is not satisfied. Therefore, we will exit from this for loop, and this means this time we will increment the value of j. This means we will jump from first row to second row. After incrementing j becomes 1. 1 is less than 2 condition is satisfied. Therefore, we'll come again inside this for loop, and k will again get initialized to 0. That means we will again start from the first column itself. But this time, we are in the second row of this first 2D array. As k is 0 and 0 is less than 3, condition is satisfied. We know that this element will get printed on the screen. Similarly, after the increment of the k, these elements will get printed on the screen. Then again, the condition will get failed when we reach at k equals to 3. 3 is not less than 3, condition is not satisfied. Therefore, we'll come outside of this for loop, and again, we will increment the value of j. This time j becomes 2 and 2 is not less than 2. Therefore, the condition is not satisfied, and hence we come outside of this for loop, and now we will increment the value of I. Because there is the need to come to the second 2-dimensional array. I will get incremented means that I now becomes 1. 1 is less than 2, condition is satisfied. Therefore, we will again come inside this power loop, and again j will get initialized to 0. This means that we are now in the first row of the second 2-dimensional array. 0 is less than 2, condition is satisfied. We will again come inside this for loop. K is again initialized to 0. That means we are now in the first column of the first row of this 2-dimensional array. 0 is less than 3. Condition is satisfied. We come inside this for loop, and we will print this particular element that is 7. After this, k will again get incremented. K now becomes 1. 1 is less than 3. Condition is satisfied. We'll print this particular element next. Then we know the next element which will get printed on the screen is 9. After this condition is failed, we'll come to this point. J will get incremented. Means that we'll come to the second row. 1 is less than 2. Condition is satisfied. Therefore, we will again come inside this for loop, and again value of k will get initialized to 0. This means now we are in the first column of the second row. Therefore, this element will get printed on the screen after this condition is satisfied. And now we know that these elements will get printed. After printing 10. After this condition failed, we'll come at this point j will again get incremented. But 2 is not less than 2. Condition is not satisfied. Therefore, we'll come outside of this for loop, and after that we will increment the value of I. I become 2 and again 2 is not less than 2. Condition is not satisfied. Therefore, finally, we will come outside of this power loop. Now we will come to practice. For this open IntelliJ. Now we create a new class file named multi-darrayExample in the Nixware consulting package, and then create a main method using shortcut PSVM. Now inside this method we write in triple square brackets 3D array equal sign new int square brackets 3 square brackets 3 square brackets 3 semicolon. Here we are creating a 3D integer array named 3D array with a size of 3 cross 3 cross 3. The first square brackets specify the number of rows, the second square brackets specifies the number of columns, and the third square brackets specify the depth or the number of layers in the 3D. So, this 3D array has 3 rows, 3 columns, and 3 layers, which mean it can hold a total of 27 integer values, that is 3 cross 3 cross 3 equals sign 27. Then we write for opening parentheses int I equals sign 0 semicolon. I less than 3 semicolon. I plus plus closing parentheses curly braces. For opening parentheses int j equals sign 0 semicolon. J less than 3 semicolon. J plus plus closing parentheses curly braces. For opening parentheses int k equals sign 0 semicolon. K less than 3 semicolon. K plus plus closing parentheses curly braces. 3D array square brackets I square brackets j square brackets k equals sign I plus j plus k semicolon. Here the outermost loop initializes a variable I to 0 and increments it by 1 after each iteration, until it reaches 3. This loop controls the layers of the 3D array, which are represented by the first dimension of the array. The second initializes a variable j to 0 and increments it by 1 after each iteration, until it reaches 3. This loop controls the rows of the 3D array, which are represented by the second dimension of the array. The innermost loop for initializes a variable k to 0 and increments it by 1 after each iteration, until it reaches 3. This loop controls the columns of the 3D array, which are represented by the third dimension of the array. Inside the innermost loop, assigns the sum of I, j, and k to the element at the current position of the 3D array. This loop fills each element of the 3D array with a value that is the sum of its corresponding indices I, j, k. In other words, this nested loop construct fills the 3D array with values that are the sum of the indices of each element. For example, the element at position row 1, column 2, depth 1 would have the value 4, because 1 plus 2 plus 1 equals 4. Then we print these inserted values. For this we copy these for loops and paste here. First we change the statement in the most inner loop and systemout.print opening parentheses 3D array square brackets I square brackets j square brackets k plus double quote space closing parentheses semicolon. Then write outside the most inner loop systemout.println opening parentheses semicolon. Then write systemout.println opening parentheses semicolon outside the inner loop. So, here inside the innermost loop, we print the value of the current element of the 3D array to the console, followed by a space. This statement prints all the values of the current row of the current layer on a single line. After the innermost loop completes all iterations for the current row of the current layer is used to move to the next line. This statement prints a new line character to the console, effectively starting a new line. After the middle loop completes all iterations for the current layer, is used again to move to the next line. This statement prints an extra new line character to the console, effectively creating a blank line between layers. Finally, after the outermost loop completes all iterations for all layers, an extra print statement is used to print another new line character to the console, effectively creating a blank line after the last layer. Now we run it. Here is the output after successfully run. Here each block of numbers in the output represents one layer of the 3D array. The rows within each block represent the rows of the corresponding layer, and the numbers within each row represent the values of the elements in the row. The first block represents the first layer of the 3D array. In this layer, the element at position row 0, column 0, and depth 0 has the value 0, the element at position row 0, column 0, depth 1 has the value 1, and so on, up to the element at position row 0, column 2, depth 2 which has the value 4. Similarly, the second block represents the second layer of the 3D array. In this layer, the element at position row 1, column 0, and depth 0 has the value 1. The element at position row 1, column 0, and depth 1 has the value 2. And so on, up to the element at position row 1, column 2, and depth 2 which has the value 5. Finally, the third block represents the third layer of the 3D array. In this layer, the element at position row 2, column 0, and depth 0 has the value 2. The element at position row 2, column 0, and depth 1 has the value 3. And so on, up to the element at position row 2, column 2, and depth 2 which has the value 6. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to List. In this lecture, we will see an introduction to list in Java. If we talk about array, that is a way to manage a list of items or having the same type. Array were a massive improvement if you needed to store items of the same type. But as you saw, arrays have some limitations. Not being able to change the number of elements in an array being one. Fortunately, Java also includes an entire library for Java containers, which they call collections. They take the arrays we worked with to the next level. They are ready to change the number of elements defined in an array for one, but there are many other improvements as well. In upcoming lectures, we will be talking about lists, which are Java containers, and explain what they are and how to use them. Two of the most common classes for lists are array list and linked lists. Arrays are mutable, and we saw that we could set or change values in the array, but we could not resize it. Just like the string builder class provides a resizable way to handle text. Java gives us several classes that let us add and remove items and resize the sequence of elements. These classes are set to implement lists behavior. So what is the list? Imagine you are working on a project that involves storing a collection of items that can be added to or removed from at any time. You need a way to keep track of these items and manipulate them as needed. This is where a list comes in. In Java, a list is an interface that represents an ordered collection of elements. It's similar to an array, but with some key differences. Unlike an array, a list can grow or shrink as needed. You can add or remove items from a list at any time, and the list will automatically adjust its size accordingly. For example, let's say you're building a program that keeps track of a user's to-do list. You could use a list to store the tasks that need to be done. When the user adds a new task, you can simply add it to the list. When a task is completed, you can remove it from the list. The list provides a convenient way to manage the user's tasks, and makes it easy to add or remove tasks as needed. So, a list is a powerful tool for managing collections of elements in Java. It allows you to store and manipulate items in an ordered manner, and provides a convenient way to add or remove items as needed. Here we use a word interface. A class can use or implement an interface, which means it agrees to have the methods that the interface describes. Here are the names of the classes that use interface, like abstract list, array list, copy on write array list, linked list, and stack, and so on. Of these classes, the array list is probably the most commonly used class here, and it's the one we will focus on next. So what the array list is, it's a resizable array. The array list is a class that really maintains an array in memory that's actually bigger than what we need in most cases. It keeps track of the capacity, which is the actual size of the array in memory. But it also keeps track of the elements that have been assigned or set, which is the size of the array list. As elements are added to an array list, its capacity may need to grow. This all happens automatically behind the scenes. This is what the array list is resizable. Now we understand this with an example. Suppose you have a class of 11 students, and you want to store their roll numbers in an array of size 11. Initially, you can create an array and add the roll numbers of the 11 students to it. However, suppose that in the middle of the year, 2 more students enroll in the class, and you need to add their roll numbers to the array. Since arrays have a fixed size, you cannot simply add the new roll numbers to the existing array. One option is to create a new array with a larger size, copy all the existing roll numbers to the new array, and then add the new roll numbers to the end of the array. This process is known as resizing the array. However, this approach has several drawbacks. First, it is time-consuming and requires a lot of code. Second, it can lead to inefficient use of memory, as you may end up creating a new array that is much larger than necessary. Third, if the array is being used in multiple places in your code, you will need to update all those places to use the new array. A better solution to this problem is to use a list instead of an array. A list has a dynamic size, which means you can add or remove elements as needed. When you create a list to store the roll numbers of the 11 students, you can simply add their roll numbers to the list. Later, when the 2 new students enroll, you can add their roll numbers to the list as well, and the list will automatically adjust its size to accommodate the new elements. Because internally, an array list maintains an array of objects to store the elements of the list. When the array is full, and a new element needs to be added, the array list automatically creates a new array with a larger size, copies the existing elements to the new array, and adds the new element to the end of the list. Similarly, when an element is removed from the list, the array list shrinks the underlying array if necessary to maintain efficiency. So, when you create an array list in Java, the array list object and its internal array are stored in the heap memory. Heap memory is a portion of the memory allocated to the Java virtual machine for the execution of Java programs. It is the memory area where objects are stored, and it is dynamically allocated at runtime to accommodate the memory requirements of the program. When you create an object in Java, such as an instance of a class or an array, the memory for that object is allocated from the heap memory. The heap memory is divided into different regions, such as the young generation and the old generation, to optimize the allocation and deallocation of memory for objects. ArrayList performs some major operations like adding elements, removing elements, getting elements, updating elements, iterating over the elements of the list. So, adding elements. You can add elements to an array list using the add method. This method adds the element at the end of the array list. Adding elements is a major operation because it is how you build the list. Removing elements. You can remove elements from an array list using the remove method. This method removes the element at the specified index, or the first occurrence of the specified element. Removing elements is a major operation because it changes the size of the list. Getting elements. You can get elements from an array list using the get method. This method returns the element at the specified index. Getting elements is a major operation because it allows you to access the data stored in the list. Updating elements. You can update elements in an array list using the set method. This method sets the element at the specified index to the specified value. Updating elements is a major operation because it changes the data stored in the list. Iterating over the elements of an array list is a common operation that allows you to access each element in the list one by one. Java.util.ArrayList is a class that provides an implementation of the list interface that uses a dynamic array to store the elements. It is part of the Java Collections framework and is commonly used to store and manipulate collections of data. The ArrayList class is included in the java.util package, which is a collection of utility classes that provide various functionalities such as collection classes, input-output operations, date and time handling, and more. So, we must import java.util.ArrayList at the top of the program before using ArrayList. Remember that, in Java, ArrayList is designed to store objects, not primitive data types directly. This is because an ArrayList is implemented using an array of object references, and each object reference can refer to an object of any class, including the wrapper classes for primitive data types such as integer, double, boolean, and so on. For example, if you want to store integers in an array list, you can use the integer wrapper class to wrap each integer value as an object and then add the objects to the array list. This allows you to store integers as objects, which provides more flexibility and enables you to use the various methods provided by the ArrayList class to manipulate the list. Now we see the syntax of ArrayList. Here is the syntax. In this syntax, data type represents the type of data that will be stored in the array list. For example, if you want to store integers in the array list, you would replace data type with integer. If you want to store strings, you would replace data type with string. List name is the name you choose to give to the array list object. You can choose any valid identifier for this name. Here is an example of declaring and initializing an array list of integers. So, here we create a new array list object of integer type and assigns it to the variable myArrayList. Here array list opening angel bracket integer closing angle bracket. This declares a new array list object that can store elements of the integer type. Then myArrayList. This is the name of the variable to which the array list object is assigned. Then new array list angle brackets integer parentheses. This creates a new array list object of the integer type with an initial capacity of 10. So, in this statement, we are creating an array list object myArrayList that can store integer values. The array list is initially empty because we did not pass any initial elements to the constructor. The array list is initialized with a default capacity of 10, which means that it can store up to 10 integer elements without needing to resize its internal array. How we analyze it that this array list has capacity of 10? Because when we use the empty parentheses with the array list constructor, it creates a new array list object with the default capacity of 10. The default capacity is set in the ArrayList class, which is why it is not explicitly mentioned in the code, but we can mention it like this. So, both statements create an ArrayList object with an initial capacity of 10. However, the second statement explicitly sets the capacity to 10, while the first statement uses the default capacity of 10. We can add elements to this array list using the add method, like this. These statements will add the values 1, 2, and 3 to the end of the array list. The array list will then contain square brackets 1, 2, 3. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Array list exercise. In this lecture, we will practice some examples using array list. So, we start with simple example. So, we program that demonstrates the use of array lists with 3 different data types: integers, doubles, and booleans. The program should create an array list of each data type, add some values to each array list, and then print out the contents of each array list. Let's start creating program. For this, open IntelliJ. Then, we create another project named ArrayList. Then we create a package named nixware.consulting. Then create a class named ArrayListExample inside the consulting folder, and then create a main method inside this class using shortcut PSVM. Inside this class, we write array list angle brackets integer int list equals sign new array list angle brackets integer parentheses semicolon. Here is a declaration statement that creates a new array list object named int list that can hold elements of type integer. The syntax specifies the type of elements that the array list can hold. In this case, it's integer, which is a wrapper class in Java for the primitive data type int. The diamond operator is used here to represent type inference, which was introduced in Java 7. This means that the compiler can infer the type of objects that the array list can hold based on the type specified on the left-hand side of the assignment operator. The new keyword is used to create a new array list object, and integer in the angle brackets specifies the type of elements that the array list can hold. The parentheses are empty because we haven't added any elements to the array list yet. Then we write int list.add parentheses 10 semicolon. Here adds an element with the value of 10 to the int list array list. The add method is a built-in method in the ArrayList class that allows us to add elements to the array list. In this case, we're adding an integer value of 10 to the end of the array list. If we wanted to add an element at a specific index in the array list, we can use the addIndex element method, where index is the position where we want to add the element and element is the value we want to add. For example, int list.add parentheses 0, 5 would add the integer value of 5 at the beginning of the int list array list, pushing all other elements 1 index to the right. Then we write systemout.println opening parentheses double quote integers plus int list closing parentheses semicolon. Here this print statement that prints out the contents of the int list array list to the console. So, the output will be the string integers, followed by the contents of the int list array list, which is in the form of an array with the elements separated by commas and enclosed in square brackets. Now we run it. Here is the output that is integers square brackets 10. The output is in the form of an array, with the enclosed in square brackets. Since we only added one element to the array list, the output shows a single element of 10. Now we add more data by writing int list.add parentheses 20 semicolon. Int list.add parentheses 30 semicolon. Now we run it again. Here is the output. Because I've added 2 more elements to the array list, the output shows 3 elements of 10, 20, and 30. Now we write array list angle brackets string fruits equals sign new array list angle brackets string parentheses semicolon. Here we create a new array list object named fruits that can store elements of the string type. Then we write fruits.add opening parentheses double quote apple closing parentheses semicolon. Fruits.add opening parentheses double quote banana closing parentheses semicolon. Fruits.add opening parentheses double quote orange closing parentheses semicolon. Fruits.add opening parentheses double quote mango closing parentheses semicolon. Here we add the string elements apple, banana, orange, and mango to the fruits list using the add method of the array list class. Then we write systemout.println opening parentheses double quote array list before removing an element closing parentheses semicolon. Systemout.println opening parentheses fruits closing parentheses semicolon. Here the first line prints the message array list before removing an element, while the second line prints the contents of the fruits list using its default toString method, which displays the list elements in square brackets and separated by commas. Now we run it. Here is the output. This output means that the fruits list contains 4 elements: apple, banana, orange, and mango. This is the current state of the fruits list before any elements are removed from it. Then we write fruits.remove parentheses double quote orange semicolon. Here we remove the element orange from the fruits list using the remove method of the array list class. The remove method takes an object as its parameter and removes the first occurrence of that object from the list if it is present. In this case, the element orange is present in the fruits list, so it will be removed from the list. Then write systemout.println opening parentheses double quote array list after removing an element closing parentheses semicolon. Systemout.println parentheses fruits semicolon. So, here we print the updated fruits list after removing the element orange using the remove method. Now we run it. Here is the output. This output indicates that the element orange has been successfully removed from the fruits array list using the remove method. The resulting array list now contains 3 elements: apple, banana, and mango. This example shows how to remove an element from an array list in Java by specifying the element to be removed as an argument to the remove method. Then we write string firstFruit equals sign fruits dot get parentheses 0 semicolon. Here we retrieve the element at the index 0, that is the first element of the fruits array list, and assigns it to the variable firstFruit. In this case, since the fruits array list contains the following elements: apple, banana, mango, the element at index 0 is apple. So, the value of firstFruit will be apple. Then write systemout.println opening parentheses double quote firstFruit in the array list plus firstFruit closing parentheses semicolon. Here we will print the value of the variable firstFruit concatenated with the string firstFruit in the array list. The get method is used to retrieve the element at a particular index in the array list. In this case, get0 is used to retrieve the element at index 0, which is the first element in the array list. The value of this element is then assigned to the variable firstFruit. Now we run it. Here is the output that is firstFruit in the array list: apple, because the first element in the fruits list is apple. Then write fruits.set opening parentheses 1 comma, kiwi closing parentheses semicolon. Here's set method call on the fruits array list that replaces the element at index 1 with the string kiwi. In other words, it updates the element at index 1 with the new value kiwi. Here, the set method is used to update the value at a specific index in the array list. The first argument to the set method is the index of the element that needs to be updated, and the second argument is the new value that should replace the existing value at that index. In this case, the value at index 1, which is banana, is replaced with kiwi. Then we write systemout.println opening parentheses double quote array list after updating an element closing parentheses semicolon. Systemout.println opening parentheses fruits closing parentheses semicolon. Here the first line is a simple message to indicate that the array list is being printed after an update. The second line prints the updated array list fruits to the console. Now we run it. Here is the output. So, the output array list after updating an element, apple, kiwi, mango, shows the updated array list where the element at index 1, which was previously banana, is now kiwi. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Summary of array and array list. In this lecture, we will see the summary of array and array list. Now we see the difference. So, array support primitive types, but array lists don't. Array list supports primitive wrappers. Both are indexed and ordered by that index. Both allow duplicate values and null values. Both inherit from java.object and immutable. And the array is not resizable, but the array list is, and I've talked at length about the many methods implemented by array list. Here I show the differences when creating a new instance of an array compared to a new instance of an array list. And the array requires square brackets in the declaration. In the new instance, square brackets are also required with a size specified inside. AutoArray should be declared with the type of element in the array list in angle brackets. We can use the diamond and operator when creating a new instance in a declaration statement. You should use a specific type rather than just the object class because Java can then perform compile's time type checking. You can use an array initializer to populate array elements during array creation. This feature lets you pass all the values in the array as a comma-delimited list in curly braces. When you use an array initializer in a declaration statement, you can use what's called the anonymous version. You can use an ArrayList constructor that takes a collection or a list of values during ArrayList creation. The list.of method can be used to create such a list with a variable argument list of elements. The number of elements is fixed when an array is created. We can get the size of the array from the attribute length on the array instance. Array elements are accessed with the use of square brackets and an index that ranges from 0 to 1 less than the number of elements. The number of elements in an array list may vary and can be retrieved with a method on the instance name size. ArrayList elements are accessed with get and set methods, also using an index ranging from 0 to 1 less than the number of elements. ArrayList come with built-in support for printing out elements, including nested lists. Arrays don't though. So you need to call array.toString, passing the array as an argument. Here these are examples of single-dimension arrays and array lists. Now we will see multidimensional arrays and array lists and how to print the elements in each. A multidimensional array simply has a type which in itself is an array list. For a multidimensional array, you need to call the arrays.deep-to-string method passing the array as an argument. For nested array lists, we could still just pass the ArrayList instance directly to system.out.println. To arrays, we can use the binary search method to find a matching element, although this method requires that the array be sorted first. In addition, if the array contains duplicate elements, the index returned from this search is not guaranteed to be positioned of the first element. For the ArrayList, we have several methods. We can use contains or contains all, which simply returns a boolean if a match or matches were found. In addition, like the string in string builder, we have the methods indexOff and lastIndexOff, which will return the index of the first or last match. When a -1 is returned from these methods, no matching entry was found. Sorting seems like a simple concept when you think about sorting numbers and strings. We know there is a natural order for numbers and even for strings. We can use arrays.sort method for arrays with numeric primitive types and wrapper classes, as well as strings and string builders. For the ArrayList, we can use the sort method again for numeric wrapper classes, strings, and string builders. We pass ArrayList sort method a comparator type argument that specifies just how to sort. We call static methods on the comparator type to get a comparator for either a natural order or reverse order sort. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to linked list in relation to an array and an array list. In this lecture, we will see the introduction to linked list in relation to an array and an array list. So, I'm going to start talking about another class Java provides that also implements many of the same list methods we have seen already. And this is the linked list. To understand why the linked list class exists, it's important to understand a few things about the way Java stores information in memory for the array list, and the linked list. Let's start with an array of primitive data types. This is the simplest thing to understand. We are going to have primitive types is allocated. Space is allocated for all of its elements contiguously, as shown here. You can see from here that we have an array of 6 integers. The index position is in the left column, and that's the number we use to access a specific array value. So the first element when we use index position 0, this will retrieve the value 15. When we use index position 1, this gets the value of 17 and so on. The addresses we show here are memory addresses represented by these numbers. If 101 is the address of an integer, and we know an integer is 4 bytes, then the address of the next integer, if it's contiguous, would be 106, as we show here for the second element. Java can use simple maths using the index and the address of the initial element in the array to get the address and retrieve the value of the element. For reference types, meaning anything that's not a primitive type, like a string or any other object, the array elements are the values, but the addresses of the reference object or string. There's a level of indirection as shown. We have learned that array lists are really implemented with arrays under the covers. This means our objects are stored contiguously in memory, but their addresses are in the array behind the array list. And again, the addresses can be easily retrieved with a bit of maths if we know the index of the element. This is a cheap lookup and does not change no matter what size the array list is. But to remove an element, the reference to address has to be re-indexed or shifted to remove an empty space. And when an element, the array that backs the array list might be too small and might need to be reallocated. All of these operations can be an expensive process if the number of elements is large. An array is created with an initial capacity depending on how many elements we create the list with, or if you specify capacity when creating the list. Here I showed an array list that has a capacity of 7 because we are passing 7 in the constructor of this list. Within its 5 elements, we can have 2 more elements using the ArrayListAdd method, and the array that is used to store the data does not need to change. The elements at indices 5 and 6 get populated. But if the number of elements exceeds the current capacity, Java needs to reallocate memory to fit all the elements, and this can be a costly operation, especially if your array list contains a lot of items. So now if our code simply calls out on this array list, the next operation is going to create a new array with more elements, but copy the existing 7 elements over. Then the new element is added. You can imagine this an operation costs more in both time and memory than the previous add methods did. When Java reallocates new memory for the array list, it automatically sets the capacity to a greater capacity. But the Java language does not really specify exactly how it determines the new capacity, or promise that it will continue to increase the capacity in the same way in future versions. We can't actually get this capacity size from the array list. Let's start with how to determine cost, which in this case is generally considered in terms of time, but may include memory usage and processing costs. Maybe you have heard about big O notation or big O and wondered what this means. I won't get too deep into it, but there are a couple of concepts that are fairly easy to grasp and will help us understand how cheap or expensive an operation is in terms of time and memory usage as the operation scales. This means it's a way to express how well the operation performs when applied to more and more elements. So, big O notation is a way of describing the performance of an algorithm or operation, and it provides a way to estimate how the performance will scale as the input size increases. In other words, it helps us to analyze the efficiency of algorithms and predict their behavior as the input size grows. The O in big O stands for order of magnitude, and the notation is used to describe the upper bound of the time or space complexity of an algorithm. It is a mathematical way of expressing how the runtime of an algorithm scales with respect to the size of the input. For example, If an algorithm has a big O notation of O of n, it means that its runtime will increase linearly with the input size. If the input size doubles, the runtime of the algorithm will also double. If an algorithm has a big O notation of on power 2, it means that its runtime will increase quadratically with the input size. If the input size doubles, the runtime of the algorithm will increase 4 times. By analyzing the big O notation of an algorithm, we can make informed decisions about which algorithms to use in different situations. We can choose algorithms that are efficient for large inputs and avoid algorithms that have poor scaling properties. In a perfect world and operations, time and complexity would never change. This ideal world in big annotation is O1, sometimes called constant time. In many situations and operations, cost is in direct correlation to the number of elements in. In big O annotation, this is O, and sometimes called linear time. For example, let's say you have a function that needs to loop through an array of elements and perform some operation on each element. If the cost of the operation stays the same regardless of the number of elements, then the time complexity of the algorithm would be O of n, meaning the cost would increase linearly with the number of elements in the array. So, if you had an array with 10 elements and the function took 1 second to complete, and then it would take 10 seconds to complete for an array with 100 elements. And if you had an array with 1,000 elements, it would take 100 seconds to complete. However, if the cost of the operation grows exponentially with the number of elements, then the time complexity of the algorithm would be much worse, such as on power 2 or O2 power n, which would significantly impact the performance of the algorithm as the input size grows. By understanding the time and space complexity of algorithms using big O notation, developers can optimize their code and choose the most efficient algorithm for a given problem. Another scenario is the one that Java docs declared for the growth of the array list, that adding an element has constant amortized time cost. In our case, in the case of adding an element to an array list in Java, the cost of the operation is typically O of 1, which means it has a constant time complexity. However, as you mentioned, at certain intervals when the array list needs to resize its underlying array, the cost of the operation can be O of n, where n is the number of elements in the array list. But because this resizing operation happens infrequently and the cost is spread out over multiple additions, the average cost of adding an element over many operations is still O of 1. This is called amortized time complexity, where the cost of a sequence of operations is averaged out to give an average cost per operation. In the case of ArrayList, the amortized time complexity of adding an element is O of 1 star, which means that the cost is O of 1 on average, but can be O of n in rare cases when the array list needs to resize its underlying array. Let's just talk about what example the contains method, which looks for a matching element and needs to traverse through the array list to find a match. The time complexity of the contains method in an array list is O of n in the worst case, where n is the number of elements in the list. This is because we may need to traverse the entire list to find a matching element. However, in the best case scenario where the matching element is found at the very first index, the time complexity would be O of 1, since we can immediately return the result. In general, the cost of the contains method would be somewhere between O of 1 and O of n, depending on where the matching element is found in the list. It's also important to note that the time complexity of other operations on an array list, such as adding or removing an element, can vary depending on the position of the element in the list and whether or not the list needs to be resized. This is why it's important to understand the time complexity of different operations on a data structure, so that we can choose the most appropriate data structure for our needs. Now that you understand why some operations are more efficient and less costly because of indexing, it's time to look at another class called the linked list. So, the linked list is not indexed at all. There is no right storing the addresses in a neat ordered way as we saw with the array list. Instead, each element that's added to a linked list forms a chain, and the chain has links to the previous element and the next element. This architecture is called a doubly linked list, meaning an element is linked to the next element, but it's also linked to a previous element in this chain of elements. The beginning of the chain is called the head of the list, and the end is called the tail. This can also be considered a queue, In this case, a double-ended queue because we can traverse both backwards and forwards through these elements. Getting an element from the list or setting a value of element isn't just simple maths anymore with the linked list type. To find an element, we'd need to start at the head or tail and check if the element matches, or keep track of the number of elements traversed if we are matching by an index because the index isn't stored as part of the list. For example, even if you know you want to find the fifth element, you still have to traverse the chain this way to get that fifth element. Its type of retrieval is considered expensive in computer currency, which is processing time and memory usage. On the other hand, inserting and removing an element is much simpler for this type of collection. In contrast to an array list, inserting or removing an item in a linked list is just a matter of breaking two links in the chain and re-establishing two different links. Their new array needs to be created and elements don't need to be shifted into different positions. A reallocation of memory to accommodate all existing elements is never required. So for linked list, inserting and removing elements is generally considered cheap in computer currency compared to doing these functions in an array list. All of that being said, there was a lot of debate about whether a linked list is ever really a preferred solution over the array list, especially as the Java language improves in performance and computer hardware itself continues to improve. So, in a linked list, adding elements to the start or end of the list is faster than in an array list. This is because in a linked list, each element stores a reference to the next element in the list, while in an array list, all the elements are stored in contiguous memory, so adding an element requires shifting all the elements after it to make space. Similarly, removing elements from the start or end of a linked list is faster than in an array list. This is because in a linked list, removing an element just requires updating the references of the neighboring elements, while in an array list, removing an element requires shifting all the elements after it to fill the gap. However, finding a specific element in a linked list is slower than in an array list, because in a linked list, you have to traverse the list from the beginning until you find the element you are looking for, while in an array list, you can directly access any element by its index. Let's say you have a list of items that you need to keep track of, like a grocery list. You can use either an array list or a linked list to store this information. If you mostly just need to read the items on your list and don't need to change them very often, an array list might be the better choice. It's like having a book where you can easily flip to a certain page to find the information you need. However, if you need to add or remove items from your list frequently, a linked list might be better. It's like having a string of beads where you can easily add or remove beads from either end, but it's harder to find a specific bead in the middle. Also, if you know that you will have a maximum number of items on your list, it's better to use an array list and set its capacity to that number. This will make it more efficient when you are reading or changing the items on your list. On the other hand, if you don't know how many items you will have, or if it might be a very large number, a linked list might be more efficient. It can handle a larger number of items than an array list, and it's better for adding or removing items from either end. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Linked list exercise. In this lecture, we will practice some examples using linked list. For this, we write a program that demonstrates the difference between array list and linked list by comparing the time it takes to retrieve an element at a specific index in each list. The program should create an array list and a linked list with 1 million elements. Add integers from 0 to 999,999 to both lists, and then retrieve the element at index 500,000 from each list. The program should output the element retrieved from both lists and the time taken to retrieve the element in nanoseconds for each list. Before we start making this program, we first revise the architecture of linked list and array list. So, linked list is a data structure consisting of a sequence of nodes, where each node stores a value and a reference to the next node in the sequence. The architecture of a linked list is quite simple and straightforward, consisting of these key components that are nodes, head, tail, size, operations. So, nodes are the basic building blocks of a linked list are the individual nodes that make up the list. Each node contains a value and a reference to the next node in the list. Then head. So, the head of the linked list is the first node in the list. It is used as a starting point for traversing the list. Then tail. So, the tail of the linked list is the last node in the list. It is used to efficiently append new nodes to the end of the list. Then size. So, the size of the linked list refers to the number of nodes in the list. Then operations. Linked lists support several basic operations, including inserting new nodes, deleting existing nodes, and searching for nodes by value or position in the list. The architecture of a linked list is quite flexible, allowing for a wide range of variations and optimizations. For example, there are several different types of linked lists, including singly linked lists where each node has a reference to the next node, doubly linked lists where each node has references to both the next and previous nodes, and circular linked lists where the last node in the list has a reference to the first node. There are also more advanced variations of linked lists that use techniques like skip pointers or caching to improve performance in certain scenarios. On the other hand, ArrayList is a dynamic array implementation in Java that allows elements to be added and removed from the list dynamically. The ArrayList class is part of the Java Collections framework and provides methods for manipulating lists of objects. The architecture of an array list in Java is based on an underlying array that is dynamically resized as elements are added or removed from the list. The size of the array is determined by the initial capacity of the array list, which can be specified when the array list is created or left to the default value of 10. When elements are added to an array list, they are inserted into the underlying array. If the array is full, a new array is created with double the capacity of the original array, and all the elements from the original array are copied into the new array. This process of doubling the array size and copying elements is known as resizing the array. Similarly, when elements are removed from an array list, the elements after the removed element are shifted to fill the gap. If the number of removed elements is greater than a certain threshold, the underlying array is resized to a smaller size to conserve memory. Let's start creating program. For this, we first create a class file named combined example in the Nixware and consulting package, and inside this class create a main method using shortcut PSVM. Then we write array list angle brackets integer array list equals sign new array list angle brackets closing parentheses semicolon. Here we create a new instance of the array list class, which is a resizable array implementation in Java. The constructor for the ArrayList class is called with no arguments, which creates an empty array list with an initial capacity of 10 elements. The capacity of the array list is the amount of memory allocated to store the elements of the array list. As elements are added to the array list, its capacity is automatically increased to accommodate the new elements. Then write linked list angle brackets integer linked list equals sign new linked list angle brackets closing parentheses semicolon. Here we create a new instance of the linked list class, which is a doubly linked list implementation in Java. The generic type parameter integer specifies that this particular linked list will hold objects of the integer class. The constructor for the linked list class is called with no arguments, which creates an empty linked list with no elements. Unlike an array list, a linked list does not have an initial capacity, as its elements are not stored in contiguous memory locations. Instead, each element of a linked list is stored in a separate node object, which contains a reference to the next and previous nodes in the list. The reference variable linked list is assigned to point to the newly created linked list object. This allows us to access and manipulate the contents of the linked list using methods provided by the linked list class, such as add, remove, get, and set. Then we write for opening parentheses into I equals sign 0 semicolon. I less than 1 million semicolon. I plus plus closing parentheses curly braces. Here this loop is used to add 1 million elements to both an array list and a linked list for the purpose of testing their performance. The loop iterates from 0 to 999 and 999 and adds each integer value to the end of both the array list and the linked list using their respective add methods. This allows us to populate both data structures with a large number of elements so that we can compare their performance in terms of element retrieval time. Then we write ArrayList.add parentheses I semicolon. LinkedList.add parentheses I semicolon. Here these two add methods used to add elements to the end of an array list and a linked list, respectively. In the given code, the loop iterates from 0 to 999,999, and for each iteration, it adds the current integer value to the end of both the array list and linked list using these methods. For an array list, the add method inserts an element at the end of the list and increases the size of the array list by 1. If the array list has to be resized, it creates a new array of double the size of the current array and copies all the elements from the current array to the new array. For a linked list, the add method inserts an element at the end of the list by creating a new node object and setting it as the next node of the last node in the list. This does not require any resizing of the data structure, but it requires more memory allocation and deallocation compared to an array list. Then right outside of the loop long start time equals sign system dot nanotime parentheses semicolon. Here system.nanotime is a method in Java that returns the current value of the running Java virtual machine's high-resolution time source in nanoseconds. It is often used for measuring elapsed time with very high precision. So, this line is used to capture the current time in nanoseconds before retrieving an element from the array list. This time is then stored in the start time variable, which is later used to calculate the elapsed time taken to retrieve the element from the data structure. By capturing the start time using system.nanotime, the code can accurately measure the time taken to perform a specific operation, regardless of other factors that may affect the system time, such as other running processes or system load. This provides a more accurate measurement of the performance of the data structures being compared. Then write-int element al equals sign array list dot get parentheses 500,000 semicolon. Here the get method is used to retrieve the element at index 500,000 from array list. The retrieved element is then stored in the element al variable, which is later printed to the console. Then write long end time equals sign system dot nanotime parentheses semicolon. Here system.nanotime is called twice, once before and once after retrieving the element from the array list. This is done to calculate the time taken to retrieve the element from each data structure. Then write long duration al equals sign end time minus start time semicolon. Here the duration al variable is assigned the difference between the end time and start time variables. Subtracting start time from end time gives the elapsed time in nanoseconds between these 2 points in the program. In this specific code, this difference represents the amount of time taken to retrieve an element from the array list. So, duration al stores the time taken to retrieve the element from the array list in nanoseconds, which is calculated by subtracting the start time from the end time. Then we write start time equals sign system dot nanotime parentheses semicolon. Int element ll equals sign linked list dot get parentheses 500,000 semicolon. End time equals sign system dot nanotime parentheses semicolon. Long duration ll equals sign end time minus start time semicolon. So, here we retrieves the element at index 500,000 from the linked list and measures the time taken to perform this operation using the system.nanotime method. So, first start time is initialized as the current time in nanoseconds. Then element ll is assigned the value retrieved from index 500,000 of the linked list using the get method. Then end time is set to the current time in nanoseconds. Then the difference between end time and start time is calculated and assigned to duration ll as the time taken to retrieve the element from the linked list. Then we write systemout.println opening parentheses double quote element retrieved from array list plus element al closing parentheses semicolon. Systemout.println opening parentheses double quote element retrieved from linked list plus element ll closing parentheses semicolon. Here these 2 lines of code are printing the value of the elements that were retrieved from the array list and linked list in the previous lines of code. It is simply outputting the value of the element at the specified index in each list. For example, if the element at index 500,000 of the array list is 500,000 and the element at index 500,000 of the linked list is 500,000, then the output will be element retrieved from array list, 500,000 element retrieved from linked list, 500,000. Note that the actual value will depend on the contents of the lists, which were populated with numbers from 0 to 999 in the previous loop. Then write systemout.println opening parentheses double quote time taken by array list plus duration L plus double quote nanoseconds closing parentheses semicolon. Systemout.println opening parentheses double quote time taken by linked list plus duration LL plus double quote nanoseconds closing parentheses semicolon. Here these two lines of code print the time taken to retrieve an element from the array list and the linked list respectively. The time taken is measured in nanoseconds and is calculated using the difference between the start time and end time of the respective operations. The output of these lines of code is important because it shows the relative performance of the array list and linked list data structures for a particular operation, in this case retrieving an element at a particular index. If the time taken by the array list is much less than the time taken by the linked list, then the array list is likely to be a more efficient data structure for this particular use case. Conversely, if the time taken by the linked list is much less than the time taken by the array list, then the linked list may be more efficient. Now we run it. Here is the output. So, the first two lines indicate that both array list and linked list were able to successfully retrieve the element at index 500,000. The next two lines show the time taken by each data structure to perform the retrieval operation. Array list took 175,000 nanoseconds or 0.0175 milliseconds, while linked list took 13,008,000 nanoseconds or 13.008 milliseconds. This means that array list is much faster than linked list in this case. This is because array list uses an array to store the elements, which allows for fast random access. On the other hand, linked list uses a linked list of nodes, which requires iterating through the list from the beginning until the desired element is found, resulting in slower performance for random access. Now we show where the linked list performs better. For this, we will remove the first element from both array list and linked list. Here we replace int element al equals sign array list dot get line with array list dot remove parentheses 0 semicolon, and also replace int element ll equals sign linked list dot get line with linked list dot remove parentheses 0 semicolon. So here we remove the first element from array list and linked list, that is the element at index 0. In an array list, removing the first element requires shifting all subsequent elements to the left by one index to fill the gap left by the removed element. This can be an expensive operation if the list is large because shifting elements requires copying each element to a new index. The time complexity of removing the first element from an array list is on, where n is the size of the list. In a linked list, removing the first element is much faster. The linked list class internally maintains a reference to the first node in the list, called the head, so removing the first element simply involves updating the head reference to point to the next node. This operation takes constant time, O1, regardless of the size of the list. Then remove these two print method lines. Now we run it. Here is the output that is time taken by array list is 254,179,000 nanoseconds and time taken by linked list is 373,000 nanoseconds. This is because, as we previously said, that here array list needs to shift all the elements to fill the gap left by the removed element. It takes more time than linked list, which only needs to update the pointers of the first node to remove it. Therefore, in this scenario, linked list is faster than array list. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to queue and stack in linked list. In this lecture, we will see an introduction to queue and stack in linked list. So, we've just talked a lot about how the linked list and the array list are different under the covers, and an array list is implemented on type of an array. But a linked list is a doubly linked list. Both implement all of list's methods, but the linked list also implements the queue and stack methods as well. When you think of a queue, you might think of standing in line. When you get in a line or a queue, you expect that you'll be processed in relationship to the first person in line. We call this a first in, first out, or FIFO data collection. If you want to remove an item, you pull the queue, getting the first element or person in the line. If you want to add an item, you offer it onto the queue, sending it to the back of the line. Single-ended queues always process elements from the start of the queue. A double-ended queue allows access to both the start and end of the queue. A linked list can be used as a double-ended queue. In a queue implemented using a linked list, enqueue and dequeue are operations that allow you to add an element to the end of the queue and remove an element from the front of the queue, respectively. So, enqueue is used to add an element to the end of the queue. You need to create a new node with the element's value and set the next pointer of the last node in the list to point to the new node. If the queue is empty, the new node becomes the first node in the list. While dequeue is used to remove an element from the front of the queue, you need to update the head pointer to point to the next node in the list, and return the value of the node that was removed. If the queue is empty, return an error message. So, there are several advantages of implementing a queue as a linked list in Java, like dynamic size. A linked list implementation allows for a dynamic size queue, meaning that we can add or remove elements as needed without any limit on the size of the queue. Efficient enqueue and dequeue. Enqueue and dequeue operations can be done efficiently in O1 time with a linked list implementation. This is because we only need to modify the front and rear pointers of the linked list when adding or removing elements. Memory efficiency. A linked list implementation of a queue only uses memory proportional to the number of elements in the queue, making it memory efficient compared to other data structures like arrays. Flexibility. The java.util.linkedList class provides a flexible implementation of a linked list, allowing for easy modification and extension of the queue implementation. For example, we can easily modify the implementation to add additional methods or change the data type of the elements. Built-in implementation. Using the linked list class provides a built-in implementation of a doubly linked list, which saves time and effort compared to implementing the linked list from scratch. The linked list class also provides additional functionality like iterators and the ability to add or remove elements from anywhere in the list. We will discuss iterators in upcoming lectures. Now we will talk about stack. A stack is a last-in first-out LIFO data structure, where elements are added and removed from the top of the stack. We can visualize a stack as a vertical pile of elements, one on top of another, where the last element added is at the top of the stack. When we add a new element to the stack, it is added on top of the current top element, and when we remove an element from the stack, we remove the topmost element. You will notice that we use the word remove and not use the word get from stack. Why do we use the word remove? Because in the context of a stack data structure, we typically use the term pop or remove instead of get to emphasize that the operation is removing an element from the top of the stack and not just retrieving it. This is because a stack is a last-in first-out LIFO data structure, which means that the last element added to the stack is the first one to be removed. When we call the pop or remove method on a stack, we are removing the most recently added element from the top of the stack. In contrast, the term get implies that we are simply retrieving an element from the stack without modifying its contents. This could be confusing when working with a stack, as the order of elements is important, and we need to keep track of the most recently added element. So, while it is technically possible to use the term get instead of pop or remove when retrieving an element from a stack, it is more common to use the latter terms to avoid confusion and to emphasize the LIFO nature of the stack data structure. A linked list can also be used as a stack as well. There are several advantages to implementing a stack as a linked list, like dynamic size. A linked list implementation allows for a dynamic size stack, meaning that we can add or remove elements as needed without any limit on the size of the stack. Efficient push and pop. Push and pop operations can be done efficiently in O1 time with a linked list implementation. This is because we only need to modify the head pointer of the linked list when adding or removing elements. Memory efficiency. A linked list implementation of a stack only uses memory proportional to the number of elements in the stack, making it memory efficient compared to other data structures like arrays. Flexibility. The java.util.linkedList class provides a flexible implementation of a linked list, allowing for easy modification and extension of the stack implementation. For example, we can easily modify the implementation to add additional methods or change the data type of the elements. Built-in implementation. Using the linked list class provides a built-in implementation of a singly linked list, which saves time and effort compared to implementing the linked list from scratch. The linked list class also provides additional functionality like iterators and the ability to add or remove elements from anywhere in the list. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Queue and stack exercise. In this lecture, we will practice some examples of using queue and stack in linked list. Now we start with simple program. So, we write a Java program that implements a queue using a linked list. The program should define a queue class with these methods. enqueue method adds the given value to the back of the queue. dequeue method removes and returns the value at the front of the queue. If the queue is empty, prints queue is empty and returns -1. In the main method, create a queue object and add 3 values to it, 1, 2, and 3 using the enqueue method. Then, call dequeue method 4 times and print the returned values. Make sure to handle the case where the queue is empty. Let's start creating program. For this, we first create a class file named queue in the nixware and consulting package. Then we write private linked list angle brackets integer list semicolon. Here we create a private instance variable of the queue class, which is a reference to a linked list that stores integer values. Then write public queue parentheses curly braces. List is equal to new linked list angle brackets integer parentheses semicolon. Here we create a constructor of the queue class. In this constructor, a new instance of the linked list class is created and assigned to the list instance variable. This initializes the linked list so that it is ready to store integer values. By creating a new linked list in the constructor, the queue object is guaranteed to have an empty list to start with, which is the expected initial state of a new queue. This also ensures that each queue object has its own separate linked list, rather than sharing a single list with other queue objects. Then write public void enqueue parentheses int value curly braces. List.add last parentheses value semicolon. Here we create a method enqueue with a parameter value. The purpose of this method is to add a new element to the back of the queue, using the linked list method addLast. When a new element is added to the queue using enqueue, it is inserted at the end of the linked list, which becomes the new rear of the queue. This ensures that elements are added to the queue in the order they were inserted, and that the first element to be removed from the queue is always the oldest element. The enqueue method takes an integer parameter value, which is the element to be added to the queue. This value is added to the back of the linked list using the addLast method, which adds the element as the last node in the list. By adding elements to the back of the linked list, the queue class maintains the FIFO that is first in, first out property of a queue, ensuring that elements are removed in the same order they were added. Then write public int dequeue parentheses curly braces. If opening parentheses list dot is empty parentheses closing parentheses curly braces. Systemout.println opening parentheses double quote queue is empty closing parentheses semicolon. Return -1 semicolon. Then write else curly braces. Return list.remove first parentheses semicolon. Here we create dequeue method. The purpose of dequeue method is to remove and return the first element from the front of the queue. So, the method first checks if the queue is empty by using the isEmpty method of the linked list. If the list is empty, the method prints a message to the console indicating that the queue is empty and returns -1 as an error code. If the queue is not empty, the method removes and returns the first element from the front of the linked list using removeFirst method. This removes the first node in the linked list, which represents the oldest element in the queue, and returns the integer value stored in that node. By removing elements from the front of the linked list, the queue class maintains the FIFO that is first in, first out property of a queue, ensuring that elements are removed in the same order they were added. Then dequeue method returns the integer value of the removed element to the caller, allowing the caller to use or process the value as needed. Now we create another class named main class in same file and create a main method using shortcut psvm. Now we write QQ is equal to new queue parentheses semicolon. Here we create a new instance of the queue class and assigns it to a variable called queue. This statement calls the default constructor of the queue class, which initializes a new instance of the linked list class and assigns it to the list field of the queue object. This creates a new empty queue. So, the Q variable now refers to the newly created Q object and can be used to call the methods of the Q class to add or remove elements from the Q. Then write q.nq parentheses 1 semicolon, q.nq parentheses 2 semicolon, q.nq parentheses 3 semicolon. Here these three statements are used to add new elements to the Q by calling the nq method of the Q class. Here the nq method takes an integer value as its parameter and adds the value to the back of the Q. In this case, the values 1, 2, and 3 are added to the back of the Q in that order. So the Q now contains 3 elements, 1 at the front, 2 in the middle, and 3 at the back. Here by calling the nq method multiple times with different values, the Q object is populated with a sequence of elements that can be removed from the front of the Q using the deq method in the same order they were added. Then we write systemout.println opening parentheses q.deq parentheses closing parentheses semicolon. Here we removes and returns the first element from the Q by calling the deq method of the Q class, and prints the returned value to the console using the print method of the system class. So, the deq method removes and returns the first element of the Q, or -1 if the Q is empty. In this case, the first element of the Q is 1, so q.deq returns 1, and this value is printed to the console by the print method. After the first deq call, the Q now contains 2 elements, 2 at the front and 3 at the back. Now we write this same line 3 more times. Now here deq is called total 4 times consecutively. We already discussed first call. Now start with second call or second line of code. In the second call to q.deq method will remove and return the next element of the Q, which is 2, and print it to the console. In the third call to q.deq will remove and return the next element of the Q, which is 3, and print it to the console. The fourth call to q.deq will try to remove an element from an empty Q, since all the elements have been deq'd in the previous calls. In this case, the deq method will print Q is empty to the console and return -1. This will be printed to the console by the print statement. Now we run it. Here is the output. So, the first 3 lines of output show the elements that were deq'd from the Q in order 1, 2, and 3. On the fourth call to deq, the Q is empty, so the deq method prints Q is empty to the console and returns -1. That is why the last line of output is -1. Now we will use same example and same code to understand the concept of stack. Let's start creating program. For this, we first create a class file named stack in the Nixware and consulting package. Now we copy all the code in the Q class and paste it in the stack class. First we change the name of constructor from Q to stack, because it's a stack class constructor. Remember that Q data structure is first in and first out in short FIFO. But stack used the data structure last in, first out in short LIFO. So, in Q, the first element added is the first one to be removed. While in a stack, the last element added is the first one to be removed. This is why the Q class implemented the remove first method, while the stack class implemented the remove last method. Similarly, the nq method is used to add elements to a Q, while the push method is used to add elements to a stack, and deq method is used to remove elements from a Q, while the pop method is used to remove elements from a stack. So, we replace the method name nq with push and deq replace with pop. And in the pop method, replace remove first method with remove last method. And also change to string from Q to stack here. Now we create another class named main class and create a main method inside this class. Then we write stack is equal to new stack parentheses semicolon. Here we creates a new instance of the stack class and assigns it to the variable stack. So, the stack class is a custom implementation of a stack data structure, which uses a linked list to store the elements. By calling the constructor, a new instance of the stack class is created, which initializes an empty linked list to store the elements. Then we write for opening parentheses int I is equal to 1 semicolon, I less than equals to 3 semicolon, I plus plus closing parentheses curly braces. Stack.push opening parentheses I multiply by 10 closing parentheses semicolon. Here we are using a loop to insert 3 values into the stack. The loop starts with I initialized to 1, and it continues while I is less than or equal to 3. During each iteration of the loop, the code multiplies I by 10, and the resulting value is pushed onto the top of the stack using the push methods. So, the first iteration pushes the value 10 onto the stack, the second iteration pushes the value 20 onto the stack, and the third iteration pushes the value 30 onto the stack. After this loop completes, the stack will contain the values 10, 20, and 30 in that order, with 30 at the top of the stack. Then write for opening parentheses int I is equal to 1 semicolon, I less than equals to 4 semicolon, I plus plus closing parentheses curly braces. Systemout.println opening parentheses stack.pop parentheses closing parentheses semicolon. Here we pop or remove and return the top elements from the stack in last in, first out order, 4 times. Since the stack was initialized with 3 elements using the push method in the previous code, the first 3 pop operations will remove and return the values 30, 20, and 10 respectively, which were added to the stack in that order. The fourth pop operation will try to remove an element from an empty stack, since there is no fourth element in the stack. This will trigger the else statement in the pop method, which prints stack is empty and returns -1. Therefore, the fourth print statement will output -1 to the console. Now we run it. Here is the output. So, the output shows that the 3 elements 30, 20, and 10 were pushed onto the stack using a loop, and then the 4 elements were popped from the stack using another loop. The first 3 pops return the values 30, 20, and 10, which were the last 3 elements pushed onto the stack, while the fourth pop returns -1 with the message stack is empty since there were no more elements left in the stack after the first 3 pops. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to iterators. In this lecture, we will see an introduction to iterators. Let's talk about the iterator. So what's an iterator? So far we've mainly used for loops to traverse or step through elements in an array or list. We can use the traditional for loop and an index to index into a list. We can use the enhanced for loop and a collection to step through the elements one at a time. But Java provides other means to traverse lists. 2 alternatives are the iterator and the list iterator. For example, imagine that you're browsing through a bookshelf at a library, and you want to go through all the books in the shelf one by one. You start at the beginning of the shelf and pick up the first book. As you finish reading it, you move on to the next book, and so on, until you reach the end of the shelf. In this example, you are essentially using a cursor to traverse the books on the shelf, similar to how an iterator works in programming. The current book you're reading is like the current element pointed to by the iterator, and you move forward through the shelf by picking up the next book, just like how an iterator moves to the next element in the collection. The bookshelf itself is like the collection being traversed by the iterator. The iterator is pretty simple. When you get an instance of an iterator, you can call the next method to get the next element in the list. So, the next method of an iterator returns the next element in the collection that the iterator is pointing to, and moves the iterator's position to the next element in the collection. If there are no more elements to return, calling next will throw an exception to let you know that there are no more elements to retrieve. In other words, next allows you to iterate through all the elements in a collection one by one and access them in sequence. Each time you call next, the iterator moves to the next element in the collection and return it. You can also use his next method to check if any elements remain to be processed. So, the hasNext method of an iterator returns a Boolean value indicating whether there are more elements in the collection that the iterator is pointing to. If there are more elements to be retrieved, hasNext returns true. Otherwise, it returns false. In other words, hasNext lets you check whether there are more elements in the collection to be processed by the iterator. If there are more elements, you can continue to call next to retrieve and process them. If hasNext returns false, you know that there are no more elements left in the collection to process, and you can exit the loop or function that is iterating over the collection. So, you can see this code, and this code creates an array list of string objects called mylist, and adds 3 strings that are apple, banana, and orange to it using the add method. The code then creates an iterator object using the iterator method of the mylist object. The iterator method returns an iterator object that can be used to iterate over the elements in the list. The code then enters a while loop that iterates over the elements in the list using hasNext and next methods of the iterator object. The hasNext method returns true if there are more elements in the list, and the next method returns the next element in the list. For each iteration of the loop, the code retrieves the next element from the list using the next method of the iterator and stores it in a string variable called element. The code then prints the value of element to the console using the println method. When there are no more elements in the list, the hasNext method will return false and the loop will terminate. So, the output of the program like this. So, to output the contents of an array list to the console, we can use an iterator. However, this work is also done in order to provide the println method with the ArrayList Why do we use iterators? Because the main difference is that println simply prints the entire collection to the console as a string, while an iterator allows you to iterate over each element of the collection and perform operations on them one at a time. Take a loop on advantages of iterator in Java. So, these are: allows for safe removal. The iterator interface provides a remove method that allows elements to be safely removed from the collection during iteration. This is not possible when using a for loop or other methods of traversing a collection. Supports multiple operations. An iterator allows you to perform multiple operations on a collection, such as adding or removing elements, while iterating over it. This is not possible when using a for loop or other methods of traversing a collection. Supports different types of collections. The iterator interface can be used to iterate over different types of collections, such as ArrayList and LinkedList among others. This makes the code more flexible and easier to maintain. Enables efficient iteration. The iterator interface allows for efficient iteration over large collections by using lazy evaluation. Elements are only retrieved from the collection when the next method is called, which can improve performance. Provides uniform interface. The iterator interface provides a uniform way of iterating over different types of collections, making it easier to write generic code that works with multiple types of collections. There are also some limitations to using iteration in Java. Some of them are like limited functionality. The iterator interface provides only basic functionality for iterating over a collection. It does not allow modification of the underlying collection during iteration. If you need to modify the collection, you have to use the appropriate methods provided by the collection itself. Performance overhead. Iterators can have a performance overhead compared to other methods of iterating over a collection, such as a for loop. This is because each call to the iterators has next and next methods involves additional function calls and object allocation. Non-concurrent modification. If the underlying collection is modified while an iterator is in use, it can cause a concurrent modification exception. To avoid this, you should either use a concurrent collection or synchronize access to the collection. Not suitable for all collections. The iterator interface is not suitable for all types of collections. For example, it does not work with arrays, which have their own iteration syntax. Code complexity. The use of an iterator can increase the complexity of your code, particularly if you need to perform complex operations on the elements of the collection during iteration. In such cases, it may be easier to use a for loop or other construct. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Linked list and iterators exercise. In this lecture, we will practice to see some examples using linked list and iterators. For this, we write a program that manages an itinerary of fruits to visit using a linked list. The program should include methods to add more fruits to the itinerary, remove fruits from the itinerary, get information about the fruits in the itinerary, and print the itinerary. The program should also demonstrate the use of both queue and stack methods for adding and removing fruits from the linked list. Finally, the program should include a method to print the itinerary with information about the starting and ending points of the trip, as well as the fruits to visit in between. Let's start creating program. For this, we first create a class file named Fruit Itinerary Manager in the Nixware and Consulting package and create a main method inside this class using shortcut PSVM. Now we write var fruits to visit is equal to new linked list angle brackets string parentheses semicolon. Here we declares and initializes a variable named fruits to visit using the var keyword, which means that the type of the variable will be inferred by the compiler based on the type of the expression used to initialize it. The expression used to initialize the variable is new linked list angle brackets string parentheses, which creates a new instance of the linked list class that can hold objects of type string. So, the variable fruits to visit will be of type linked list string, which means it can hold a sequence of strings. It will initially be empty because no elements are added to it yet. This statement is more concise and requires less typing as compared to traditional way of declaring linked list object. It can make the code easier to read and less error-prone, especially when the type name is long or complex. However, it can also make the code less explicit and harder to understand, especially for beginners who are not familiar with the concept of type inference. Then write fruits to visit dot add parentheses double quote apple semicolon. Fruits to visit dot add parentheses 0 comma double quote banana semicolon. System out dot print ln opening parentheses fruits to visit closing parentheses semicolon. So, here we add elements to the linked list object named fruits to visit, and then print the contents of the list to the console. The first line adds the string apple to the end of the list. The linked list is initially empty, so this is the first element added to the list. The second line adds the string banana to the beginning of the list at index 0. This shifts the previously added element apple to index 1. After executing these two lines, the list contains two elements, banana at index 0 and apple at index 1. The third line prints the contents of the list to the console. Then we create another method named addMoreFruits by writing private static void addMoreFruits opening parentheses linked list angle brackets string list closing parentheses curly braces. So, the purpose of this method is to add more fruits to the linked list object passed as a parameter. Then write list.add first parentheses double quote pineapple semicolon. List.last first parentheses double quote mango semicolon. Here add first method adds the element pineapple to the beginning of the linked list. This method inserts the specified element at the beginning of the list, pushing all the other elements one position to the right. On the other hand, add last method adds the element mango to the end of the linked list. This method inserts the specified element at the end of the list, after the last existing element. The addLast method is equivalent to the offerLast method, which adds an element to the end of the list and returns true if the operation was successful. Now go into the main method and write addMoreFruits parentheses fruits to visit semicolon. Systemout.println opening parentheses fruits to visit closing parentheses semicolon. So, after adding the elements banana and apple to the fruits to visit list using the add method, the addMoreFruits method is called with fruits to visit as an argument. After calling addMoreFruits method, the fruits to visit list will contain all the elements added in the main method as well as the new elements added in the addMoreFruits method. Therefore, when we print the contents of the fruits to visit list using print method, we will see all the fruits in the list, including the ones added in addMoreFruits. Now we run it. Here is the output. Here the first line is the output after adding the elements banana and apple to the fruits to visit list using the add method in the main method, and the second line is the output after calling the addMoreFruits method with fruits to visit list as an argument. Inside addMoreFruits method, we add more fruits to the linked list using methods like addFirst, addLast. So, in the fruits to visit list in the order they were added, with pineapple added to the beginning of the list using addFirst, mango added to the end of the list using addLast. Go back into the addMoreFruits method and write list.offer parentheses double quote orange semicolon. Here we use offer method is used to add an element to the end of a linked list. It works in a similar way as addLast. However, the difference is that offer returns a Boolean value, which is true if the element is successfully added to the list and false otherwise. Now run it again. Now you can see orange added in the last of the list. Then we write list.offer first parentheses double quote papaya semicolon. List.offer last parentheses double quote kiwi semicolon. So, the offer first method is used to add an element to the beginning of a linked list. It works in a similar way as add first. However, The difference is that offer first returns a Boolean value, which is true if the element is successfully added to the list and false otherwise. The offer last method is used to add an element to the end of a linked list. It works in a similar way as add last. However, the difference is that offer last returns a Boolean value, which is true if the element is successfully added to the list and false otherwise. Then write list.push parentheses double quote grapes semicolon. Here we add the element grapes to the beginning of the linked list, effectively making it the first element. This operation is a part of the stack methods available to a linked list, treating it as a stack data structure. The push method is equivalent to add first method of the linked list, which adds the element to the front of the list. Now we run it. Here you can see the output. So, in the output list.push method adds grapes to the front of the list. List.offer first method adds papaya to the front of the list, after grapes. List.add first method adds pineapple to the front of the list, before grapes. List.add method adds banana to the end of the list. List.add method adds apple to the end of the list. List.add last method adds mango to the end of the list, after apple. List.offer method adds orange to the end of the list, after mango. List.offer last method adds kiwi to the end of the list, after orange. Now we create another method named remove fruits by writing private static void remove fruits opening parentheses linked list angle brackets string list closing parentheses semicolon. Here the remove fruits method is defined to remove elements from the given linked list. Then we write list.remove parentheses 4 semicolon. List.remove parentheses double quote papaya semicolon. In the first line we remove the element at index 4 that is fifth element from the linked list. In the second line we remove the first occurrence of the string papaya from the linked list. Now we go into the main method and write remove fruits parentheses fruits to visit semicolon. Systemout.println opening parentheses fruits to visit closing parentheses semicolon. Here the remove fruits method is called, which removes the fruit papaya using the remove method with the object parameter and the fruit at index 4 using the remove method with the index parameter. The linked list is printed again to show the modified list. Now we run it. Here is the output. So, in the third list output, apple is not present because it was removed in the remove fruits method call, where the element at index 4 was removed, which was apple in the original list. Papaya is also not present because it was removed using the remove method call, which removes the first occurrence of the element papaya in the list. Therefore, in the second list output, only the remaining fruits are printed after the removal operations. Now we go again in the remove fruits method and write systemout.println opening parentheses list semicolon. String s1 is equal to list.remove parentheses semicolon. Systemout.println opening parentheses s1 plus double quote was removed closing parentheses semicolon. Here we first prints out the contents of the linked list using print method. Then, it calls the remove method on the linked list. This method removes and returns the first element in the list. The element that was removed is stored in the string variable s1. After that, the code prints out a message to indicate which element was removed using print method. Now we run it. Here it confirmed that grapes was removed from the list, which was the first item in our list. Now we copy and paste these 3 lines and change s1 with s2 in both places and use the method remove first method and run it. Here it confirmed that pineapple was removed from the list, which became the first item in our list after removal of grapes. Now we copy and paste these 2 lines and change s2 with s3 in both places and use the method remove last method and run it. Here it confirmed that kiwi was removed from the list, which was the last item in our list. Now we write string p1 is equal to list.poll parentheses semicolon. Systemout.println opening parentheses p1 plus double quote was removed closing parentheses semicolon. Here the poll method in the queue is used to retrieve and remove the head of the queue, or return null if the queue is empty. When applied to a linked list, the poll method removes and returns the first element of the list. In the given code, list.poll is used to remove and retrieve the first element of the list and assign it to the p1 variable. Then the string was removed is concatenated to the p1 value and printed to the console. Now we copy and paste these two lines and change p1 with p2 in both places and use the poll first method. Then again copy and paste these two lines and change p2 with p3 in both places and use the poll last method. So here the statement p2 removes and returns the first element of the list and stores it in the variable p2. Then prints the value of p2 along with the message was removed. Similarly, the statement p3 removes and returns the last element of the list and stores it in the variable p3. Then prints the value of p3 along with the message was removed. Now we run it. So, it shows banana was removed, mango was removed, and orange was removed, and in the last, it shows the list empty. Now let's set a couple of elements back to our list before we test one more method. Let's use the push method here. Another stack method that pushes the item to the top of the stack, the start of the list. For this we write list.push parentheses double quote apple semicolon. List.push parentheses double quote papaya semicolon. List.push parentheses double quote banana semicolon. Systemout.println opening parentheses list closing parentheses semicolon. So, here we create a new linked list of strings and adds 3 elements to it, using the push method of the linked list class. The push method is a method inherited from the deck interface, and adds an element to the head of the list that is the first element. So, the first element added is banana, followed by papaya, and then apple. Then prints the contents of the list. We will test the stack method for removing an element, which is the pop method. I remove the first element and assign it to p4. Then I will print it out. So let's run this code. And we can confirm banana gets removed using the pop method. Using the push methods, there was the last element in, and with pop it was the first element out. Now we create another method named gettingFruits by writing private static void gettingFruits opening parentheses linked list angle brackets string list closing parentheses curly braces. Systemout.println opening parentheses double quote retrieved fruit is equal to plus list.get parentheses 4 closing parentheses semicolon. This method simply retrieves the 5th element in the list and prints that out. Let's have a call to this method in the main method. First of all, comment out the call to the remove elements method. Then, we write gettingFruits parentheses fruits to visit semicolon. Now we run this. We can see we retrieved the element at index 4 or the 5th fruit in our list, apple. I've said this is a method on both array list and linked list. However, on the array list, the bigger annotation is one of its worst, whereas for linked list, the worst cases are in. It's actually not as bad as that on a linked list. Since it's a double-ended queue, Java will decide where to start searching. The retriever will start moving from one link to the next, either from the start or the end of the list, whichever is closer to the specified index. So it would never traverse the entire number of elements. In addition to the get method, the linked list has the get first and gets last methods. I will print out the first and last elements. You can get first and get last. We were calling each method and printing the result in the system .out.println statement. No, we run it. We get grapes from the getFirst method and kiwi from the getLast method. We can also use the methods index of and last index of to see if an element is in a list as we did with the array list. First I will print the index of pineapple. And do the same thing for orange. The big O notation is the same for these methods as it is for the array list. The worst case is I went for both if the element retrieved is the element at the last position to be checked. Running this code tells us the positions of these towns in our list. So pineapple is at position 2 and orange is at position 6. As you would expect, linked list has additional methods for retrieving an element. The first is appropriately named element, which is a queue method. Now print out the element returned by the method. This method takes no arguments. So what element does it return? Remember I have said it's a queue method, and a queue is first in first out. So this should indicate that element gets the first item out of the list. Running this. We can confirm that because we get grapes. Now let's set the stack retrieval methods, which are peek and similar methods like peek first and peek last. And print out the result of calling peek. So for this, we write systemout.println opening parentheses double quote element from peak parentheses is equal to plus list.peak parentheses closing parentheses semicolon. Systemout.println opening parentheses double quote element from peak first parentheses is equal to plus list.peak first parentheses closing parentheses semicolon. Systemout.println opening parentheses double quote element from peak last parentheses is equal to plus list.peak last parentheses closing parentheses semicolon. Running that, we can see that peak and peak first get the first element of the list grapes and peak last gets the last element to kiwi. So, we have covered quite a few ways to add, remove, and get elements from this linked list. Now let's switch keys and talk about traversing and manipulating the elements in the list. First, let's use a simple for loop. We will say this list of fruits is our itinerary, and we plan to travel to each list in the order we have defined here. I will call the method printItinerary and pass it a linked list of string. So, we create another method named printItinerary by writing public static void print itinerary opening parentheses linked list angle brackets string list closing parentheses curly braces. Systemout.println opening parentheses double quote starts eating plus list dot get first parentheses closing parentheses semicolon. Systemout.println opening parentheses double quote ends eating plus list dot get last parentheses closing parentheses semicolon. This method uses the get first and gets last methods to print out the starting and ending of eating our fruits. Now go into the main method first comment this calling method, then call this method. So, running this code, we should see our list of fruits and then that the starts eating from grapes and ends at kiwi. Now let's include a loop to print the fruits in between. So, for this, we write for opening parentheses int I is equal to 1 semicolon. I list dot size parentheses semicolon. I plus plus closing parentheses curly braces. Systemout.println opening parentheses double quote arrow from plus list dot get parentheses I minus 1 plus double quote to plus list dot get parentheses I closing parentheses semicolon. So, this for loop in the print itinerary method is used to iterate through the linked list and print out the fruits in the itinerary. The loop starts at index 1 and ends at list.size minus 1, which means it skips the first element that is which was already printed as the starting point. Inside the loop, it prints out from and to eating fruits using the get method to access the fruits at the current and previous index. In simple words, the loop prints out the transitions between each pair of adjacent fruits in the list. Let's try another method, this time using the for each loop. I'm going to copy and paste this method, renaming it to printItinerary2. And I'm going to remove the code for the traditional for loop, now that the enhanced for loop. For this, we remove for loop and write string previous fruit is equal to list.get first parentheses semicolon. For opening parentheses string fruit colon list closing parentheses curly braces. Systemout.println opening parentheses double quote arrow from plus previous fruit plus double quote to plus fruit closing parentheses semicolon. Previous fruit is equal to fruit semicolon. So, the printItinerary2 method prints out the eating itinerary in the order of the fruits to be eaten, similar to the printItinerary method. However, instead of using the get method to access each fruit in the list, it uses a for each loop to iterate over the list of fruits. During each iteration of the loop, the method prints out a message indicating the path from the previous fruit to the current fruit. It keeps track of the previous fruit using the previous fruit variable, which is initialized to the first fruit in the list. At the end of each iteration, the current fruit is set as the new previous fruit for the next iteration. Finally, the method prints out a message indicating the end of the eating itinerary, which is the last fruit in the list. Remember that an iterator is not used explicitly in the code. The enhanced for loop is performing the same task of iterating over the elements of the linked list. Now in the main method, instead of printItinerary, I will make that printItinerary2. So this is a bit more efficient, but it also prints out from grapes to grapes on that second line. Using the slip limits us to looping through the elements one at a time, from the very first to the last. The traditional for loop is much more flexible if we don't want to loop through every element one at a time. But now let's look at another way to do this without using either of the for loops. So now time comes to use iterator. So I will copy and paste this method print itinerary2 and rename it to print itinerary3. Now we remove for each loop and write list iterator angle brackets, string iterator equals list.list iterator parentheses semicolon. While opening parentheses, iterator dot has next parentheses, closing parentheses curly braces. Var fruits equals iterator dot next parentheses semicolon. Here I have made 3 changes. I have set up a local variable with a type of list iterator with type string. And I have named iterator and assigned it to a method on linked list iterator. After this, I changed the for loop to a while loop. And we're using a method on list iterator to call hasNext method, which will return true if there are more elements to process. After this, we have a local loop variable, which we're calling fruit again. And we're setting this to the result of another method on the list iterator called next. Now go into the main method, and instead of calling print itinerary2, I will call print itinerary3. When I run this code, we get the same output as before, including the problematic first line that we don't really want. Let's make one change to this print itinerary3 method. When we make that call to the method list iterator on the linked list, we will call an overloaded version, passing the index of the first element we want to process, and we will run this again. And you will notice that we don't have that problematic first line, because this particular method gets an iterator that is not set before the first element, but is set before the second element in between index 0 and 1. I hope you learned something useful in this lecture as well, and I will see you in the next one. Introduction to Autoboxing and Unboxing. In this lecture, we will see an introduction to autoboxing and unboxing. In this lecture, we will revisit the topic of primitive data types and their wrapper classes in Java, which we have previously discussed in the context of Java's support for collections such as lists and arrays. While some object-oriented languages do not have support for primitive data types, meaning that everything is an object, most of the popular object-oriented languages, including Java, support both primitive types and objects. Primitive types usually represent the way data is stored in an operating system, and they offer certain advantages over objects, particularly as the number of elements or magnitude increases. Object-oriented languages often choose to provide support for primitive types in addition to objects, because as the number of elements or magnitude increases, primitives offer more efficient memory usage and processing. While objects may take up additional memory, we can still create objects with primitive data types as field types and return primitive types from methods. As a result, we can easily mix and match primitives with objects in Java. Despite the ability to mix and match primitives with objects in Java, classes such as ArrayList and LinkedList do not support primitive data types as the collection type. To clarify, it is not possible to create a linked list using a primitive type, as it is not supported by classes such as LinkedList and ArrayList. As a result, we are unable to utilize the numerous functions that these classes offer when working with primitive values. This limitation is particularly significant as it prevents us from using primitives with features that we will be learning about in the future, such as generics. Java provides convenient classes for each primitive type, and we can easily convert between a primitive type and its corresponding wrapper class, a process called boxing or unboxing, respectively. In Java, a primitive data type can be boxed or wrapped within a containing class, where the primary data is the primitive value. There is a wrapper class for each primitive data type, which we have already discussed. Each wrapper class corresponds to a specific primitive value. To box a primitive value, we can use the static overloaded factory method value of provided by each wrapper class, which takes a primitive value as input and returns an instance of the corresponding wrapper class. As you may recall, factory methods are frequently used in Java to create new instances of a class instead of using the new keyword. The following code example demonstrates the use of a factory method to create an instance of the java.lang.integer class and assign it to a boxed integer variable with the value 10. We can describe this code as manually boxing a primitive integer. Another method of boxing that you may encounter in older Java code involves creating a new instance of the wrapper class using the new keyword and passing the primitive value to the constructor. An example of this is shown here. However, it's worth noting that if you attempt to use this method in IntelliJ with any Java version beyond JDK 9, IntelliJ will notify you that this is deprecated code. When a feature or method is marked as deprecated, it means that it is outdated and may no longer be supported in future versions of the software. Therefore, it is advisable to find an alternative approach to achieve the same functionality. According to Java documentation, using the constructor to box primitives is not the most optimal approach. Instead, it is recommended to use the static factory method value of, as it typically results in better space and time performance. This deprecation applies to all wrapper classes constructors, not just integer. Fortunately, Java provides a feature called autoboxing, which allows primitive types to be automatically converted to their corresponding wrapper class objects. This can save developers from manually boxing primitives and can simplify code readability. In Java, we can use autoboxing to assign a primitive to a wrapper variable directly, without manually boxing it using a factory method or a constructor. This approach is actually preferred over manual boxing. When we assign a primitive value to a wrapper variable, Java automatically creates an instance of the corresponding wrapper class and sets its value to the primitive value. This is done underneath the covers, and Java's autoboxing mechanism provides the best way to do it. So, unboxing is the process of obtaining the primitive value from the wrapper object. Every wrapper class in Java provides a method to retrieve the primitive value it contains. In the example as shown here, the primitive value 10 is assigned to a variable called boxedInteger using autoboxing. This gives us an object which is an integer wrapper class and has the value of 10. To unbox this integer object and get the primitive int value, we can use the intValue method of the integer class. This process of unboxing is also called manual unboxing or simply unboxing. However, in most cases, it's unnecessary to manually unbox as Java provides automatic unboxing when needed. In most cases, automatic unboxing is simply referred to as unboxing. We can directly assign an instance of a wrapper class to a primitive variable. The code shown here demonstrates this. In the second statement, we are assigning an object instance to a primitive variable. This is allowed because the object instance is an integer wrapper, and we're assigning it to a primitive type variable. Again, this is the recommended way to unbox a wrapper instance. Now we see another simple example of boxing and unboxing. Here you can see the example. In this example, we start by boxing a primitive integer value of 10 into an integer object using the value of method. This creates a new instance of the integer class with the value 10 and assigns it to the boxedInt variable. Next, we perform unboxing by creating a new integer object with the value 20 using the constructor, and then calling the intValue method to extract the primitive integer value and assign it to the primitive int2 variable. Note that starting from Java 5, autoboxing and auto-unboxing features were introduced that allow Java to automatically convert between primitive types and their corresponding wrapper classes. So, the above example could also be written using autoboxing and auto-unboxing as this example. In this case, Java automatically boxes the primitive integer value 10 into an integer object and assigns it to the boxedInt variable without the need for the value of method. Similarly, Java automatically unboxes the boxedInt2 variable into a primitive integer value and assigns it to the primitive int2 variable without the need for the intValue method. Let's see how boxing and unboxing differ from casting in Java. Boxing and unboxing are different from casting in Java as they involve conversion between primitive types and their corresponding wrapper classes, whereas casting involves conversion between different object types or between object types and primitive types. Boxing is the process of converting a primitive type to its corresponding wrapper class. For example, converting an int to an integer. Unboxing is the opposite process of converting a wrapper class to its corresponding primitive type. For example, converting an integer to an int. Casting, on the other hand, is used to convert an object from one type to another, or to convert a primitive type to another primitive type. For example, casting a parent class object to a child class object, or casting an int to a double. Casting can be done between different types of objects or between objects and primitives, but it cannot be done between primitive types and their corresponding wrapper classes. So, boxing and unboxing in Java provide several advantages, including convenience. Boxing and unboxing provide a convenient way to convert between primitive types and their corresponding object types without the need for explicit conversion. Generic support. Boxing and unboxing support generics, which means that you can use them with generic types and collections. We will discuss generics concept in upcoming lectures. Interoperability. Boxing and unboxing allow for interoperability between primitive types and their object counterparts. This is useful when working with libraries that only accept objects. Improved performance. With auto-boxing and auto-unboxing, the performance overhead is minimal, making it a viable option for most applications. Reduced memory footprint. Boxing and unboxing help reduce the memory footprint by allowing primitive types to be stored in collections and other data structures that require objects. As here are some potential disadvantages of boxing and unboxing in Java. Performance overhead. Boxing and unboxing operations can have performance overhead, as the process of creating an object and converting between primitive and wrapper types can take more time than simple variable assignments or operations. Memory consumption. Since boxing involves creating objects, it can lead to increased memory consumption. This can be a problem in cases where large amounts of data are being processed, or when memory usage is a concern. Difficulty in comparing values. When comparing wrapper types, you need to be careful to use the equals method instead of the equal sign operator, since the latter may not work as expected due to the way that objects are compared in Java. In summary, boxing and unboxing are concepts in Java related to the conversion of primitive types to their corresponding wrapper classes and vice versa. Boxing refers to the process of converting a primitive type to its corresponding wrapper class. For example, converting an int to an integer, or a double to a double. This is done automatically in Java using a mechanism called auto-boxing, which creates an object of the wrapper class with the primitive value. Unboxing, on the other hand, is the process of converting a wrapper class instance to its corresponding primitive type. For example, converting an integer to an int or a double to a double. This is done automatically in Java using a mechanism called auto-unboxing, which extracts the primitive value from the wrapper class instance. Both boxing and unboxing are useful in situations where primitive types need to be treated as objects. For example, when using them with Java collections or when calling methods that expect object arguments. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Auto-boxing and unboxing exercise. In this lecture, we will practice to see some examples using auto-boxing and unboxing. So, we start with a simple program. For this, we write a Java program to demonstrate auto-boxing and unboxing. Your program should perform the following operations. Create an integer variable with the value of 10. Use auto-boxing to convert the integer variable to an integer object. Print the value of the integer object to the console. Create an integer object with the value of 20. Use unboxing to convert the integer object to an integer variable. Print the value of the integer variable to the console. Let's start creating program. For this, open IntelliJ. Now, we first create a class file named AutoBoxingExample in the Nixware and Consulting package, and inside this class create a main method using shortcut PSVM. Then write int I is equal to 10 semicolon. Integer object is equal to I semicolon. Here an integer variable I is declared and initialized with a value of 10. Then, the value of I is assigned to an integer object variable integer object. This is an example of auto-boxing, which is the process of converting a primitive type that is int in this case, to its corresponding object wrapper class that is integer in this case. Java automatically performs this conversion because integer is an object type, and the is equal to operator requires that the types of the two operands match. So, the integer value 10 is automatically boxed into an integer object and assigned to integer object. After this line of code executes, integer object contains a reference to an integer object with the value of 10. Then we write systemout.println opening parentheses double quote the value of integer object colon plus integer object closing parentheses semicolon. This line of code will output a message to the console that says that the value of integer object is 10, because integer object contains a reference to an integer object with a value of 10. Then we write integer object 2 is equal to new integer parentheses 20 semicolon. Int j is equal to integer object 2 semicolon. Here an integer object variable integer object 2 is declared and initialized with a value of 20 using a constructor. Then, the value of integer object 2 is assigned to an integer variable j. This is an example of unboxing, which is the process of converting an object wrapper class that is integer to its corresponding primitive type that is int. Java automatically performs this conversion because int is a primitive type, and the is equal to operator requires that the types of the two operands match. So, the int value method of integer object 2 is called implicitly to unbox its value, which is then assigned to j. After this line of code executes, j contains the value of 20, which is the unboxed value of integer object 2. Then write systemout.println opening parentheses double quote the value of j plus j closing parentheses semicolon. This line of code will output a message to the console that says the value of j is 20, because j contains the unboxed value of integer object 2, which is 20. Now we run it. Here is the output that is, the value of integer object is 10, and the value of j is 20. Now we see another example. For this, write a program that have a fraction class. The program should create a fraction object with numerator 5 and denominator 2, and then print the fraction object to the console. Next, the program should unbox the fraction object and convert it to a double value, which should be printed to the console as well. The fraction class should have a constructor that takes in two integer parameters to set the numerator and denominator, a toString method that returns the fraction as a string in the format numerator divided by sign denominator, and a double value method that returns the decimal value of the fraction as a double. Let's start creating program. For this, we first create another class file named fraction in the Nixware and consulting package. Then we write private int numerator semicolon, private int denominator semicolon. Here the numerator and denominator are instance variables declared with private access modifier in the fraction class. They are used to store the numerator and denominator values of the fraction object. By declaring these variables as private, they can only be accessed within the fraction class and cannot be accessed directly from outside the class. Now we create a constructor by using IntelliJ functionality. For this, click on Code, then Generate, then Constructor, then select both fields and press OK. So, here we create a constructor that takes two integer parameters numerator and denominator. This constructor is used to create a new fraction object by initializing the numerator and denominator instance variables of the object with the values passed as arguments to the constructor. In the fraction constructor, this .numerator and this .denominator refer to the instance variables of the current object, while numerator and denominator refer to the parameters passed to the constructor. Then use a toString method. For this again, click on Code, then Generate, then toString, then select both fields and press OK. Now remove the statement inside this method and write return numerator plus double quote forward slash plus denominator semicolon. So, in the fraction class, the toString method is overridden to return a string representation of a fraction object in the form of a fraction. The method returns the numerator instance variable followed by a double quote divided by sign character, and then the denominator instance variable, concatenated as a string. For example, if the numerator is 5 and the denominator is 2, the toString method will return the string double quote 5 divided by sign 2. Then write public double value parentheses curly braces. Return parentheses double numerator divided by denominator semicolon. Here double value method in the fraction class is used to convert a fraction object to a double value. This method returns the result of dividing the numerator instance variable by the denominator instance variable, but casts the result to a double. This is done to ensure that the result is a floating point value and not an integer, which would result in the loss of any decimal places. For example, if the numerator is 5 and the denominator is 2, the result of numerator divided by denominator would be 2 if we don't cast the result to a double. However, casting the result to a double will give us 2.5, which is the correct decimal value of 5 divided by 2. This method is useful when we want to perform mathematical operations with fraction objects that require floating point values, such as calculating the average of several fractions. Now we create another class named main class in the same file. Now we create a main method inside this class using shortcut PSVM. Now we write int numerator is equal to 5 semicolon. Int denominator is equal to 2 semicolon. Here two integer variables numerator and denominator are declared and initialized with the values 5 and 2, respectively. These variables are then used to create a new fraction object called fraction object, using the fraction class constructor that takes two integer arguments. The numerator variable represents the top part of a fraction, and the denominator variable represents the bottom part of the fraction. So, we write fraction object is equal to new fraction opening parentheses numerator comma, denominator closing parentheses semicolon. Here we create a new fraction object with numerator 5 and denominator 2, and assigns it to the fraction object reference variable. So, in this code, boxing is not explicitly performed as the numerator and denominator variables are of primitive data type int. However, when the fraction object is created using these primitive values as arguments in the constructor, they are automatically boxed into integer objects as the fraction class constructor takes in two integer objects as parameters. This automatic conversion of primitive data types to their corresponding object wrapper classes is called auto-boxing. Therefore, when the fraction object is created, the numerator and denominator values are boxed into integer objects before being assigned to the numerator and denominator fields of the fraction object. Then write systemout.println opening parentheses double quote the value of fraction object plus fraction object closing parentheses semicolon. Here the toString method of the fraction class is called on the fraction object instance. This method returns a string representation of the fraction in the form numerator divided by denominator, which is concatenated with the string the value of fraction object using the concatenation operator plus. The resulting string is then passed as an argument to the print method of the system.out object, which prints the string to the console. Then we write double decimal value is equal to fraction object dot double value parentheses semicolon. Systemout.println opening parentheses double quote the decimal value of fraction object plus decimal value closing parentheses semicolon. Here the double value method in the fraction class returns a primitive double value. Therefore, when we call fraction object dot double value, the fraction object is automatically unboxed. That Isaiah the double value is extracted from the object and assigned to the variable decimal value. Finally, decimal value is printed using print method. Now we run it. Here is the output. In the first line of output, a new fraction object is created with a numerator of 5 and a denominator of 2. The toString method is called on this object when it is printed to the console, resulting in the output, the value of fraction object is 5 divided by sign 2. Then, in the second line of output, the double value method is called on fraction object, which returns the result of dividing the numerator by the denominator as a double value. This value is then printed to the console, resulting in the output, the decimal value of fraction object is 2.5. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to the enumeration. In this lecture, we will talk about the introduction to the enumeration. We already covered array lists and linked lists, which have a list of elements of the same type. Now we want to look at another list type in Java called an enum. The enum type is Java's type to support something called an enumeration. So, an enumeration is a type of data that consists of a fixed set of named values, which are also known as constants. These named values are defined within an enum type and are typically used to represent a specific group of related constants. Once an enum is defined, its values cannot be changed at runtime, making it a safe and convenient way to define a group of related constants that are used throughout an application. Enum types in Java are implemented using the enum keyword and can also have methods and fields defined within them. So, Java defines the enum type as a unique data type that comprises a predefined set of constant values. A constant is a type of variable whose value remains fixed once it has been assigned. In comparison to an array, the elements of an enum are predetermined and cannot be altered. Additionally, enum elements can be accessed through a constant name rather than an index position. An enum is similar to a class, with the difference being that it is defined using the enum keyword instead of class. Enum names can be any valid identifier, but like a class, it is recommended to use upper camel case as the naming convention. Within the enum body, you declare a list of constant identifiers separated by commas. By convention, these are all uppercase labels. An example of using an enum in Java is to represent different types of animals in a zoo. Each animal type can be declared as a constant within the enum, such as lion, tiger, bear, elephant, and giraffe. The order of the constants is not relevant in this case, as there is no natural order for animal types. Enum is a convenient way to define a limited set of constants that are related and used throughout an application. Another example of using an enum in Java is to represent the months of the year. The months can be declared as constants within the enum, such as January, February, March, and so on, with December being the last month of the year. Enum is a convenient way to define a limited set of constants that are related and used throughout an application. In this case, the order of the constants is based on the chronological order of the months in the year. Other examples of enum declarations might include the seasons of the year, types of vehicles such as cars, trucks, motorcycles, and boats, or different flavors of ice cream such as chocolate, vanilla, strawberry, and mint. There are several advantages of using enums in Java, like type safety. Enums provide type safety by restricting the possible values that a variable can take on. This helps to avoid runtime errors and makes code more reliable. Readability. Enums provide better readability to the code as compared to using constants or integer values. The constant names used in enums provide a more descriptive and meaningful representation of the values. Maintenance. Enums are easy to maintain as new values can be added to the enum without changing the existing code. Easy to use. Enums are simple to use and require less code than other methods of defining constants. Switch statement. Enums can be used in switch statements, which makes code more concise and easier to read. While enums have many advantages, there are also some potential limitations to consider when using them in Java, like limited flexibility. Enums are designed to represent a fixed set of values, so they may not be suitable for situations where the range of possible values is not known in advance or may need to change dynamically. Increased memory usage. Enums can consume more memory than other approaches to defining constants, as each enum value is implemented as an object with its own data and behavior. Limited extensibility. Once an enum is defined, it cannot be extended or modified. This means that if new values need to be added or existing values need to be changed, the enum must be modified and all the code that uses it must be updated. Can be overused. Enums can be tempting to use for every type of constant, even when other approaches might be more appropriate. This can lead to code that is harder to maintain and understand. So, the syntax for declaring an enum in Java is shown here. Here, enum name is the name of the enum, and constant 1, constant 2, up to, constant n are the constant values defined within the enum. The constants are separated by commas and are typically written in all caps. Each constant value in the enum is an instance of the enum name class and has its own name, which can be accessed using the dot notation, like this, enumName.constant1. You can also add additional fields, constructors, and methods to an enum, just like you can with a class. Here you can see an example of an enum that includes some additional fields and a method. So, in this example, an enum in Java that defines the types of animals with their names and number of legs. The animal enum includes 3 constants, dog, cat, and bird, each with its own name and number of legs. Here, dog is a constant defined in the enum animal. The parameters inside the parentheses define the name and the number of legs of the dog, respectively. Fido is the name of the dog, and 4 is the number of legs that a typical dog has. Similarly, the constant cat is defined as you can see here. Here, Fluffy is the name of the cat, and 4 is the number of legs that a typical cat has. Finally, the constant bird is defined. Here, Tweety is the name of the bird, and 2 is the number of legs that a typical bird has. The animal enum also includes a constructor that takes the name and number of legs as parameters and sets the corresponding fields. In this case, the constructor is defined like this. The getName and getNumLegs methods are defined to retrieve the name and number of legs of the animal, respectively. These methods can be called on any constant of the animal enum to get the corresponding values. I hope you learned something useful in this lecture as well, and I'll see you in the next one.